Completed 100 XP. 4 minutes. DevOps is the union of people, process, and products to enable continuous Completed 100 XP. 4 minutes. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. According to Donovan Brown in What is DevOps? The DevOps learning paths will help you prepare for a DevOps journey. You'll learn the main characteristics of the DevOps process, tools, and people involved during the lifecycle. Also, it prepares you for the Microsoft DevOps Solutions certification exam. You'll see other content to ensure you have a complete picture of DevOps. The module's content includes graphics, reference links, module review questions, and optional hands-on labs. You'll learn the following: how to plan for DevOps, use source control, scale Git for an enterprise, combine artifacts, design a dependency management strategy, manage secrets, implement continuous integration, implement a container build strategy, design a release strategy, set up a release management workflow, implement a deployment pattern, optimize feedback mechanisms, plan before you act. This module will help you understand what DevOps is and how to plan for a DevOps transformation journey. What is the DevOps transformation journey? Why should I take the DevOps learning path? People in these modules are interested in designing and implementing DevOps processes. Also, they're preparing for the AZ-400 Designing and Implementing Microsoft DevOps Solutions certification exam. The certification exam is for DevOps professionals. Combine people, processes, and technologies to continuously deliver valuable products and services that meet end-user needs and business goals. DevOps professionals streamline delivery by optimizing practices, improving communications and collaboration, and creating automation. They design and implement application code and infrastructure strategies that allow continuous integration, testing, delivery, monitoring, and feedback. Exam candidates must be proficient with Agile practices. They must be familiar with Azure administration, development, and experts in at least one of these areas. DevOps professionals must design and implement DevOps practices for version control, compliance, infrastructure as code, configuration management, build, release, and testing using Azure technologies. There are 5 domain areas. AZ-400 domain area. Weight. Design and implement processes and communications. 11%. Design and implement a source control strategy. 13%. Design and implement build and release pipelines. 51%. Develop a security and compliance plan. 16%. Implement an instrumentation strategy. 9%. Learning objectives. After completing the series, students and professionals can design and implement traceability and flow of work. Design and implement appropriate metrics and queries for DevOps. Configure collaboration and communication. Design and implement branching strategies for the source code. Configure and manage repositories. Design and implement a package management strategy. Design and implement a testing strategy for pipelines. Design and implement pipelines. Design and implement deployments. Design and implement infrastructure as code, IAC. Maintain pipelines. Design and implement authentication and authorization methods. Design and implement a strategy for managing sensitive information in automation. Automate security and compliance scanning. Configure monitoring for a DevOps environment. Analyze metrics from instrumentation. Prerequisites. Successful learners will have prior knowledge and understanding of the following. Cloud computing concepts include understanding PaaS, SaaS, and IaaS implementations. Azure administration and Azure development with proven expertise in at least one of these areas. Foundational DevOps concepts, including version control, agile software development, and core software development principles. It would be helpful to have experience in an organization that delivers software. If you're new to DevOps, consider taking the free online DevOps Foundations, the core principles and practices new. Instructor-led course, AZ-2008, DevOps Foundations, the core principles and practices new. If you're new to Azure and cloud computing, consider one of the following resources. Free online, Azure Fundamentals. Instructor-led course, AZ-900, Azure Fundamentals. If you're new to Azure administration, consider taking the free online Prerequisites for Azure Administrators. Instructor-led courses, AZ-104, Microsoft Azure Administrator. If you're new to Azure Developer, consider taking the free online Create Serverless Applications. Instructor-led courses, AZ-400, Developing Solutions for Microsoft Azure. You must create an Azure DevOps organization for some exercises. If you don't have it yet, see the following. You must create a GitHub account at github.com for some exercises. If you don't have it yet, see the following. What is DevOps? Completed 100 XP. 3 minutes. The contraction of Dev and Ops refers to replacing siloed development and operations. The idea is to create multidisciplinary teams that now work together with shared and efficient practices and tools. Essential DevOps practices include agile planning, continuous integration, continuous delivery, and monitoring of applications. DevOps is a constant journey. Understand your cycle time. Let us start with a basic assumption about software development. We will describe it with the OODA, observe, orient, decide, act, loop. Originally designed to keep fighter pilots from being shot out of the sky, the OODA loop is an excellent way to think about staying ahead of your competitors. You start with observing business, market, needs, current user behavior, and available telemetry data. Then you orient with the enumeration of options for what you can deliver, perhaps with experiments. Next, you decide what to pursue, and you act by delivering working software to real users. You can see all occurring in some cycle time. Become data-informed. We recommend you use data to inform what to do in your next cycle. Many experience reports tell us that roughly 1/3 of the deployments will have negative business results. Approximately 1/3 will have positive results, and 1/3 will make no difference. Fail fast on effects that do not advance the business and double down on outcomes that support the business. Sometimes the approach is called pivot or persevere. Strive for validated learning. How quickly you can fail fast or double down is determined by your cycle time. Also, in how long that loop takes, or in lean terms. Your cycle time determines how quickly you can gather feedback to determine what happens in the next loop. The feedback that you collect with each cycle should be factual, actionable data. We call it validated learning. Shorten your cycle time. When you adopt DevOps practices, you shorten your cycle time by working in smaller batches, using more automation, hardening your release pipeline, improving your telemetry, deploying more frequently. Optimize validated learning. The more frequently you deploy, the more you can experiment. The more opportunity you have to pivot or persevere and gain validated learning each cycle. This acceleration in validated learning is the value of the improvement. Think of it as the sum of progress that you achieve and the failures that you avoid. Completed 100 XP. 4 minutes. Remember, the goal is to shorten cycle time. Start with the release pipeline. How long does it take to deploy a change of one line of code or configuration? Ultimately, that is the brake on your velocity. Continuous integration drives the ongoing merging and testing of code, leading to an early finding of defects. Other benefits include less time wasted fighting merge issues and rapid feedback for development teams. Continuous delivery of software solutions to production and testing environments helps organizations quickly fix bugs and respond to ever-changing business requirements. Version control, usually with a Git-based repository, enables teams worldwide to communicate effectively during daily development activities. Also, integrate with software development tools for monitoring activities such as deployments. Use agile planning and lean project management techniques to plan and isolate work into sprints. Manage team capacity and help teams quickly adapt to changing business needs. A DevOps definition of done is working software collecting telemetry against the intended business goals. Monitoring and logging of running applications, including production environments for application health and customer usage. It helps organizations create a hypothesis and quickly validate or disprove strategies. Rich data is captured and stored in various logging formats. Public and hybrid clouds have made the impossible easy. The cloud has removed traditional bottlenecks and helped commoditize infrastructure. You can use infrastructure as a service, IaaS, to lift and shift your existing apps or platform as a service, PaaS, to gain unprecedented productivity. The cloud gives you a data center without limits. Infrastructure as code, IAC, enables the automation and validation of the creation and teardown of environments to help deliver secure and stable application hosting platforms. Use microservices architecture to isolate business use cases into small reusable services that communicate via interface contracts. This architecture enables scalability and efficiency. Containers are the next evolution in virtualization. They're much more lightweight than virtual machines, allow much faster hydration, and easily configure files. DevOps may hurt at first. If it hurts, do it more often. Adopting new practices like going to the gym is likely to hurt first. The more you exercise the new techniques, the easier they'll become. Like training at the gym, where you first exercise large muscles before small muscles, adopt practices that have the most significant impact. Cross-train to develop synergy. Note: the source article defines DevOps. Identify transformation teams. Completed 100 XP. 2 minutes. Unless you're building an entirely new organization, one of the significant challenges of any DevOps transformation project is dealing with actions that conflict in some way with ongoing business states. The first challenge is the availability of staff. If the staff members leading the transformation project are also involved in existing day-to-day work within the organization, it will be challenging for them to focus on the transformation when their current role directly impacts customer outcomes. We all know that desperate situations involving customers will always win over a long-term project like DevOps transformations. Another issue is how the organization operates. Implementing existing processes and procedures to support current business outcomes can make it difficult to disrupt the status quo required for a true DevOps transformation. In the book Beyond the Idea, How to Execute Innovation, Dr. Vijay Govindarajan and Dr. Chris Trimble noted that successful innovation often occurs despite existing organizational processes. They concluded that it only works by creating a separate team to pursue the transformation. For DevOps transformations, the separate team should be composed of staff members focused on and measured by the transformation outcomes, not involved in the day-to-day operational work. The team might also include external experts who can fill knowledge gaps and advise on processes that are new to existing staff members. Ideally, the staff members recruited should already be well regarded throughout the organization and offer a broad knowledge base to think outside the box as a group. Define organization structure for agile practices. Completed 100 XP. 3 minutes. For most organizations, reorganizing to be agile is difficult. It requires a mind shift and a culture shift that challenges many existing policies and processes within the organization. Good governance in organizations, particularly in large organizations, often leads to many relatively rigid rules, operating structures, and methods. It also tends to avoid a broad delegation of authority. While most large organizations haven't moved to an agile structure, most are now experimenting with doing so. Their business environments are volatile and complex, and they have seen the limitations of their current systems, mainly an inability to cope with change quickly. They realize that it's common today for long-term established businesses and their industries to be disrupted by startups. Horizontal versus vertical teams. Traditionally, horizontal team structures divide teams according to the software architecture. In this example, the teams have been divided into the user interface, service-oriented architecture, and data teams. By comparison, vertical team structures span the architecture and are aligned with skill sets or disciplines. Vertical teams have been shown to provide more good outcomes in agile projects. Each product must have an identified owner. Another key benefit of the vertical team structure is that scaling can occur by adding teams. In this example, feature teams have been created rather than just project teams. Explore shared goals and define timelines. Completed 100 XP. 2 minutes. Explore shared goals. These outcomes should include specific, measurable targets like reduce the time spent on fixing bugs by 60%. Reduce the time spent on unplanned work by 70%. Reduce the out-of-hours work required by staff to no more than 10% of total working time. Remove all direct patching of production systems. Note: one of the aims of DevOps is to provide more excellent customer value, so outcomes should have a customer value focus. Define timelines for goals. Measurable goals also need to have timelines. While it is easy to set longer-term goals, it is also easy to put off work when you do not require it for a while. It is essential to have an ongoing series of short-term goals. Overall, projects should have timelines that span anywhere from a few months to a year or two in any DevOps transformation project. Every few weeks, the improvements should be clear and measurable. Ideally, evident to the organization or its customers. The timeline should not be too short and should always be challenging yet achievable. A review should occur after each short-term goal to help plan the next one. There are several advantages of the shorter timelines. It is easier to change plans for priorities when necessary. The reduced delay between doing work and getting feedback helps ensure that the learnings and feedback are incorporated quickly. It is easier to keep organizational support when positive outcomes are clear. What is Azure DevOps? Completed 100 XP. 2 minutes. Azure DevOps is a software as a service (SaaS) platform from Microsoft that provides an end-to-end DevOps toolchain for developing and deploying software. It also integrates with the most leading tools on the market and is an excellent option for orchestrating a DevOps toolchain. What does Azure DevOps provide? Azure DevOps includes a range of services covering the complete development lifecycle. Azure Boards, Agile Planning work item tracking, visualization, and reporting tool. Azure Pipelines, a language, platform, and cloud-agnostic CI/CD platform supporting containers or Kubernetes. Azure Repos provides cloud-hosted private Git repos. Azure Artifacts provides integrated package management with support for Maven, NPM, Python, and NuGet package feeds from public or private sources. Azure Test Plans provides an integrated planned and exploratory testing solution. Also, you can use Azure DevOps to orchestrate third-party tools. What if we are not a Microsoft/Microsoft.NET organization? Azure DevOps is not focused on organizations that are end-to-end Microsoft or Windows. Azure DevOps provides a platform that is flexible. You do not have to go all in on Azure DevOps. It is possible to adopt each of the services independently and integrate them with your existing toolchain. Most popular tools are supported. Cross-platform, designed to work with any platform, Linux, Mac OS, and Windows. Or language, including Node.js, Python, Java, PHP, Ruby, C/C++, .NET, Android, and iOS apps. Azure DevOps is not aimed at organizations building and shipping on the Microsoft technology stack. Cloud agnostic, continuous delivery is supported to AWS, GCP, and Azure. What is GitHub? Completed 100 XP. 1 minute. GitHub is a software as a service (SaaS) platform from Microsoft that provides Git-based repositories and DevOps tooling for developing and deploying software. It has a wide range of integrations with other leading tools. What does GitHub provide? GitHub provides a range of services for software development and deployment. Codespaces provides a cloud-hosted development environment based on Visual Studio Code that can be operated from within a browser or external tools. Eases cross-platform development. Repos, public and private repositories based upon industry-standard Git commands. Actions allows for the creation of automation workflows. These workflows can include environment variables and customized scripts. Packages, the majority of the world's open source projects are already contained in GitHub repositories. GitHub makes it easy to integrate with this code and with other third-party offerings. Security provides detailed code scanning and review features, including automated code review assignment. Design a license management strategy. Completed 100 XP. 1 minute. When designing a license management strategy, you first need to understand your progress in the DevOps implementation phase. If you have a draft of the architecture you're planning for the DevOps implementation, you already know part of the resources to consume. For example, you started with a version control implementing Git and created some pipelines to build and release your code. If you have multiple teams building their solutions, you don't want to wait in the queue to start building yours. Probably, you want to pay for parallel jobs and make your builds run in parallel without depending on the queue availability. To consider. What phase are you in? How many people are using the feature? How long are you willing to wait if in the queue for pipelines? Is this urgent? Is this a validation only? Should all users access all features? Are they stakeholders? Basic users? Do they already have a Visual Studio license? Do you have an advanced package management strategy? Maybe you need more space for artifacts. For the latest, most up-to-date Azure DevOps pricing information, visit Azure DevOps Pricing. For the latest, most up-to-date GitHub pricing information, visit GitHub Pricing. What is source control? Completed 100 XP. 2 minutes. A source control system or version control system allows developers to collaborate on code and track changes. Use version control to save your work and coordinate code changes across your team. Source control is an essential tool for multi-developer projects. The version control system saves a snapshot of your files, history, so that you can review and even roll back to any version of your code with ease. Also, it helps to resolve conflicts when merging contributions from multiple sources. For most software teams, the source code is a repository of invaluable knowledge and understanding about the problem domain that the developers have collected and refined through careful effort. Source control protects source code from catastrophe and the casual degradation of human error and unintended consequences. Without version control, you're tempted to keep multiple copies of code on your computer. It could be dangerous. Easy to change or delete a file in the wrong code copy, potentially losing work. Version control systems solve this problem by managing all versions of your code but presenting you with a single version at a time. Tools and processes alone aren't enough to accomplish the above, such as adopting Agile, continuous integration, and DevOps. Believe it or not, all rely on a solid version control practice. Version control is about keeping track of every change to software assets, tracking and managing the who, what, and when. Version control is the first step needed to assure quality at the source, ensure flow and pull value, and focus on the process. All of these create value not just for the software teams, but ultimately for the customer. Version control is a solution for managing and saving changes made to any manually created assets. If changes are made to the source code, you can go back in time and easily roll back to previous working versions. Version control tools will enable you to see who made changes, when, and what exactly was changed. Version control also makes experimenting easy and, most importantly, makes collaboration possible. Without version control, collaborating over source code would be a painful operation. There are several perspectives on version control. For developers, it's a daily enabler for work and collaboration to happen. It's part of the daily job, one of the most used tools. For management, the critical value of version control is in IP security, risk management, time to market speed through continuous delivery, where version control is a fundamental enabler. Describe working with Git locally. Completed 100 XP. 7 minutes. Git and continuous delivery is one of those delicious chocolate and peanut butter combinations. We occasionally find two great tastes that taste great together in the software world. Continuous delivery of software demands a significant level of automation. It's hard to deliver continuously if you don't have a quality codebase. Git provides you with the building blocks to take charge of quality in your codebase. It allows you to automate most of the checks in your codebase. Also, it works before committing the code into your repository. To fully appreciate the effectiveness of Git, you must first understand how to carry out basic operations on Git. For example, clone, commit, push, and pull. The natural question is, how do we get started with Git? One option is to go native with the command line or look for a code editor that supports Git natively. Visual Studio Code is a cross-platform open-source code editor that provides powerful developer tooling for hundreds of languages. To work in open source, you need to embrace open-source tools. This recipe starts by setting up the development environment with Visual Studio Code, creating a new Git repository, committing code changes locally, pushing changes to a remote repository on Azure DevOps, getting ready. This tutorial teaches us how to initialize a Git repository locally. Then we use the ASP.NET Core MVC project template to create a new project and version it in the local Git repository. We'll then use Visual Studio Code to interact with the Git repository to do basic commit, pull, and push operations. You need to set up your working environment with the following: .NET 8 SDK or later, download .NET. Visual Studio Code, download Visual Studio Code. C# Visual Studio Code extension, C# programming with Visual Studio Code. Git downloads. Git for Windows, if you're using Windows, Git for Windows. The Visual Studio Marketplace features several extensions for Visual Studio Code that you can install to enhance your experience of using Git. Git Lens, this extension brings visualization for code history by using Git lame annotations and code lens. The extension enables you to seamlessly navigate and explore the history of a file or branch. Also, the extension allows you to gain valuable insights via powerful comparison commands and much more. Git History brings visualization and interaction capabilities to view the Git log, file history, and compare branches or commits. How to do it? Open the command prompt and create a new working folder. CMD. Dear My Web App CD My Web App. In My Web App, initialize a new Git repository. CMD. Git init. Configure global settings for the name and email address to be used when committing in this Git repository. CMD. Git config global user.name John Doe Git config global user.email john.doe@contoso.com. If you're working behind an enterprise proxy, you can make your Git repository proxy aware by adding the proxy details in the Git global configuration file. Different variations of this command allow you to set up an HTTP/HTTPS proxy with username password and optionally bypass SSL verification. Run the below command to configure a proxy in your global Git config. CMD. Git config global http.proxy http://proxy username, proxy password at proxy.server.com, port. Create a new ASP.NET Core application. The new command offers a collection of switches that can be used for language, authentication, and framework selection. More details can be found on Microsoft Learn. CMD. .NET New MVC. Launch Visual Studio Code in the context of the current working folder. CMD. Code. When the project opens in Visual Studio Code, select Yes for the required assets to build and debug are missing from My Web App. Add them. Warning message. Select Restore for the There are unresolved dependencies info message. Hit F5 to debug the application, then My Web App will load in the browser, as shown in the following screenshot. If you prefer to use the command line, you can run the following commands in the context of the Git repository to run the web application. CMD. .NET build .NET run. You notice the .vs code folder is added to your working folder. To avoid committing this folder to your Git repository, you can include it in the .gitignore file. Select a file from the .vs code folder, hit F1 to launch the command window in Visual Studio Code, type gitignore, and accept the option to include the selected file in the new gitignore file. Open your .gitignore, remove the file name from the path, and leave the folder with a slash, for example, .vscode/star. To stage and commit the newly created My Web App project to your Git repository from Visual Studio Code, navigate the Git icon from the left panel. Add a commit comment and commit the changes by clicking the checkmark icon. It will stage and commit the changes in one operation. Open program.cs, you notice Git Lens decorates the classes and functions with the commit history and brings this information in line to every line of code. Now launch CMD in the context of the Git repository and run git branch list. It shows you that only the main branch currently exists in this repository. Now run the following command to create a new branch called Feature DevOps Homepage. CMD. Git branch Feature DevOps Homepage Git checkout Feature DevOps Homepage Git branch list. You have created a new branch with these commands and checked it out. The list keyword shows you a list of all branches in your repository. The green color represents the branch that is currently checked out. Now navigate to the file \views\home\index.cshtml and replace the contents with the text below. C#. At view data title equals homepage div class equals text center h1 class equals display for welcome /h1p learn about a ref equals https://azure.microsoft.com/services/devops/azure devops/a angryface/p/div. Refresh the web app in the browser to see the changes. In the context of the Git repository, execute the following commands. These commands stage the changes in the branch and then commit them. CMD. Git status git add. Git commit m updated welcome page git status. To merge the changes from the Feature DevOps homepage into the main, run the following commands in the context of the Git repository. CMD. Git checkout main git merge Feature DevOps homepage. Run the below command to delete the feature branch. CMD. Git branch delete Feature DevOps homepage. How it works. The easiest way to understand the outcome of the steps done earlier is to check the history of the operation. Let us have a look at how to do it. In Git, committing changes to a repository is a two-step process. Running, add. The changes are staged but not committed. Finally, running the commit promotes the staged changes in the repository. To see the history of changes in the main branch, run the command git log v. To investigate the actual changes in the commit, you can run the command git log p. There is more. Git makes it easy to back out changes. Following our example, if you want to take out the changes made to the welcome page, you can do it hard resetting the main branch to a previous version of the commit using the following command. cmd git reset hard 5d2441f0b4f1e4ca1f8f83b56312513678c. Running the above command would reset the branch to the project init change. If you run git log v, you see that the changes done to the welcome page are removed from the repository. Introduction to Azure Repos. Completed 100 XP. 2 minutes. Azure Repos is a set of version control tools that you can use to manage your code. Using version control is a good idea whether your software project is large or small. Azure Repos provides two types of version control. Git, distributed version control. Team Foundation version control, TFVC centralized version control. What do I get with Azure Repos? Use free private Git repositories, pull requests, and code search. Get unlimited private Git repository hosting and support for TFVC that scales from a hobby project to the world's largest repository. Support for any Git client. Securely connect with and push code into your Git repository from any IDE, editor, or Git client. Webhooks and API integration. Add validations and extensions from the marketplace or build your own using webhooks and REST APIs. Semantic code search. Quickly find what you are looking for with a code-aware search that understands classes and variables. Collab to build better code. Do more effective Git code reviews with threaded discussion and continuous integration for each change. Use forks to promote collaboration with inner source workflows. Automation with built-in CI/CD. Set up continuous integration/continuous delivery, CI/CD, to automatically trigger builds, tests, and deployments, including every completed pull request using Azure pipelines or your tools. Protection of your code quality with branch policies. Keep code quality high by requiring code reviewer sign-out, successful builds, and passing tests before merging pull requests. Customize your branch policies to maintain your team's high standards. Usage of your favorite tools. Use Git and TFVC repositories on Azure Repos with your favorite editor and IDE. For further reference on using Git in Azure Repos, refer to Microsoft Learn. Introduction to GitHub. Completed 100 XP. 3 minutes. GitHub is the largest open source community in the world. Microsoft owns GitHub. GitHub is a development platform inspired by the way you work. You can host and review code, manage projects, and build software alongside 40 million developers from open source to business. GitHub is a Git repository hosting service that adds many of its features. While Git is a command line tool, GitHub provides a web-based graphical interface. It also provides access control and several collaboration features, such as wikis and essential task management tools for every project. So what are the main benefits of using GitHub? Nearly every open source project uses GitHub to manage its project. Using GitHub is free if your project is open source and includes a wiki and issue tracker, making it easy to have more in-depth documentation and get feedback about your project. What are some of the features offered by GitHub? Automate from code to cloud, cycle your production code faster, and simplify your workflow with GitHub packages and built-in CI/CD using GitHub Actions. Automate your workflows, build, test, deploy, and run CI/CD how you want in the same place you manage code. Trigger actions from any GitHub event to any available API. Build your actions in the language of your choice, or choose from thousands of workflows and actions created by the community. Packages at home with their code. Use actions to automatically publish new package versions to GitHub packages. Install packages and images hosted on GitHub packages or your preferred packages registry in your CI/CD workflows. It is always free for open source, and data transfer within actions is unlimited for everyone. Securing software together. GitHub plays a role in securing the world's code, developers, maintainers, researchers, and security teams. On GitHub, development teams everywhere can work together to secure the world's software supply chain, from fork to finish. Get alerts about vulnerabilities in your code. GitHub continuously scans security advisories for popular languages. Also, it sends security alerts to maintainers of affected repositories with details so they can remediate risks. Automatically update vulnerabilities. GitHub monitors your project dependencies and automatically opens pull requests to update dependencies to the minimum version that resolves known vulnerabilities. Stay on top of CVEs. Stay updated with the latest common vulnerabilities and exposures, CVEs, and learn how they affect you with the GitHub Advisory Database. Find vulnerabilities that other tools miss. CodeQL is the industry's leading semantic code analysis engine. GitHub's revolutionary approach treats code as data to identify security vulnerabilities faster. Eliminate variance. Never make the same mistake twice. Proactive vulnerability scanning prevents vulnerabilities from ever reaching production. Keep your tokens safe. Accidentally commit a token to a public repository? GitHub got you. With support from 20 service providers, GitHub takes steps to keep you safe. Seamless code review. Code review is the surest path to better code and is fundamental to how GitHub works. Built-in review tools make code review an essential part of your team's process. Propose changes. Better code starts with a pull request, a living conversation about changes where you can talk through ideas, assign tasks, discuss details, and conduct reviews. Request reviews. If you are on the other side of a review, you can request reviews from your peers to get the detailed feedback you need. See the difference. Reviews happen faster when you know exactly what changes. Disks compare versions of your source code, highlighting the new, edited, or deleted parts. Comment in context. Discussions happen in comment threads within your code. Bundle comments into one review or reply to someone else who is in line to start a conversation. Give clear feedback. Your teammates should not have to think too hard about what a thumbs up emoji means. Specify whether your comments are required changes or just a few suggestions. Protect branches. Only merge the highest quality code. You can configure repositories to require status checks, reducing human error and administrative overhead. All your code and documentation in one place. Hundreds of millions of private, public, and open source repositories are hosted on GitHub. Every repository has tools to help your host, version, and release code and documentation. Code where you collaborate. Repositories keep code in one place and help your teams collaborate with the tools they love, even if you work with large files using Git LFS. You can create or import as many projects as possible with unlimited private repositories for individuals and groups. Documentation alongside your code. Host your documentation directly from your repositories with GitHub pages. Use Jekyll as a static site generator and publish your pages from the /docs folder on your main branch. Manage your ideas, coordinate early, stay aligned, and get more done with GitHub's project management tools. See your project's large picture, see everything happening in your project, and choose where to focus your team's efforts with projects and task boards that live right where they belong, close to your code. Track and assign tasks. Issues help you identify, assign, and keep track of tasks within your team. You can open an issue to track a bug, discuss an idea within a mention, or start distributing work. The human side of software. Building software is more about managing teams and communities than coding. Whether on a group of 2 or 2,000, GitHub has the support your people need. Manage and grow teams. Help people organize with GitHub teams, level up to access administrative roles, and fine-tune your permissions with nested teams. Keep conversations. Moderation tools, like issue and pull request locking, help your team stay focused on code. And if you maintain an open source project, user blocking reduces noise and ensures productive conversations. Set community guidelines. Set roles and expectations without starting from scratch. Customize standard codes of conduct to create the perfect one for your project. Then choose a pre-written license right from your repository. GitHub offers excellent learning resources for its platform. You can find everything from Git introduction training to deep dive on publishing static pages to GitHub and how to do DevOps on GitHub right here. Knowledge check. Completed 200 XP. 4 minutes. Choose the best response for each question. Then select check your answers. Check your knowledge. 1. Which of the following choices best describes DevOps? DevOps is the role of who manages source control, pipelines, and monitor environments to continue delivering value to the software project. DevOps is a union of people, process, and products to enable continuous delivery of value to our end users. DevOps is the new process of creating continuous delivery and continuous integration for software projects. 2. Which of the following choices drives the ongoing merging and testing of code that leads to finding defects early? Continuous integration. Continuous delivery. Continuous feedback. 3. Which of the following choices is a practice that enables the automated creation of environments? Infrastructure as a service, IaaS. Infrastructure as code, IAC. Software as a service, SaaS. You must answer all questions before checking your work. Summary. Completed 100 XP. 2 minutes. This module explored the key areas that organizations must apply to start their DevOps transformation journey, change the team's mindset, and define timelines and goals. You learned how to describe the benefits and usage of. Understand what DevOps is and the steps to accomplish it. Identify teams to implement the process. Plan for the transformation with shared goals and timelines. Plan and define timelines for goals. Learn more. Introduction. Completed 100 XP. 3 minutes. This module introduces you to GitHub projects, GitHub project boards, and Azure boards. It explores ways to link Azure boards in GitHub, configure GitHub projects and project views, and manage work with GitHub projects. Learning objectives. After completing this module, students and professionals can describe GitHub projects and Azure boards. Link Azure boards in GitHub. Configure and manage GitHub projects and boards. Customize project views. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. You need to create a GitHub account at github.com and a project for some exercises. If you don't have it yet, join GitHub. If you already have your GitHub account, create a new repository creating a new repository GitHub Docs. Introduction to GitHub projects and project boards. Completed 100 XP. 3 minutes. Project boards. During the application or project lifecycle, it's crucial to plan and prioritize work. With project boards, you can control specific feature work, roadmaps, release plans, etc. Project boards are made up of issues, pull requests, and notes categorized as cards you can drag and drop into your chosen columns. The cards contain relevant metadata for issues and pull requests, like labels, assignees, the status, and who opened it. There are different types of project boards. User-owned project boards can contain issues and pull requests from any personal repository. Organization-wide project boards can contain issues and pull requests from any repository that belongs to an organization. Repository project boards are scoped to issues and pull requests within a single repository. To create a project board for your organization, you must be an organization member. It's possible to use templates to set up a new project board that will include columns and cards with tips. The templates can be automated and already configured. Templates. Description. Basic Kanban. Track your tasks with to do, in progress, and done columns. Automated Kanban. Cards automatically move between to do, in progress, and done columns. Automated Kanban with review. Cards automatically move between to do, in progress, and done columns, with extra triggers for pull request review status. Bug triage. Triage and prioritize bugs with to do, high priority, low priority, and closed columns. For more information about project boards, see Projects. Projects are a new, customizable, and flexible tool version of projects for planning and tracking work on GitHub. A project is a customizable spreadsheet in which you can configure the layout by filtering, sorting, grouping your issues and PRs, and adding custom fields to track metadata. You can use different views such as board or spreadsheet/table. If you change your pull request or issue, your project reflects that change. You can use custom fields in your tasks. For example, a date field to track target ship dates. A number field to track the complexity of a task. A single select field to track whether a task is low, medium, or high priority. A text field to add a quick note. An iteration field to plan work week by week, including support for breaks. For more information about projects, see Introduction to Azure Boards. Completed 100 XP. 3 minutes. Azure Boards is a customizable tool to manage software projects supporting Agile, Scrum, and Kanban processes by default. Track work, issues, and code defects associated with your project. Also, you can create your custom process templates and use them to create a better and more customized experience for your company. You have multiple features and configurations to support your teams, such as calendar views, configurable dashboards, and integrated reporting. The Kanban board is one of several tools that allows you to add, update, and filter user stories, bugs, features, and epics. You can track your work using the default work item types such as user stories, bugs, features, and epics. It's possible to customize these types or create your own. Each work item provides a standard set of system fields and controls, including discussion for adding and tracking comments, history, links, and attachments. If you need to create reports or a list of work with specific filters, you can use the Queries Hub to generate custom lists of work items. Queries support the following tasks. Find groups of work items with something in common. Triage work to assign to a team member or sprint and set priorities. Perform bulk updates. View dependencies or relationships between work items. Create status and trend charts that you can optionally add to dashboards. Delivery plans. It's possible to create another view with deliverables and track dependencies across several teams in a calendar view using delivery plans. Delivery plans are fully interactive, supporting the following tasks. View up to 15 team backlogs, including a mix of backlogs and teams from different projects. View custom portfolio backlogs and epics. View work that spans several iterations. Add backlog items from a plan. View roll-up progress of features, epics, and other portfolio items. View dependencies that exist between work items. For more information about Azure Boards, see Configure projects and teams in Azure DevOps. Completed 100 XP. 3 minutes. In today's highly dynamic software development landscape, efficient project organization and team collaboration are essential components of DevOps strategy. Projects and teams in Azure DevOps form the foundation for efficient communication, clear accountability, and streamlined workflow management. They also contribute towards enhanced agility, accelerated delivery, and proper alignment with business objectives. Planning. To build the optimal approach to implementing projects and teams, you should first analyze the organizational structure, its operational model, and the roles that contribute to the development lifecycle. This analysis should consider such factors as departmental divisions, current business initiatives, and any existing projects that might introduce potential cross-project dependencies. Next, for each new project, determine its scope, objectives, and stakeholders. Based on the organizational model and project requirements, identify the optimal way to structure the project's teams. Decide whether teams will be cross-functional or organized based on such criteria as features and components. Identify the roles and responsibilities within the project teams. Common roles include developers, testers, product owners, scrum masters, and project managers. Clearly define the expectations and responsibilities associated with each role. Ensure sufficient techniques and methods for collaboration and communication within and between teams. Establish governance policies and guidelines for project management, including version control policies, branching strategies, code review processes, and verification of compliance requirements. Define the Agile processes and methodologies that will be used for project management. Keep in mind that you can customize the Agile tools in Azure DevOps to support your decision. To streamline the process of creating new projects, consider defining templates or blueprints that define project structure, processes, and artifacts. Such templates might include predefined settings of source code repositories, work item tracking, pipelines, and test plans. Implementation. Once you complete all the preparations, proceed with implementing the planned project. At the very outset, you need to specify the project's visibility, public or private, decide between the Git and Team Foundation version control as the version control mechanism, and choose the work item process. That choice includes the following options. Agile focuses on iterative development and delivering customer value through user stories, backlogs, sprints, and visual boards for tracking progress. Basic offers a simple and flexible approach with generic work items and basic backlog and board functionalities, most suitable for small teams or projects. CMMI, Capability Maturity Model Integration, provides formalized processes and standards for managing work items, requirements, and quality assurance, which is most suitable for organizations seeking process improvement and compliance. Scrum employs an iterative, self-organizing framework with product and sprint backlogs, daily stand-ups, and artifacts for managing work and delivering incremental changes. Customized Scrum facilitates tailoring of the Scrum process to fit specific needs through flexibility in work item types, fields, and workflow states. With the project in place, you can proceed to building its team structure. By default, every project includes one team which name is derived from the project name, so, depending on the outcome of your planning, you might need to modify it. You might also want to create additional teams. Each team must have at least one administrator. Each team administrator can add team members. When creating a team, it is also possible to automatically generate an area path with the matching name. Area paths help organize work items within a project, facilitating better visibility, reporting, and access control. Associating individual teams with a dedicated area path helps clearly delineate between their areas of responsibility. Once the teams are created, you can configure for each of them a wide range of additional settings, including customized permissions. By default, team members are added to the contributors group on the project level. At this point, you can also start managing project resources such as repositories, boards, pipelines, and test plans and assign them to specific teams as required. In the spirit of continuous improvement, you should regularly review and refine the project and team configuration based on feedback from teams and project's members. This will ensure that your organization can efficiently manage the process of developing software products regardless of their complexity. Link GitHub to Azure Boards. Completed 100 XP. 2 minutes. Use GitHub, track work in Azure Boards. Use Azure Boards to plan and track your work in GitHub as source control for software development. Connect Azure Boards with GitHub repositories, enabling linking GitHub commits, pull requests, and issues to work items in Boards. Azure Boards app. The integration is created using the Azure Boards app, acting as a bridge between Azure Boards and GitHub. To install the app, you must be an administrator or owner of the GitHub repository or the GitHub organization. The app is installed from the GitHub Marketplace. Azure Boards app. Authenticating to GitHub. Azure Boards can connect to GitHub. For GitHub in the cloud, when adding a GitHub connection, the authentication options are username password, personal access token, PAT. For a walkthrough on making the connection, see Connect Azure Boards to GitHub. You can configure other Azure Boards/Azure DevOps projects, github.com repositories, or change the current configuration from the Azure Boards app page. Once you've integrated Azure Boards with GitHub using the Azure Boards app, you can add or remove repositories from the web portal for Azure Boards. Supported integration scenarios. Azure Boards GitHub integration supports the following connections. From GitHub. Support integration for all repositories for a GitHub account or organization or select repositories. Add or remove GitHub repositories participating in the integration and configure the project they connect to. Suspend Azure Boards GitHub integration or uninstall the app. From Azure Boards. Connect one or more GitHub repositories to an Azure Boards project. Add or remove GitHub repositories from a GitHub connection within an Azure Boards project. Completely remove a GitHub connection for a project. Allow a GitHub repository to connect to one or more Azure Boards projects within the same Azure DevOps organization or collection. Azure Boards GitHub integration supports the following operational tasks. Create links between work items and GitHub commits, pull requests, and issues based on GitHub mentions. Support state transition of work items to a done or completed state when using GitHub mention by using fix, fixes, or fixed. Support full traceability by posting a discussion comment to GitHub when linking from a work item to a GitHub commit, pull request, or issue. Show links to GitHub code artifacts within the work item development section. Show links to GitHub artifacts as annotations on Kanban board cards. Support status badges of Kanban board columns added to GitHub repositories. The following tasks aren't supported at this time. Query for work items with links to GitHub artifacts. However, you can query for work items with an external link count greater than 0. Note. Reference, Azure Boards GitHub integration. For more information, see. Configure GitHub projects. Completed 100 XP. 3 minutes. Create a project. To start working with GitHub projects, you first need to create an organization or user project. To create an organization project, on GitHub, navigate to the main page of your organization. Click Projects. Select the New Project drop-down menu and click New Project. To create a user project, on any GitHub page, click on your avatar, then select your projects. Select the New Project drop-down menu and click New Project. Create a project description or a README file. Navigate to your project. In the top right, click to open the menu. In the menu, click Settings. Under Add a Description, type your description in the text box and click Save. To update your project's README, type your content in the text box under README. Click Save. Adding issues. When your new project initializes, it prompts you to add items. Click on the plus symbol sign to add more issues. Project settings and permissions. You can view and make quick changes to your project description and README by navigating to your project and clicking on the top right. You can create custom fields to add to your project. Manage access and permissions by adding collaborators. For more information about projects, see Manage work with GitHub project boards. Completed 100 XP. 2 minutes. GitHub projects allow you to control project deliverables, release dates, and iterations to plan upcoming work. You can create an iteration to associate items with specific repeating blocks of time. Set to any length of time. Include breaks. It's possible to configure your project to group by iteration to visualize the balance of upcoming work. When you first create an iteration field, 3 iterations are automatically created. You can add other iterations if needed. Iteration field. You can use the command palette or the project's interface to create an iteration field. Tip. To open the project command palette, press Ctrl+K, Windows/Linux, or Command+K, Mac. Start typing any part of Create New Field. When Create New Field displays in the command palette, select it. Or follow the steps using the interface. Navigate to your project. Click in the plus symbol sign in the rightmost field header. A drop-down menu with the project fields will appear. Click in the new field. Enter a name for the new iteration field. Select the drop-down menu below and click Iteration. Optional, change the starting date from the current day, select the calendar drop-down next to Starts On, and click on a new starting date. To change the duration of each iteration, type a new number, then select the drop-down and click either days or weeks. Click Save and Create. Adding new iterations. Navigate to your project. In the top right, click to open the menu. In the menu, click Settings to access the project settings. Click the name of the iteration field you want to adjust. To add a new iteration of the same duration, click Add Iteration. Optional, customize the duration of the new iteration and when it starts. Click Next to add iteration. Select a starting date and duration. Click Add. Click Save Changes. Also, you can insert breaks into your iterations to communicate when you're taking time away from scheduled work. For more information about iterations, see Customize project views. Completed 100 XP. 3 minutes. Using project views, you can organize information by changing the layout, grouping, sorting, and filtering your work. You can create and use different visualizations, for example, board view. Project command palette. Use the project command palette to change settings and run commands in your project. Open the project command palette by pressing Command+K, Mac, or Control+K, Windows/Linux. Type any command part or navigate through the command palette window to find a command. You have multiple commands to apply, such as Switch Layout, Table. Show, Milestone. Sort by Assignees, ASC. Remove Sort by. Group by, Status. Remove Group by. Column Field by, Status. Filter by Status. Delete View. Note. For more information about GitHub Command Palette, see GitHub Command Palette GitHub Docs. Also, you can perform changes using the interface. Creating a project view. Project views allow you to view specific aspects of your project. Each view is displayed on a separate tab in your project. For example, you can have a view that shows all items not yet started, filter on status. A view that shows the workload for each team, grouped by a custom team field. A view that shows the items with the earliest target ship date, sort by a date field. To add a new view. To open the project command palette, press Command+K, Mac, or Control+K, Windows/Linux. Start typing New View to create a new view, or Duplicate View to duplicate the current view. Choose the required command. The new view is automatically saved. For more information about projects, beta, see Collaborate using team discussions. Completed 100 XP. 3 minutes. GitHub discussions can help make your team plan together, update one another, or talk about any topic you'd like in discussion posts on your team's page in an organization. You can use team discussions for conversations that span across projects or repositories, issues, pull requests, etc. Instead of opening an issue in a repository to discuss an idea, you can include the entire team by having a conversation in a team discussion. With team discussions, you can post on your team's page or participate in a public discussion. Link to any team discussion to reference it elsewhere. Pin important posts to your team's page. Receive email or web notifications. Team discussions are available in organizations by default. You can also use organization discussions to facilitate conversations across your organization. For more information about team discussion, see Design and implement a strategy for feedback cycles. Completed 100 XP. 3 minutes. The continuing success of practically every software product is contingent on the ability to assess its state from any stage of its life cycle. Feedback cycles deliver the data required for this assessment, promoting continuous improvement. Robust notification systems ensure that teams developing and supporting the product have up-to-date information to act on and can respond in a timely manner. Effective issue management facilitates swift resolution through effective tracking and triage mechanisms. Design. Designing a strategy for feedback cycles, notifications, and issue management in Azure DevOps starts with defining channels for receiving feedback. This involves identifying sources such as user feedback forms, customer support tickets, bug reports, and automated testing results, and establishing processes to collect, organize, and prioritize this feedback. Notification rules play a crucial role in keeping team members informed about relevant software lifecycle events. The rules generate alerts for new work items, build failures, code reviews, and pull request approvals. They are customizable and can be tailored based on project requirements and individual preferences. Additionally, Azure DevOps supports integration of its internal feedback mechanisms with several external feedback delivery tools, which streamlines the process of aggregating relevant information from multiple sources. Customizable review and triage processes further enhance the efficiency of feedback management by supporting a range of prioritization criteria, including severity, impact, and customer value. Implementation. The implementation phase involves setting up notification rules within Azure DevOps to ensure that relevant stakeholders are promptly informed about key events and updates. This includes configuring notification settings based on team roles and project requirements. Issue tracking and management systems can be implemented by using Azure boards. Work item types are created to categorize different types of feedback, such as bugs, tasks, and user stories. Workflows provide guidance with issue resolution. Integration with external feedback tools and systems is typically facilitated through Azure DevOps extensions, allowing for seamless data synchronization and centralized feedback management. This could include linking to customer feedback portals, help desk systems, and third-party testing tools. Another important aspect of implementation is tracking of key performance indicators related to feedback cycles. Most followed indicators include response time, resolution time, customer satisfaction scores, and defect density. Regular reviews of feedback metrics assist with establishing baselines, identifying trends, and detecting anomalies indicative of emerging issues. In addition, such reviews help identify opportunities for process optimization, product enhancements, and quality improvements. Azure DevOps analytics and reporting capabilities considerably simplify reaching these objectives. Similarly, retrospectives and postmortems foster reviews of feedback cycles and lessons learned, leading to corrective actions that minimize the possibility of repeating past mistakes. Design and implement source, bug, and quality traceability. Completed 100 XP. 3 minutes. In the context of DevOps, traceability refers to the ability to track changes and actions throughout the software development lifecycle. This concept applies to different aspects of that lifecycle, including changes to source code, bug resolution, and maintaining quality control. Its implementation is essential to ensure product reliability, maintainability, and customer satisfaction. Source traceability enables developers to track code changes in collaboration scenarios. Bug traceability facilitates identifying, prioritizing, and resolving issues with the source code. Quality traceability ensures that software meets quality standards and user expectations by linking testing activities, metrics, and feedback to development efforts. Design. At a high level, traceability is tool agnostic, but the way to approach it depends on the aspect of software development lifecycle it is meant to target. Similarly, objectives and design considerations differ between source code, bug, and quality traceability. In particular, source traceability involves tracking the history of code changes, including who made the changes, when they were made, and the purpose of the changes. It facilitates code reviews, debugging, and understanding the evolution of the codebase over time. From the design standpoint, this functionality ties closely to Git branching and merging strategies that organize development work. Developers create feature branches for new work, commit changes to their branches, and submit pull requests for review. At that point, their peers conduct code reviews and, once successfully completed, approve the changes to be merged into the main branch. Bug traceability involves tracing bugs or defects reported during testing or production back to their root cause in the codebase. It also commonly relies on capturing information such as the bug report details, steps to reproduce, affected components, and related code changes. Its objectives include prioritizing and resolving bugs efficiently in order to address software deficiencies. Quality traceability encompasses tracing quality-related activities and artifacts throughout the software development process. This involves linking quality metrics, test cases, test results, and other quality assurance activities to requirements, user stories, and code changes. Quality traceability helps assess the impact of software changes on its quality and identify areas for improvement. Implementing traceability. Traceability implementation details differ to some extent depending on the DevOps platform. Source traceability. Since both GitHub and Azure DevOps support Git as their source control mechanism, a number of source traceability techniques apply to both of them. As the result, implementing source code traceability in both cases involves adopting best practices such as writing descriptive commit messages, using a well-defined branching strategy, and requiring pull requests for code reviews. However, there are also some differences between them. Implementing source traceability in GitHub repositories typically involves utilizing features such as branch protection rules to enforce code review processes and ensure changes are reviewed before merging. GitHub's integration with issues allows for linking code changes to corresponding issues, providing traceability between code modifications and project requirements. Azure DevOps offers branch policies and pull request policies for enforcing code quality checks and linking changes to work items, enabling traceability between code changes in user stories or tasks. Additionally, Azure DevOps provides more extensive integration with its work item tracking system, allowing for deeper traceability and reporting capabilities compared to GitHub's issue tracking. Bug traceability. In Azure DevOps, bug traceability is facilitated through Azure Boards, where bugs are tracked as work items and can be linked to code changes, commits, and pull requests. Azure Boards allows for creating custom workflows for bug management, defining states such as new, active, resolved, and closed, providing visibility into the bug's lifecycle. Additionally, Azure DevOps offers rich integration between bugs and other work items, enabling traceability between bugs and user stories, tasks, and epics. In GitHub, bug traceability relies on the integration between issues and code changes, where bugs reported as issues can be linked to commits and pull requests. GitHub Actions offer the ability to implement customizable workflows, including those related to bug traceability. With GitHub Actions, you can define workflows that automate processes triggered by events in your GitHub repository, such as the creation or modification of issues. This allows you to create custom workflows for managing bugs, including defining states, assigning tasks, and automating actions based on specific conditions. Effectively, while GitHub Actions provide flexibility in workflow automation, they typically require more effort and customization compared to the built-in features of Azure Boards in Azure DevOps. Quality traceability. In Azure DevOps, quality traceability can be managed using test plans, which allow teams to organize, execute, and track test cases. Test plans provide comprehensive quality metrics, including test case pass rates, test run outcomes, and test coverage reports. Additionally, Azure DevOps offers integration with code coverage tools to measure test coverage and identify areas of the codebase that require additional testing. GitHub offers similar functionality through GitHub Actions, enabling teams to automate various types of tests, such as unit tests, integration tests, and end-to-end tests. Here as well, GitHub Actions provides flexibility in setting up test workflows and integrating with third-party testing tools, but they tend to require additional configuration to achieve the same level of comprehensive quality metrics and test coverage reporting as Azure DevOps test plans. Agile Plan and Portfolio Management with Azure Boards. Completed 100 XP. 57 minutes. Estimated time, 60 minutes. Scenario. In this lab, you'll learn about the Agile planning and portfolio management tools and processes provided by Azure Boards and how they can help you quickly plan, manage, and track work across your entire team. You'll explore the product backlog, sprint backlog, and task boards that can track the flow of work during an iteration. We'll also look at the enhanced tools in this release to scale for larger teams and organizations. Objectives. After completing this lab, you'll be able to manage teams, areas, and iterations. Manage work items. Manage sprints and capacity. Customize Kanban boards. Define dashboards. Customize team process. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Exercises. During this lab, you'll complete the following exercises. Exercise 0. Configure the lab prerequisites. Exercise 1. Manage an Agile project. Exercise 2. Optional define dashboards. Knowledge check. Completed 200 XP. 3 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices best describes the Azure DevOps and GitHub integration? Azure Boards have direct integration with Azure Repos, but it can also be integrated with GitHub to plan and track work linking commits, PRs, and issues. Azure Boards has direct integration with Azure Repos. Azure Repos only integrates with GitHub using extensions from Marketplace for the read-only track. Azure Boards has direct integration with GitHub for tracking activities and moving tasks on both sides Azure Boards to GitHub and GitHub to Azure Repos. 2. Which of the following project boards types can contain issues and pull requests from any personal repository? User-owned project boards. Organization-wide project boards. Repository project boards. 3. Which of the following choices isn't a project board's supported template by default? Basic Kanban. Automated Kanban with review. Automated CMI. You must answer all questions before checking your work. Summary. Completed 100 XP. 3 minutes. This module introduced you to GitHub projects, GitHub project boards, and Azure boards. It explored ways to link Azure boards in GitHub, configure GitHub projects and project views, and manage work with GitHub projects. You learned how to describe the benefits and usage of. Describe GitHub projects and Azure boards. Link Azure boards in GitHub. Configure and manage GitHub projects and boards. Customize project views. Learn more. Introduction. Completed 100 XP. 1 minute. This module explores Git branching types, concepts, and models for the continuous delivery process. It helps companies define their branching strategy and organization. Learning objectives. After completing this module, students and professionals can describe Git branching workflows, implement feature branches, fork a repo, prerequisites, understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Explore branch workflow types. Completed 100 XP. 4 minutes. What is a successful Git branch workflow? When evaluating a workflow for your team, you must consider your team's culture. You want the workflow to enhance your team's effectiveness and not be a burden that limits productivity. Some things to consider when evaluating a Git workflow are: does this workflow scale with team size? Is it easy to undo mistakes and errors with this workflow? Does this workflow impose any new unnecessary cognitive overhead on the team? Common branch workflows. Most popular Git workflows will have some sort of centralized repo that individual developers will push and pull from. Below is a list of some popular Git workflows that we'll go into more detail about in the next section. These comprehensive workflows offer more specialized patterns about managing branches for feature development, hotfixes, and eventual release. Trunk-based development. Trunk-based development is a logical extension of centralized workflow. The core idea behind the trunk-based development workflow is that all development work takes place directly on the main branch, often called trunk or master. This approach emphasizes continuous integration, with developers frequently committing small, incremental changes to the main branch. Continuous integration and automated testing play a crucial role in maintaining code quality and stability. Feature branch workflow. The feature branch workflow emphasizes encapsulating each new feature or change in its dedicated branch separate from the main branch. Developers create a new branch for each feature or issue they are working on, develop and test the changes in isolation, and then merge the feature branch back into the main branch once it's complete and tested. This approach allows for parallel development of multiple features, facilitates code review, and ensures that the main branch remains stable. Release branch workflow. In a release branch workflow, a dedicated branch is created from the main branch when preparing for a release. This branch is used to stabilize the code, address any last-minute bugs or issues, and perform final testing before deploying the release to production. Once the release is considered to be ready, it is merged back into the main branch, and potentially into other long-lived branches such as development or feature branches. This strategy allows for a controlled and organized release process while keeping the main branch stable for ongoing development work. Forking workflow. The forking workflow is fundamentally different from the other workflows discussed in this tutorial. Instead of using a single server-side repository to act as the central codebase, it gives every developer a server-side repository. It means that each contributor has 2 Git repositories, a private local one and a public server-side one. This approach promotes a high degree of parallel development and collaboration among contributors while maintaining a clean and organized codebase. Explore feature branch workflow. Completed 100 XP. 4 minutes. The core idea behind the feature branch workflow is that all feature development should take place in a dedicated branch instead of the main branch. The encapsulation makes it easy for multiple developers to work on a particular feature without disturbing the main codebase. It also means the main branch will never contain broken code, a huge advantage for continuous integration environments. Encapsulating feature development also makes it possible to use pull requests, which are a way to start discussions around a branch. They allow other developers to sign out on a feature before it integrates into the official project. Or, if you get stuck in the middle of a feature, you can open a pull request asking for suggestions from your colleagues. Pull requests make it incredibly easy for your team to comment on each other's work. Also, feature branches can, and should, be pushed to the central repository. It allows sharing a feature with other developers without touching any official code. Since the main is the only special branch, storing several feature branches on the central repository doesn't pose any problems. It's also a convenient way to back up everybody's local commits. Release branch workflow. In addition to the feature branch workflow, another commonly used strategy in Git branching workflows is the release branch strategy. This strategy involves the creation of dedicated branches specifically for preparing releases. The release branch is typically created from a stable feature branch, ensuring that it contains only thoroughly tested and validated code. Once created, the release branch undergoes additional testing, bug fixes, and stabilization efforts to prepare the codebase for deployment. The release branch allows for the isolation of release-related activities from ongoing feature development, providing a controlled environment for finalizing and polishing the upcoming release. After all necessary adjustments and verifications have been made on the release branch, it is then merged into the main branch or deployed directly to production, depending on the team's release process. The release branch strategy helps teams manage the complexities of coordinating release activities while maintaining a stable main branch for ongoing development. Trunk-based development workflow. The trunk-based development workflow assumes a central repository, and the main represents the official project history. Instead of committing directly to their local main branch, developers create a new branch whenever they start working on a new feature. Feature branches should have descriptive names, like New Banner Images or Bug 91. The idea is to give each branch a clear, highly focused purpose. Git makes no technical distinction between the main and feature branches, so developers can edit, stage, and commit changes to a feature branch. Create a branch. When you're working on a project, you will have many different features or ideas in progress at any given time, some of which are ready to go and others that aren't. Branching exists to help you manage this workflow. When you create a branch in your project, you create an environment where you can try out new ideas. In addition to creating branches for new features or fixes, teams following a release branch workflow also create dedicated branches specifically for preparing releases. These release branches are typically derived from stable feature branches to ensure they contain thoroughly tested and validated code. Once created, the release branch undergoes additional testing, bug fixes, and stabilization efforts to prepare the codebase for deployment. Add commits. Once your branch has been created, it's time to make changes. Whenever you add, edit, or delete a file, you make a commit and add them to your branch. Adding commits keeps track of your progress as you work on a feature branch. Commits also create a transparent history of your work that others can follow to understand your actions and why. Each commit has an associated commit message explaining why a particular change was made. Furthermore, each commit is considered a separate unit of change. It lets you roll back changes if a bug is found or you decide to head in a different direction. Commit messages are essential, especially since Git tracks your changes and displays them as commits once pushed to the server. By writing clear commit messages, you can make it easier for others to follow along and provide feedback. Open a pull request. The pull requests start a discussion about your commits. Because they're tightly integrated with the underlying Git repository, anyone can see exactly what changes would be merged if they accept your request. You can open a pull request at any point during the development process when you've little or no code but want to share screenshots or general ideas. You're stuck and need help or advice. You're ready for someone to review your work. Using the mention system in your pull request message, you can ask for feedback from specific people or teams, whether they're down the hall or 10 time zones away. Pull requests help contribute to projects and for managing changes to shared repositories. If you're using a fork and pull model, pull requests provide a way to notify project maintainers about the changes you'd like them to consider. If you're using a shared repository model, pull requests help start code review and conversation about proposed changes before they're merged into the main branch. Discuss and review your code. Once a pull request has been opened, the person or team reviewing your changes may have questions or comments. Perhaps the coding style doesn't match project guidelines, the change is missing unit tests, everything looks excellent, and the props are in order. Pull requests are designed to encourage and capture this type of conversation. You can also continue to push to your branch, considering discussion and feedback about your commits. Suppose someone comments that you forgot to do something, or if there's a bug in the code, you can fix it in your branch and push up the change. Git will show your new commits and any feedback you may receive in the unified pull request view. Pull request comments are written in Markdown, so you can embed images and emojis, use pre-formatted text blocks, and other lightweight formatting. Deploy. With Git, you can deploy from a branch for final testing in an environment before merging to the main. Once your pull request has been reviewed and the branch passes your tests, you can deploy your changes to verify them. You can roll it back if your branch causes issues by deploying the existing main. Merge. Once your changes have been verified, it's time to merge your code into the main branch. Once merged, pull requests preserve a record of the historical changes to your code. Because they're searchable, they let anyone go back in time to understand why and how a decision was made. You can associate issues with code by incorporating specific keywords into your pull request text. When your pull request is merged, the related issues can also close. This workflow helps organize and track branches focused on business domain feature sets. Other Git workflows, like the Git forking workflow and the Git flow workflow, are repo-focused and can use the Git feature branch workflow to manage their branching models. Explore Git branch model for continuous delivery. Completed 100 XP. 3 minutes. The purpose of writing code is to ship enhancements to your software. A branching model that introduces too much process overhead doesn't help increase the speed of getting changes to customers. Developing a branching model gives you enough padding not to ship poor quality changes. But, at the same time, doesn't introduce too many processes to slow you down. The internet is full of branching strategies for Git. While there's no right or wrong, a perfect branching strategy works for your team. You'll learn always to use the combination of feature branches and pull requests to have a ready-to-ship main branch. Getting ready. Let's cover the principles of what we suggest. The main branch. The main branch is the only way to release anything to production. The main branch should always be in a ready-to-release state. Protect the main branch with branch policies. Any changes to the main branch flow through pull requests only. Tag all releases in the main branch with Git tags. The feature branch. Use feature branches for all new features and bug fixes. Use feature flags to manage long-running feature branches. Changes from feature branches to the main only flow through pull requests. Name your feature to reflect its purpose. The release branch. Create a dedicated release branch from a stable feature branch to prepare for deployment. Ensure the release branch undergoes thorough testing and stabilization efforts. Apply bug fixes and necessary changes to the release branch before deployment. Tag releases in the release branch to mark significant milestones. List of branches. CMD. Bugfix/description features/featurename features/feature area/featurename hotfix/description users/username/description users/username/work item. Pull requests. Review and merge code with pull requests. Automate what you inspect and validate as part of pull requests. Tracks pull request completion duration and set goals to reduce the time it takes. We'll be using the My Web app created in the previous exercises. See Describe working with Git locally. In this recipe, we'll be using 3 trendy extensions from the marketplace. Azure CLI is a command line interface for Azure. Azure DevOps CLI. It's an extension of the Azure CLI for working with Azure DevOps and Azure DevOps Server designed to seamlessly integrate with Git, CI pipelines, and Agile tools. With the Azure DevOps CLI, you can contribute to your projects without leaving the command line. CLI runs on Windows, Linux, and Mac. Git pull request merge conflict. This open source extension created by Microsoft DevLabs allows you to review and resolve the pull request merge conflicts on the web. Any conflicts with the target branch must be resolved before a Git pull request can complete. With this extension, you can resolve these conflicts on the web as part of the pull request merge instead of doing the merge and resolving conflicts in a local clone. The Azure DevOps CLI supports returning the query results in JSON, Senc, YAML, YAMLC, table, TSV, and none. You can configure your preference by using the configure command. How to do it. Important. You need to have the project created in the first learning path. Describe working with Git locally. After you've cloned the main branch into a local repository, create a new feature branch, MyFeature1. My Web App. CMD. Git checkout bfeature/MyFeature1. Output. Switch to a new branch feature/MyFeature1. Run the git branch command to see all the branches. The branch showing up with an asterisk is the currently checked out branch. My Web App. CMD. Git branch. Output. Feature/MyFeature1. Main. Make a change to the program.cs file in the feature/MyFeature1 branch. My Web App. CMD. Notepad program.cs. Stage your changes and commit locally, then publish your branch to remote. My Web App. CMD. Git status. Output. On branch feature/MyFeature1 changes not staged for commit, use git add file. To update what will be committed, use git checkout file. To discard changes in working directory, modified, program.cs. My Web App. CMD. Git add. Git commit mfeature1 added to program.cs. Output. Feature/MyFeature170f6072. Feature1 added to program.cs. 1 file changed. 1 insertion, plus. My Web App. CMD. Git push uOrigin feature/MyFeature1. Output. Delta compression using up to 8 threads. Compressing objects, 100%, 3/3, done. Writing objects, 100%, 3/3, 348 bytes, 348.00 KB/s, done. Total 3, Delta 2, reuse 0, Delta 0, remote, analyzing objects. 3/3, 10 milliseconds, remote, storing pack file, done. 44 milliseconds, remote, storing index, done. 62 ms, to https://devazure.com/organization/team project/_git/mywebapp*, new branch. Feature/MyFeature1-feature/MyFeature1 branch feature/MyFeature1 set up to track remote branch feature/MyFeature1 from origin. The remote shows the history of the changes. Configure Azure DevOps CLI for your organization and project. Replace organization and project name. CMD. AZ DevOps configure default organization equals https://devazure.com/organization project equals project name. Create a new pull request using the Azure DevOps CLI to review the changes in the Feature1 branch. CMD. AZ repos PR create title review feature 1 before merging to main work items 3839 description hashtag merge feature 1 to main source branch feature / my feature 1 target branch main repository my web app open. Use the open switch when raising the pull request to open it in a web browser after it has been created. The delete source branch switch can be used to delete the branch after the pull request is complete. Also, consider using autocomplete to complete automatically when all policies have passed, and the source branch can be merged into the target branch. Note: for more information about AZ repos PR create parameter, see create a pull request to review and merge code. The team jointly reviews the code changes and approves the pull request. The main is ready to release. Team tags the main branch with the release number. Start work on feature 2. Create a branch on remote from the main branch and do the checkout locally. My web app. CMD. Git push origin main refs / head / feature / my feature 2. Output. Total 0, delta 0, reuse 0, delta 0 to https://devazure.com ** organization ** team project */ /git / my web app * new branch origin / head - ref / head / feature / my feature 2. My web app. CMD. Git checkout feature / my feature 2. Output. Switch to a new branch feature / my feature 2 branch feature / my feature 2 set up to track remote branch feature / my feature 2 from origin. Modify program.cs by changing the same comment line in the code changed in feature 1. Public class program // editing the same line file from feature 2 branch public static void main string args build web host args run public static I web host build web host string args equals web host.create default builder args.use startup.build. Commit the changes locally, push them to the remote repository, and then raise a pull request to merge the changes from feature / my feature 2 to the main branch. CMD. AZ repos PR create title review feature 2 before merging to main work items 4042 description hashtag merge feature 2 to main source branch feature / my feature 2 target branch main repository my web app open. A critical bug is reported in production against the feature 1 release with the pull request in flight. To investigate the issue, you need to debug against the version of the code currently deployed in production. To investigate the issue, create a new FOF branch using the release_feature 1 tag. My web app. CMD. Git checkout bfof / bug 1 release_feature 1. Output. Switch to a new branch FOF / bug 1. Modify program.cs by changing the same line of code that was changed in the feature 1 release. Public class program // editing the same line file from feature FOF branch public static void main string args build web host args run public static I web host build web host string args equals web host.create default builder args.use startup.build. Stage and commit the changes locally, then push changes to the remote repository. My web app. CMD. Git add. Git commit m adding FOF changes. Git push u origin FOF / bug 1. Output. To https://devazure.com ** organization */ team project */ /git / my web app * new branch FOF / bug 1 FOF / bug 1 branch FOF / bug 1 set up to track remote branch FOF / bug 1 from origin. Immediately after the changes have been rolled out to production, tag the FOF / bug 1 branch with the release_bug 1 tag, then raise a pull request to merge the changes from FOF / bug 1 back into the main. CMD. AZ repos PR create title review bug 1 before merging to main work items 100 description hashtag merge bug 1 to main source branch FOF / bug 1 target branch main repository my web app open. As part of the pull request, the branch is deleted. However, you can still reference the entire history using the tag. With the critical bug fix out of the way, let's review the feature 2 pull request. The branches page makes it clear that the feature / my feature 2 branch is 1 change ahead of the main and 2 changes behind the main. If you try to approve the pull request, you'd see an error message informing you of a merge conflict. The Git pull request merge conflict resolution extension makes it possible to resolve merge conflicts right in the browser. Navigate to the Conflicts tab and click on program.cs to resolve the merge conflicts. The user interface allows you to take the source, target, add custom changes, review, and submit the merge. With the changes merged, the pull request is completed. At this point, you can create a release branch based on the critical bug fix implemented in the FOF / bug 1 branch and merged into master. Using the git checkout command, create a dedicated release branch from the master branch. CMD. Git checkout be release / v1.1 main. This command creates a new branch named release / v1.1 based on the master branch. As significant milestones are reached during the release process, tag releases in the release branch using git tags. Tags serve as markers to denote specific versions of the software. CMD. Git tag a version 1.1 m release version 1.1. This command creates a tag named version 1.1 to mark the release version 1.1 in the release branch. How it works. We learned how the Git branching model gives you the flexibility to work on features in parallel by creating a branch for each feature. The pull request workflow allows you to review code changes using the branch policies. Git tags are a great way to record milestones, such as the version of code released. Tags give you a way to create branches from tags. We created a branch from a previous release tag to fix a critical bug in production. The branches view in the web portal makes it easy to identify branches ahead of the main. Also, it forces a merge conflict if any ongoing pull requests try to merge to the main without resolving the merge conflicts. A lean branching model allows you to create short-lived branches and push quality changes to production faster. Explore GitHub Flow. Completed 100 XP. 3 minutes. GitHub is the best tool to enable collaboration in your projects. GitHub Flow is a branch-based workflow suggested for GitHub. Note: to implement GitHub Flow, you'll need a GitHub account and a repository. See signing up for GitHub and create a repo. Tip: you can complete all steps of GitHub Flow through the GitHub web interface, command line, GitHub CLI, or GitHub desktop. The first step is to create a branch in your repository to work without affecting the default branch, and you give collaborators a chance to review your work. For more information, see creating and deleting branches within your repository. Make any desired changes to the repository. If you make a mistake, you can revert or push extra changes to fix it. Commit and push your changes to your branch to back up your work to remote storage, giving each commit a descriptive message. Each commit should contain an isolated, complete change, making it easy to revert if you take a different approach. Anyone collaborating with your project can see your work, answer questions, and make suggestions or contributions. Continue to create, commit, and push changes to your branch until you're ready to ask for feedback. Tip: you can make a separate branch for each change to make it easy for reviewers to give feedback or for you to understand the differences. Once you're ready, you can create a pull request to ask collaborators for feedback on your changes. See creating a pull request. Pull request review is one of the most valuable features of collaboration. You can require approval from your peers and team before merging changes. Also, you can mark it as a draft in case you want early feedback or advice before you complete your changes. Describe the pull request as much as possible with the suggested changes and what problem you're resolving. You can add images, links, related issues, or any information to document your change and help reviewers understand the PR without opening each file. See basic writing and formatting syntax and linking a pull request to an issue. Another way to improve PR quality and documentation and explicitly point something out to the reviewers is to use the comment section area. Also, you can mention or request a review from specific people or teams. There are other pull request configurations, such as automatically requesting a review from specific teams or users when a pull request is created or checks to run on pull requests. For more information, see about status checks and about protected branches. After the reviewer's comments and checks validation, the changes should be ready to be merged, and they can approve the pull request. See merging a pull request. If you have any conflicts, GitHub will inform you to resolve them. Addressing merge conflicts. After a successful pull request merges, there's no need for the remote branch to stay there. You can delete your branch to prevent others from accidentally using old branches. For more information, see deleting and restoring branches in a pull request. Note: GitHub keeps the commit and merges history if you need to restore or revert your pull request. Explore fork workflow. Completed 100 XP. 3 minutes. The forking workflow is fundamentally different than other popular Git workflows. Instead of using a single server-side repository to act as the central codebase, it gives every developer their server-side repository. It means that each contributor has 2 Git repositories: a private local, a public server-side. The forking workflow is most often seen in public open-source projects. The main advantage of the forking workflow is that contributions can be integrated without the need for everybody to push to a single central repository. Developers push to their server-side repositories, and only the project maintainer can push to the official repository. It allows the maintainer to accept commits from any developer without giving them written access to the official codebase. The forking workflow typically will be intended for merging into the original project maintainer's repository. The result is a distributed workflow that provides you a flexible way for large, organic teams, including untrusted third parties, to collaborate securely. This also makes it an ideal workflow for open-source projects. How it works. As in the other Git workflows, the forking workflow begins with an official public repository stored on a server. But when a new developer wants to start working on the project, they don't directly clone the official repository. Instead, they fork the official repository to create a copy of it on the server. This new copy serves as their personal public repository. No other developers can push to it, but they can pull changes from it. We'll see why this is necessary in a moment. After they've created their server-side copy, the developer does a git clone to get a copy of it onto their local machine. It serves as their private development environment, just like in the other workflows. When they're ready to publish a local commit, they push the commit to their public repository, not the official one. Then, they file a pull request with the main repository, which lets the project maintainer know that an update is ready to be integrated. The pull request also serves as a convenient discussion thread if there are issues with the contributed code. The following is a step-by-step example of this workflow. A developer forks an official server-side repository. It creates their server-side copy. The new server-side copy is cloned to their local system. A Git remote path for the official repository is added to the local clone. A new local feature branch is created. The developer makes changes to the new branch. New commits are created for the changes. The branch gets pushed to the developer's server-side copy. The developer opens a pull request from the new branch to the official repository. The pull request gets approved for merge and is merged into the original server-side repository. To integrate the feature into the official codebase, the maintainer pulls the contributor's changes into their local repository. Checks to make sure it doesn't break the project. Merges it into their local main branch. Pushes the main branch to the official repository on the server. The contribution is now part of the project, and other developers should pull from the official repository to synchronize their local repositories. It's essential to understand that the notion of an official repository in the forking workflow is merely a convention. The only thing that makes the official repository so official is that it's the repository of the project maintainer. Forking versus cloning. It's essential to note that forked repositories and forking aren't special operations. Forked repositories are created using the standard git clone command. Forked repositories are generally server-side clones managed and hosted by a Git service provider such as Azure Repos. There's no unique git command to create forked repositories. A clone operation is essentially a copy of a repository and its history. Implement branch merging restrictions. Completed 100 XP. 3 minutes. Branch merging restrictions in version control systems hosted by Azure DevOps and GitHub are essential for controlling code quality, facilitating collaboration, and enhancing stability in software development projects. They help organizations enforce code reviews, validate successful completion of automated tests, and prevent forced pushes to designated branches. These constraints help maintain the integrity of the codebase, prevent accidental changes, and ensure that only verified and approved changes are merged into production branches. The general concepts of branch merging restrictions are platform agnostic. While their implementation differs somewhat between Azure DevOps and GitHub, there are also plenty of similarities, providing, for the most part, feature parity between them. Azure DevOps. In Azure DevOps, you can implement branch merging restrictions by using branch protection-based policies. To implement branch protection, navigate to your repository in the Azure DevOps portal and select the branch you want to apply merging restrictions to. Alternatively, you can scope protection to the current and future branches that match a specified pattern. As part of the protection configuration, you can apply the following branch policies. Require a minimum number of reviewers, ensures that changes cannot be merged without the required number of approvals. Check for linked work items, encourages traceability by checking for linked items on pull requests. Check for comment resolution, verifies that all comments have been resolved on pull requests. Limit merge types, controls branch history by limiting the available types of merge when pull requests are completed. This includes the option to selectively enable or disable the following merge types. Basic merge, no fast forward preserves history exactly as it happened during development. Rebase and fast forward, creates a linear history by replaying the source branch commits onto the target without a merge commit. Squash merge, creates a linear history by condensing the source branch commits into a single new commit on the target branch. Rebase with merge commit, creates a semi-linear history by replaying the source branch commits onto the target and then creating a merge commit. Optionally, you can configure the following constraints. Build validation, validates code by pre-merging and building pull request changes. Status checks, require other services to post successful status to complete pull requests. Status checks are automated tasks that are triggered during the pull request process to verify certain criteria before allowing the pull request to be merged into the target branch. In Azure DevOps, status checks are associated with build pipelines and release pipelines. Automatically include reviewers, designate code reviewers to automatically include when pull requests change certain areas of code. You also have the option of locking a branch, effectively making it read-only. Note that Azure DevOps provides two options to bypass policy requirements for a repository. To implement them, you need to alter the default security configuration of the repository by setting the permissions to perform the following actions to allow. Bypass policies when completing pull requests. Bypass policies when pushing. It is essential to ensure that these permissions are granted only to designated individuals that understand the implications of these actions on the compliance with organizational standards and can exercise sound judgment regarding their use. GitHub. In GitHub, you can implement branch merging restrictions using branch protection rules. Branch protection rules define whether collaborators can delete or force push to the branch and set requirements for any pushes to the branch, such as passing status checks or a linear commit history. As with Azure DevOps, you can apply them to specific branches based on name pattern match. To implement branch protection rules, navigate to your repository in the GitHub web interface, on the Settings tab, and, in the navigation menu, select the Branches menu item. This will allow you to access the branch protection rules configuration. As part of the protection configuration, you can apply the following rules. Require a pull request before merging, requires that contributors submit pull requests for review and approval before merging their changes. Require status checks to pass before merging, designates status checks that must pass before allowing merges. When enabled, commits must first be pushed to another branch, then merged or pushed directly to a branch that matches this rule after status checks have passed. Require conversation resolution before merging. Ensures that all discussions and comments related to code changes are resolved before merging pull requests. Require signed commits. Mandates that commit push to protected branches are signed with verified signatures, enhancing security and ensuring the authenticity of code contributions. Require linear history. Prevents merge commits in protected branches, enforcing a linear history, which makes it easier to track and, if needed, reverse any changes. This effectively means that any pull requests must use a squash merge or a rebase merge. Require deployments to succeed before merging. Dictates that changes proposed in pull requests are thoroughly tested and validated before being integrated into the codebase. Lock branch, as its Azure DevOps equivalent, restricts write access to the branch, making it read-only. Do not allow bypassing the above settings. Eliminates the possibility of the other rules being bypassed by administrators and users granted the bypass branch protections permission. Allow force pushes. Allow users with the push privileges to force push changes. As with Azure DevOps, this is meant as an emergency measure only. Allow deletions. Allows users with push privileges to delete protected branches. While this flexibility can streamline branch management, it also poses a risk of accidental or malicious branch deletions and should be carefully controlled to prevent data loss and maintain repository integrity. Version control with Git in Azure repos. Completed 100 XP. 60 minutes. Estimated time, 60 minutes. Scenario. Azure DevOps supports two types of version control, Git and Team Foundation Version Control, TFVC. Here's a quick overview of the two version control systems. Team Foundation Version Control, TFVC is a centralized version control system. Typically, team members have only one version of each file on their dev machines. Historical data is maintained only on the server. Branches are path-based and created on the server. Git is a distributed version control system. Git repositories can live locally on a developer's machine. Each developer has a copy of the source repository on their dev machine. Developers can commit each set of changes on their dev machine, perform version control operations such as history, and compare without a network connection. Git is the default version control provider for new projects. You should use Git for version control in your projects unless you need centralized version control features in TFVC. In this lab, you'll learn to establish a local Git repository, which can easily be synchronized with a centralized Git repository in Azure DevOps. In addition, you'll learn about Git branching and merging support. You'll use Visual Studio Code, but the same processes apply to using any Git-compatible client. Objectives. After completing this lab, you'll be able to clone an existing repository, save work with commits, review the history of changes, work with branches by using Visual Studio Code. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. If you don't have Git 2.44.0 or later installed, start a web browser, navigate to the Git for Windows download page, and install it. If you don't have Visual Studio Code installed yet, navigate to the Visual Studio Code download page from the web browser window, download it, and install it. If you don't have the Visual Studio C# extension installed yet, navigate to the C# extension installation page in the web browser window and install it. Exercises. During this lab, you'll complete the following exercises. Exercise 0. Configure the lab prerequisites. Exercise 1. Clone an existing repository. Exercise 2. Save work with commits. Exercise 3. Review history. Exercise 4. Work with branches. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices isn't a branch workflow type? Forking workflow. Trunk-based development. SmartFlow workflow. 2. Which of the following choices gives every developer a server-side repository? Feature branching. Trunk-based. Forking. 3. Which of the following choices creates a feature branch using Git commands? Git checkout be feature underscore branch. Git checkout and feature underscore branch. Git feature start feature underscore branch. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explored Git branching types, concepts, and models for the continuous delivery process. It helped companies define their branching strategy and organization. You learned how to describe the benefits and usage of. Describe Git branching workflows. Implement feature branches. Fork a repo. Learn more. Introduction. Completed 100 XP. 2 minutes. This module presents pull requests for collaboration and code reviews using Azure DevOps and GitHub Mobile for pull request approvals. It helps understand how pull requests work and how to configure them. Learning objectives. After completing this module, students and professionals can use pull requests for collaboration and code reviews. Give feedback using pull requests. Configure branch policies. Use GitHub Mobile for pull request approvals. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Collaborate with pull requests. Completed 100 XP. 4 minutes. Pull requests let you tell others about changes you've pushed to a GitHub repository. Once a pull request is sent, interested parties can review the set of changes, discuss potential modifications, and even push follow-up commits if necessary. Pull requests are commonly used by teams and organizations collaborating using the shared repository model. Everyone shares a single repository, and topic branches are used to develop features and isolate changes. Many open-source projects on GitHub use pull requests to manage changes from contributors. They help provide a way to notify project maintainers about changes one has made. Also, start code review and general discussion about a set of changes before being merged into the main branch. Pull requests combine the review and merge of your code into a single collaborative process. Once you're done fixing a bug or new feature in a branch, create a new pull request. Add the team members to the pull request so they can review and vote on your changes. Use pull requests to review works in progress and get early feedback on changes. There's no commitment to merge the changes, as the owner can abandon the pull request at any time. Get your code reviewed. The code review done in a pull request isn't just to find bugs, that's what your tests are concerning. A good code review catches less obvious problems that could lead to costly issues later. Code reviews help protect your team from bad merges and broken builds that sap your team's productivity. The review catches these problems before the merge, protecting your essential branches from unwanted changes. Cross-pollinate expertise and spread problem-solving strategies by using a wide range of reviewers in your code reviews. Diffusing skills and knowledge makes your team more robust and more resilient. Give great feedback. High-quality reviews start with high-quality feedback. The keys to great feedback in a pull request are: have the right people review the pull request. Make sure that reviewers know what the code does. Give actionable, constructive feedback. Reply to comments promptly. When assigning reviewers to your pull request, make sure you select the right set of reviewers. You want reviewers who know how your code works and try to include developers working in other areas to share their ideas. Also, who can provide a clear description of your changes and build your code that has your fix or feature running in it. Reviewers should try to provide feedback on changes they disagree with. Identify the issue and give a specific suggestion on what you would do differently. This feedback has clear intent and is easy for the owner of the pull request to understand. The pull request owner should reply to the comments, accept the suggestion, or explain why the suggested change isn't ideal. Sometimes the suggestion is good, but the changes are outside the scope of the pull request. Take these suggestions and create new work items and feature branches separate from the pull request to make those changes. Protect branches with policies. Your repos will typically contain one or more branches, including main, which require extra protection due to their criticality. Azure repos offer several policy-based mechanisms which you should consider implementing to help you reach this goal. The basic premise of these mechanisms is to apply constraints to pull requests. For example, you may include enforcing specific code review policies, such as requiring a minimum number of approvals from designated reviewers before a pull request can be merged. Leveraging collective expertise is bound to enhance the quality and reliability of code changes. In addition, consider implementing the check for linked work items policy. This verifies that every pull request is linked to a work item, providing context and promoting traceability. The check for comment resolution policy helps ensure that all code review comments are addressed before merging the pull request. Policies related to automated code analysis, testing, and compliance checks confirm that changes meet predefined standards before integration. Limiting merge types help maintain control branch history. For example, you have the option to permit only fast-forward and squash merges. It is also possible to mandate clean builds of new code versions before allowing them to be merged into the critical branches. This will ensure that the merged changes do not introduce build failures or regression issues. Status checks can be used to make completion of pull requests contingent on signals generated by external services. For example, such signals can be generated by Azure pipelines running automated tests and code analysis. Any branches that have required policies configured automatically block direct push, effectively enforcing pull requests for all changes. In addition, such branches cannot be deleted. Exercise Azure repos collaborating with pull requests. Completed 100 XP. 60 minutes. Code issues that are found sooner are both easier and cheaper to fix. So development teams strive to push code quality checks as far left into the development process as possible. As the name suggests, branch policies give you a set of out-of-the-box policies that can be applied to the branches on the server. Any changes being pushed to the server branches need to follow these policies before the changes can be accepted. Policies are a great way to enforce your team's code quality and change management standards. In this recipe, you'll learn how to configure branch policies on your main branch. Getting ready. The out-of-the-box branch policies include several policies, such as build validation and enforcing a merge strategy. We'll only focus on the branch policies needed to set up a code review workflow in this recipe. How to do it. Open the branches view for the My Web App Git repository in the Parts Unlimited team portal. Select the main branch, and from the pull-down context menu, choose Branch Policies. In the Policies view, it presents out-of-the-box policies. Set the minimum number of reviewers to 1. The Allow Requesters to Approve Their Own Changes option allows the submitter to self-approve their changes. While this might be acceptable for mature teams, in general, it should be avoided. Use the review policy with the comment resolution policy. It allows you to enforce that the code review comments are resolved before the changes are accepted. The requester can take the feedback from the comment and create a new work item and resolve the changes. It at least guarantees that code review comments aren't lost with the acceptance of the code into the main branch. A requirement instigates a code change in the team project. If the work item triggered the work isn't linked to the change, it becomes hard to understand why it was made over time. It's especially useful when reviewing the history of changes. Configure the Check for Linked Work Items policy to block changes that don't have a work item linked to them. Select the option to automatically include reviewers when a pull request is raised automatically. You can map which reviewers are added based on the area of the code being changed. How it works. With the branch policies in place, the main branch is now fully protected. The only way to push changes to the main branch is by first making the changes in another branch and then raising a pull request to trigger the change acceptance workflow. Choose to create a new branch from one of the existing user stories in the Work Item Hub. By creating a new branch from a work item, that work item automatically gets linked to the branch. You can optionally include more than one work item with a branch as part of the create workflow. Prefix in the name when creating the branch to make a folder for the branch to go in. In the preceding example, the branch will go in the folder. It is a great way to organize branches in busy environments. With the newly created branch selected in the web portal, edit the homecontroller.cs file to include the following code snippet and commit the changes to the branch. In the image below, you'll see that you can directly commit the changes after editing the file by clicking the commit button. The file path control in the team portal supports search. Start typing the file path to see all files in your Git repository under that directory, starting with these letters showing up in the file path search results dropdown. The code editor in the web portal has several new features in Azure DevOps Server, such as support for bracket matching and toggle white space. You can load the command palette by pressing it. Among many other new options, you can now toggle the file using a file minimap, collapse, and expand, and other standard operations. To push these changes from the new branch into the main branch, create a pull request from the pull request view. Select the new branch as the source and the main as the target branch. The new pull request form supports Markdown, so you can add the description using the Markdown syntax. The description window also supports mentions and hashtag to link work items. The pull request is created. The overview page summarizes the changes and the status of the policies. The Files tab shows you a list of changes and the difference between the previous and the current versions. Any updates pushed to the code files will show up in the Updates tab, and a list of all the commits is shown under the Commits tab. Open the Files tab. This view supports code comments at the line level, file level, and overall. The comments support both @ mentions and hashtag to link work items, and the text supports Markdown syntax. The code comments are persisted in the pull request workflow. The code comments support multiple iterations of reviews and work well with nested responses. The reviewer policy allows for a code review workflow as part of the change acceptance. It's an excellent way for the team to collaborate on any code changes pushed into the main branch. When the required number of reviewers approves the pull request, it can be completed. You can also mark the pull request to autocomplete after your review. It autocompletes the pull requests once all the policies have been successfully compiled. There's more. Have you ever been in a state where a branch has been accidentally deleted? It can be easy to figure out what happened. Azure DevOps Server now supports searching for deleted branches. It helps you understand who deleted it and when. The interface also allows you to recreate the branch. Deleted branches are only shown if you search for them by their exact name to cut out the noise from the search results. To search for a deleted branch, enter the full branch name into the branch search box. It will return any existing branches that match that text. You'll also see an option to search for an exact match in the list of deleted branches. If a match is found, you'll see who deleted it and when. You can also restore the branch. Restoring the branch will recreate it at the commit to which is last pointed. However, it won't restore policies and permissions. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check Your Answers. Check your knowledge. 1. Which of the following statements best describe a pull request? Pull requests are commonly used by teams and organizations collaborating, where everyone shares a single repository, and topic branches are used to develop features and isolate changes. Pull requests are used to publish new changes from feature branches into production branches and update the environments with the latest code version. Pull request creates reports from the latest branch updates and generates remediation summary for resolving issues during development. 2. Which of the following choices isn't a benefit of using pull requests? Protect branches with policies. Give feedback. Create reports about code security and quality. 3. Which of the following choices is the most effective way to avoid direct updates from feature branches into main? Branch policies. Branch security. Branch lock. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. Choose your shell. This module presented pull requests for collaboration and code reviews using Azure DevOps and GitHub Mobile for pull request approvals. It helped understanding how pull requests work and how to configure them. You learned how to describe the benefits and usage of. Use pull requests for collaboration and code reviews. Give feedback using pull requests. Configure branch policies. Use GitHub Mobile for pull requests approvals. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes Git hooks and their usage during the development process, implementation, and behavior. Learning objectives. After completing this module, students and professionals can understand Git hooks. Identify when used Git hooks. Implement Git hooks for automation. Explain Git hooks behavior. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but is not necessary. Beneficial to have experience in an organization that delivers software. Introduction to Git hooks. Completed 100 XP. 3 minutes. Continuous delivery demands a significant level of automation. You can't be continuously delivering if you don't have a quality code base. It's where Git fares so well. It lets you automate most of the checks in your code base before committing the code into your local repository, let alone the remote. Git hooks. Git hooks are a mechanism that allows code to be run before or after certain Git lifecycle events. For example, one could hook into the commit message event to validate that the commit message structure follows the recommended format. The hooks can be any executable code, including Shell, PowerShell, Python, or other scripts. Or they may be a binary executable. Anything goes. The only criteria are that hooks must be stored in the .git/hooks folder in the repo root. Also, they must be named to match the related events, git2.x. Apply patch message. Pre-apply patch. Post-apply patch. Pre-commit. Prepare commit message. Commit message. Post-commit. Pre-rebase. Post-checkout. Post-merge. Pre-receive. Update. Post-receive. Post-update. Pre-auto-GC. Post-rewrite. Pre-push. Practical use cases for using Git hooks. Since Git hooks execute the scripts on the specific event type they're called on, you can do much anything with Git hooks. Some examples of where you can use hooks to enforce policies, ensure consistency, and control your environment. In enforcing preconditions for merging. Verifying work item ID association in your commit message. Preventing you and your team from committing faulty code. Sending notifications to your team's chat room, Teams, Slack, HipChat, etc. In the next unit, you will see how to implement Git hooks. Implement Git hooks. Completed 100 XP. 4 minutes. Prioritizing code quality in the development process should start with local code development. It's important to identify opportunities for this practice even before starting pull requests to detect and rectify potential code quality issues. Git hooks offer a great opportunity. They serve as a mechanism for executing custom scripts in response to significant events within the Git lifecycle, such as commits, merges, and pushes. The scripts, located within the .git/hooks directory of the repository, provide practically unlimited flexibility in automating software development tasks and enforcing development standards. How to implement Git hooks. Let's start by exploring client-side Git hooks. Navigate to the repo.git/hooks directory. You find there many files with the extension sample. This extension not only indicates their purpose, but also effectively prevents them from running. The file names designate the Git actions that trigger their execution once you remove the sample extension. Rename the pre-commit sample file to pre-commit. As the name of the file indicates, the script it contains will run whenever you invoke the git commit action. The commit follows only if your pre-commit script exits with a 0 return value. However, it's important to note that, by default, this won't work as intended in any of the Windows operating systems. The commonly overlooked reason for this behavior is the first line of the script. Bash. #bin/sh. On Linux operating systems, the hashtag prefix indicates to the program loader that the remainder of the file contains a script to be interpreted and /bin/sh is the full path to the interpreter that should be used. While Git for Windows supports bash commands and shell scripts, it doesn't follow the same convention when designating file system paths. Instead, you need to provide full path to the sh.exe file, starting with the drive letter. However, there's an extra caveat, which results from the fact Git for Windows by default gets installed in the c:\program files directory. Since this directory contains a space in its name, the resulting path to the sh.exe file would be interpreted as two separate paths, resulting in a failure. To avoid it, it's necessary to add a single / symbol in front of the space to serve as an escape character. Effectively, when using the 64-bit version of Git for Windows, the first line of the script should have the following format. Bash. #c/program /files git/usr/bin/sh.exe. How to do it. How can you use the newly discovered functionality of Git pre-commit scripts? How about stopping you from accidentally leaking secrets to GitHub? Let's use the Git hook to scan the code being committed into your local repository for specific keywords. Replace the content of the pre-commit shell file with the following code. Bash. #c/program /files git/usr/bin/sh.exe matches $$ git diff index patch head grep + grep pi password secret if Z $matches, then cat \EOT error, words from the blocked list were present in the diff, EOT echo $matches exit 1 phi. This example is meant to illustrate the concept rather than a full-fledged solution, so the keyword list is intentionally trivial. By using regular expressions, you can significantly extend its scope and flexibility. You also have the option of referencing an external file, which would considerably simplify ongoing maintenance. How it works. Once invoked, the pre-commit hook script uses the git diff and grep commands to identify keywords or patterns within the incremental changes to the code that are being committed. If any matches are detected, the script generates an error message and prevents the commit from taking place. There's more. Other, common use cases of pre-commit hook scripts include code formatting, linting, or running custom tests to ensure the commit adheres to project standards. Prepare commit message runs before the commit message editor is launched. It allows for dynamic generation of commit messages in order to enforce naming conventions, such as the use of designated prefixes, for example, feat, for features or fix, for bug fixes. For example, the following prepare commit message script automatically prepends the current branch name to the commit message when creating a new commit. It modifies the commit message file, $1, by adding the branch name followed by a colon and space at the beginning of the file. Bash. Hashtag C/program /files git /usr /bin /sh.exe hashtag get the current branch name equals $, git branch show current, hashtag check if the commit message file exists if, $1, then hashtag prepend the branch name to the commit message set I1s /caret /branch name $1 phi. Post commit script executes after a commit completes. It can be used to trigger notifications or generate documentation. For example, the following script sends an email notification to a designated recipient after each commit. The script can be customized by modifying the recipient email address, SMTP server, and subject and body of the email. Additionally, you may need to configure your system to send emails using the Send Mail Message PowerShell kubelet or use a different method to send notifications, depending on your environment and requirements. Bash. Hashtag C/program /files git /usr /bin /sh.exe hashtag set the recipient email address $recipient equals your at email.com hashtag set the subject of the email $subject equals git commit notification hashtag set the body of the email $body equals a new commit has been made to the repository. Hashtag send the email notification send mail message to $recipient subject body $body SMTP server your .smtp.server. It's worth noting that the repo.git /hooks folder isn't committed into source control. You may wonder whether there's a way to share the scripts you developed with other member of your development team. The good news is that, starting with Git version 2.9, you can map Git hooks to a folder that can be committed into source control. You could do that by updating the global settings configuration for your Git repository. Bash. Git config global core.hooks path /githooks. If you ever need to overwrite the Git hooks you have set up on the client side, you can do so by using the noverify switch. Bash. Git commit noverify. Server-side hooks. While client-side Git hooks offer robust capabilities for enhancing the development workflow, Azure Repos also provides server-side hooks to further augment the development process, including support for creating pull requests. For more information, see the Azure Repos Service Hooks Events reference. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check Your Answers. Check your knowledge. 1. Which of the following choices isn't a Git hook event? Post-checkout. Pre-commit. After commit. 2. Which of the following choices is a practical use case for using Git hooks? Enforce preconditions for merging applying custom code with the event post-merge. Send notifications to your team's chat room. Validate code and merge branches automatically using the commit message event. 3. Which of the following choices is a valid event to verify work item ID association in your commit message before commit? Commit message. Commit message ID. Message commit. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described Git hooks and their usage during the development process, implementation, and behavior. You learned how to describe the benefits and usage of. Understand Git hooks. Identify when used Git hooks. Implement Git hooks for automation. Explain Git hooks behavior. Learn more. Introduction. Completed 100 XP. 1 minute. This module explains how to use Git to foster inner source and implement fork and its workflows. Learning objectives. After completing this module, students and professionals can use Git to foster inner source across the organization. Implement fork workflow. Choose between branches and forks. Share code between forks. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but is not necessary. Beneficial to have experience in an organization that delivers software. Explore foster inner source. Completed 100 XP. 3 minutes. The fork-based pull request workflow is popular with open source projects because it allows anybody to contribute to a project. You don't need to be an existing contributor or write access to a project to offer your changes. This workflow isn't just for open source. Forks also help support inner source workflows within your company. Before forks, you could contribute to a project using pull requests. The workflow is simple enough. Push a new branch up to your repository, open a pull request to get a code review from your team, and have Azure repos evaluate your branch policies. You can click one button to merge your pull request into main and deploy when your code is approved. This workflow is great for working on your projects with your team. But what if you notice a simple bug in a different project within your company and you want to fix it yourself? What if you're going to add a feature to a project that you use, but another team develops? It's where forks come in. Forks are at the heart of inner source practices. Inner source. Inner source, sometimes called internal open source, brings all the benefits of open source software development inside your firewall. It opens your software development processes so that your developers can easily collaborate on projects across your company. It uses the same processes that are popular throughout the open source software communities. But it keeps your code safe and secure within your organization. Microsoft uses the inner source approach heavily. As part of the efforts to standardize a one engineering system throughout the company, backed by Azure repos, Microsoft has also opened the source code to all our projects to everyone within the company. Before the move to the inner source, Microsoft was siloed. Only engineers working on Windows could read the Windows source code. Only developers working on Office could look at the Office source code. So, if you're an engineer working on Visual Studio and you thought that you found a bug in Windows or Office, or wanted to add a new feature, you're out of luck. But by moving to offer inner sources throughout the company, powered by Azure repos, it's easy to fork a repository to contribute back. As an individual making the change, you don't need to write access to the original repository, just the ability to read it and create a fork. Implement the fork workflow. 5 minutes. Most commonly, forks are used to propose changes to someone else's project. Most commonly, forks are used to propose changes. Completed 100 XP. 5 minutes. A fork is a copy of a repository. Forking a repository allows you to experiment with changes without affecting the original project freely. Most commonly, forks are used to propose changes to someone else's project, or use someone else's project as a starting point for your idea. A fork is a complete copy of a repository, including all files, commits, and, optionally, branches. Forks are a great way to support an inner source workflow. You can create a fork to suggest changes when you don't have permission to write to the original project directly. Once you're ready to share those changes, it's easy to contribute them back using pull requests. What's in a fork? A fork starts with all the contents of its upstream, original, repository. You can include all branches or limit them to only the default branch when you create a fork. None of the permissions, policies, or build pipelines are applied. The new fork acts as if someone cloned the original repository, then pushed it to a new, empty repository. After a fork has been created, new files, folders, and branches aren't shared between the repositories unless a pull request, PR, carries them along. Sharing code between forks. You can create PRs in either direction, from fork to upstream or upstream to fork. The most common approach will be from fork to upstream. The destination repository's permissions, policies, builds, and work items will apply to the PR. Choosing between branches and forks. For a small team, 2 to 5 developers, we recommend working in a single repo. Everyone should work in a topic branch, and the main should be protected with branch policies. As your team grows more significant, you may find yourself outgrowing this arrangement and prefer to switch to a forking workflow. We recommend the forking workflow if your repository has many casual or infrequent committees, like an open source project. Typically, only core contributors to your project have direct commit rights into your repository. It would help if you asked collaborators from outside this core set of people to work from a fork of the repository. Also, it will isolate their changes from yours until you've had a chance to vet the work. The forking workflow. Create a fork. Clone it locally. Make your changes locally and push them to a branch. Create and complete a PR to upstream. Sync your fork to the latest from upstream. Create the fork. Navigate to the repository to fork and choose fork. Specify a name and choose the project where you want the fork to be created. If the repository contains many topic branches, we recommend you fork only the default branch. Choose the ellipsis, then fork to create the fork. Note: you must have the create repository permission in your chosen project to create a fork. We recommend you create a dedicated project for forks where all contributors have the create repository permission. For an example of granting this permission, see set get repository permissions. Clone your fork locally. Once your fork is ready, clone it using the command line or an IDE like Visual Studio. The fork will be your origin remote. For convenience, after cloning, you'll want to add the upstream repository, where you forked from, as a remote named upstream. CMD. Git remote add upstream, upstream_URL. Make and push changes. It's possible to work directly in main after all, this fork is your copy of the repo. We recommend you still work in a topic branch, though. It allows you to maintain multiple independent workstreams simultaneously. Also, it reduces confusion later when you want to sync changes into your fork. Make and commit your changes as you normally would. When you're done with the changes, push them to origin, your fork. Create and complete a PR. Open a pull request from your fork to the upstream. All the policies required reviewers and builds will be applied in the upstream repo. Once all policies are satisfied, the PR can be completed, and the changes become a permanent part of the upstream repo. Important: anyone with the read permission can open a PR to upstream. If a PR build pipeline is configured, the build will run against the code introduced in the fork. Sync your fork to the latest. When you've gotten your PR accepted into upstream, you'll want to make sure your fork reflects the latest state of the repo. We recommend rebusing on upstream's main branch, assuming main is the main development branch. CMD. Git fetch upstream main git rebase upstream / main git push origin. The forking workflow lets you isolate changes from the main repository until you're ready to integrate them. When you're ready, integrating code is as easy as completing a pull request. Describe inner source with forks. Completed 100 XP. 5 minutes. People fork repositories when they want to change the code in a repository they don't have to write access to. If you don't have write access, you aren't part of the team contributing to that repository, so why would you modify the code repository? We tend to look for technical reasons to improve something in our work. You may find a better way to implement the solution or enhance functionality by contributing to or improving an existing feature. You can fork repositories in the following situations. I want to make a change. I think the project is exciting and may wish to use it. I want to use some code in that repository as a starting point for my project. Software teams are encouraged to contribute to all projects internally, not just their software projects. Forks are a great way to foster a culture of inner open source. Forks are a recent addition to the Azure DevOps Git repositories. This recipe will teach you to fork an existing repository and contribute changes upstream via a pull request. Getting ready. A fork starts with all the contents of its upstream, original, repository. When you create a fork in Azure DevOps, you can include all branches or limit them to only the default branch. A fork doesn't copy the permissions, policies, or build definitions of the repository being forked. After a fork has been created, the newly created files, folders, and branches aren't shared between the repositories unless you start a pull request. Pull requests are supported in either direction, from fork to upstream or upstream to fork. The most common approach for a pull request will be from fork to upstream. How to do it? Choose the fork button 1, then select the project where you want the fork to be created 2. Give your fork a name and choose the fork button 3. Once your fork is ready, clone it using the command line or an IDE, such as Visual Studio. The fork will be your origin remote. For convenience, you'll want to add the upstream repository, where you forked from, as a remote named upstream. On the command line, type cmd git remote add upstream _URL. It's possible to work directly in the main. This fork is your copy of the repo. We recommend you still work in a topic branch, though. It allows you to maintain multiple independent workstreams simultaneously. Also, it reduces confusion later when you want to sync changes into your fork. Make and commit your changes as you normally would. When you finish the modifications, push them to the origin, your fork. Open a pull request from your fork to the upstream. The upstream repo will apply all the policies required for reviewers and builds. Once all the policies are satisfied, the PR can be completed, and the changes become a permanent part of the upstream repo. When your PR is accepted upstream, you must ensure your fork reflects the latest repo state. We recommend rebusing on the upstream's main branch, assuming the main is the main development branch. On the command line, run cmd git fetch upstream main git rebase upstream / main git push origin. For more information about Git, see knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select check your answers. Check your knowledge. 1. Which of the following is a correct statement about a fork? A fork is a copy of a repository. A fork is a branch for future development. A fork is a branching strategy when working with centralized version control. 2. Which of the following choices are the correct forking workflow steps? Create a fork, make your changes locally and push them to a branch, create and complete a PR to the upstream. Create a fork, clone it locally, make your changes locally, push them to a branch, create and complete a PR to the upstream, and sync your fork to the latest from upstream. Create a fork, clone it locally, make your changes locally, create and complete a PR to the upstream, push the changes to a branch. 3. Which of the following choices is the recommended team size to use a single repo instead of fork workflow? Large teams. 10 to 20 developers. 2 to 5 developers. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explained how to use Git to foster inner source and implement fork and its workflows. You learned how to describe the benefits and usage of. Use Git to foster inner source across the organization. Implement fork workflow. Choose between branches and forks. Share code between forks. Learn more. Introduction. Completed 100 XP. 1 minute. This module explores how to work with large repositories and purge repository data. Learning objectives. After completing this module, students and professionals can understand large Git repositories. Explain Git Virtual File System, GVFS. Use Git Large File Storage, LFS. Purge repository data. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Work with large repositories. Completed 100 XP. 4 minutes. Git is a great version control system widely adopted and recommended, but a few concerns should be made and taken care of when working with large repositories. While having a local copy of repositories in a distributed version control system is functional, that can be a significant problem when large repositories are in place. For example, Microsoft discovered this issue when migrating a repository with over 300 gigabytes of data from an internal system to Git. Why repositories become large? There are 2 primary causes for large repositories. Long history. Large binary files. Shallow clone. If developers don't need all the available history in their local repositories, a good option is to implement a shallow clone. It saves both space on local development systems and the time it takes to sync. You can specify the depth of the clone that you want to execute. DOS. Git clone depth, clone URL. You can also reduce clones by filtering branches or cloning only a single branch. VFS for Git. VFS for Git helps with large repositories. It requires a Git LFS client. Typical Git commands are unaffected, but the Git LFS works with the standard file system to download necessary files in the background when you need files from the server. The Git LFS client was released as open source. The protocol is a straightforward one with 4 endpoints similar to REST endpoints. For more information on large repositories, see Working with Large Files and Virtual File System for Git. Enable Git at enterprise scale. Scalar. Scalar is a .NET Core application available for Windows and Mac OS, with tools and extensions for Git to allow very large repositories to maximize your Git command performance. Microsoft uses it for Windows and Office repositories. If Azure Repos hosts your repository, you can clone a repository using the GDFS protocol. It achieves by enabling some advanced Git features, such as partial clone, reduces time to get a working repository by not downloading all Git objects right away. Background prefetch, downloads Git object data from all remotes every hour, reducing the time for foreground Git fetch calls. Sparse checkout, limits the size of your working directory. File system monitor, tracks the recently modified files and eliminates the need for Git to scan the entire work tree. Commit graph, accelerates commit walks and reachability calculations, speeding up commands like git log. Multi-pack index, enables fast object lookups across many pack files. Incremental repack, repacks the packed Git data into fewer pack files without disrupting concurrent commands using the multi-pack index. Note: we update the list of features that Scalar automatically configures as a new Git version is released. For more information, see Explore monorepo versus multiple repos. Completed 100 XP. 3 minutes. A repository is where your work history is stored, usually in a Git subdirectory. How should you organize your code repository? Development teams aim to separate concerns in their software and repositories. As time passes, it isn't unusual for code repositories to become cluttered with irrelevant code and artifacts. When it comes to organizing your repositories, there are two main philosophies: using a single repository, monorepo, or multiple repositories. Monorepos is a source control pattern where all source code is kept in one repository. It's easy to give all employees access to everything at once. Clone it, and you're done. Organizing your projects into separate repositories is referred to as multiple repositories. The fundamental difference between monorepo and multiple repo philosophies is what enables teams to work together most efficiently. In an extreme scenario, the multiple repos view suggests that each subteam can work in its repository. It allows them to work in their respective areas using the libraries, tools, and development workflows that optimize their productivity. The cost of consuming anything not developed within a given repository is equivalent to using a third-party library or service, even if it was written by someone sitting nearby. If you come across a bug in your library, you should address it in the corresponding repository. Once you have published a new artifact, you can return to your repository and make the necessary code changes. However, if the bug is in a different codebase or involves different libraries, tools, or workflows, you may need to seek assistance from the owner of that system and wait for their response. When using the monorepo view, managing complex dependency graphs can increase the difficulty of using a single repository. The benefits of allowing different teams to work independently aren't substantial. Some teams may find an efficient way of working, but this may not be true for all groups. Furthermore, other teams may choose a suboptimal approach, negating any benefits gained by others. Consolidating all your work in a monorepo lets you focus on closely monitoring the single repository. The hassle of making changes in other repos or waiting for teams to make changes for you is avoided in a monorepo where anyone can change anything. If you discover a bug in a library, fixing it's as easy as finding a bug in your own code. Note: in Azure DevOps, it's common to use a separate repository for each associated solution within a project. Implement a changelog. Completed 100 XP. 3 minutes. The concept of a changelog is simple enough. It's a file that has a list of changes made to a project, usually in date order. The typical breakdown is to separate a list of versions, and then within each version, show added features, modified/improved features, deleted features. Some teams will post changelogs as blog posts, others will create a changelog.md file in a GitHub repository. Automated changelog tooling. While changelogs can be created and manually maintained, you might want to consider using an automated changelog creation tool, at least as a starting point. Using native GitHub commands. The git log command can be useful for automatically creating content. Example: create a new section per version. Bash. Git log options, vx.x.x, vx.x.y, helper script project changelogs /x.x.y. Git changelog. One standard tool is to changelog. This tool is based on Python. GitHub changelog generator. Another standard tool is called GitHub changelog generator. Bash. $GitHub_changelog_generator, u GitHub changelog generator, p timer trend 3.0. This tool is based on Gem. Should you use auto-generated log-based data? Preference is always to avoid dumping log entries into a changelog. Logs are noisy, so it's easy to generate a mess that isn't helpful. Implement Scalar and cross-repo when cross-repo sharing. Completed 100 XP. 3 minutes. As software projects grow in complexity and scale, traditional Git workflows may encounter challenges that impede efficiency and collaboration. These challenges can be addressed through a comprehensive repository management strategy that includes techniques such as Scalar and cross-repo sharing. Scalar. Scalar is a Git virtual file system extension developed by Microsoft that optimizes performance when managing large repositories, resulting in accelerated cloning and checkout operations. This is accomplished by using a combination of caching and background maintenance. When Scalar is used to clone a Git repository, it will cache the repository's metadata and store it locally on the user's machine. This metadata includes information about the repository's branches, tags, and commit history. By caching this data, Scalar can significantly reduce the time it takes to clone the repository. Subsequent Git operations can then use the cached data, further improving performance. Scalar also uses background maintenance to keep the cached metadata up to date. This means that Scalar will periodically fetch any changes to the repository and update the cached metadata accordingly. By doing this, Scalar ensures that the cached data is always current and accurate, which helps to further improve performance. Cross-repository sharing. Cross-repository sharing refers to the practice of sharing code, dependencies, and resources across multiple Git repositories within an organization. This promotes code reuse, collaboration, and maintainability by leveraging shared components and libraries across projects. Scaling and optimizing Git repositories. When designing an organizational strategy that supports scaling and optimization of Git repositories, you should account for several key considerations. Implementing Scalar for large repositories. Assess the size and complexity of each repository in your organization. Identify those of larger sizes and contain significant amounts of historical data. Consider implementing Scalar to improve their performance and reduce resource usage. Follow Microsoft's guidance on configuring Scalar to prefetch and cache data in a manner that optimizes performance. Optimizing repository structure. Evaluate the current structure of your Git repositories. Consider breaking down large monolithic repositories into smaller, more manageable ones, each focusing on a specific component or module. Adopt a modular approach to the way repositories are organized. Use Git submodules or Git subrepositories to manage dependencies between repositories while promoting code reuse and sharing across projects. Git submodules provide a way to include a Git repository as a subdirectory within another Git repository. This is useful when you want to include external code or libraries in your project. When you add a Git submodule, Git creates a text file called a .gitmodules file that contains information about the submodule, including its URL and the commit it's currently pointing to. Git subrepositories represent a newer approach to including a Git repository as a subdirectory within another Git repository. Unlike submodules, subrepositories are managed by a separate tool called Git subrepo and don't require a separate .gitmodules file. Additionally, subrepositories can be split off into their own standalone repositories at any time, while submodules always remain as part of the main repository. Promoting cross-repository sharing. Establish clear guidelines and best practices for sharing code and resources across repositories within your organization. Encourage the use of Git submodules or Git subrepositories to reference shared components or libraries hosted in separate repositories. As part of your design, consider a centralized package registry or artifact repository to publish and consume shared dependencies consistently across projects. Ensure to clearly communicate your strategy throughout the organization. Foster collaboration between teams to identify opportunities for code sharing and reuse and implement it based on your guidance. Recover specific data by using Git commands. Completed 100 XP. 3 minutes. The ability to recover data by using Git commands is crucial for developers to revert accidental changes, restore deleted files, or recover lost commits. It contributes to minimizing unexpected downtime and ensuring project continuity. However, while its benefits are clear, it's important to point out its potential risks. When applying the Git command described in this unit, it's essential to exercise proper caution, especially when manipulating commit history or reverting changes, as mistakes can lead to data loss. Git data recovery commands. Git commands that deal with data recovery can be grouped into several categories, including recovering commits, files, specific lines of code, and deleted commits or branches. Recovering commits. Git log lists the commit history of a repository. You can navigate through the log to find the commit you want to recover. Git checkout commit switches to a specific commit, effectively recovering the state of the repository at that commit. Git cherry-pick commit applies the changes introduced by a specific commit onto your current branch. Recovering files. Git checkout commit file restores a specific file from a previous commit. Git restore file discards local changes and restores the file to its last committed state, assuming that you haven't yet committed the changes. Recovering specific lines of code. Git blame file displays the revision and author of each line in a file, helping you identify the commit that introduced a particular change. Git show commit file displays the content of a file at a specific commit. You can specify the commit and file path to see the content as it existed at that point in time. Recovering deleted commits or branches. Git reflog displays a record of all commits. You can use it to find the SHA1 hash of a previously deleted commit or branch and then check out or restore it. Git fsck lost found checks the integrity of the repository and lists any commits that aren't reachable from any branch or tag. You can use this to recover lost commits. Remember to use these commands with caution, especially when manipulating commit history or reverting changes. Always make sure to create a backup of your repo before you start or use Git stash to save your current changes before attempting any recovery operations. Sample scenario. Let's step through a sample scenario that illustrates the process of using Git commands to recover a deleted file. We assume that a file named example.txt residing in your Git repository has been accidentally deleted and you need to recover it. Viewing commit history. Start by displaying the commit history, git log. In the commit history listing, identify the SHA1 hash of the commit where the file example.txt was last present. Restoring the deleted file. Once you've identified the SHA1 hash of the commit, use git checkout to restore the file, git checkout commit_sha_example.txt. Replace commit_sha with the SHA1 hash of the commit. The caret symbol indicates the parent of that commit, effectively restoring the file to its state before deletion. Verifying changes. After restoring the file, verify that it has been successfully restored by checking the repository status, git status. Validate that example.txt listed as a modified or untracked file. Staging and committing changes. If the file is listed as modified, stage it for commit, git add example.txt. Commit the changes with an appropriate commit message, git commit m restored example.txt. Purge repository data. Completed 100 XP. 4 minutes. While one of the benefits of Git is its ability to hold long histories for repositories efficiently, there are times when you need to purge data. The most common situations are where you want to significantly reduce the size of a repository by removing history. Remove a large file that was accidentally uploaded. Remove a sensitive file that shouldn't have been uploaded. If you commit sensitive data, for example, password key, to Git, it can be removed from history. Two tools are commonly used. Git Filter Repo Tool. The Git Filter Repo is a tool for rewriting history. Its core filter repo contains a library for creating history rewriting tools. Users with specialized needs can quickly create entirely new history rewriting tools. Note: more details are in the repository Git Filter Repo. BFG Repo Cleaner. BFG Repo Cleaner is a commonly used open source tool for deleting or fixing content in repositories. It's easier to use than the git filter branch command. For a single file or set of files, use the delete files option. Bash. $BFG delete files file _I_should_not_have _committed. The following bash shows how to find all the places that a file called passwords.txt exists in the repository. Also, to replace all the text in it, you can execute the replace text option. Bash. $BFG replace text passwords.txt. For more information, see. Quickly rewrite Git repository history. Removing files from Git large file storage. Removing sensitive data from a repository. BFG Repo Cleaner. Manage releases with GitHub repos. Completed 100 XP. 4 minutes. Part of the release process starts with your version control. You'll understand how to manage releases in the repository using GitHub. In the following modules, you'll see details about deploying a piece of software after packaging your code, binary files, release notes, and related tasks. Releases in GitHub are based on Git tags. You can think of a tag as a photo of your repository's current state. If you need to mark an essential phase of your code or your following deliverable code is done, you can create a tag and use it during the build and release process to package and deploy that specific version. For more information, see viewing your repository's releases and tags. When creating new releases with release notes, it's possible to mentions contributors, add links to binary files and edit or delete existing releases. Image reference, releases Microsoft/Azure Pipelines Agent, github.com. Also, you can publish an action from a specific release in GitHub Marketplace. Choose whether Git LFS objects are included in the zip files and tarballs GitHub creates for each release. Receive notifications when new releases are published in a repository. Creating a release. To create a release, use the ghrelease create command. Replace the tag with the desired tag name for the release and follow the interactive prompts. ghrelease create tag. To create a pre-release with the specified title and notes. ghrelease create version 1.2.1 title. If you mention any GitHub users in the notes, the published release on github.com will include a contributors section with an avatar list of all the mentioned users. You can check other commands and arguments from the GitHub CLI manual. Editing a release. You can't edit releases with GitHub CLI. To edit, use the web browser. Navigate to the main repository page on github.com. Click Releases to the right of the list of files. Click on the edit icon on the right side of the page, next to the release you want to edit. Edit the details for the release, then click Update Release. Deleting a release. To delete a release, use the following command, replace the tag with the release tag to delete, and use the Y flag to skip confirmation. ghrelease delete tag Y. For more information, see. Automate release notes with GitHub. Completed 100 XP. 5 minutes. After learning how to create and manage release tags in your repository, you'll learn how to configure the automatically generated release notes template from your GitHub releases. You can generate an overview of the contents of a release, and you can also customize your automated release notes. It's possible to use labels to create custom categories to organize pull requests you want to include or exclude specific labels and users from appearing in the output. Creating automatically generated release notes. While configuring your release, you see the option Auto-Generate Release Notes to include all changes between your tag and the last release. If you never created a release, it consists of all changes from your repository. You can choose if you want to customize it or leave it as it is. Configuring Automatically Generated Release Notes template. You can customize the Auto-Generate Release Notes template by using the following steps. Navigate to your repository and create a new file. You can use the name .github/release.yml to create the release.yml file in the .github directory. Specify in YAML the pull request labels and authors you want to exclude from this release. You can also create new categories and list the pull request labels in each. For more information about configuration options, see Automatically Generated Release Notes GitHub Docs. Example configuration. YML. #.github/release.yml changelog, exclude, labels, ignore for release authors, Octocat categories, title, breaking changes hammer and wrench labels, Semver major, breaking change title, exciting new features party popper labels, Semver minor enhancement title, other changes labels, asterisk. Commit your new file. Try to create a new release and click plus auto-generate release notes to see the template structure. For more information, see Create API documentation. Completed 100 XP. 3 minutes. Documenting the API of a source code repository is essential for providing clarity, accessibility, and ease of use to developers maintaining and consuming the API. Comprehensive documentation serves as a guide for understanding the functionality, inputs, outputs, and usage of the API endpoints. When documenting the API, you should select the most suitable presentation format, such as OpenAPI specification or Markdown, including examples and usage scenarios, keep it up to date with code changes, and solicit feedback from API consumers to continually improve its quality. While the general approach to documenting API is platform agnostic, there are some differences in its implementation between Azure DevOps and GitHub. Documenting API in Azure DevOps. To add API documentation to an Azure DevOps project in the most efficient manner, you should consider utilizing a dedicated documentation tool or platform that integrates with your development workflow. Popular choices in this category include Swagger, OpenAPI, API Blueprint, and Markdown-based documentation systems like MKDocs or Docusaurus. Their Azure DevOps integration capabilities help automate the process of generation documentation, keeping it in sync with the codebase. Most documentation tools also support parsing inline comments and including them in the auto-generated documentation. You should publish the API documentation to a central location accessible to your team members and stakeholders. This could be a dedicated documentation website, a wiki within Azure DevOps, or an external documentation portal. Alternatively, you can use code annotations or decorators directly within your code to add metadata that describes its API endpoints. Tools like Swagger CodeGen or SpringFox are able to process these annotations and generate the OpenAPI specification files. Set up automated processes within your Azure pipelines to generate API documentation automatically whenever there's a change to the codebase. This ensures that your documentation stays up to date and reflects the latest changes in your APIs. Documenting API in GitHub. When using GitHub, consider generating API documentation by leveraging tools that are part of the GitHub ecosystem. Start by documenting your API endpoints, operations, parameters, responses, and any other relevant information. Consider creating that documentation in a Markdown format to account for its broad support and ease of use. Define a consistent structure of individual documents, dividing each into sections that describe authentication, endpoints, request parameters, response examples, etc. As with Azure DevOps, you can use documentation generators or static site generators to streamline the process of generating API documentation from Markdown files. Popular choices include Jekyll, MKDocs, Docusaurus, and Hugo. Configure the generator to parse Markdown files and generate static HTML pages. You can customize the layout, theme, and styling to match your project's branding and preferences. To publish the HTML content, leverage GitHub pages, which allow you to host static websites directly from your GitHub repository. You can create for this purpose a dedicated branch and push the HTML files into this branch. You can also implement GitHub Actions to automatically build and deploy your API documentation whenever there's a change to the documentation files or the codebase. Set up GitHub Actions to automatically build and deploy your API documentation whenever there's a change to the documentation files or the codebase. Configure the automation workflow to generate the HTML documentation files using the chosen documentation generator and deploy them to GitHub pages. Implement automation of Git history documentation. Completed 100 XP. 3 minutes. Automated publishing of Git commit history, release notes, and API documentation streamlines the process of building comprehensive and up-to-date release documentation for software projects. This helps developers keep track of and communicate changes introduced in each release, promoting transparency and collaboration. Automating generation of API documentation ensures its synchronization with code changes, providing developers with accurate information about access to APIs and their functionality. Incorporating Git history summaries into release documentation offers additional context and traceability, facilitating frictionless release cycles and improving overall project management. Together, these automation efforts optimize documentation workflows, saving time and effort while enhancing the quality and consistency of release documentation. The process of implementing this functionality can be divided into the following activities. Automating API documentation generation. Use OpenAPI, formerly Swagger, or other API documentation tools to automatically generate API documentation from your codebase. Integrate this process into your CI/CD pipeline to ensure that API documentation is updated and reflects the latest changes in your API endpoints. Alternatively, consider tools like Swagger CodeGen or Retically to automate the generation of API documentation from your OpenAPI specification file or code annotations. Generating release notes from Git history. Use Git commands or tools like Git changelog to automate generation of release notes from Git commit history. This involves parsing commit messages and extracting relevant information such as feature additions and bug fixes. Customize the release notes format to include details such as commit author, timestamp, commit message, and associated pull requests or issues. Including Git history in release documentation. Incorporate Git history summaries or changelogs into your release documentation alongside release notes and API documentation. This provides additional context and transparency regarding the changes introduced in each release. Use Markdown or other documentation formats to structure and present the Git history in a clear and easy-to-comprehend manner. Integrating release notes into documentation pipeline. Integrate the generation of release notes into your documentation pipeline or CI/CD workflow. This ensures that release notes are automatically updated and included in your release documentation whenever a new version is tagged or a release is generated. Use scripting or automation tools like Azure Pipelines or GitHub Actions to trigger the generation of release notes as part of the documentation build process. Automating documentation publishing. Automate the publishing of your release documentation, including release notes, API documentation, and Git history summaries, to a central location accessible to all teams and stakeholders in your organization. Take advantage of GitHub pages, Azure DevOps wikis, or dedicated documentation hosting services to publish your documentation. Configure source control repository permissions using GitHub. Completed 100 XP. 3 minutes. Implementing GitHub repository permissions in an optimal manner involves finding a proper balance between facilitating collaboration and protecting codebases from abuse and misuse. GitHub supports fine-grained access controls which allow teams to efficiently interact with each other, while maintaining the principles of data privacy, security, and integrity. The permission model differs depending on the GitHub account type. There are 5 types of accounts that individuals and organizations can create. GitHub Free for personal accounts, free for individual use, including unlimited collaborators on unlimited public repositories with a full feature set, and on unlimited private repositories with a limited feature set, such as issues and pull requests. GitHub Pro, for professional developers, including unlimited public and private repositories, unlimited collaborators, and advanced code review tools. GitHub Free for organizations, including unlimited collaborators on unlimited public repositories with a full feature set, and on unlimited private repositories with a limited feature set. In addition to the features available with GitHub Free for personal accounts, GitHub Free for organizations offers higher limits of GitHub Actions minutes per month and higher GitHub packages storage. GitHub Team, for teams, including all the features of GitHub Pro, as well as team and user permissions, code review tools, and advanced tools and features in private repositories. GitHub Enterprise, for enterprise-level organizations, including all the features of GitHub Team, as well as enterprise-level security features such as single sign-on, audit logs, and compliance controls. This plan is self-hosted and can be run on-premises or in a cloud environment, GitHub Enterprise Cloud. Repo permissions in GitHub Free for personal accounts. GitHub Free for personal accounts. For public repositories, anyone can view and fork the repository. For private repositories, the repository owner has full control over who can access and contribute to the repository, with up to 3 collaborators allowed. There can be only one owner, so ownership permissions can't be shared with another personal account. In addition, in a private repository, repository owners can only grant write access to collaborators. In other words, collaborators can't have read-only access to repositories owned by a personal account. Repo permissions in GitHub Pro. GitHub Pro includes all the same repository permission levels as GitHub Free for personal accounts, but with more advanced collaboration features, such as protected branches and code owners. Repo permissions in GitHub Free for organizations. GitHub Free for organizations includes the ability to create teams, which can be granted access to specific repositories with different permission levels. Teams can be granted write access or admin access, and custom roles can be created to grant specific permissions to different users or groups. The default, non-administrative role for users in an organization is the organization member. By default, organization members have a few permissions, including the ability to create repositories. Other organization roles have elevated permissions to repositories, such as organization moderators, hiding comments in public repositories owned by the organization. Security managers, reading all repositories in the organization. Owners, all repository-related permissions, including adding collaborators, as well as writing to and deleting repositories. Organization owners can set base permissions that apply to all members of an organization when accessing any of its repositories. Base permissions don't apply to outside collaborators. Granting a higher level of access for individual repositories overrides the base permission. Customized access to repositories can be implemented by assigning built-in repository roles to organization members and outside collaborators. These roles include Read, recommended for non-code contributors who want to be able to review the content of the repository. Triage, recommended for contributors who need to proactively manage issues, discussions, and pull requests without write access. Write, recommended for contributors who actively push to the repository. Maintain, recommended for project managers who need to manage the repository without access to sensitive or destructive actions. Admin, recommended for people who need full privileges, including sensitive and destructive actions like managing security or deleting the repository. Repo permissions in GitHub Team. GitHub Team includes all the same repository permission levels as GitHub Free for organizations, with the addition of support for teams and more advanced security features such as authorized IP ranges and enterprise-grade authentication. Teams are groups of organization members. Organization owners and team maintainers can grant teams permission to repositories. Repo permissions in GitHub Enterprise Cloud. GitHub Enterprise Cloud is designed for enterprise-level organizations and includes all the features of GitHub Team, as well as Enterprise Leave. Security features such as single sign-on, audit logs, and compliance controls. GitHub Enterprise Cloud supports very granular control over repository permissions, including the ability to manage permissions at the branch level. Organization owners can also create custom roles to grant more granular permissions to different users or teams than those available with the built-in read, triage, write, maintain, and admin roles. Configure GitHub tags to organize repositories. Completed 100 XP. 3 minutes. Tags in GitHub repositories are markers that denote specific points in the history of a project, such as designated commits or release versions. By assigning tags to commits or releases, developers can create a structured timeline of their project's development, making it easier to track and reference important software lifecycle milestones. Planning. To take full advantage of tags in GitHub repositories to organize your codebase, making it easier to navigate and understand, consider the following considerations when planning for their implementation. Release versions. Tag specific commits or releases as versions. Follow the semantic versioning notation, broadly accepted as de facto standard for labeling software releases. It is common to prefix your version names with the letter V, e.g. version 1.0.0 or version 2.3.4. If the tag isn't meant for production use, add a pre-release version after the version name, e.g. v0.2.0 alpha or v5.9 beta.3. This helps users and collaborators easily distinguish between stable releases and features that are still in the testing phase. Feature releases. Tag commits or merges that introduce new features or significant changes to the codebase. Use descriptive tags like feature/new login page or feature/payment integration to highlight specific feature releases. These tags provide a clear history of feature additions and help track the progress of individual features over time. Bug fixes. Tag commits or merges that address bug fixes or issues reported by users or collaborators. Use tags like bugfix/issue 123-inch or fix/critical bug to denote bug fix releases. Bug fix tags make it easy to identify commits that resolve specific issues and ensure that fixes are applied consistently across different versions of the project. Maintenance releases. Tag commits or merges that involve maintenance tasks such as code refactoring, documentation updates, or dependency upgrades. Use tags like maintenance/code refactor or update/documentation to mark maintenance releases. Maintenance release tags help track changes related to code maintenance and ensure that necessary updates are documented and applied correctly. Custom tags. Create custom tags to categorize commits or releases based on your organization's specific needs or workflows. For example, you can create tags like documentation, performance, or security to classify commits according to their focus areas. Custom tags provide additional flexibility in organizing and structuring your codebase according to your project's requirements. Implementing. To assign a tag to a Git repository in GitHub, you can follow these steps. Identify the specific commit or release that you want to tag in your repository. You can find the commit hash or release version in the commit history or releases section of your repository. If you're tagging a commit, copy the commit hash associated with the commit you want to tag. If you're tagging a release, copy the release version, e.g. version 1.0.0. In a local clone of the repository, use the git tag command line to create a tag. The basic syntax for creating a tag is git tag _name commit _hash. Replace tag _name with the name of your tag and commit _hash with the commit hash or release version you copied earlier. Push the tag to GitHub by running the command git push origin tag _name. Replace tag _name with the name of the tag you created. After pushing the tag, you can verify that it has been successfully created by navigating to the releases/tags page of your repository on GitHub. Note that you can create tag protection rules for your repository to prevent contributors from creating or deleting tags. However, keep in mind that, as of March 2024, tag protection rules are in beta and subject to change. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check Your Answers. Check your knowledge. 1. Which of the following choices is for working with large files in repositories? Package management. Git LFS. Git. 2. Which of the following choices isn't a common situation when you need to purge data from repositories? When you need to reduce the size of a repository significantly by removing history. When you need to remove a sensitive file that shouldn't have been uploaded. When you need to hide code in history without removing permissions. 3. Which of the following choices is the built-in git command for removing files from the repository? Git remove branch command. Git filter branch command. Git purge branch command. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explored how to work with large repositories and purge repository data. You learned how to describe the benefits and usage of. Understand large Git repositories. Explain Git Virtual File System, GVFS. Use Git Large File Storage, LFS. Purge repository data. Learn more. Introduction. Completed 100 XP. 1 minute. This module examines technical debt, complexity, quality metrics, and plans for effective code reviews and code quality validation. Learning objectives. After completing this module, students and professionals can identify and manage technical debt, integrate code quality tools, plan code reviews, describe complexity and quality metrics. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Examine code quality. Completed 100 XP. 3 minutes. The quality of code shouldn't be measured subjectively. A developer writing code would rate the quality of their code high, but that isn't a great way to measure code quality. Different teams may use different definitions based on context. Code that is considered high quality may mean one thing for an automotive developer, and it may mean another for a web application developer. The quality of the code is essential, as it impacts the overall software quality. A study on software defect origins and removal methods found that individual programmers are less than 50% efficient at finding bugs in their software. And most forms of testing are only 35% efficient. It makes it difficult to determine quality. There are 5 key traits to measure for higher quality. Reliability. Reliability measures the probability that a system will run without failure over a specific period of operation. It relates to the number of defects and availability of the software. Several defects can be measured by running a static analysis tool. Software availability can be measured using the mean time between failures, MTBF. Low defect counts are crucial for developing a reliable codebase. Maintainability. Maintainability measures how easily software can be maintained. It relates to the codebase size, consistency, structure, and complexity. And ensuring maintainable source code relies on several factors, such as testability and understandability. You can't use a single metric to ensure maintainability. Some metrics you may consider to improve maintainability are the number of stylistic warnings and Halstead complexity measures. Both automation and human reviewers are essential for developing maintainable codebases. Testability. Testability measures how well the software supports testing efforts. It relies on how well you can control, observe, isolate, and automate testing, among other factors. Testability can be measured based on how many test cases you need to find potential faults in the system. The size and complexity of the software can impact testability. So, applying methods at the code level, such as cyclomatic complexity, can help you improve the testability of the component. Portability. Portability measures how usable the same software is in different environments. It relates to platform independence. There isn't a specific measure of portability, but there are several ways you can ensure portable code. It's essential to regularly test code on different platforms rather than waiting until the end of development. It's also good to set your compiler warning levels as high as possible and use at least 2 compilers. Enforcing a coding standard also helps with portability. Reusability. Reusability measures whether existing assets, such as code, can be used again. Assets are more easily reused if they have modularity or loose coupling characteristics. The number of interdependencies can measure reusability. Running a static analyzer can help you identify these interdependencies. Examine complexity and quality metrics. Completed 100 XP. 3 minutes. While there are various quality metrics, a few of the most important ones are listed here. Complexity metrics can help in measuring quality. Cyclomatic complexity measures the number of linearly independent paths through a program's source code. Another way to understand quality is through calculating Halstead complexity measures. This measure. Program vocabulary. Program length. Calculated program length. Volume. Difficulty. Effort. Code analysis tools can be used to check for security, performance, interoperability, language usage, and globalization and should be part of every developer's toolbox and software build process. Regularly running a static code analysis tool and reading its output is a great way to improve as a developer because the things caught by the software rules can often teach you something. Common quality-related metrics. One of the promises of DevOps is to deliver software both faster and with higher quality. Previously, these 2 metrics have been almost opposites. The more quickly you went, the lower the quality. The higher the quality, the longer it took. But DevOps processes can help you find problems earlier, which usually means that they take less time to fix. We've previously talked about some general project metrics and KPIs. The following is a list of metrics that directly relate to the quality of the code being produced and the build and deployment processes. Failed builds percentage overall, what percentage of builds are failing? Failed deployments percentage overall, what percentage of deployments are failing? Ticket volume, what is the overall volume of customer or bug tickets? Bug bounce percentage, what percentage of customer or bug tickets are reopened? Unplanned work percentage, what percentage of the overall work is unplanned? Introduction to technical debt. Completed 100 XP. 5 minutes. Technical debt is a term that describes the future cost that will be incurred by choosing an easy solution today instead of using better practices because they would take longer to complete. The term technical debt was chosen for its comparison to financial debt. It's common for people in financial debt to make decisions that seem appropriate or the only option at the time, but in so doing, interest increases. The more interest that accumulates, the harder it is for them in the future and the more minor options available to them later. With financial debt, soon, interest increases on interest, creating a snowball effect. Similarly, technical debt can build up to the point where developers spend almost all their time sorting out problems and doing rework, either planned or unplanned, rather than adding value. So, how does it happen? The most common excuse is tight deadlines. When developers are forced to create code quickly, they'll often take shortcuts. For example, instead of refactoring a method to include new functionality, let us copy to create a new version. Then I only test my new code and can avoid the level of testing required if I change the original method because other parts of the code use it. Now I have two copies of the same code that I need to modify in the future instead of one, and I run the risk of the logic diverging. There are many causes. For example, there might be a lack of technical skills and maturity among the developers or no clear product ownership or direction. The organization might not have coding standards at all. So, the developers didn't even know what they should be producing. The developers might not have precise requirements to target. Well, they might be subject to last-minute requirement changes. Necessary refactoring work might be delayed. There might not be any code quality testing, manual or automated. In the end, it just makes it harder and harder to deliver value to customers in a reasonable time frame and at a reasonable cost. Technical debt is one of the main reasons that projects fail to meet their deadlines. Over time, it increases in much the same way that monetary debt does. Common sources of technical debt are lack of coding style and standards, lack of or poor design of unit test cases, ignoring or not understanding object-oriented design principles, monolithic classes and code libraries, poorly envisioned the use of technology, architecture, and approach, forgetting that all system attributes affecting maintenance, user experience, scalability, and others need to be considered. Over-engineering code, adding or creating code that isn't required, adding custom code when existing libraries are sufficient, or creating layers or components that aren't needed. Insufficient comments and documentation. Not writing self-documenting code, including class, method, and variable names that are descriptive or indicate intent. Taking shortcuts to meet deadlines. Leaving dead code in place. Note: over time, the technical debt must be paid back. Otherwise, the team's ability to fix issues and implement new features and enhancements will take longer and eventually become cost-prohibitive. We have seen that technical debt adds a set of problems during development and makes it much more difficult to add extra customer value. Having technical debt in a project saps productivity, frustrates development teams, makes code both hard to understand and fragile, increases the time to make changes and validate those changes. Unplanned work frequently gets in the way of planned work. Longer term, it also saps the organization's strength. Technical debt tends to creep up on an organization. It starts small and grows over time. Every time a quick hack is made or testing is circumvented because changes need to be rushed through, the problem grows worse and worse. Support costs get higher and higher, and invariably, a serious issue arises. Eventually, the organization can't respond to its customers' needs in a timely and cost-efficient way. Automated measurement for monitoring. One key way to minimize the constant acquisition of technical debt is to use automated testing and assessment. In the demos that follow, we'll look at one of the common tools used to assess the debt, Sonar Cloud. The original on-premises version was Sonar Cube. There are other tools available, and we'll discuss a few of them. Later, in the next hands-on lab, you'll see how to configure your Azure pipelines to use Sonar Cloud, understand the analysis results, and finally how to configure quality profiles to control the rule sets that are used by Sonar Cloud when analyzing your projects. For more information, see Sonar Cloud. To review, Azure DevOps can be integrated with a wide range of existing tooling used to check code quality during builds. Which code quality tools do you currently use, if any? What do you like or don't you like about the tools? Measure and manage technical debt. Completed 100 XP. 2 minutes. Integrating the assessment and measurement of technical debt and code quality overall is essential as part of your continuous integration and deployment pipelines in Azure DevOps. In the continuous integration course in this series, we showed how to add support for Sonar Cloud into an Azure DevOps pipeline. After it's added and a build done, you can see an analysis of your code. If you drill into the issues, you can see what the issues are, along with suggested remedies and estimates of the time required to apply a remedy. Introduction to GitHub Advanced Security. Completed 100 XP. 3 minutes. GitHub Advanced Security, GHAS, is a comprehensive suite of security features designed to enhance the security posture of software development projects. Besides being tightly integrated with GitHub, GHAS is also available as an extension to Azure DevOps, providing similar capabilities on both platforms. While GHAS is not designed to directly measure technical debt, its capabilities can greatly contribute to its discovery and remediation. GHAS offers code analysis, dependency management, and advanced code reviews along with security scanning services, such as code scanning, secret scanning, and dependency scanning. GHAS also provides detailed insights and recommendations to help prioritize and address security vulnerabilities. By leveraging these features, organizations can proactively identify and address technical debt early in the development lifecycle. This reduces security risks, enhances code quality, and facilitates long-term maintainability of their software projects. CodeQL analysis. CodeQL is a semantic code analysis engine that assists developers with identifying issues within their codebases. It provides a declarative query language designed to search for patterns that help identify coding errors and design flaws, all of which contribute to accumulation of technical debt. Its analytics capabilities can also be used to detect potential security vulnerabilities, such as injection flaws, authentication issues, and access control problems, which are often indicative of underlying technical debt. Dependency management. Dependency management is critical for managing technical debt associated with outdated or vulnerable dependencies. GHAS dependency scanning provides visibility into project dependencies, including information on outdated packages, security vulnerabilities, and licensing issues. Dependabot can automatically update dependencies with security vulnerabilities, helping you keep your codebase up to date and secure. Code scanning. Code scanning automatically scans code repositories for potential security vulnerabilities and coding errors, including code smells and anti-patterns, using a combination of static analysis techniques. It detects common security issues, such as cross-site scripting, XSS, SQL injection, and buffer overflows, which, similarly to CodeQL-based analysis, commonly indicate technical debt resulting from insecure coding practices. In addition, security code scanning provides actionable insights into code quality and security risks, helping prioritize and address technical debt in the most efficient and effective manner. Integrate other code quality tools. Completed 100 XP. 3 minutes. Many tools can be used to assess aspects of your code quality and technical debt. Ndepend. For .NET developers, a common tool is Ndepend. Ndepend is a Visual Studio extension that assesses the amount of technical debt a developer has added during a recent development period, typically in the last hour. With this information, the developer might make the required corrections before ever committing the code. Ndepend lets you create code rules expressed as C#LANQ queries, but it has many built-in rules that detect a wide range of code smells. ResHarper Code Quality Analysis. ResHarper can make a code quality analysis from the command line. Also, be set to fail builds when code quality issues are found automatically. Rules can be configured for enforcement across teams. Search in Azure DevOps. To find other code quality tools that are easy to integrate with Azure DevOps, search for the word quality when adding a task into your build pipeline. For more information, you can see Ndepend. Visual Studio Marketplace. ResHarper Code Quality Analysis. Plan effective code reviews. Completed 100 XP. 2 minutes. Most developers would agree that code reviews can improve the quality of the applications they produce, but only if the process for the code reviews is effective. It is essential, upfront, to agree that everyone is trying to achieve better code quality. Achieving code quality can seem to challenge because there's no single best way to write any piece of code, at least code with any complexity. Everyone wants to do good work and to be proud of what they create. It means that it's easy for developers to become overprotective of their code. The organizational culture must let all involved feel that the code reviews are more like mentoring sessions where ideas about improving code are shared than interrogation sessions where the aim is to identify problems and blame the author. The knowledge sharing that can occur in mentoring-style sessions can be one of the most important outcomes of the code review process. It often happens best in small groups, even 2 people, rather than in large team meetings. And it's important to highlight what has been done well, not just what needs improvement. Developers will often learn more in effective code review sessions than they'll in any formal training. Reviewing code should be an opportunity for all involved to learn, not just as a chore that must be completed as part of a formal process. It's easy to see 2 or more people working on a problem and think that one person could have completed the task by themselves. That is a superficial view of the longer-term outcomes. Team management needs to understand that improving the code quality reduces the cost of code, not increases it. Team leaders need to establish and foster an appropriate culture across their teams. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check Your Answers. Check your knowledge. 1. Which of the following choices is a characteristic in source code possibly indicating a deeper problem? Memory leak. Bug. Code smell. 2. Which of the following choices can measure the probability that a system will run without failure over a specific period of operation? Maintainability. Reliability. Reusability. 3. Which of the following tools can you use to do code quality checks? Veracode. Sonar Cloud. Azure Security Center. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module examined technical debt, complexity, quality metrics, and plans for effective code reviews and code quality validation. You learned how to describe the benefits and usage of. Identify and manage technical debt. Integrate code quality tools. Plan code reviews. Describe complexity and quality metrics. Learn more. Introduction. Completed 100 XP. 1 minute. Azure Pipelines is a fully featured service used to create cross-platform CI, continuous integration, and CD, continuous deployment. It works with your preferred Git provider and can deploy to most major cloud services, including Azure. Azure DevOps offers a comprehensive pipelines offering. This module introduces Azure Pipelines concepts and explains key terms and components of the tool, helping you decide your pipeline strategy and responsibilities. Learning objectives. After completing this module, students and professionals can describe Azure Pipelines, explain the role of Azure Pipelines and its components, decide pipeline automation responsibility, understand Azure Pipeline key terms, prerequisites, understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but is not necessary. Beneficial to have experience in an organization that delivers software. Explore the concept of pipelines in DevOps. Completed 100 XP. 3 minutes. Business demands continuous delivery of value. Value is created only when a product is delivered to a satisfied customer. It's not created when one silo in the process is completed. It demands that you reset focus from silos to an end-to-end flow of value. The core idea is to create a repeatable, reliable, and incrementally improving process for taking software from concept to customer. The goal is to enable a constant flow of changes into production via an automated software production line. Think of it as a pipeline. The pipeline breaks down the software delivery process into stages. Each stage aims to verify the quality of new features from a different angle to validate the new functionality and prevent errors from affecting your users. The pipeline should provide feedback to the team. Also, visibility into the changes flows to everyone involved in delivering the new features. A delivery pipeline enables the flow of more minor changes more frequently, with a focus on flow. Your teams can concentrate on optimizing the delivery of changes that bring quantifiable value to the business. This approach leads teams to continuously monitor and learn where they're finding obstacles, resolve those issues, and gradually improve the pipeline's flow. As the process continues, the feedback loop provides new insights into new issues and barriers to be resolved. The pipeline is the focus of your continuous improvement loop. A typical pipeline will include the following stages: build automation and continuous integration, test automation, and deployment automation. Build automation and continuous integration. The pipeline starts by building the binaries to create the deliverables passed to the following stages. New features implemented by the developers are integrated into the central codebase, built, and unit tested. It's the most direct feedback cycle that informs the development team about the health of their application code. Test automation. The new version of an application is rigorously tested throughout this stage to ensure that it meets all wished system qualities. It's crucial that all relevant aspects, whether functionality, security, performance, or compliance, are verified by the pipeline. The stage may involve different types of automated or, initially, at least, manual activities. Deployment automation. A deployment is required every time the application is installed in an environment for testing, but the most critical moment for deployment automation is rollout time. Since the preceding stages have verified the overall quality of the system, it's a low-risk step. The deployment can be staged, with the new version being initially released to a subset of the production environment and monitored before being rolled out. The deployment is automated, allowing for the reliable delivery of new functionality to users within minutes if needed. Your pipeline needs platform provisioning and configuration management. The deployment pipeline is supported by platform provisioning and system configuration management. It allows teams to create, maintain, and tear down complete environments automatically or at the push of a button. Automated platform provisioning ensures that your candidate applications are deployed to, and tests carried out against correctly configured and reproducible environments. It also helps horizontal scalability and allows the business to try out new products in a sandbox environment at any time. Orchestrating it all, release and pipeline orchestration. The multiple stages in a deployment pipeline involve different groups of people collaborating and supervising the release of the new version of your application. Release and pipeline orchestration provide a top-level view of the entire pipeline, allowing you to define and control the stages and gain insight into the overall software delivery process. By carrying out value stream mappings on your releases, you can highlight any remaining inefficiencies and hotspots and pinpoint opportunities to improve your pipeline. These automated pipelines need infrastructure to run on. The efficiency of this infrastructure will have a direct impact on the effectiveness of the pipeline. Describe Azure Pipelines. Completed 100 XP. 3 minutes. Azure Pipelines is a cloud service that automatically builds and tests your code project and makes it available to other users. It works with just about any language or project type. Azure Pipelines combines continuous integration, CI, and continuous delivery, CD, to test and build your code and ship it to any target constantly and consistently. Does Azure Pipelines work with my language and tools? Azure Pipelines is a fully featured cross-platform CI and CD service. It works with your preferred Git provider and can deploy to most major cloud services, including Azure services. Languages. You can use many languages with Azure Pipelines, such as Python, Java, PHP, Ruby, C#, and Go. Version control systems. Before you use continuous integration and continuous delivery practices for your applications, you must have your source code in a version control system. Azure Pipelines integrates with GitHub, GitLab, Azure Repos, Bitbucket, and Subversion. Application types. You can use Azure Pipelines with most application types, such as Java, JavaScript, Python, .NET, PHP, Go, Xcode, and C++. Deployment targets. Use Azure Pipelines to deploy your code to multiple targets. Targets including container registries, virtual machines, Azure services, or any on-premises or cloud target such. Microsoft Azure, Google Cloud, Amazon Web Services, AWS. Package formats. To produce packages that others can consume, you can publish NuGet, NPM, or Maven packages to the built-in package management repository in Azure Pipelines. You also can use any other package management repository of your choice. Why should I use CI and CD and Azure Pipelines? Implementing CI and CD pipelines help to ensure consistent and quality code that's readily available to users. Azure Pipelines is a quick, easy, and safe way to automate building your projects and making them available to users. Use CI and CD for your project. Continuous integration is used to automate tests and builds for your project. CI helps to catch bugs or issues early in the development cycle when they're easier and faster to fix. Items known as artifacts are produced from CI systems. The continuous delivery release pipelines use them to drive automatic deployments. Continuous delivery is used to automatically deploy and test code in multiple stages to help drive quality. Continuous integration systems produce deployable artifacts, which include infrastructure and apps. Automated release pipelines consume these artifacts to release new versions and fixes to the target of your choice. Continuous integration, CI. Continuous delivery, CD. Increase code coverage. Automatically deploy code to production. Build faster by splitting test and build runs. Ensure deployment targets have the latest code. Automatically ensure you don't ship broken code. Use tested code from the CI process. Run tests continually. Use Azure Pipelines for CI and CD. There are several reasons to use Azure Pipelines for your CI and CD solution. You can use it to work with any language or platform. Deploy to different types of targets at the same time. Integrate with Azure deployments. Build on Windows, Linux, or macOS machines. Integrate with GitHub. Work with open source projects. Understand Azure Pipelines key terms. Completed 100 XP. 3 minutes. Understanding the basic terms and parts of Azure Pipelines helps you further explore how it can help you deliver better code more efficiently and reliably. Agent. When your build or deployment runs, the system begins one or more jobs. An agent is installable software that runs a build or deployment job. Artifact. An artifact is a collection of files or packages published by a build. Artifacts are made available for the tasks, such as distribution or deployment. Build. A build represents one execution of a pipeline. It collects the logs associated with running the steps and the test results. Continuous delivery. Continuous delivery, CD, also known as continuous deployment, is a process by which code is built, tested, and deployed to one or more test and production stages. Deploying and testing in multiple stages helps drive quality. Continuous integration systems produce deployable artifacts, which include infrastructure and apps. Automated release pipelines consume these artifacts to release new versions and fix existing systems. Monitoring and alerting systems constantly run to drive visibility into the entire CD process. This process ensures that errors are caught often and early. Continuous integration. Continuous integration, CI, is the practice used by development teams to simplify the testing and building of code. CI helps to catch bugs or problems early in the development cycle, making them more accessible and faster to fix. Automated tests and builds are run as part of the CI process. The process can run on a schedule whenever code is pushed, or both. Items known as artifacts are produced from CI systems. The continuous delivery release pipelines use them to drive automatic deployments. Deployment target. A deployment target is a virtual machine, container, web app, or any service used to host the developed application. A pipeline might deploy the app to one or more deployment targets after the build is completed and tests are run. Job. A build contains one or more jobs. Most jobs run on an agent. A job represents an execution boundary of a set of steps. All the steps run together on the same agent. For example, you might build two configurations x86 and x64. In this case, you have one build and two jobs. Pipeline. A pipeline defines the continuous integration and deployment process for your app. It's made up of steps called tasks. It can be thought of as a script that describes how your test, build, and deployment steps are run. Release. When you use the Visual Designer, you can create a release or a build pipeline. A release is a term used to describe one execution of a release pipeline. It's made up of deployments to multiple stages. Stage. Stages are the primary divisions in a pipeline. Build the app, run integration tests, and deploy to user acceptance testing are good examples of stages. Task. A task is the building block of a pipeline. For example, a build pipeline might consist of build and test tasks. A release pipeline consists of deployment tasks. Each task runs a specific job in the pipeline. Trigger. A trigger is set up to tell the pipeline when to run. You can configure a pipeline to run upon a push to a repository at scheduled times or upon completing another build. All these actions are known as triggers. Knowledge check. Completed 200 XP. 6 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices aren't characteristic of a pipeline? Reliable, repeatable, immutable. 2. Which of the following is a correct statement about Azure pipelines? Azure Pipelines works exclusively with Azure and Microsoft technology. For open source, GitHub is recommended. Azure Pipelines work with any language or platform. Azure Pipelines only deploys in cloud environments. 3. Which of the following choices is a continuous integration, CI, benefit? Automatically ensure you don't ship broken code. Automatically deploy code to production. Ensure deployment targets have the latest code. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module introduced Azure Pipelines concepts and explained key terms and components of the tool. It helped you decide your pipeline strategy and responsibilities. You learned how to describe the benefits and usage of. Describe Azure Pipelines. Explain the role of Azure Pipelines and its components. Decide pipeline automation responsibility. Understand Azure Pipeline key terms. Learn more. Introduction. Completed 100 XP. 1 minute. This module explores the differences between Microsoft-hosted and self-hosted agents, detail job types, and introduces agent pool configuration. Understand typical situations to use agent pools and how to manage their security. Learning objectives. After completing this module, students and professionals can choose between Microsoft-hosted and self-hosted agents. Install and configure Azure Pipelines agents. Configure agent pools. Make the agents and pools secure. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Choose between Microsoft-hosted versus self-hosted agents. Completed 100 XP. 3 minutes. To build your code or deploy your software, you generally need at least one agent. As you add more code and people, you'll eventually need more. When your build or deployment runs, the system begins one or more jobs. An agent is an installable software that runs one build or deployment job at a time. Microsoft-hosted agent. If your pipelines are in Azure Pipelines, then you've got a convenient option to build and deploy using a Microsoft-hosted agent. With a Microsoft-hosted agent, maintenance and upgrades are automatically done. Each time a pipeline is run, a new virtual machine instance is provided. The virtual machine is discarded after one use. For many teams, this is the simplest way to build and deploy. You can try it first and see if it works for your build or deployment. If not, you can use a self-hosted agent. A Microsoft-hosted agent has job time limits. Self-hosted agent. An agent that you set up and manage on your own to run build and deployment jobs is a self-hosted agent. You can use a self-hosted agent in Azure Pipelines. A self-hosted agent gives you more control to install dependent software needed for your builds and deployments. You can install the agent on Linux, Mac OS, Windows, Linux Docker containers. After you've installed the agent on a machine, you can install any other software on that machine as required by your build or deployment jobs. A self-hosted agent doesn't have job time limits. Explore job types. Completed 100 XP. 2 minutes. In Azure DevOps, there are 4 types of jobs available. Agent pool jobs. Container jobs. Deployment group jobs. Agentless jobs. Agent pool jobs. The most common types of jobs. The jobs run on an agent that is part of an agent pool. Container jobs. Similar jobs to agent pool jobs run in a container on an agent part of an agent pool. Deployment group jobs. Jobs that run on systems in a deployment group. Agentless jobs. Jobs that run directly on the Azure DevOps. They don't require an agent for execution. It's also often called server jobs. Introduction to agent pools. Completed 100 XP. 1 minute. Instead of managing each agent individually, you organize agents into agent pools. An agent pool defines the sharing boundary for all agents in that pool. In Azure Pipelines, pools are scoped to the entire organization so that you can share the agent machines across projects. If you create an agent pool for a specific project, only that project can use the pool until you add the project pool into another project. When creating a build or release pipeline, you can specify which pool it uses, organization, or project scope. Pools scoped to a project can only use them across build and release pipelines within a project. To share an agent pool with multiple projects, use an organization scope agent pool and add them in each of those projects, add an existing agent pool, and choose the organization agent pool. If you create a new agent pool, you can automatically grant access permission to all pipelines. Explore predefined agent pool. Completed 100 XP. 1 minute. Azure Pipelines provides a predefined agent pool named Azure Pipelines with Microsoft-hosted agents. It will often be an easy way to run jobs without configuring build infrastructure. The following virtual machine images are provided by default. Windows Server 2022 with Visual Studio 2022. Windows Server 2019 with Visual Studio 2019. Ubuntu 20.04. Ubuntu 18.04. macOS 11 Big Sur. macOS X Catalina 10.15. By default, all contributors in a project are members of the user role on each hosted pool. It allows every contributor to author and run build and release pipelines using a Microsoft-hosted pool. Pools are used to run jobs. Learn about specifying pools for jobs. Note: see Microsoft-hosted agents for the most up-to-date list of agent pool images. Also, the complete list of software installed on these machines. Understand typical situations for agent pools. Completed 100 XP. 3 minutes. If you've got many agents intended for different teams or purposes, you might want to create more pools, as explained below. Create agent pools. Here are some typical situations when you might want to create agent pools. You're a project member, and you want to use a set of machines your team owns for running build and deployment jobs. First, make sure you're a member of a group in all pools with the administrator role. Next, create a new project agent pool in your project settings and select the option to create a new organization agent pool. As a result, both an organization and project level agent pool will be created. Finally, install and configure agents to be part of that agent pool. You're a member of the infrastructure team and would like to set up a pool of agents for use in all projects. First, make sure you're a member of a group in all pools with the administrator role. Next, create a new organization agent pool in your admin settings and select auto-provision corresponding project agent pools in all projects while creating the pool. This setting ensures all projects have a pool pointing to the organization agent pool. The system creates a pool for existing projects, and in the future, it will do so whenever a new project is created. Finally, install and configure agents to be part of that agent pool. You want to share a set of agent machines with multiple projects, but not all of them. First, create a project agent pool in one of the projects and select the option to create a new organization agent pool while creating that pool. Next, go to each of the other projects and create a pool in each of them while selecting the option to use an existing organization agent pool. Finally, install and configure agents to be part of the shared agent pool. Communicate with Azure pipelines. Completed 100 XP. 4 minutes. The agent communicates with Azure pipelines to determine which job to run and reports the logs and job status. The agent always starts this communication. All the messages from the agent to Azure pipelines over HTTPS depend on how you configure the agent. This pull model allows the agent to be configured in different topologies, as shown below. Here's a standard communication pattern between the agent and Azure pipelines. The user registers an agent with Azure pipelines by adding it to an agent pool. You must be an agent pool administrator to register an agent. The identity of the agent pool administrator is needed only at the time of registration. It isn't persisted on the agent or used to communicate further between the agent and Azure pipelines. Once the registration is complete, the agent downloads a listener OAuth token and uses it to listen to the job queue. Periodically, the agent checks to see if a new job request has been posted in the job queue in Azure pipelines. The agent downloads the job and a job-specific OAuth token when a job is available. Azure pipelines generate this token for the scoped identity specified in the pipeline. That token is short-lived and is used by the agent to access resources, for example, source code, or modify resources, for example, upload test results, on Azure pipelines within that job. Once the job is completed, the agent discards the job-specific OAuth token and checks if there's a new job request using the listener OAuth token. The payload of the messages exchanged between the agent and Azure pipelines are secured using asymmetric encryption. Each agent has a public-private key pair, and the public key is exchanged with the server during registration. The server uses the public key to encrypt the job's payload before sending it to the agent. The agent decrypts the job content using its private key. Secrets stored in build pipelines, release pipelines, or variable groups are secured when exchanged with the agent. Communicate to deploy to target servers. Completed 100 XP. 2 minutes. When you use the agent to deploy artifacts to a set of servers, it must have line-of-sight connectivity to those servers. The Microsoft-hosted agent pools, by default, have connectivity to Azure websites and servers running in Azure. Suppose your on-premises environments don't have connectivity to a Microsoft-hosted agent pool because of intermediate firewalls. In that case, you'll need to manually configure a self-hosted agent on the on-premises computers. The agents must have connectivity to the target on-premises environments and access to the internet to connect to Azure pipelines or Azure DevOps Server, as shown in the following diagram. Examine other considerations. Completed 100 XP. 5 minutes. Authentication. To register an agent, you need to be a member of the administrator role in the agent pool. The identity of the agent pool administrator is only required at the time of registration. It's not persisted on the agent and isn't used in any following communication between the agent and Azure pipelines. Also, you must be a local administrator on the server to configure the agent. Your agent can authenticate to Azure DevOps using one of the following methods. Personal Access Token, PAT. Generate and use a PAT to connect an agent with Azure pipelines. PAT is the only scheme that works with Azure pipelines. Also, as explained above, this PAT is used only when registering the agent and not for succeeding communication. Interactive versus service. You can run your agent as either a service or an interactive process. Whether you run an agent as a service or interactively, you can choose which account you use to run the agent. It's different from your credentials when registering the agent with Azure Pipelines. The choice of agent account depends solely on the needs of the tasks running in your build and deployment jobs. For example, to run tasks that use Windows authentication to access an external service, you must run the agent using an account with access to that service. However, if you're running UI tests such as Selenium or coded UI tests that require a browser, the browser is launched in the context of the agent account. After configuring the agent, we recommend you first try it in interactive mode to ensure it works. Then, we recommend running the agent in one of the following modes so that it reliably remains to run for production use. These modes also ensure that the agent starts automatically if the machine is restarted. You can use the Service Manager of the operating system to manage the lifecycle of the agent. Also, the experience for auto-upgrading the agent is better when it's run as a service. As an interactive process with Autologon enabled. In some cases, you might need to run the agent interactively for production use, such as UI tests. When the agent is configured to run in this mode, the screensaver is also disabled. Some domain policies may prevent you from enabling Autologon or disabling the screensaver. In such cases, you may need to seek an exemption from the domain policy or run the agent on a workgroup computer where the domain policies don't apply. Note: there are security risks when you enable automatic login or disable the screensaver. You allow other users to walk up to the computer and use the account that automatically logs on. If you configure the agent to run in this way, you must ensure the computer is physically protected, for example, located in a secure facility. If you use remote desktop to access the computer on which an agent is running with Autologon, simply closing the remote desktop causes the computer to be locked, and any UI tests that run on this agent may fail. To avoid this, use the tscon command to disconnect from remote desktop. Agent version and upgrades. Microsoft updates the agent software every few weeks in Azure Pipelines. The agent version is indicated in the format major, minor. For instance, if the agent version is 2.1, the major version is 2, and the minor version is 1. When a newer version of the agent is only different in minor versions, it's automatically upgraded by Azure Pipelines. This upgrade happens when one of the tasks requires a newer version of the agent. If you run the agent interactively or a newer major version of the agent is available, you must manually upgrade the agents. Also, you can do it from the Agent Pools tab under your project collection or organization. You can view the version of an agent by navigating to Agent Pools and selecting the Capabilities tab for the wanted agent. CMD. Azure Pipelines, https://devazure.com/ your_organization /admin/agent pool, https://dev.azure.com/left brace your_organization right brace /admin/agent pool. Question and answer. Do self-hosted agents have any performance advantages over Microsoft-hosted agents? In many cases, yes. Specifically, if you use a self-hosted agent, you can run incremental builds. For example, you define a CI build pipeline that doesn't clean the repo or do a clean build. Your builds will typically run faster. You don't get these benefits when using a Microsoft-hosted agent. The agent is destroyed after the build or release pipeline is completed. A Microsoft-hosted agent can take longer to start your build. While it often takes just a few seconds for your job to be assigned to a Microsoft-hosted agent, it can sometimes take several minutes for an agent to be allocated, depending on the load on our system. Can I install multiple self-hosted agents on the same machine? Yes. This approach can work well for agents who run jobs that don't consume many shared resources. For example, you could try it for agents that run releases that mostly orchestrate deployments and don't do much work on the agent itself. In other cases, you might find that you don't gain much efficiency by running multiple agents on the same machine. For example, it might not be worthwhile for agents that run builds that consume many disks and I/O resources. You might also have problems if parallel build jobs use the same singleton tool deployment, such as NPM packages. For example, one build might update a dependency while another build is in the middle of using it, which could cause unreliable results and errors. Further instructions on how to set up self-hosted agents can be found at Describe security of agent pools. Completed 100 XP. 4 minutes. Understanding how security works for agent pools helps you control sharing and use of agents. Azure Pipelines. In Azure Pipelines, roles are defined on each agent pool. Membership in these roles governs what operations you can do on an agent pool. Note: there are differences between organization and project agent pools. Role on an organization agent pool. Purpose: reader. Members of this role can view the organization's agent pool and agents. You typically use it to add operators that are responsible for monitoring the agents and their health. Service account. Members of this role can use the organization agent pool to create a project agent pool in a project. If you follow the guidelines above for creating new project agent pools, you typically don't have to add any members here. Administrator. Also, with all the above permissions, members of this role can register or unregister agents from the organization's agent pool. They can also refer to the organization agent pool when creating a project agent pool in a project. Finally, they can also manage membership for all roles of the organization agent pool. The user that made the organization agent pool is automatically added to the administrator role for that pool. Más términos. The All Agent Pools node in the Agent Pools tab is used to control the security of all organization agent pools. Role memberships for individual organization agent pools are automatically inherited from the All Agent Pools node. Roles are also defined on each organization's agent pool. Memberships in these roles govern what operations you can do on an agent pool. Role on a project agent pool. Purpose. Reader. Members of this role can view the project agent pool. You typically use it to add operators responsible for monitoring the build and deployment jobs in that project agent pool. User. Members of this role can use the project agent pool when authoring build or release pipelines. Administrator. Also, to all the above operations, members of this role can manage membership for all roles of the project agent pool. The user that created the pool is automatically added to the administrator role for that pool. The All Agent Pools node in the Agent Pools tab controls the security of all project agent pools in a project. Role memberships for individual project agent pools are automatically inherited from the All Agent Pools node. By default, the following groups are added to the administrator role of all agent pools: build administrators, release administrators, project administrators. Configure agent pools and understand pipeline styles. Completed 100 XP. 45 minutes. Estimated time, 45 minutes. Scenario. YAML-based pipelines allow you to fully implement CI/CD as code, in which pipeline definitions reside in the same repository as the code that is part of your Azure DevOps project. YAML-based pipelines support a wide range of features that are part of the classic pipelines, such as pull requests, code reviews, history, branching, and templates. Regardless of the choice of the pipeline style, to build your code or deploy your solution by using Azure pipelines, you need an agent. An agent hosts compute resources that run one job at a time. Jobs can be run directly on the host machine of the agent or in a container. You have an option to run your jobs using Microsoft-hosted agents, which are managed for you, or implementing a self-hosted agent that you set up and manage on your own. In this lab, you will learn how to implement and use self-hosted agents with YAML pipelines. Objectives. After completing this lab, you'll be able to implement YAML-based pipelines. Implement self-hosted agents. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Git for Windows download page. This will be installed as part of the prerequisites for this lab. Visual Studio Code. This will be installed as part of the prerequisites for this lab. Exercises. During this lab, you'll complete the following exercises. Exercise 0, configure the lab prerequisites. Exercise 1, author YAML-based Azure pipelines. Exercise 2, manage Azure DevOps agent pools. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices are the two types of agents being used in pipelines? Client-hosted and server-hosted. Self-hosted and Microsoft-hosted. Windows-hosted and Linux-hosted. 2. Which of the following is a correct statement about agent pools? Agent pools are scoped to the entire project and can be shared across pipelines. Agent pools are scoped to the entire repository and can be shared across pipelines. Agent pools are scoped to the entire organization and can be shared across projects. 3. Which of the following choices is the role that can manage membership for all roles of the project agent pool? Administrator. User. Contributor. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explored differences between Microsoft-hosted and self-hosted agents, detailed job types, and introduced agent pools configuration. You learned how to describe the benefits and usage of. Choose between Microsoft-hosted and self-hosted agents. Install and configure Azure Pipelines agents. Configure agent pools. Make the agents and pools secure. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes parallel jobs and how to estimate their usage. Also, it presents Azure DevOps for open source projects, explores Visual Designer and YAML pipelines. Learning objectives. After completing this module, students and professionals can use and estimate parallel jobs. Use Azure Pipelines for open source or private projects. Use Visual Designer. Work with Azure Pipelines and YAML. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but is not necessary. Beneficial to have experience in an organization that delivers software. Understand parallel jobs. Completed 100 XP. 4 minutes. How a parallel job is consumed by a build or release. Consider an organization that has only one Microsoft-hosted parallel job. This job allows users in that organization to collectively run only one build or release job at a time. When more jobs are triggered, they're queued and will wait for the previous job to finish. A release consumes a parallel job only when it's being actively deployed to a stage. While the release is waiting for approval or manual intervention, it doesn't consume a parallel job. A simple example of parallel jobs. Fabricam Fiber CI Build 102 main branch starts first. Deployment of Fabricam Fiber Release 11 is triggered by the completion of Fabricam Fiber CI Build 102. Fabricam Fiber CI Build 101 feature branch is triggered. The build can't start yet because Release 11's deployment is active. So, the build stays queued. Release 11 waits for approvals. Fabricam CI Build 101 starts because a release waiting for approvals doesn't consume a parallel job. Release 11 is approved. It resumes only after Fabricam CI Build 101 is completed. Relationship between jobs and parallel jobs. The term job can refer to multiple concepts, and its meaning depends on the context. When you define a build or release, you can define it as a collection of jobs. When a build or release runs, you can run multiple jobs as part of that build or release. Each job consumes a parallel job that runs on an agent. When there aren't enough parallel jobs available for your organization, then the jobs are queued up and run one after the other. You don't consume any parallel jobs when you run a server job or deploy to a deployment group. Estimate parallel jobs. Completed 100 XP. 6 minutes. Determine how many parallel jobs you need. You could begin by seeing if the free tier offered in your organization is enough for your teams. When you've reached the 1,800 minutes per month limit for the free tier of Microsoft-hosted parallel jobs, you can start by buying one parallel job to remove this monthly time limit before deciding to purchase more. As the number of queued builds and releases exceeds the number of parallel jobs you have, your build and release queues will grow longer. When you find the queue delays are too long, you can purchase extra parallel jobs as needed. Simple estimate. A simple rule of thumb, estimate that you'll need one parallel job for every 4 to 5 users in your organization. Detailed estimate. In the following scenarios, you might need multiple parallel jobs. If you have multiple teams, and if each of them requires a CI build, you'll likely need a parallel job for each team. If your CI build trigger applies to multiple branches, you'll likely need a parallel job for each active branch. If you develop multiple applications by using one organization or server, you'll likely need more parallel jobs, one to deploy each application simultaneously. View available parallel jobs. Browse to Organization Settings Pipelines Parallel Jobs. Location of parallel jobs in organization settings. URL example, https:// your organization /settings /build queue _a equals concurrent jobs. View the maximum number of parallel jobs that are available in your organization. Select View in Progress Jobs to display all the builds and releases that are actively consuming an available parallel job or queued waiting for a parallel job to be available. Sharing of parallel jobs across projects in a collection. Parallel jobs are purchased at the organization level, and they're shared by all projects in an organization. Currently, there isn't a way to partition or dedicate parallel job capacity to a specific project or agent pool. For example, you purchase 2 parallel jobs in your organization. You queue 2 builds in the first project, and both the parallel jobs are consumed. You queue a build in the second project. That build won't start until one of the builds in your first project is completed. Describe Azure pipelines and open source projects. Completed 100 XP. 6 minutes. Azure DevOps offers developers a suite of DevOps capabilities, including source control, agile planning, build, release, test, and more. But to use Azure DevOps features requires the user to first sign in using a Microsoft or GitHub account. However, this blocks many engaging scenarios where you want to publicly share your code and artifacts or provide a wiki library or build status page for unauthenticated users. With public projects, users can mark an Azure DevOps team project as public. This will enable anonymous users to view the contents of that project in a read-only state, enabling collaboration with anonymous, unauthenticated users that wasn't possible before. Anonymous users will essentially see the same views as authenticated users, with non-public functionality such as settings or actions, such as queue build, hidden or disabled. Public versus private projects. Projects in Azure DevOps provide a repository for source code and a place for a group of developers and teams to plan, track progress, and collaborate on building software solutions. One or more projects can be defined within an organization in Azure DevOps. Users that aren't signed into the service have read-only access to public projects on Azure DevOps. Private projects require users to be granted access to the project and signed in to access the services. Supported services. Non-members of a public project will have read-only access to a limited set of services, precisely. Browse the codebase, download code, view commits, branches, and pull requests. View and filter work items. View a project page or dashboard. View the project wiki. Do a semantic search of the code or work items. For more information, see differences and limitations for non-members of a public project. A practical example, .NET Core CLI. Supporting open source development is one of the most compelling scenarios for public projects. A good example is the .NET Core CLI. Their source is hosted on GitHub, and they use Azure DevOps for their CI builds. However, if you click on the build badges in their README, you'll not see the build results unless you were one of the project's maintainers. Since this is an open source project, everybody should view the full results to see why a build failed and maybe even send a pull request to help fix it. Thanks to public project's capabilities, the team will enable just that experience. Everyone in the community will have access to the same build results, whether they are a maintainer on the project. How do I qualify for the free tier of Azure pipelines for public projects? Microsoft will automatically apply the free tier limits for public projects if you meet both conditions. Your pipeline is part of an Azure Pipelines public project. Your pipeline builds a public repository from GitHub or the same public project in your Azure DevOps organization. Are there limits on who can use Azure pipelines? You can have as many users as you want when you're using Azure pipelines. There's no per-user charge for using Azure pipelines. Users with both basic and stakeholder access can author as many builds and releases as they want. Are there any limits on the number of builds and release pipelines that I can create? No. You can create hundreds or even thousands of definitions for no charge. You can register any number of self-hosted agents for no cost. As a Visual Studio Enterprise subscriber, do I get more parallel jobs for Azure pipelines? Yes. Visual Studio Enterprise subscribers get one self-hosted parallel job in each Azure DevOps Services organization where they're a member. When you're using the per-minute plan, you can run only one job at a time. If you run builds for more than 14 paid hours in a month, the per-minute plan might be less cost-effective than the parallel jobs model. See Azure DevOps Services Pricing, Microsoft Azure for current pricing. Explore Azure Pipelines and Visual Designer. Completed 100 XP. 4 minutes. You can create and configure your build and release pipelines in the Azure DevOps web portal with the Visual Designer, often referred to as classic pipelines. Configure Azure Pipelines to use your Git repo. Use the Azure Pipelines Visual Designer to create and configure your build and release pipelines. Push your code to your version control repository. This action triggers your pipeline and runs tasks such as building or testing code. The build creates an artifact used by the rest of your pipeline to run tasks such as deploying to staging or production. Your code is now updated, built, tested, and packaged. It can be deployed to any target. Benefits of using the Visual Designer. The Visual Designer is great for new users in continuous integration, CI, and continuous delivery, CD. The visual representation of the pipelines makes it easier to get started. The Visual Designer is in the same hub as the build results. This location makes it easier to switch back and forth and make changes. If you think the designer workflow is best for you, create your first pipeline using the Visual Designer. Describe Azure pipelines in YAML. Completed 100 XP. 4 minutes. Mirroring the rise of interest in infrastructure as code, there has been considerable interest in defining pipelines as code. However, pipeline as code doesn't mean executing a script that's stored in source control. Codified pipelines use their programming model to simplify the setup and maximize reuse. A typical microservice architecture will require many deployment pipelines that are identical. It's tedious to craft these pipelines via a user interface or SDK. The ability to define the pipeline and the code helps apply all principles of code sharing, reuse, templatization, and code reviews. Azure DevOps offers you both experiences. You can either use YAML to define your pipelines or use the Visual Designer to do the same. You will, however, find that more product-level investments are being made to enhance the YAML pipeline experience. When you use YAML, you define your pipeline mostly in code, a YAML file, alongside the rest of the code for your app. When using the Visual Designer, you define a build pipeline to build and test your code and publish artifacts. You also specify a release pipeline to consume and deploy those artifacts to deployment targets. Use Azure Pipelines with YAML. You can configure your pipelines in a YAML file that exists alongside your code. Configure Azure Pipelines to use your Git repo. Edit your Azure Pipelines.yml file to define your build. Push your code to your version control repository. This action kicks off the default trigger to build and deploy and then monitor the results. Your code is now updated, built, tested, and packaged. It can be deployed to any target. Benefits of using YAML. The pipeline is versioned with your code and follows the same branching structure. You get validation of your changes through code reviews in pull requests and branch build policies. Every branch you use can modify the build policy by adjusting the Azure Pipelines.yml file. A change to the build process might cause a break or result in an unexpected outcome. Because the change is in version control with the rest of your codebase, you can more easily identify the issue. If you think the YAML workflow is best for you, create your first pipeline by using YAML. While there's a slightly higher learning curve and a higher degree of code orientation when defining pipelines with YAML, it's now the preferred method. Enable continuous integration with Azure Pipelines. Completed 100 XP. 45 minutes. Estimated time, 45 minutes. Scenario. In this lab, you will learn how to define build pipelines in Azure DevOps using YAML. The pipelines will be used in 2 scenarios. As part of pull request validation process. As part of the continuous integration implementation. Objectives. After completing this lab, you'll be able to include build validation as part of a pull request. Configure CI pipeline as code with YAML. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, Create one by following the instructions available at Create an Organization or Project Collection. Exercises. During this lab, you'll complete the following exercises. Exercise 0. Configure the lab prerequisites. Exercise 1. Include build validation as part of a pull request. Exercise 2. Configure CI pipeline as code with YAML. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices isn't used to create and configure an Azure pipeline? XML. YAML. Visual Designer. 2. Which of the following choices is a benefit of using the Visual Designer? Every branch you use can modify the build policy by modifying the Azure Pipelines.yml file. The Visual Designer is in the same hub as the build results. A change to the build process might cause a break or result in an unexpected outcome. Because the change is in version control with the rest of your codebase, you can more easily identify the issue. 3. Which of the following choices is a benefit of using YAML? The pipeline is versioned with your code and follows the same branching structure. The YAML representation of the pipelines makes it easier to get started. The YAML is in the same hub as the build results. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described parallel jobs and how to estimate their usage. Also, it presented Azure DevOps for open source projects, explored Visual Designer and YAML pipelines. You learned how to describe the benefits and usage of. Use and estimate parallel jobs. Use Azure pipelines for open source or private projects. Use Visual Designer. Work with Azure pipelines and YAML. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes pipeline strategies, configuration, implementation of multi-agent builds, and what source controls Azure Pipeline supports. Learning objectives. After completing this module, students and professionals can define a build strategy, explain and configure demands, implement multi-agent builds, use different source control types available in Azure Pipelines. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Configure agent demands. Completed 100 XP. 5 minutes. Not all agents are the same. We've seen that they can be based on different operating systems, but they can also install different dependencies. To describe it, every agent has a set of capabilities configured as name-value pairs. The capabilities such as machine name and operating system type that are automatically discovered are referred to as system capabilities. The ones that you define are called user-defined capabilities. There's a tab for capabilities on the agent pools page at the organization level when you select an agent. You can use it to see the available capabilities for an agent and to configure user capabilities. Opening a configured self-hosted agent, you can see the capabilities on that tab. When you configure a build pipeline and the agent pool to use, you can specify specific demands that the agent must meet on the Options tab. In the build job image, the has payment service is required in the collection of capabilities. And an exists condition, you can choose that a capability equals a specific value. For more information, see capabilities. Explore multi-configuration and multi-agent. Completed 100 XP. 5 minutes. You might need to run the tasks of a pipeline multiple times, but with a slightly different configuration or split a large batch of work among various agents. There are 3 different types of jobs you can run. None, tasks will run on a single agent. Multi-configuration, run the same set of tasks on multiple configurations as specified in the multipliers. Configurations will run in parallel, and each configuration will use a single agent. For example, run the release once with configuration setting A on web app A and setting B for web app B. Deploy to different geographic regions. Multi-agent, run the same set of tasks on multiple agents using the specified number of agents. For example, you can run a broad suite of 1,000 tests on a single agent. Or you can use 2 agents and run 500 tests on each one in parallel. For more information, see specify jobs in your pipeline. Do you see a purpose for release jobs in your pipeline? How would you set it up? Topics you might want to consider are: do you have artifacts from multiple sources? Do you want to run deployments on different servers simultaneously? Do you need multiple platforms? How long does your release take? Can you run your deployment in parallel, or does it need to run in sequence? Integrate GitHub repos and Azure pipelines. Completed 100 XP. 3 minutes. Integrating GitHub repositories with Azure pipelines offers a solution for teams that plan to create new or have existing repositories on GitHub but seek to leverage the capabilities of Azure pipelines for continuous integration and deployment. This approach allows organizations to capitalize on their existing expertise in Azure pipelines while benefiting from the collaborative features and familiarity of GitHub for version control and code management. Planning. While GitHub and Azure pipelines offer tight integration with each other, they're 2 independent services with their own organization, user management, and permission model. To implement and managing that integration, you should consider several considerations. Naming convention. Consider aligning the way GitHub repos and Azure pipelines are named and structured. In particular, if you don't have an Azure DevOps organization yet, create one named the same as your GitHub organization or account. For example, assuming that your GitHub organization is named org1, the resulting Azure DevOps organization URL would be https://dev.azure.com/org1. In the Azure DevOps organization, create projects named the same as the GitHub repositories. For example, assuming that your GitHub repo is named repo1, the resulting URL would be https://dev.azure.com/org1/repo1. In the DevOps project, create pipelines named after the corresponding GitHub organization and repository, such as org1.repo1. Note that this alignment isn't required, but it will help you clearly indicate the relationship between GitHub repos and their respective Azure pipelines. User management. By default, GitHub users don't have access to Azure pipelines. Similarly, Azure pipelines aren't aware of GitHub identities. Consequently, it isn't possible to configure Azure pipelines to automatically notify these users about build or deployment-related issues. To remediate this, add the user accounts to the Azure DevOps organization and configure their permissions to match those in the GitHub organization. At that point, you'll be able to set up Azure Pipelines user notifications. Azure Pipeline permissions. Azure Pipelines must be able to access GitHub repositories to trigger their builds and fetch their code during builds. You can grant this access by using the following methods. GitHub app authentication with the Azure Pipelines identity. OAuth with your personal GitHub identity. GitHub Personal Access Token, PAT, with your personal GitHub identity. GitHub app authentication. The Azure Pipelines GitHub app is the recommended authentication type for continuous integration pipelines, since it doesn't rely on your personal GitHub identity. In addition, this method supports GitHub checks to display build, test, and code coverage results in GitHub. OAuth. OAuth authorization is suitable when working with personal GitHub accounts. In this case, GitHub status updates are performed in the security context of your personal GitHub identity. GitHub Personal Access Token. As with OAuth, PAT relies on your personal GitHub identity for authentication, but its permissions can be configured in a very granular manner. On the other hand, PAT is subject to expiration and revocation, so you need to ensure that it remains valid for as long as you need to run the corresponding pipelines. Implementation. To use the GitHub app, install it in your GitHub organization for all repositories, as the organization owner, or some of them as the repo admin. Following the installation, any pipelines targeting these repositories will, by default, use this authentication method. To use OAuth, select Choose a different connection under the list of repositories while creating a pipeline. Then, select Authorize to sign into GitHub and authorize with OAuth. An OAuth connection is saved in your Azure DevOps project. You'll be able to reference later if needed when creating additional pipelines. To use a PAT, use the GitHub settings page. Set the permissions to repo, admin, repo_hook, read user, and user email. Copy the generated PAT into a new GitHub service connection in your Azure DevOps project settings. Reference the service connection name when creating pipelines. When creating a pipeline, select the target GitHub repository and then a YAML file in that repository. The repository in which the YAML file is present is called self. By default, this is the repository that the pipeline will build. You can also configure the same pipeline to check out additional repositories. When you create pipelines for a single repository across multiple Azure DevOps organizations, only the first pipeline can be automatically triggered by GitHub commits or pull requests. The remaining pipelines can access the repository, but invoking them requires manual or scheduled triggers. Design and implement a comprehensive testing strategy. Completed 100 XP. 3 minutes. Testing is a fundamental aspect of software development that validates the quality, reliability, and functionality of applications. It's a key concern during the local developer process, the inner loop, but also is an essential component of the complete DevOps lifecycle, the outer loop, in which code traverses the path from release pipeline to the production environment. Test types. The need for validation spans entire software lifecycle, relying on a range of different types of testing to detect defects, verify functionality, and assess performance. Unit testing focuses on running individual components or modules in isolation, ensuring that each unit behaves as expected. Integration testing evaluates interactions between different components to assess their integration and functionality. Functional testing primarily focuses on evaluating individual components or features within the application to ensure they meet functional requirements. These tests validate the behavior of specific functions or units of code, often in isolation from the rest of the system, and are typically designed to verify that each component performs its intended function correctly. Smoke testing identifies whether infrastructure and application components are available and function as expected. Common smoke testing scenarios include reaching the HTTPS endpoint of a web application, querying a database, and simulating a single user flow in the application. UI testing validates that application user interfaces are deployed and that user interface interactions function as expected. It's recommended to use UI automation tools to drive automation. During automated UI tests, a script mimics a real user scenario. Load testing verifies scalability and application functionality by increasing the load until reaching a predefined threshold, ensuring the system operates effectively under stress. This test usually focuses on specific user pathways to ensure the application meets performance requirements when subjected to defined levels of load. Stress testing involves subjecting the system to excessive loads to assess its resiliency and capacity to handle extreme conditions. This helps with identifying performance bottlenecks and evaluating the ability to recover in a graceful manner. Performance testing combines load and stress testing to validate performance under load and establish a benchmark for application operation. Chaos testing introduces simulated failures into the system to assess its response and validate the resilience strategies, operational protocols, and mitigation techniques. This method evaluates the system's ability to withstand unexpected disruptions and gracefully recover from them. Penetration testing ensures that an application and its environment meet the requirements of an expected security posture. Its goal is to identify security vulnerabilities. Security testing can include end-to-end software supply chain and package dependencies, with scanning and monitoring for known common vulnerabilities and exposures, CVE. End-to-end testing simulates real user scenarios by testing the entire software system from start to finish, including all integrated components and external dependencies. These tests mimic user interactions with the application and validate its behavior across multiple layers, helping to ensure that the system functions correctly as a whole and delivers the intended user experience. You can perform different tests in a single environment, and, in some cases, it might be required. For example, for chaos testing to provide meaningful results, you must first place the application under load so you can understand how the application responds to injected faults. Consequently, chaos testing and load testing are typically performed together. Designing and implementing testing strategy. Designing and implementing a comprehensive DevOps testing strategy involves several key considerations. Assessment and planning. Evaluate your project requirements, including the application architecture, technology stack, and deployment targets. Use your findings to identify the types of tests needed, such as unit tests, integration tests, end-to-end tests, performance tests, and security tests. Define testing goals, criteria for success, and key performance indicators, KPIs, to measure the effectiveness of your testing strategy. Tools and framework selection. Choose appropriate testing tools and frameworks based on your project requirements and technology stack. Consider factors such as language support, integration with CI/CD pipelines, reporting capabilities, and community support. Popular testing frameworks include JUnit, NUnit, MSTest for unit testing, Selenium, Cypress for UI testing, and JMeter, Gatling for performance testing. Test automation. Prioritize test automation to accelerate the testing process and ensure consistent results. Write automated tests for different layers of your application, including unit tests for individual components, integration tests for interactions between components, and end-to-end tests for user workflows. Integrate automated tests into your CI/CD pipeline to run them automatically on code changes. Continuous integration, CI. Configure CI pipelines in Azure DevOps or GitHub Actions to trigger automated builds and tests on code changes. Ensure that your CI pipeline includes steps for compiling code, running automated tests, and generating test reports. Use features like build triggers, matrix builds, and parallel jobs to optimize your CI pipeline for speed and efficiency. Continuous deployment, CD. Implement CD pipelines to automate the deployment of tested code to different environments, such as development, staging, and production. Include approval gates, manual interventions, and deployment gates in your CD pipeline to ensure quality and compliance before promoting code to production. Leverage deployment strategies like blue-green deployments, canary releases, and feature flags to minimize downtime and risk during deployments. Monitoring and feedback. Set up monitoring and alerting systems to track application performance, errors, and anomalies in real time. Collect feedback from automated tests, production monitoring, and user feedback to continuously improve your testing strategy and address issues proactively. Use metrics and dashboards to visualize test results, identify trends, and make data-driven decisions to optimize your testing processes. Documentation and training. Document your testing strategy, including test plans, test cases, test data, and known issues. Provide training and resources to team members on testing best practices, tools, and techniques to ensure consistent execution of the testing strategy across the organization. Implement code coverage and show in the pipeline. Completed 100 XP. 3 minutes. Code coverage is a metric used to measure the proportion of source code that is executed during automated tests. It provides insight into the effectiveness of test suites by identifying areas of code that lack sufficient test coverage. By ensuring comprehensive code coverage, development teams can increase confidence in their software's reliability, identify potential bugs early in the development process, and ultimately deliver higher quality products to end users. While the concept of code coverage is platform agnostic, its implementation details differ between Azure DevOps and GitHub. These details also differ across development frameworks and programming languages. Azure DevOps. Let's assume that you have a .NET C# project for which you want to implement code coverage by using Azure pipelines. This would involve the following sequence of tasks. Set up test and coverage tools. Use a testing framework that supports code coverage analysis such as NUnit, MSTest, or XUnit for .NET. Integrate a code coverage tool such as Coverlet or OpenCover into your project. These tools can generate code coverage reports in various formats compatible with Azure pipelines. Configure Azure pipelines. In the Azure DevOps portal, navigate to your Azure DevOps project and select the pipeline where you want to add code coverage. Edit the pipeline configuration and add steps to install dependencies and build your project. Add code coverage tasks. Add tasks to the pipeline to run tests with code coverage enabled and generate coverage reports. Use the appropriate command line arguments for your test runner to enable code coverage analysis and specify the output format for coverage reports. Publish code coverage reports. Publish the generated code coverage reports as artifacts or attach them to the pipeline run. Use Azure Pipeline's built-in publishing capabilities or custom tasks to upload coverage reports to Azure DevOps or external services. Here is a sample pipeline that illustrates this approach. Trigger, main pool, VM image, Windows latest steps, task, use.NET at 2 inputs, package type, SDK version, 8.0.x script, .NET restore display name, restore dependencies script, .NET build configuration release display name, build solution script, .NET test no build verbosity normal/p, collect coverage equals true/p, coverlet output format equals open cover display name, run tests with code coverage task, publish code coverage results at 2 inputs. Summary file location, $agent.temp directory, /****star.xml fail if coverage empty, true. This pipeline generates code coverage reports as part of the build process. This allows you to review and analyze the coverage results in the Azure DevOps portal. To perform more detailed analysis, you could download code coverage artifacts and examine them by using Visual Studio, when using the Visual Studio Test task, or code coverage tool-specific options. GitHub. To facilitate comparison with Azure DevOps-based approach, let's assume again that you have a .NET C# project for which you want to implement code coverage by using GitHub Actions workflow. This would involve the following sequence of tasks. Set up test and coverage tools. As with Azure DevOps, use a testing framework that supports code coverage analysis. Verify that these tools can generate code coverage reports in the formats compatible with GitHub. Create GitHub Actions workflow. On the GitHub repository page, navigate to the .github/workflows directory. Create a new YAML file, e.g., ci.yml, to define your workflow configuration. Define triggers for your workflow, such as pull requests or pushes to specific branches. Configure workflow steps. Define steps in your workflow YAML to set up the environment, restore dependencies, build your project, run tests, and generate code coverage reports. Ensure that your project source code, test configuration, and necessary dependencies are included in the repository. Use actions such as action/checkout to check out your repository, action/setup.net to set up .NET Core SDK, and cover allsap/GitHub action or codecov/codecov action to upload code coverage reports. Here is a sample workflow that illustrates this approach. YAML. Name. Code cover agent, pull_request, branches, main push, branches, main jobs, build, runs on Ubuntu latest steps, name, checkout repository uses, action/checkout at v2 name, setup.NET Core uses, action/setup.NET at v1 with, .NET version, 8.0.x name, restore dependencies run, .NET restore name, build solution run, .NET build configuration release name, run tests run. .NET test no build verbosity normal/p, collect coverage equals true/p, coverlet output format equals open cover name, upload code coverage report uses, cover allsap/GitHub action at v1 with, GitHub token, $secrets.github_token. This GitHub Actions workflow will automatically run tests and generate code coverage reports whenever a pull request is created or code is pushed to the main branch. Make sure you have the necessary permissions and API tokens to upload code coverage reports to third-party services like Coveralls or Codecov. Implement multi-job builds. Completed 100 XP. 5 minutes. You can use multiple build agents to support multiple build machines. Either distribute the load, run builds in parallel, or use different agent capabilities. As an example, components of an application might require different incompatible versions of a library or dependency. Multiple jobs in a pipeline. Adding multiple jobs to a pipeline lets you break your pipeline into sections that need different agent pools or self-hosted agents. Publish artifacts in one job and consume them in one or more subsequent jobs. Build faster by running multiple jobs in parallel. Enable conditional execution of tasks. To add another agent job to an existing pipeline, click on the ellipsis and choose as shown in this image. Parallel jobs. At the organization level, you can configure the number of parallel jobs that are made available. The free tier allows for one parallel job of up to 1,800 minutes per month. The self-hosted agents have higher levels. Note: you can define a build as a collection of jobs rather than as a single job. Each job consumes one of these parallel jobs that run on an agent. If there aren't enough parallel jobs available for your organization, the jobs will be queued and run sequentially. Build-related tooling. Azure DevOps can be integrated with a wide range of existing tooling used for builds or associated with builds. Which build-related tools do you currently use? What do you like or don't like about the tools? Explore source control types supported by Azure Pipelines. Completed 100 XP. 3 minutes. Azure Pipelines offers YAML and classic pipelines. The table shows the repository types supported by both. Repository type. Azure Pipelines, YAML. Azure Pipelines, Classic Editor. Azure Repos Git. Yes. Yes. Azure Repos TFVC. No. Yes. Bitbucket Cloud. Yes. Yes. Other Git, generic. No. Yes. GitHub. Yes. Yes. GitHub Enterprise Server. Yes. Yes. Subversion. No. Yes. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select check your answers. Check your knowledge. 1. Which of the following choices could be a user capability? Agent.computername. Agent.os. Contoso application path. 2. Which of the following choices is the scope of where parallel jobs are defined? Project scope. Organization scope. Pipeline scope. 3. Which of the following choices of repository types does a YAML pipeline supports? Azure Repos TFVC. Azure Repos Git. Other Git, generic. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described pipeline strategies, configuration, implementation of multi-agent builds, and what source controls Azure Pipeline supports. You learned how to describe the benefits and usage of. Define a build strategy. Explain and configure demands. Implement multi-agent builds. Use different source control types available in Azure Pipelines. Learn more. Introduction. Completed 100 XP. 1 minute. This module details Azure Pipeline's anatomy and structure, templates, YAML resources, and how to use multiple repositories in your pipeline. Also, it explores communication to deploy using Azure Pipelines to target servers. Learning objectives. After completing this module, students and professionals can describe advanced Azure Pipelines anatomy and structure, detail templates and YAML resources, implement and use multiple repositories, explore communication to deploy using Azure Pipelines. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Understanding of Azure Pipelines. Beneficial to have experience in an organization that delivers software. Describe the anatomy of a pipeline. Completed 100 XP. 6 minutes. Azure Pipelines can automatically build and validate every pull request and commit to your Azure Repos Git repository. Azure Pipelines can be used with Azure DevOps public projects and Azure DevOps private projects. In future training sections, we'll also learn how to use Azure Repos with external code repositories such as GitHub. Let's start by creating a Hello World YAML pipeline. Hello World. Start slowly and create a pipeline that echoes Hello World to the console. No technical course is complete without a Hello World example. YAML. Name 1.0 rev.r hashtag simplified trigger implied branch trigger main hashtag equivalence trigger hashtag branches hashtag include hashtag main variables name John Poole VM image Ubuntu latest jobs job hello world steps checkout self script echo hello $name. Most pipelines will have these components. Name, though often it's skipped. If it's skipped, a database name is generated automatically. Trigger, more on triggers later, but without an explicit trigger. There's an implicit trigger on every commit to any path from any branch in this repo. Variables, inline variables, more on other types of variables later. Job, every pipeline must have at least one job. Pool, you configure which pool, queue, the job must run on. Checkout, the checkout, self tells the job which repository, or repositories if there are multiple checkouts, to check out for this job. Steps, the actual tasks that need to be executed, in this case, a script task, the script is an alias that can run inline scripts. Name. The variable name is a bit misleading since the name is in the build number format. You'll get an integer number if you don't explicitly set a name format. A monotonically increasing number of runs triggered off this pipeline, starting at 1. This number is stored in Azure DevOps. You can make use of this number by referencing $rev. To make a database number, you can use the format $date $YYYYMMDD to get a build number like 20221003. To get a semantic number like 1.0.x, you can use something like 1.0 $rev.r. Triggers. If there's no explicit trigger section, then it's implied that any commit to any path in any branch will trigger this pipeline to run. However, you can be more precise by using filters such as branches or paths. Let's consider this trigger. YAML. Trigger branches include main. This trigger is configured to queue the pipeline only when a commit to the main branch exists. What about triggering for any branch except the main? You guessed it, use exclude instead of include. YAML. Trigger branches exclude main. Tip. You can get the name of the branch from the variables build.sourceBranch, for the full name like ref/head/main, or build.sourceBranchName, for the short name like main. What about a trigger for any branch with a name that starts with topic/ and only if the change is in the web app folder? Trigger branches include feature/asterisk paths include web app/***. You can mix includes and excludes if you need to. You can also filter on tags. Tip: don't forget one overlooked trigger, none. You can use none if you never want your pipeline to trigger automatically. It's helpful if you're going to create a pipeline that is only manually triggered. There are other triggers for other events, such as pull requests, PRs, can also filter branches and paths. Schedules allow you to specify cron expressions for scheduling pipeline runs. Pipelines will enable you to trigger pipelines when other pipelines are complete, allowing pipeline chaining. You can find all the documentation on triggers here. Jobs. A job is a set of steps an agent executes in a queue or pool. Jobs are atomic, they're performed wholly on a single agent. You can configure the same job to run on multiple agents simultaneously, but even in this case, the entire set of steps in the job is run on every agent. You'll need 2 jobs if you need some steps to run on one agent and some on another. A job has the following attributes besides its name. Display name, a friendly name. Depends on, a way to specify dependencies and ordering of multiple jobs. Condition, a binary expression. If it evaluates to true, the job runs. If false, the job is skipped. Strategy, used to control how jobs are parallelized. Continue on error, specify if the rest of the pipeline should continue if this job fails. Pool, the pool name, queue, to run this job on. Workspace, managing the source workspace. Container, for specifying a container image to execute the job later. Variables, variables scoped to this job. Steps, the set of steps to execute. Timeout in minutes and cancel timeout in minutes for controlling timeouts. Services, sidecar services that you can spin up. Dependencies. When you define multiple stages in a pipeline, by default, they run sequentially in the order in which you define them in the YAML file. The exception to this is when you add dependencies. With dependencies, stages run in the order of the depends on requirements. Pipelines must contain at least one stage with no dependencies. Let's look at a few examples. Consider this pipeline. YAML. Jobs, job, a steps, #steps omitted for brevity job, B steps, #steps omitted for brevity. Because no depends on was specified, the jobs will run sequentially, first A and then B. To have both jobs run in parallel, we add depends on to job B. YAML. Jobs, job, a steps, #steps omitted for brevity job, B depends on, this removes the implicit dependency on the previous stage and causes this to run in parallel. Steps, #steps omitted for brevity. If we want to fan out and fan in, we can do that too. YAML. Jobs, job, a steps, script, echo job A, job, B depends on, a steps, script, echo job B, job, C depends on, a steps, script, echo job C, job, D depends on, B, C steps, script, echo job D, job, E depends on, B, D steps, script, echo job E. Checkout. Classic builds implicitly check out any repository artifacts, but pipelines require you to be more explicit using the checkout keyword. Jobs check out the repo they're contained in automatically unless you specify checkout, none. Deployment jobs don't automatically check out the repo, so you'll need to specify checkout, self for deployment jobs if you want access to the YAML files repo. Download. Downloading artifacts requires you to use the download keyword. Downloads also work the opposite way for jobs and deployment jobs. Jobs don't download anything unless you explicitly define a download. Deployment jobs implicitly do a download, current, which downloads any pipeline artifacts created in the existing pipeline. To prevent it, you must specify download, none. Resources. What if your job requires source code in another repository? You'll need to use resources. Resources let you reference other repositories. Pipelines. Builds, classic builds. Containers, for container jobs. Packages. To reference code in another repo, specify that repo in the resources section and then reference it via its alias in the checkout step. YAML. Resources, repositories, repository, app code type, git name, other repo steps, checkout, app code. Steps are tasks. Steps are the actual things that execute in the order specified in the job. Each step is a task, out of the box, OOB, tasks come with Azure DevOps. Many have aliases and tasks installed on your Azure DevOps organization via the marketplace. Creating custom tasks is beyond the scope of this chapter, but you can see how to make your custom tasks here. Variables. It would be tough to achieve any sophistication in your pipelines without variables. Though this classification is partly mine, several types of variables exist, and pipelines don't distinguish between these types. However, I found it helpful to categorize pipeline variables to help teams understand nuances when dealing with them. Every variable is a key value pair. The key is the variable's name, and it has a value. To dereference a variable, wrap the key in $. Let's consider this example. YAML. Variables, name, John steps, script, echo hello, $, name. It will write hello, John. To the log. Understand the pipeline structure. Completed 100 XP. 4 minutes. A pipeline is one or more stages that describe a CI/CD process. Stages are the primary divisions in a pipeline. The stages build this app, run these tests, and deploy to pre-production are good examples. A stage is one or more jobs, units of work assignable to the same machine. You can arrange both stages and jobs into dependency graphs. Examples include run this stage before that one, and this job depends on the output of that job. A job is a linear series of steps. Steps can be tasks, scripts, or references to external templates. This hierarchy is reflected in the structure of a YAML file like pipeline. Stage A. Job 1. Step 1.1. Step 1.2. Job 2. Step 2.1. Step 2.2. Stage B. Simple pipelines don't require all these levels. For example, you can omit the containers for stages and jobs in a single job build because there are only steps. Because many options shown in this article aren't required and have reasonable defaults, your YAML definitions are unlikely to include all of them. Pipeline. The schema for a pipeline. YAML. Name, string hashtag build numbering format resources, pipelines, pipeline resource, containers, container resource, repositories, repository resource, variables, hashtag several syntaxes trigger, trigger PR stages, stage, template reference. If you have a single stage, you can omit the stages keyword and directly specify the jobs keyword. YAML. Hashtag other pipeline level keywords jobs, job, template reference. If you have a single stage and a single job, you can omit the stages and jobs keywords and directly specify the steps keyword. YAML. Hashtag other pipeline level keyword steps, script, bash, PWSH, PowerShell, checkout, task, template reference. Stage. A stage is a collection of related jobs. By default, stages run sequentially. Each stage starts only after the preceding stage is complete. Use approval checks to control when a stage should run manually. These checks are commonly used to control deployments to production environments. Checks are a mechanism available to the resource owner. They control when a stage in a pipeline consumes a resource. As an owner of a resource like an environment, you can define checks required before a stage that consumes the resource can start. This example runs 3 stages, one after another. The middle stage runs 2 jobs in parallel. YAML. Stages, stage, build jobs, job, build job steps, script, echo building. Stage, test depends on, build jobs, job, test on Windows steps, script, echo testing on Windows. Job, test on Linux steps, script, echo testing on Linux. Stage, deploy depends on, test jobs, job, deploy steps, script, echo deploying the code. Job. A job is a collection of steps run by an agent or on a server. Jobs can run conditionally and might depend on previous jobs. YAML. Jobs, job, my job display name, my first job continue on error, true workspace, clean, output steps, script, echo my first job. Deployment strategies. Deployment strategies allow you to use specific techniques to deliver updates when deploying your application. Techniques examples. Enable initialization. Deploy the update. Route traffic to the updated version. Test the updated version after routing traffic. If there's a failure, run steps to restore to the last known good version. Run once. Run once is the most straightforward deployment strategy in all the presented lifecycle hooks. YAML. Strategy, run once, pre-deploy, pool, server, pool, hashtag cpool schema. Steps, script, bash, PWSH, PowerShell, checkout, task, template reference, deploy, pool, server, pool, hashtag cpool schema. Steps. Route traffic, pool, server, pool, steps. Post route traffic, pool, server, pool, steps. On, failure, pool, server, pool, steps. Success, pool, server, pool, steps. For details and examples, see deployment jobs. Rolling. A rolling deployment replaces instances of the previous version of an application with instances of the new version. It can be configured by specifying the keyword rolling under the strategy node. YAML. Strategy, rolling, max parallel, number or percentage as X%, pre-deploy, steps, script, bash, PWSH, PowerShell, checkout, task, template reference, deploy, steps. Route traffic, steps. Post route traffic, steps. On, failure, steps. Success, steps. For details and examples, see deployment jobs. Canary. Using this strategy, you can first roll out the changes to a small subset of servers. The Canary deployment strategy is an advanced deployment strategy that helps mitigate the risk of rolling out new versions of applications. As you gain more confidence in the new version, you can release it to more servers in your infrastructure and route more traffic to it. YAML. Strategy, Canary, increments, number, pre-deploy, pool, server, pool, hashtag cpool schema. Steps, script, bash, PWSH, PowerShell, checkout, task, template reference, deploy, pool, server, pool, hashtag cpool schema. Steps. Route traffic, pool, server, pool, steps. Post route traffic, pool, server, pool, steps. On, failure, pool, server, pool, steps. Success, pool, server, pool, steps. For details and examples, see deployment jobs. Lifecycle hooks. You can achieve the deployment strategies technique by using lifecycle hooks. Depending on the pool attribute, each resolves into an agent or server job. Lifecycle hooks inherit the pool specified by the deployment job. Deployment jobs use the $pipeline workspace system variable. Available lifecycle hooks. Predeploy, used to run steps that initialize resources before application deployment starts. Deploy, used to run steps that deploy your application. Download artifact task will be auto-injected only in the deploy hook for deployment jobs. To stop downloading artifacts, use download, none or choose specific artifacts to download by specifying download pipeline artifact task. Route traffic, used to run steps that serve the traffic to the updated version. Post-route traffic, used to run the steps after the traffic is routed. Typically, these tasks monitor the health of the updated version for a defined interval. On failure or on success, used to run steps for rollback actions or cleanup. Steps. A step is a linear sequence of operations that make up a job. Each step runs its process on an agent and accesses the pipeline workspace on a local hard drive. This behavior means environment variables aren't preserved between steps, but file system changes are. YAML. Steps script echo this run in the default shell on any machine bash. Echo this multiline script always runs in bash. Echo even on Windows machines. PWSH write host this multiline script always runs in PowerShell core. Write host even on non-Windows machines. Tasks. Tasks are the building blocks of a pipeline. There's a catalog of tasks available to choose from. YAML. Steps task vs build at 1 display name build timeout in minutes 120 inputs solution ****star.sln. Detail templates. Completed 100 XP. 3 minutes. Template references. You can export reusable sections of your pipeline to a separate file. These individual files are known as templates. Azure Pipeline supports 4 types of templates: stage, job, step, variable. You can also use templates to control what is allowed in a pipeline and define how parameters can be used. Parameter. Templates themselves can include other templates. Azure Pipelines supports 50 individual template files in a single pipeline. Stage templates. You can define a set of stages in one file and use it multiple times in other files. In this example, a stage is repeated twice for 2 testing regimes. The stage itself is specified only once. YAML. Hashtag file, stages/test.yml parameters, name, test file, stages, stage, test _ parameters.name, jobs, job, $parameters.name _ Windows pool, VM image, Windows latest steps, script, npm install script, npm test file equals $parameters.test file, job, $parameters.name _ Mac pool, VM image, macOS latest steps, script, npm install script, npm test file equals $parameters.test file. Templated pipeline. YAML. Hashtag file, Azure Pipelines.yml stages, template, stages/test.yml hashtag template reference parameters, name, mini test file, test/minisuite.js template, stages/test.yml hashtag template reference parameters, name, full test file, test/fullsuite.js. Job templates. You can define a set of jobs in one file and use it multiple times in other files. In this example, a single job is repeated on 3 platforms. The job itself is specified only once. YAML. Hashtag file, job/build.yml parameters, name, pool, sign, false jobs, job, $parameters.name, pool, $parameters.pool, steps, script, npm install script, npm test $if eq, parameters.sign, true, script, sign. YAML. Hashtag file, Azure Pipelines.yml jobs, template, jobs/build.yml hashtag template reference parameters, name, macOS pool, VM image, macOS latest template, jobs/build.yml hashtag template reference parameters, name, Linux pool, VM image, Ubuntu latest template, jobs/build.yml hashtag template reference parameters, name, Windows pool, VM image, Windows latest sign, true hashtag extra step on Windows only. Step templates. You can define a set of steps in one file and use it multiple times in another. YAML. Hashtag file, steps/build.yml steps, script, npm install script, npm test. YAML. Hashtag file, Azure Pipelines.yml jobs, job, macOS pool, VM image, macOS latest steps, template, steps/build.yml hashtag template reference job, Linux pool, VM image, Ubuntu latest steps, template, steps/build.yml hashtag template reference job, Windows pool, VM image, Windows latest steps, template, steps/build.yml hashtag template reference script, sign hashtag extra step on Windows only. Variable templates. You can define a set of variables in one file and use it multiple times in other files. In this example, a set of variables is repeated across multiple pipelines. The variables are specified only once. YAML. Hashtag file, variables/build.yml variables, name, VM image value, Windows latest name, Arch value, x64 name, config value, debug. YAML. Hashtag file, component xpipeline.yml variables, template, variables/build.yml hashtag template reference pool, VM image, $variables.vm image, steps, script, build x $variables.arch, $variables.config. YAML. Hashtag file, component ypipeline.yml variables, template, variables/build.yml hashtag template reference pool, VM image, $variables.vm image, steps, script, build y $variables.arch, $variables.config. Explore YAML resources. Completed 100 XP. 2 minutes. Resources in YAML represent sources of pipelines, repositories, and containers. For more information on resources, see here. General schema. YAML. Resources, pipelines, pipeline, repositories, repository, containers, container. Pipeline resource. If you have an Azure pipeline that produces artifacts, your pipeline can consume the artifacts by using the pipeline keyword to define a pipeline resource. YAML. Resources, pipelines, pipeline, MyApp A source, MyCI pipeline A pipeline, MyApp B source, MyCI pipeline B trigger, true pipeline, MyApp C project, DevOps project source, MyCI pipeline C branch, releases/M159 version, 20,190,718.2 trigger, branches, include, master releases/* exclude, users/*. Container resource. Container jobs let you isolate your tools and dependencies inside a container. The agent launches an instance of your specified container, then runs steps inside it. The container keyword lets you specify your container images. Service containers run alongside a job to provide various dependencies like databases. YAML. Resources, containers, container, Linux image, Ubuntu, 16.04, container, Windows image, myprivate.azure.cr/io/Windows Server Core :1803 endpoint, my_ACR_connection container, my_service image, my_service, tag ports, 8080:80 hashtag bind container port 80 to 8080 on a host machine, 6379 hashtag bind container port 6379 to a random available port on a host machine volumes, /src/dir, /dst/dir hashtag mount /src/dir on a host into /dst/dir in the container. Repository resource. Let the system know about the repository if your pipeline has templates in another repository. If you want to use multi-repo checkout with a repository that requires a service connection. The repository keyword lets you specify an external repository. YAML. Resources, repositories, repository, common type, GitHub name, Contoso/Common Tools endpoint, my Contoso service connection. Use multiple repositories in your pipeline. Completed 100 XP. 3 minutes. You might have micro-Git repositories providing utilities used in multiple pipelines within your project. Pipelines often rely on various repositories. You can have different repositories with sources, tools, scripts, or other items that you need to build your code. By using multiple checkout steps in your pipeline, you can fetch and check out other repositories to the one you use to store your YAML pipeline. Previously, Azure Pipelines hasn't offered support for using multiple code repositories in a single pipeline. Using artifacts or directly cloning other repositories via script within a pipeline, you can work around it. It leaves access management and security down to you. Repositories are now first-class citizens within Azure Pipelines. It enables some exciting use cases, such as checking out specific repository parts and checking multiple repositories. There's also a use case for not checking out any repository in the pipeline. It can be helpful in cases where you're setting up a pipeline to do a job that has no dependency on any repository. Specify multiple repositories. Repositories can be specified as a repository resource or in line with the checkout step. Supported repositories are Azure Repos Git, GitHub, and Bitbucket Cloud. The following combinations of checkout steps are supported. If there are no checkout steps, the default behavior is checkout, self is the first step. If there's a single checkout, none step, no repositories are synced or checked out. If there's a single checkout, self step, the current repository is checked out. If there's a single checkout step that isn't self or none, that repository is checked out instead of self. If there are multiple checkout steps, each named repository is checked out to a folder named after the repository. Unless a different path is specified in the checkout step, use checkout, self as one of the checkout steps. Repository resource, how to do it. If your repository type requires a service connection or other extended resources field, you must use a repository resource. Even if your repository type doesn't require a service connection, you may use a repository resource. For example, you have a repository resource defined already for templates in a different repository. In the following example, 3 repositories are declared as repository resources. The repositories and the current self-repository containing the pipeline YAML are checked out. YAML. Resources, repositories, repository, my GitHub repo hashtag the name used to reference this repository in the checkout step. Type, GitHub endpoint, my GitHub service connection name, my GitHub org user / my GitHub repo repository, my Bitbucket repo type, Bitbucket endpoint, my Bitbucket service connection name, my Bitbucket org user / my Bitbucket repo repository, my Azure repos Git repository type, Git name, my project / my Azure repos Git repo trigger, main pool, VM image, Ubuntu latest steps, checkout, self-checkout, my GitHub repos checkout, my Bitbucket repos checkout, my Azure repos Git repository script, dir $build.sources directory. If the self-repository is named current repo, the script command produces the following output: current repo my Azure repos Git repo my Bitbucket repo my GitHub repo. In this example, the repository's names are used for the folders because no path is specified in the checkout step. Inline, how to do it. If your repository doesn't require a service connection, you can declare it according to your checkout step. YAML. Steps, checkout, git // my project / my repo # Azure repos Git repository in the same organization. The default branch is checked out unless you choose a specific ref. If you're using inline syntax, choose the ref by appending at ref. For example, YAML. Checkout, git // my project / my repo at features / tools # checks out the features / tools branch checkout, git // my project / my repo at ref / head / features / tools # also checks out the features / tools branch. Checkout, git // my project / my repo at ref / tag / my tag # checks out the commit referenced by my tag. GitHub repository. Azure pipelines can automatically build and validate every pull request and commit to your GitHub repository. When creating your new pipeline, you can select a GitHub repository and then a YAML file in that repository, self-repository. By default, this is the repository that your pipeline builds. Azure pipelines must be granted access to your repositories to trigger their builds and fetch their code during builds. There are 3 authentication types for granting Azure pipelines access to your GitHub repositories while creating a pipeline. GitHub app. OAuth. Personal access token, PAT. You can create a continuous integration, CI, trigger to run a pipeline whenever you push an update to the specified branches or push selected tags. YAML pipelines are configured by default with a CI trigger on all branches. YAML. Trigger, main releases ***. You can configure complex triggers that use exclude or batch. YAML. Hashtag specific branches build trigger, branches, include, master releases *** exclude, releases /old ***. Also, it's possible to configure pull request, PR, triggers to run whenever a pull request is opened with one of the specified target branches or when updates are made to such a pull request. You can specify the target branches when validating your pull requests. To validate pull requests that target main and releases ** and start a new run the first time a new pull request is created, and after every update made to the pull request. YAML. PR, main releases ***. You can specify the full name of the branch or a wildcard. For more information and guidance about GitHub integration, see Migrate a pipeline from Classic to YAML in Azure Pipelines. Completed 100 XP. 3 minutes. Migrating classic Azure pipelines to YAML-based configurations offers a more efficient approach to defining and managing CI/CD pipelines. YAML enables version-controlled, code-like representations of pipelines, enhancing maintainability and flexibility compared to the traditional UI-based approach. By transitioning to YAML, development teams can leverage code review processes, reuse pipeline configurations across repositories, and easily track changes over time. Pipeline conversion. The Azure DevOps portal includes the feature that facilitates migration from classic build pipelines to their YAML equivalents. You can access it via the Export to YAML context-sensitive menu option of individual build pipelines. Selecting this option automatically generates a file containing the YAML representation of the converted content and downloads it to your computer. The classic pipeline is left intact. The conversion process provides support for the following features: all tasks and all inputs, event and schedule-based triggers, individual and multiple jobs, job and step conditions, checkout options, execution plan parallelism, pool selection. There are, however, 2 features which aren't converted. Variables. Variables in a classic pipeline are excluded from the conversion process. Instead, they're mentioned by name in the comments of the auto-generated YAML pipeline as a reminder that you need to configure them manually. Time zone translation. Classic pipeline schedules are in the organization's time zone, while cron schedules in YAML are in UTC. To avoid any potential time zone conversion issues, the schedule is exported in its original format. This is also captured in the comments included in the new pipeline. For release pipelines, you can leverage the View YAML link available for individual pipeline tasks. Selecting the link generates the YAML code corresponding to the configuration of the task. This helps to identify the underlying YAML syntax used to define the task. Note that this code doesn't include values of the individual task properties, but instead substitutes them with variables. To set the values, refer to the graphical interface of the task and compare it against its YAML representation. There's no equivalent option to view the YAML at the job or stage level. Effectively, this part of the conversion relies on your familiarity with the syntax of YAML pipelines. Pipeline authoring. For those who are relatively new to YAML pipelines, Azure DevOps offers Task Assistant. Implemented as an extra pane displayed on the right side of the YAML pipeline editor page, the assistant helps with creating and modifying YAML steps. Unlike the View YAML feature, it works directly in the YAML pipeline. It simplifies the process of authoring a pipeline by providing a listing of tasks, which you can individually select, configure via a graphical interface, and add to the pipeline in the YAML format. In addition, the Task Assistant provides intelligent autocomplete suggestions based on the context of the pipeline, inline documentation for task parameters to aid in understanding their usage, real-time validation to catch syntax errors or missing parameters, and the ability to search for specific tasks or task groups available in the Azure DevOps Marketplace. Knowledge check. Completed 200 XP. 4 minutes. Choose the best response for each question. Then select Check Your Answers. Check your knowledge. 1. Which of the following choices is the YAML property responsible for creating a dependency between jobs? Steps. Depends on. Condition. 2. Which of the following choices is responsible for always starting the communication between Azure Pipelines and its agent? Service hook. Azure Pipelines. Agent. 3. Which of the following choices describes a reason for installing an agent using interactive mode? To run UI tests. To run Java pipelines. To communicate with cloud environments from on-premises agents, self-hosted. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module detailed Azure Pipeline's anatomy and structure, templates, YAML resources, and how to use multiple repositories in your pipeline. Also, it explored communication to deploy using Azure Pipelines to target servers. You learned how to describe the benefits and usage of. Describe advanced Azure Pipeline's anatomy and structure. Detail templates and YAML resources. Implement and use multiple repositories. Explore communication to deploy using Azure Pipelines. Learn more. Introduction. Completed 100 XP. 2 minutes. GitHub Actions are the primary mechanism for automation within GitHub. They can be used for a wide variety of purposes, but one of the most common is to implement continuous integration. In this module, you will learn what GitHub Actions, action flow, and its elements are. Understand what events are, explore jobs and runners, and how to read console output from actions. Learning objectives. After completing this module, students and professionals can explain GitHub Actions and workflows. Create and work with GitHub Actions and workflows. Describe events, jobs, and runners. Examine the output and release management for actions. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. What are actions? Completed 100 XP. 2 minutes. Actions are the mechanism used to provide workflow automation within the GitHub environment. They're often used to build continuous integration, CI, and continuous deployment, CD, solutions. However, they can be used for a wide variety of tasks. Automated testing. Automatically responding to new issues, mentions. Triggering code reviews. Handling pull requests. Branch management. They're defined in YAML and stay within GitHub repositories. Actions are executed on runners either hosted by GitHub or self-hosted. Contributed actions can be found in the GitHub Marketplace. See Marketplace Actions. Explore Actions Flow. Completed 100 XP. 2 minutes. GitHub tracks events that occur. Events can trigger the start of workflows. Workflows can also start on cron-based schedules and can be triggered by events outside of GitHub. They can be manually triggered. Workflows are the unit of automation. They contain jobs. Jobs use actions to get work done. Understand workflows. Completed 100 XP. 3 minutes. Workflows define the automation required. It details the events that should trigger the workflow. Also, define the jobs that should run when the workflow is triggered. The job defines the location in which the actions will run, like which runner to use. Workflows are written in YAML and live within a GitHub repository at the place.github/workflows. Example workflow. YAML. #.github/workflows/build.yml name, node build. On, push, jobs, main build, runs on, $matrix.os, strategy, matrix, node version, 12.x, os, Windows latest, steps, uses, action/checkout at v1 name, run node.js on latest Windows. Uses, action/setup node at v1 with, node version, $matrix.node version, name, install npm and build. Run, npm ci npm run build. You can find a set of starter workflows here, starter workflows. You can see the allowable syntax for workflows here, workflow syntax for GitHub Actions. Describe standard workflow syntax elements. Completed 100 XP. 2 minutes. Workflows include several standard syntax elements. Name is the name of the workflow. It's optional but is highly recommended. It appears in several places within the GitHub UI. On is the event or list of events that will trigger the workflow. Jobs is the list of jobs to be executed. Workflows can contain one or more jobs. Runs on tells actions which runner to use. Steps, it's the list of steps for the job. Steps within a job execute on the same runner. Uses tells actions which predefined action needs to be retrieved. For example, you might have an action that installs node.js. Run tells the job to execute a command on the runner. For example, you might execute an npm command. You can see the allowable syntax for workflows here. Workflow syntax for GitHub Actions. Explore events. Completed 100 XP. 3 minutes. Events are implemented by the on clause in a workflow definition. There are several types of events that can trigger workflows. Scheduled events. With this type of trigger, a cron schedule needs to be provided. YAML. On schedule, cron 08 to 17 ** 1 to 5. Cron schedules are based on 5 values. Minute 0 to 59. Hour 0 to 23. Day of the month 1 to 31. Month 1 to 12. Day of the week 0 to 6. Aliases for the months are JANDEC and for days of the week are Sunday through Saturday. A wildcard means any. Asterisk is a special value in YAML, so the cron string will need to be quoted. So, in the example above, the schedule would be 8 a.m. to 5 p.m. Monday to Friday. Code events. Code events will trigger most actions. It occurs when an event of interest occurs in the repository. YAML. On pull_request. The above event would fire when a pull request occurs. YAML. On push pull_request. The above event would fire when either a push or a pull request occurs. YAML. On pull_request, branches, develop. The event shows how to be specific about the section of the code that is relevant. In this case, it will fire when a pull request is made in the develop branch. Manual events. There's a unique event that is used to trigger workflow runs manually. You should use the workflow_dispatch event. Your workflow must be in the default branch for the repository. Webhook events. Workflows can be executed when a GitHub webhook is called. YAML. On Golem. This event would fire when someone updates or first creates a wiki page. External events. Events can be on repository_dispatch. That allows events to fire from external systems. For more information on events, see events that trigger workflows. Explore jobs. Completed 100 XP. 3 minutes. Workflows contain one or more jobs. A job is a set of steps that will be run in order on a runner. Steps within a job execute on the same runner and share the same file system. The logs produced by jobs are searchable, and artifacts produced can be saved. Jobs with dependencies. By default, if a workflow contains multiple jobs, they run in parallel. YAML. Jobs, startup, runs on Ubuntu latest steps, run, /setup_server_configuration.sh build, steps, run, /build_new_server.sh. Sometimes you might need one job to wait for another job to complete. You can do that by defining dependencies between the jobs. YAML. Jobs, startup, runs on Ubuntu latest steps, run, /setup_server_configuration.sh build, needs, startup steps, run, /build_new_server.sh. Note. If the startup job in the example above fails, the build job won't execute. For more information on job dependencies, see the section Creating Dependent Jobs at Managing Complex Workflows. Explore runners. Completed 100 XP. 3 minutes. GitHub runners are compute resources that execute GitHub Actions workflows. Each runner can run a single job at a time. They allow developers to perform build, test, and deployment tasks directly within from GitHub repositories. There are 2 main types of GitHub runners. GitHub-hosted runners are virtualized or containerized compute resources provided and managed by GitHub. Self-hosted runners are physical, virtualized, or containerized compute resources that GitHub users and organizations provision and manage themselves. Each type has some unique characteristics, features a number of distinct capabilities, and warrants several different considerations. It is important to note that GitHub strongly recommends against using self-hosted runners in public repos. Doing so introduces a significant security risk, since it potentially allows anyone to run code within the organization's private environment. GitHub-hosted runners. GitHub-hosted runners offer a convenient solution for executing workflows within GitHub Actions, eliminating the need to administer the underlying hardware and software components. They are designed to scale automatically based on demand, ensuring optimal performance during peak usage periods. GitHub provides several pre-configured environments for GitHub-hosted runners, covering different software configurations and operating systems, including Ubuntu Linux, Microsoft Windows, and Mac OS. GitHub-hosted runners include the operating system's default built-in tools. For example, Ubuntu and Mac OS runners include grep, find, and witch. To identify all other tools pre-installed on runners, users can review the Software Bill of Materials, SBOM, for each build of the Windows and Ubuntu runner images. Alternatively, users can review the runner image subsection of the Setup Job section in Workflow Logs. The link following the included software entry describes all pre-installed tools on the runner that ran the workflow. It is also possible to install additional software on GitHub-hosted runners by creating a job that installs the packages as part of the existing workflow. GitHub-hosted runners run on GitHub's cloud infrastructure, leveraging virtual machines or containers to execute workflows. Each workflow execution is isolated within its own environment, ensuring security and reproducibility. GitHub-hosted runners seamlessly integrate with GitHub Actions, enabling users to reference them directly within workflows hosted in GitHub repositories. There are some limits on GitHub Actions usage when using GitHub-hosted runners. In particular, each job in a workflow has the maximum of 6 hours of execution time. If a job reaches this limit, the job is terminated and fails to complete. Each workflow run is limited to 35 days. If a workflow run reaches this limit, its run gets cancelled. This period includes execution duration and time spent on waiting and approval. Prerequisites. Before implementing GitHub-hosted runners, users must have a GitHub repository where they can define workflows using GitHub Actions. Runners are available to all GitHub users with access to GitHub Actions. Implementation. Unlike self-hosted runners, GitHub-hosted ones are provisioned automatically as part of an individual workflow execution. Users define workflows as YAML-formatted files stored in the .github/workflows directory in GitHub repositories. Within the workflow configuration, users specify the desired runner environment, including the operating system and software dependencies. Runners with matching specifications are set up on demand whenever the workflow is triggered, with one runner per job. Triggers can be either manual or automatic, based on such events as code pushes, pull requests, or repository dispatch events. GitHub-hosted runners authenticate with GitHub by using tokens or credentials provided by GitHub Actions. They rely on built-in connectivity to communicate with the GitHub platform and to download workflow artifacts. Maintenance. GitHub manages updates and maintenance of GitHub-hosted runners, ensuring that they remain up-to-date with the latest software versions and security patches. The software tools included in the runners are updated weekly. Runner activities are monitoring and logged, facilitating tracking workflow executions and troubleshooting. Licensing and cost. GitHub-hosted runners are included in the pricing for GitHub Actions, with usage-based billing for workflow minutes beyond the free tier. Users benefit from the automated and cost-efficient scaling, as GitHub automatically provisions and deallocates runners based on demand. Self-hosted runners. Compared to GitHub-hosted runners, self-hosted ones provide greater control and customization options, with execution environments capable of accommodating a wider range of requirements. They can be deployed on-premises or in the cloud, depending on such criteria as network connectivity, cost, and resource availability. Self-hosted runners are provisioned and managed by users, giving them full control over the execution environment. They are fully customizable, including hardware specifications, software configurations, and network settings. They also facilitate integration with existing infrastructure and tooling, minimizing the possibility of compatibility and interoperability issues. Unlike with GitHub-hosted runners, there are no limits on the time it takes to complete individual job execution and workflow runs. Prerequisites. Users must set up and configure self-hosted runners on their chosen infrastructure, including installing the runner software and any additional software dependencies. The source code for the self-hosted runners is available as an open source project on GitHub at https://github.com/actions/runner. Each self-hosted runner acts as an agent that communicates with GitHub Actions to execute workflows. Self-hosted runners require outbound network connectivity, authentication credentials, and authorization to access the GitHub platform and download workflow artifacts. Depending on the location of the runners, it might be necessary to configure firewall rules to satisfy these requirements. Implementation. As with GitHub-hosted runners, the implementation involves defining YAML-formatted workflows and storing them the .github/workflows directory in GitHub repositories. However, in order for workflows to use self-hosted runners, users need to register them first, providing the required authentication tokens or credentials. As part of the registration, users specify such characteristics as the runner name, labels, and execution environment parameters. The registration can take place at different levels within an enterprise. Repository level, single repository. Organizational level, multiple repositories in an organization. Enterprise level, multiple organizations across an enterprise. Maintenance. Users are responsible for updating and maintaining self-hosted runners, including installing software updates and security patches. Maintenance also involves monitoring runner health and performance, as well as troubleshooting any issues that arise throughout the runner runtime. Licensing and cost. Self-hosted runners do not incur additional licensing charges beyond the pricing for GitHub Actions and any associated infrastructure costs, including compute, storage, and network. Optimizing resource allocation and utilization become the user's responsibility. Examine release and test in action. Completed 100 XP. 4 minutes. Actions will often produce console output. You don't need to connect directly to the runners to retrieve that output. The console output from Actions is available directly from within the GitHub UI. Select Actions on the top repository menu to see a list of executed workflows to see the output. Next, click on the job's name to see the steps output. Console output can help debug. If it isn't sufficient, you can also enable more logging. See Enabling debug logging. Release management for Actions. While you might be happy to retrieve the latest version of the action, there are many situations where you might want a specific version of the action. You can request a specific release of action in several ways. Tags. Tags allow you to specify the precise versions that you want to work. YAML. Steps uses action/install timer at v2.0.1. SHA-based hashes. You can specify a requested SHA-based hash for an action. It ensures that the action hasn't changed. However, the downside to this is that you also won't receive updates to the action automatically either. YAML. Steps uses action/install timer at 327239021F7CC39F7327647B21379985398. Branches. A common way to request actions is to refer to the branch you want to work with. You'll then get the latest version from that branch. That means you'll benefit from updates, but it also increases the chance of code breaking. YAML. Steps uses action/install timer at develop. Test in action. GitHub offers several learning tools for actions. GitHub Actions, Hello World. You'll see a basic example of how to organize and identify workflow files, add executable scripts, create workflow and action blocks, trigger workflows, discover workflow logs, knowledge check, completed 200 XP, 5 minutes. Choose the best response for each question. Then select check your answers. Check your knowledge. 1. Which of the following choices is a keyword to make one job wait for another job to complete? On. Needs. Uses. 2. Which of the following choices isn't a level that self-hosted runners can be added within an enterprise? Enterprise level, multiple organizations across an enterprise. Organizational level, multiple repositories in an organization. Project level. 3. Which of the following choices is the location where you can find workflows? .github/workflows. .github/build/workflows. .github/action/workflows. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. In this module, you learned what GitHub Actions, action flow, and its elements are. Also, understood what events are, explored jobs and runners, and how to read console output from actions. You learned how to describe the benefits and usage of. Explain GitHub Actions and workflows. Create and work with GitHub Actions and workflows. Describe events, jobs, and runners. Examine the output and release management for actions. Learn more. Introduction. Completed 100 XP. 1 minute. This module details continuous integration using GitHub Actions and describes environment variables, artifacts, best practices, and how to secure your pipeline using encrypted variables and secrets. Learning objectives. After completing this module, students and professionals can implement continuous integration with GitHub Actions. Use environment variables. Share artifacts between jobs and use Git tags. Create and manage secrets. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Describe continuous integration with actions. Completed 100 XP. 3 minutes. It's an example of a basic continuous integration workflow created by using actions. YAML. Name, .NET build on, push, branches, main jobs, build, runs on, Ubuntu latest strategy, matrix, node version, 10.x, steps, uses, action/checkout at main uses, action/setup.NET at v1 with, .NET version, 3.1.x run, .NET build awesome project. On, specifies what will occur when code is pushed. Jobs, there's a single job called build. Strategy, it's being used to specify the node.js version. Steps, are doing a checkout of the code and setting up .NET. Run, is building the code. Examine environment variables. Completed 100 XP. 3 minutes. When using actions to create CI or CD workflows, you'll typically need to pass variable values to the actions. It's done by using environment variables. Built-in environment variables. GitHub provides a series of built-in environment variables. It all has a GitHub_ prefix. Note: setting that prefix for your variables will result in an error. Examples of built-in environment variables are: GitHub_workflow is the name of the workflow. GitHub_action is the unique identifier for the action. GitHub_repository is the name of the repository, but also includes the name of the owner in owner/repo format. Using variables in workflows. Variables are set in the YAML workflow files. They're passed to the actions that are in the step. YAML. Jobs, verify connection, steps, name, verify connection to SQL Server run, node test connection.jsenv, project_server, ph202323v project_database, hamster. For more information on environment variables, including a list of built-in environment variables, see environment variables. Share artifacts between jobs. Completed 100 XP. 4 minutes. When using actions to create CI or CD workflows, you'll often need to pass artifacts created by one job to another. The most common ways to do it are by using the upload artifact and download artifact actions. Upload artifact. This action can upload one or more files from your workflow to be shared between jobs. You can upload a specific file. YAML. Uses action/upload artifact with name, harness build log path, bin/output/log/harness.log. You can upload an entire folder. YAML. Uses action/upload artifact with name, harness build logs path, bin/output/log/. You can use wildcards. YAML. Uses action/upload artifact with name, harness build logs path, bin/output/log/harness ab/**. You can specify multiple paths. YAML. Uses action/upload artifact with name, harness build logs path, bin/output/log/harness.log bin/output/log/harnessbuild.txt. For more information on this action, see upload artifact. Download artifact. There's a corresponding action for downloading or retrieving artifacts. YAML. Uses action/download artifact with name, harness build log. If no path is specified, it's downloaded to the current directory. For more information on this action, see download artifact. Artifact retention. A default retention period can be set for the repository, organization, or enterprise. You can set a custom retention period when uploading, but it can't exceed the defaults for the repository, organization, or enterprise. YAML. Uses action/upload artifact with name, harness build log path, bin/output/log/harness.log retention days, 12. Deleting artifacts. You can delete artifacts directly in the GitHub UI. For details, you can see removing workflow artifacts. Examine workflow badges. Completed 100 XP. 3 minutes. Badges can be used to show the status of a workflow within a repository. They show if a workflow is currently passing or failing. While they can appear in several locations, they typically get added to the readme.md file for the repository. Badges are added by using URLs. The URLs are formed as follows. https://github.com/owner/workflows/actions/workflows/workflow_file/badge.svg. Where AAAAA is the account name. RRRR is the repository name. www is the workflow name. They usually indicate the status of the default branch, but can be branch specific. You do this by adding a URL query parameter. Branch equals BBBBB. Where BBBBB is the branch name. For more information, see adding a workflow status badge. Describe best practices for creating actions. Completed 100 XP. 2 minutes. It's essential to follow best practices when creating actions. Create shenable actions. Don't create large monolithic actions. Instead, create smaller functional actions that can be chained together. Version your actions like other code. Others might take dependencies on various versions of your actions. Allow them to specify versions. Provide the latest label. If others are happy to use the latest version of your action, make sure you provide the latest label that they can specify to get it. Add appropriate documentation. As with other codes, documentation helps others use your actions and can help avoid surprises about how they function. Add details action.yml metadata. At the root of your action, you'll have an action.yml file. Ensure it has been populated with author, icon, expected inputs, and outputs. Consider contributing to the marketplace. It's easier for us to work with actions when we all contribute to the marketplace. Help to avoid people needing to relearn the same issues endlessly. Mark releases with Git tags. Completed 100 XP. 2 minutes. Releases are software iterations that can be packed for release. In Git, releases are based on Git tags. These tags mark a point in the history of the repository. Tags are commonly assigned as releases are created. Often these tags will contain version numbers, but they can have other values. Tags can then be viewed in the history of a repository. For more information on tags and releases, see About Releases. Create encrypted secrets. Completed 100 XP. 3 minutes. Actions often can use secrets within pipelines. Common examples are passwords or keys. In GitHub Actions, it's called secrets. Secrets. Secrets are similar to environment variables but encrypted. They can be created at 2 levels. Repository. Organization. If secrets are created at the organization level, access policies can limit the repositories that can use them. Creating secrets for a repository. To create secrets for a repository, you must be the repository's owner. From the repository settings, choose Secrets, then New Secret. For more information on creating secrets, see Encrypted Secrets. Use secrets in a workflow. Completed 100 XP. 3 minutes. Secrets aren't passed automatically to the runners when workflows are executed. To make a secret available to an action, you must set the secret as an input or environment variable in the workflow file. To accomplish this, you can use the secret's context as illustrated in following example. YAML. Steps, name, test database connectivity with db_username, $secrets.db username, db_password, $secrets.db password. Referencing secrets from the command line. When referencing secrets from the command line, you can treat them like shell environment variables, as illustrated by the following example. Steps. YAML. Shell, pwshenv, db_password, $secrets.db password, run, db_test, $env, db_password. It's important to follow this approach, which minimizes the risk of their accidental exposure. Secrets passed between processes from the command line can be viewed by using the PowerShell command and captured in security audit logs. Using secrets in if conditionals. Since secrets can't be directly referenced in if conditionals, as a workaround, consider setting secrets as job-level environment variables, then referencing the environment variables to conditionally run steps in the job, as in the following example. YAML. Name, run a step if a secret has been set on, push jobs, sample job, runs on, Ubuntu latest env, job_secret, $secrets.jobSecret, steps, if, $env.job_secret equals, run, echo, the secret has a value set. If, $env.job_secret equals, run, echo, the secret does not have a value set. Limitations. Workflows can use up to 100 secrets, regardless of their location. Secrets are limited to 48 kilobytes in size. To use secrets that are larger than 48 kilobytes, you can use a workaround to store secrets in your repository and save the decryption passphrase as a secret on GitHub. For details regarding this procedure, refer to Storing Large Secrets topic in GitHub documentation. Note that with the exception of GitHub_token, secrets aren't passed to the runner when a workflow is triggered from a forked repository. Implement GitHub Actions for CI/CD. Completed 100 XP. 40 minutes. Estimated time, 40 minutes. Scenario. In this lab, you'll learn how to implement a GitHub action workflow that deploys an Azure web app. Objectives. After completing this lab, you'll be able to implement a GitHub action workflow for CI/CD. Explain the basic characteristics of GitHub action workflows. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Identify an existing Azure subscription or create a new one. Verify that you have a Microsoft or Entra account with the contributor or the owner role in the Azure subscription. For details, refer to List Azure role assignments using the Azure portal. If you don't already have a GitHub account that you can use for this lab, follow the instructions available at signing up for a new GitHub account to create one. Exercises. During this lab, you'll complete the following exercises. Exercise 0. Import eShop on Web to your GitHub repository. Exercise 1. Set up your GitHub repository and Azure Access. Exercise 2. Remove the Azure Lab resources. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices is where the database passwords that are needed in a CI pipeline should be stored? Repo. Action.yml. Encrypted secrets. 2. Which of the following files is the metadata for an action held? Workflow.yml. Action.yml. Meta.yml. 3. Which of the following choices is how can the status of a workflow be shown in a repository? Using badges. Status files. Conversation tab. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module detailed continuous integration using GitHub Actions. It described environment variables, artifacts, best practices, and how to secure your pipeline using encrypted variables and secrets. You learned how to describe the benefits and usage of. Implement continuous integration with GitHub Actions. Use environment variables. Share artifacts between jobs and use Git tags. Create and manage secrets. Learn more. Introduction. Completed 100 XP. 4 minutes. Container. Containers are the third computing model, after bare metal and virtual machines, and containers are here to stay. Unlike a VM, which provides hardware virtualization, a container provides operating system level virtualization by abstracting the user space, not the entire operating system. The operating system level architecture is being shared across containers. It's what makes containers so lightweight. Docker gives you a simple platform for running apps in containers. Either old or new apps on Windows and Linux, and that simplicity is a powerful enabler for all aspects of modern IT. Containers aren't only faster and easier to use than VMs, they also make far more efficient use of computing hardware. Also, they have provided engineering teams with dramatically more flexibility for running cloud-native applications. Containers package up the application services and make them portable across different computing environments for dev/test and production use. With containers, it's easy to ramp application instances to match spikes in demand quickly. And because containers draw on resources of the host OS, they're much lighter weight than virtual machines. It means containers make highly efficient use of the underlying server infrastructure. Though the container runtime APIs are well suited to managing individual containers, they're woefully inadequate for managing applications that might comprise hundreds of containers spread across multiple hosts. You need to manage and connect containers to the outside world for scheduling, load balancing, and distribution. It's where a container orchestration tool like Azure Kubernetes Services, AKS, comes into its own. AKS handles the work of scheduling containers onto a compute cluster and manages the workloads to ensure they run as the user intended. AKS is an open-source system for deploying, scaling, and managing containerized applications. Instead of bolting operations as an afterthought, AKS brings software development and operations together by design. AKS enables an order of magnitude increase in the operability of modern software systems, with declarative, infrastructure-agnostic constructs to describe how applications are composed, also how they interact and how they're managed. This module helps you plan a container build strategy, explains containers and their structure, and introduces Docker and related services. What other benefits do containers offer? Containers are portable. A container will run wherever Docker is supported. Containers allow you to have a consistent development environment. For example, a SQL Server 2019 CU2 container that one developer is working with will be identical to another developer. Containers can be lightweight. A container may be only tens of megabytes in size, but a virtual machine with its entire operating system may be several gigabytes. Because of it, a single server can host far more containers than virtual machines. Containers can be efficient, fast to deploy, fast to boot, fast to patch, and quick to update. Learning objectives. After completing this module, students and professionals can design a container strategy, work with Docker containers. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Examine structure of containers. Completed 100 XP. 5 minutes. If you're a programmer or techie, you've at least heard of Docker, a helpful tool for packing, shipping, and running applications within containers. With all the attention it's getting these days, it would be hard not to, from developers and system admins alike. There's a difference between containers and Docker. A container is a thing that runs a little program package, while Docker is the container runtime and orchestrator. What are containers, and why do you need them? Containers are a solution to the problem of how to get the software to run reliably when moved from one computing environment to another. It could be from a developer's laptop to a test environment, from a staging environment to production. Also, from a physical machine in a data center to a VM in a private or public cloud. Problems arise when the supporting software environment isn't identical. For example, say you'll develop using Python 3, but when it gets deployed to production, it will run on Python 2.7. It's likely to cause several issues. It's not limited to the software environment. You're likely to come across issues in production if there are differences in the networking stack between the two environments. How do containers solve this problem? A container consists of an entire runtime environment, an application plus all its dependencies, libraries and other binaries, configuration files needed to run it, bundled into one package. You can resolve it by containerizing the application platform and its dependencies. Also, differences in OS distributions and underlying infrastructure are abstracted. What's the difference between containers and virtualization? Containers and VMs are similar in their goals, to isolate an application and its dependencies into a self-contained unit that can run anywhere. They remove the need for physical hardware, allowing for more efficient use of computing resources, energy consumption, cost effectiveness. The main difference between containers and VMs is in their architectural approach. Let's take a closer look. Virtual machines. A VM is essentially an emulation of a real computer that executes programs like a real computer. VMs run on top of a physical machine using a hypervisor. As you can see in the diagram, VMs package up the virtual hardware, a kernel, OS, and user space for each new VM. Container. Unlike a VM, which provides hardware virtualization, a container provides operating system-level virtualization by abstracting the user space. This diagram shows that containers package up just the user space, not the kernel or virtual hardware like a VM does. Each container gets its isolated user space to allow multiple containers to run on a single host machine. We can see that all the operating system-level architecture is being shared across containers. The only parts that are created from scratch are the bins and libs. It's what makes containers so lightweight. Work with Docker containers. Completed 100 XP. 2 minutes. Container lifecycle. The standard steps when working with containers are: Docker build, you create an image by executing a Docker file. Docker pull, you retrieve the image, likely from a container registry. Docker run, you execute the container. An instance is created of the image. You can often execute the Docker run without needing first to do the Docker pull. In that case, Docker will pull the image and then run it. Next time, it won't need to pull it again. Understand Dockerfile core concepts. Completed 100 XP. 4 minutes. Dockerfiles are text files that contain the commands needed by Docker build to assemble an image. Here's an example of a basic Docker file. From Ubuntu label maintainer equals John Doe at contoso.com add app setup /run /bin/bash c source $home /.bashrc /echo $home cmd echo hello world from within the container. The first line refers to the parent image based on which this new image will be based. Generally, all images will be based on another existing image. In this case, the Ubuntu image would be retrieved from either a local cache or from Docker Hub. An image that doesn't have a parent is called a base image. In that rare case, the from line can be omitted, or from scratch can be used instead. The second line indicates the email address of the person who maintains this file. Previously, there was a maintainer command, but that has been deprecated and replaced by a label. The third line adds a file to the root folder of the image. It can also add an executable. The fourth and fifth lines are part of a run command. Note the use of the backslash to continue the fourth line onto the fifth line for readability. It's equivalent to having written it instead. Run/bin/bash c source $home/.bashrc echo $home. The run command is run when the Docker build creates the image. It's used to configure items within the image. By comparison, the last line represents a command that will be executed when a new container is created from the image. It's run after container creation. For more information, you can see Docker file reference. Examine multi-stage Docker files. Completed 100 XP. 4 minutes. What are multi-stage Docker files? Multi-stage builds give the benefits of the builder pattern without the hassle of maintaining 3 separate files. Let us look at a multi-stage Docker file. Docker. From mcr.microsoft.com/.net/core/spnetcore:3.1 AS base workdir/app expose 80 expose 443 from mcr.microsoft.com/.net/core/sdk:3.1 AS build workdir/src copy web application 1.sproj run.net restore./web application 1.sproj copy workdir/src/dot run.net build web application 1.sproj c release o/app/build from build as publish run.net publish web application 1.sproj c release o/app/publish from base as final workdir/app copy from equals publish/app/publish entrypunt.net web application 1.dll. At first, it simply looks like several Docker files stitched together. Multi-stage Docker files can be layered or inherited. When you look closer, there are a couple of key things to realize. Notice the third stage. From build is publish. Build isn't an image pulled from a registry. It's the image we defined in stage 2, where we named the result of our build, SDK, image builder. Docker build will create a named image we can later reference. We can also copy the output from one image to another. It's the real power to compile our code with one base SDK image, mcr.microsoft.com/.net/core/sdk:3.1, while creating a production image based on an optimized runtime image, mcr.microsoft.com/.net/core/aspnet:3.1. Notice the line. Copy from equals publish/app/publish. It takes the /app/publish directory from the published image and copies it to the working directory of the production image. Breakdown of stages. The first stage provides the base of our optimized runtime image. Notice it derives from mcr.microsoft.com/.net/core/aspnet:3.1. We would specify extra production configurations, such as registry configurations, msexec of other components. You would hand off any of those environment configurations to your ops folks to prepare the VM. The second stage is our build environment. mcr.microsoft.com/.net/core/sdk:3. This includes everything we need to compile our code. From here, we have compiled binaries we can publish or test, more on testing in a moment. The third stage derives from our build stage. It takes the compiled output and publishes them in .NET terms. Publish means taking all the output required to deploy your app/publish/service/component and placing it in a single directory. It would include your compiled binaries, graphics, images, JavaScript, and so on. The fourth stage takes the published output and places it in the optimized image we defined in the first stage. Why is publish separate from the build? You'll likely want to run unit tests to verify your compiled code. Or the aggregate of the compiled code from multiple developers being merged continues to function as expected. You could place the following stage between builder and publish to run unit tests. Docker. From build as test workdir/src/web.test run.net test. If your tests fail, the build will stop to continue. Why is base first? You could argue it's simply the logical flow. We first define the base runtime image. Get the compiled output ready, and place it in the base image. However, it's more practical. While debugging your applications under Visual Studio Container Tools, VS will debug your code directly in the base image. When you hit F5, Visual Studio will compile the code on your dev machine. The first stage then volume mounts the output to the built runtime image. You can test any configurations you have made to your production image, such as registry configurations or otherwise. When the Docker build target base is executed, Docker starts processing the Docker file from the beginning through the stage, target, defined. Since the base is the first stage, we take the shortest path, making the F5 experience as fast as possible. If the base were after compilation, builder, you would have to wait for all the next steps to complete. One of the perf optimizations we make with VS Container Tools is to take advantage of the Visual Studio compilations on your dev machine. Examine considerations for multiple stage builds. Completed 100 XP. 3 minutes. Adopt container modularity. Try to avoid creating overly complex container images that couple together several applications. Instead, use multiple containers and try to keep each container to a single purpose. The website and the database for a web application should likely be in separate containers. There are always exceptions to any rule, but breaking up application components into separate containers increases the chances of reusing containers. It also makes it more likely that you could scale the application. For example, in the web application mentioned, you might want to add replicas of the website container, but not for the database container. Avoid unnecessary packages. To help minimize image sizes, it's also essential to avoid including packages that you suspect might be needed but aren't yet sure if they're required. Only include them when they're required. Choose an appropriate base. While optimizing the contents of your Docker files is essential, it's also crucial to choose the appropriate parent, base, image. Start with an image that only contains packages that are required. Avoid including application data. While application data can be stored in a container, it will make your images more prominent. It would be best to consider using Docker volume support to maintain the isolation of your application and its data. Volumes are persistent storage mechanisms that exist outside the lifespan of a container. For more information, see Use Multiple Stage Builds. Explore Azure Container-Related Services. Completed 100 XP. 4 minutes. Azure provides a wide range of services that help you work with containers. Here are the essential services that are involved. Azure Container Instances, ACI. Running your workloads in Azure Container Instances, ACI, allows you to create your applications rather than provisioning and managing the infrastructure that will run the applications. ACIs are simple and fast to deploy, and when you're using them, you gain the security of hypervisor isolation for each container group. It ensures that your containers aren't sharing an operating system kernel with other containers. Azure Kubernetes Service, AKS. Kubernetes has quickly become the de facto standard for container orchestration. This service lets you quickly deploy and manage Kubernetes to scale and run applications while maintaining overall solid security. This service started life as Azure Container Services, ACS, and supported Docker Swarm and Mesos/Mesosphere DC/OS at release to manage orchestrations. These original ACS workloads are still supported in Azure, but Kubernetes support was added. It quickly became so popular that Microsoft changed the acronym for Azure Container Services to AKS and later changed the name of the service to Azure Kubernetes Service, also AKS. Azure Container Registry, ACR. This service lets you store and manage container images in a central registry. It provides you with a Docker private registry as a first-class Azure resource. All container deployments, including DC/OS, Docker Swarm, and Kubernetes, are supported. The registry is integrated with other Azure services such as the App Service, Batch, Service Fabric, and others. Importantly, it allows your DevOps team to manage the configuration of apps without being tied to the configuration of the target hosting environment. Azure Container Apps. Azure Container Apps allows you to build and deploy modern apps and microservices using serverless containers. It deploys containerized apps without managing complex infrastructure. You can write code using your preferred programming language or framework and build microservices with full support for Distributed Application Runtime, DAPR. Scale dynamically based on HTTP traffic or events powered by Kubernetes Event-Driven Autoscaling, KEDA. Azure App Service. Azure Web Apps provides a managed service for both Windows and Linux-based web applications and provides the ability to deploy and run containerized applications for both platforms. It provides autoscaling and load balancing options and is easy to integrate with Azure DevOps. Deploy Docker containers to Azure App Service Web Apps. Completed 100 XP. 30 minutes. Estimated time, 30 minutes. Scenario. In this lab, you'll learn how to use an Azure DevOps CI/CD pipeline to build a custom Docker image, push it to Azure Container Registry, and deploy it as a container to Azure App Service. Objectives. After completing this lab, you'll be able to build a custom Docker image by using a Microsoft-hosted Linux agent. Push an image to Azure Container Registry. Deploy a Docker image as a container to Azure App Service by using Azure DevOps. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Identify an existing Azure subscription or create a new one. Verify that you have a Microsoft or Entra account with the contributor or the owner role in the Azure subscription. For details, refer to List Azure role assignments using the Azure portal and view and assign administrator roles in Entra ID. Exercises. During this lab, you'll complete the following exercises. Exercise 0, configure the lab prerequisites. Exercise 1, manage the service connection. Exercise 2, import and run the CI pipeline. Exercise 3, import and run the CD pipeline. Exercise 4, remove the Azure Lab resources. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following commands do you use to retrieve an image from a container registry? Docker run. Docker pull. Docker build. 2. Which of the following choices isn't container-related Azure services? Azure App Service. Azure Container Instances. Azure Virtual Machine Scale Sets. 3. Which of the following choices creates an instance of the image? Docker Run. Docker Build. Docker Pull. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module helped you plan a container build strategy, explained containers and their structure, introduced Docker and related services. You learned how to describe the benefits and usage of. Design a container strategy. Work with Docker containers. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes Azure Pipeline's capabilities, build and release tasks, and multi-configuration and multi-agent differences. Learning objectives. After completing this module, students and professionals can explain the terminology used in Azure DevOps and other release management tooling. Describe what a build and release task is, what it can do, and some available deployment tasks. Implement release jobs. Differentiate between multi-agent and multi-configuration release jobs. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Describe Azure DevOps release pipeline capabilities. Completed 100 XP. 3 minutes. Azure DevOps has extended support for pipelines as code, also called YAML pipelines, for continuous deployment and started introducing various release management capabilities into pipelines as code. The existing UI-based release management solution in Azure DevOps is referred to as Classic Release. You'll find a list of capabilities and availability in YAML pipelines versus Classic Build and Release pipelines in the following table. Feature. YAML. Classic Build. Classic Release. Notes. Agents. Yes. 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 Specifies a required resource on which the pipeline runs. Approvals. Yes. No. Yes. Defines a set of validations required before completing a deployment stage. Artifacts. Yes. 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 Supports publishing or consuming different package types. Caching. Yes. Yes. No. Reduces build time by allowing outputs or downloaded dependencies from one run to be reused in later runs. In preview, available with Azure Pipelines only. Conditions. Yes. 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 Specifies conditions to be met before running a job. Container jobs. Yes. No. No. Specifies jobs to run in a container. Demands. Yes. 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 Ensures pipeline requirements are met before running a pipeline stage. Requires self-hosted agents. Dependencies. Yes. 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 Specifies a requirement that must be met to run the next job or stage. Deployment groups. Yes. No. Yes. Defines a logical set of deployment target machines. Deployment group jobs. No. No. Yes. Specifies a job to release to a deployment group. Deployment jobs. Yes. No. No. Defines the deployment steps. Requires multi-stage pipelines experience. Environment. Yes. No. No. Represents a collection of resources targeted for deployment. Available with Azure Pipelines only. Gates. No. No. Yes. Supports automatic collection and evaluation of external health signals before completing a release stage. Available with Azure Pipelines only. Jobs. Yes. 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 Defines the execution sequence of a set of steps. Service connections. Yes. 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 Enables a connection to a remote service that is required to execute tasks in a job. Service containers. Yes. No. No. Enables you to manage the lifecycle of a containerized service. Stages. Yes. No. Yes. Organizes jobs within a pipeline. Task groups. No. Yes. Yes. Encapsulates a sequence of tasks into a single reusable task. If using YAML, see templates. Tasks. Yes. 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 Defines the building blocks that make up a pipeline. Templates. Yes. No. No. Defines reusable content, logic, and parameters. Triggers. Yes. 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 Defines the event that causes a pipeline to run. Variables. Yes. 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 represents a value to be replaced by data to pass to the pipeline. Variable groups. Yes. 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 Used to store values that you want to control and make available across multiple pipelines. Most terminos. Explore release pipelines. Completed 100 XP. 3 minutes. A release pipeline takes artifacts and releases them through stages and finally into production. Let us quickly walk through all the components step by step. The first component in a release pipeline is an artifact. Artifacts can come from different sources. The most common source is a package from a build pipeline. Another commonly seen artifact source is, for example, source control. Furthermore, a release pipeline has a trigger, the mechanism that starts a new release. A trigger can be a manual trigger, where people start to release by hand. A scheduled trigger, where a release is triggered based on a specific time. A continuous deployment trigger, where another event triggers a release. For example, a completed build. Another vital component of a release pipeline is stages, or sometimes called environments. It's where the artifact will be eventually installed. For example, the artifact contains the compiled website installed on the web server or somewhere in the cloud. You can have many stages, environments. Part of the release strategy is finding the appropriate combination of stages. Another component of a release pipeline is approval. People often want to sign a release before installing it in the environment. In more mature organizations, this manual approval process can be replaced by an automatic process that checks the quality before the components move on to the next stage. Finally, we have the tasks within the various stages. The tasks are the steps that need to be executed to install, configure, and validate the installed artifact. In this part of the module, we'll detail all the release pipeline components and talk about what to consider for each element. The components that make up the release pipeline or process are used to create a release. There's a difference between a release and the release pipeline or process. The release pipeline is the blueprint through which releases are done. We'll cover more of it when discussing the quality of releases and releases processes. See also release pipelines. Explore artifact sources. Completed 100 XP. 4 minutes. What is an artifact? An artifact is a deployable component of your application. These components can then be deployed to one or more environments. In general, the idea about build and release pipelines and continuous delivery is to build once and deploy many times. It means that an artifact will be deployed to multiple environments. The artifact should be a stable package if you want to achieve it. The configuration is the only thing you want to change when deploying an artifact to a new environment. The contents of the package should never change. It's what we call immutability. We should be 100% sure that the package that we build, the artifact, remains unchanged. How do we get an artifact? There are different ways to create and retrieve artifacts, and not every method is appropriate for every situation. The most common way to get an artifact within the release pipeline is to use a build artifact. The build pipeline compiles, tests, and eventually produces an immutable package stored in a secure place, storage account, database, and so on. The release pipeline then uses a secure connection to this secured place to get the build artifact and do extra actions to deploy it to an environment. The significant advantage of using a build artifact is that the build produces a versioned artifact. The artifact is linked to the build and gives us automatic traceability. We can always find the sources that made this artifact. Another possible artifact source is version control. We can directly link our version control to our release pipeline. The release is related to a specific commit in our version control system. With that, we can also see which version of a file or script is eventually installed. In this case, the version doesn't come from the build but from version control. Consideration for choosing a version control artifact instead of a build artifact can be that you only want to deploy one specific file. If you don't need to run more actions before using this file in your release pipeline, creating a version package, build artifact, containing only one file doesn't make sense. Helper scripts that do actions to support the release process, cleanup, rename, string actions, are typically good candidates to get from version control. Another possibility of an artifact source can be a network share containing a set of files. However, you should be aware of the possible risk. The risk is that you aren't 100% sure that the package you're going to deploy is the same package that was put on the network share. If other people can also access the network share, the package might be compromised. Therefore, this option won't be sufficient to prove integrity in a regulated environment, banks, insurance companies. Finally, container registries are a rising star regarding artifact sources. Container registries are versioned repositories where container artifacts are stored. Pushing a version container to the content repository and consuming that same version within the release pipeline has more or less the same advantages as using a build artifact stored in a safe location. Choose the appropriate artifact source. Completed 100 XP. 3 minutes. When you use a release pipeline to deploy your packages to production, you need traceability. That means you want to know where the package that you're deploying originates from. It's essential to understand that the sources that you built and checked into your version control are precisely the same as the sources that you're going to deploy to the various environments that are going to be used by your customers. Primarily when you work in a regulated environment like a bank or an insurance company, auditors ask you to provide traceability to sources that you deploy to prove the integrity of the package. Another crucial aspect of your artifacts is auditability. You want to know who changed that line of code and who triggered the build that produces the artifact deployed. A proper mechanism to make sure you can provide the correct traceability and auditability is using immutable packages. It isn't something that you can buy, but something that you need to implement yourself. Using a build pipeline that produces a package stored in a location that humans can't access, you ensure the sources are unchanged throughout the whole release process. It's an essential concept of release pipelines. You identify an immutable package by giving it a version so that you can refer to it at a later stage. Versioning strategy is a complex concept and isn't in the scope of this module. Still, having a unique identification number or label attached to the package and ensuring that this number or label cannot be changed or modified afterward ensures traceability and auditability from source code to production. Read more about semantic versioning. Choosing the right artifact source is tightly related to the requirements you have about traceability and auditability. If you need an immutable package containing multiple files that can never be changed and be traced, a build artifact is the best choice. If it's one file, you can directly link to source control. You can also point at a disk or network share, but it implies some risk concerning auditability and immutability. Can you ensure the package never changed? See also release artifacts and artifact sources. Examine considerations for deployment to stages. Completed 100 XP. 3 minutes. When you have a clear view of the different stages you'll deploy, you need to think about when you want to deploy to these stages. As we mentioned in the introduction, continuous delivery is about deploying multiple times a day and can deploy on demand. When we define our cadence, questions that we should ask ourselves are: do we want to deploy our application? Do we want to deploy multiple times a day? Can we deploy to a stage? Is it used? For example, a tester testing an application during the day might not want to deploy a new version of the app during the test phase. Another example is when your application incurs downtime, you don't want to deploy when users use the application. The frequency of deployment, or cadence, differs from stage to stage. A typical scenario we often see is continuous deployment during the development stage. Every new change ends up there once it's completed and builds. Deploying to the next phase doesn't always occur multiple times, but only at night. When designing your release strategy, choose your triggers carefully and consider the required release cadence. Some things we need to take into consideration are: what is your target environment? Does one team use it, or do multiple teams use it? If a single team uses it, you can deploy it frequently. Otherwise, it would be best if you were a bit more careful. Who are the users? Do they want a new version multiple times a day? How long does it take to deploy? Is there downtime? What happens to performance? Are users affected? Explore build and release tasks. Completed 100 XP. 4 minutes. A build and release platform requires executing any number of repeatable actions during the build process. Tasks are units of executable code used to do selected actions in a specified order. Add steps to specify what you want to build, the tests you want to run, and all the other steps needed to complete the build process. There are steps for building, testing, running utilities, packaging, and deploying. If a task isn't available, you can find numerous community tasks in the marketplace. Jenkins, Azure DevOps, and Atlassian have an extensive marketplace where other tasks can be found. Links. For more information, see also. Explore custom build and release tasks. Completed 100 XP. 3 minutes. Instead of using out-of-the-box tasks, a command line, or a shell script, you can also use your custom build and release task. By creating your tasks, the tasks are available publicly or privately to everyone you share them with. Creating your task has significant advantages. You get access to variables that are otherwise not accessible. You can use and reuse a secure endpoint to a target server. You can safely and efficiently distribute across your whole organization. Users don't see implementation details. For more information, see Add a build or release task. Explore release jobs. Completed 100 XP. 4 minutes. You can organize your build or release pipeline into jobs. Every build or deployment pipeline has at least one job. A job is a series of tasks that run sequentially on the same target. It can be a Windows server, a Linux server, a container, or a deployment group. A release job is executed by a build/release agent. This agent can only run one job at the same time. You specify a series of tasks you want to run on the same agent during your job design. When the build or release pipeline is triggered at runtime, each job is dispatched to its target as one or more. A scenario that speaks to the imagination, where jobs plays an essential role, is the following. Assume that you built an application with a backend in .NET, a front-end in Angular, and a native iOS mobile app. It might be developed in 3 different source control repositories, triggering 3 other builds and delivering 3 other artifacts. The release pipeline brings the artifacts together and wants to deploy the backend, front-end, and mobile app all together as part of one release. The deployment needs to take place on different agents. If an iOS app needs to be built and distributed from a Mac, the Angular app is hosted on Linux, so best deployed from a Linux machine. The backend might be deployed from a Windows machine. Because you want all 3 deployments to be part of one pipeline, you can define multiple release jobs targeting the different agents, servers, or deployment groups. By default, jobs run on the host machine where the agent is installed. It's convenient and typically well-suited for projects just beginning to adopt continuous integration, CI. Over time, you may want more control over the stage where your tasks run. For more information, see Jobs in Azure Pipelines. Understand database deployment task. Completed 100 XP. 3 minutes. Integrating database deployment tasks into CI/CD Azure pipelines and GitHub Actions workflows is meant to automate provisioning and updating of databases alongside applications which data they host. This integration facilitates seamless coordination between application and database lifecycles, reducing the risk of errors and inconsistencies that may result from manual deployments. Automating database provisioning facilitates faster release cycles, reduces the possibility of human errors, and improves collaboration between development, operations, and database teams. Considerations. Including data components in automated software deployment introduces additional considerations regarding maintaining data integrity and preventing potential data loss. To address and mitigate these risks, take into account the following provisions. Data separation. Maintain a clear separation between database schema changes and data manipulation operations. Database schema changes, such as table modifications or schema updates, should be managed separately from data manipulation operations, such as seeding initial data or importing and exporting datasets. Data preservation. Implement strategies to preserve existing data during pipeline or workflow redeployment. This may involve backing up critical data before deploying changes or using data migration scripts to transfer data between environments without overriding existing data. Idempotent operations. Ensure that database deployment operations are idempotent, which means that they can be safely rerun multiple times, resulting always in the same outcome. Idempotency should eliminate the possibility of creating duplicate schema objects and/or records. Versioning and rollback. Maintain version control over database schema changes, data migrations, and deployment scripts to track changes and facilitate rollback procedures. Use source control repositories to manage database scripts, apply version tags or labels to database changes, and implement rollback strategies that revert database changes. Testing and validation. Perform thorough testing and validation of database changes in a staging or testing environment before deploying to production. Use automated testing frameworks, database unit tests, and integration tests to verify the database deployments and ensure compatibility with existing data. Monitoring and alerting. Implement monitoring and alerting mechanisms to detect anomalies, errors, or performance issues during database deployments. Monitor database health metrics, track audit logs, and configure alerts triggered by any unexpected behavior or failures. The fundamental concepts and activities are similar between Azure pipelines and GitHub Actions workflows. At a high level, incorporating deployment of databases into Azure pipelines involves several implementation tasks. Creating database deployment scripts to define the database schema, seed data, and apply any additional configurations. The scripts should reside in the source control repository to facilitate change tracking and versioning. Creating database connection strings and storing them securely via secret variables or Azure Key Vault secrets. This also requires granting pipelines access to the secrets. Using Azure DevOps tasks or third-party extensions to execute database deployment scripts as part of the pipeline. Configuring the pipeline to deploy any necessary dependencies, such as SQL Server instances, along with required tools and utilities. Including database testing tasks in the pipeline to validate database changes and ensure that deployments are successful. This typically involves running database unit tests, integration tests, or data validation checks. Implementing rollback and recovery mechanisms in the pipeline to handle deployment failures or unexpected errors. This may include creating database snapshots, backups, or transactional rollback scripts to revert changes in case of issues. The specifics of these implementation tasks vary considerably depending on the target database technology. The following section examines these specifics in the context of deploying Azure SQL services. SQL Server and Azure SQL-specific techniques and tools. When working with SQL Server or Azure SQL Database in CI/CD pipelines, there are numerous tools and techniques you can leverage, including the following ones. SQL Server Data Tools, SSDT, a development toolset that enables database developers to build, debug, maintain, and refactor database schemas and objects in Visual Studio. You can use SSDT projects to manage database schema changes and generate deployment scripts for SQL Server or Azure SQL Database. SQL Package.exe, a command line utility included in SSDT that simplifies automating deployments of SQL Server databases using Data Tier Application Component (DACPAC) files. You can use SQL Package.exe in CI/CD pipelines to deploy database changes to SQL Server or Azure SQL Database. Azure DevOps tasks, built-in tasks such as Azure SQL Database deployment and SQL Azure DACPAC deployment that allow you to deploy database changes directly from DACPAC files to Azure SQL Database. These tasks integrate database deployment into CI/CD pipelines without requiring custom scripting. Azure Command Line Interface, CLI, a utility that allows you to interact with Azure resources, including Azure SQL Database, from the command line. You can use Azure CLI commands in CI/CD pipelines to automate database provisioning, configuration, and deployment tasks such as creating database servers, deploying DACPAC files, and executing SQL scripts. SQL Server Management Studio, SSMS, a graphical tool provided by Microsoft for managing SQL Server databases. While primarily used for manual administration tasks, SSMS can also generate deployment scripts and automate database deployments using the Generate Scripts wizard or the Deploy Database to Microsoft Azure SQL Database feature. Entity Framework, EF, a programmatic technique that supports the Object Relational Mapper (ORM) functionality. You can leverage EF-based migration capability to manage database schema changes and automate database migrations in CI/CD pipelines. EF migrations enable you to define changes to your database schema using code-first migrations and apply them automatically during application startup. Custom scripts, PowerShell, Bash, or SQL scripts that automate database deployment tasks in CI/CD pipelines. These scripts can use SQL CMD or Azure PowerShell modules to execute SQL scripts, deploy DATPack files, or interact with Azure SQL database programmatically. Configure pipelines as code with YAML. Completed 100 XP. 60 minutes. Scenario. Many teams prefer to define their build and release pipelines using YAML. This allows them to access the same pipeline features as those using the Visual Designer, but with a markup file that can be managed like any other source file. YAML build definitions can be added to a project by simply adding the corresponding files to the repository's root. Azure DevOps also provides default templates for popular project types and a YAML designer to simplify the process of defining build and release tasks. Objectives. After completing this lab, you'll be able to configure CI/CD pipelines as code with YAML in Azure DevOps. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Identify an existing Azure subscription or create a new one. Verify that you have a Microsoft account or a Microsoft Entra account with the owner role in the Azure subscription and the global administrator role in the Microsoft Entra ID tenant associated with the Azure subscription. For details, refer to List Azure role assignments using the Azure portal and view and assign administrator roles in Microsoft Entra ID. Exercises. During this lab, you'll complete the following exercises. Exercise 0. Configure the lab prerequisites. Exercise 1. Configure CI/CD pipelines as code with YAML in Azure DevOps. Exercise 2. Configure environment settings for CI/CD pipelines as code with YAML in Azure DevOps. Exercise 3. Remove the Azure Lab resources. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices is a job type you can run? Multi-configuration. Multi-job. Multi-pool. 2. Which of the following choices is how many deployment jobs can be run concurrently by a single agent? 3. Which of the following choices describes the job type correctly? None. Tasks will run on a single agent or more agents in parallel. Multi-configuration. Run the same set of tasks with a single configuration per agent. Multi-agent. Run the same set of tasks on multiple agents using the specified number of agents. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described Azure Pipeline's capabilities, build and release tasks, and multi-configuration and multi-agent differences. You learned how to describe the benefits and usage of. Explain the terminology used in Azure DevOps and other release management tooling. Describe what a build and release task is, what it can do, and some available deployment tasks. Implement release jobs. Differentiate between multi-agent and multi-configuration release jobs. Learn more. Introduction. Completed 100 XP. 1 minute. This module explores the critical release strategy recommendations organizations must consider when designing automated deployments. It explains how to define components of a release pipeline and artifact sources, creates approval, and configure release gates. Learning objectives. After completing this module, students and professionals can explain things to consider when designing your release strategy. Define the components of a release pipeline and use artifact sources. Create a release approval plan. Implement release gates. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. For some exercises, you need to create an Azure DevOps organization and a team project. If you don't have it, see Create an Organization Azure DevOps. Understand the delivery cadence and 3 types of triggers. Completed 100 XP. 1 minute. Release and stages make use of triggers. There are 3 types of triggers we recognize. Continuous deployment trigger. You can set up this trigger on your release pipeline. Once you do that, your release pipeline will trigger every time a build completes and creates a new release. Scheduled triggers. It allows you to set up a time-based manner to start a new release, for example, every night at 3 a.m. or 12 o'clock p.m. You can have one or multiple daily schedules, but it will always run at this specific time. Manual trigger. With a manual trigger, a person or system triggers the release based on a specific event. When it's a person, it probably uses some UI to start a new release. When it's an automated process, some events will likely occur. You can trigger the release from another system using the automation engine, which is usually part of the release management tool. For more information, see also. Explore release approvals. Completed 100 XP. 4 minutes. As we've described in the introduction, continuous delivery is all about delivering on demand. But, as we discussed in the differences between release and deployment, delivery, or deployment, it's only the technical part of the continuous delivery process. It's all about how you can technically install the software on an environment, but it doesn't say anything about the process that needs to be in place for a release. Release approvals don't control how but control if you want to deliver multiple times a day. Manual approvals also suit a significant need. Organizations that start with continuous delivery often lack a certain amount of trust. They don't dare to release without manual approval. After a while, when they find that the approval doesn't add value and the release always succeeds, the manual approval is often replaced by an automatic check. Things to consider when you're setting up a release approval are: what do we want to achieve with the approval? Is it an approval that we need for compliance reasons? For example, we need to adhere to the 4 I's principle to get out SOX compliance. Or is it an approval that we need to manage our dependencies? Or is it an approval that needs to be in place purely because we need a sign-out from an authority like security officers or product owners? Who needs to approve? We need to know who needs to approve the release. Is it a product owner, security officer, or just someone that isn't the one that wrote the code? It's essential because the approver is part of the process. They're the ones that can delay the process if not available. So be aware of it. When do you want to approve? Another essential thing to consider is when to approve. It's a direct relationship with what happens after approval. Can you continue without approval? Or is everything on hold until approval is given? By using scheduled deployments, you can separate approval from deployment. Although manual approval is a great mechanism to control the release, it isn't always helpful. On many occasions, the check can be done at an earlier stage. For example, it's approving a change that has been made in source control. Scheduled deployments have already solved the dependency issue. You don't have to wait for a person in the middle of the night. But there's still a manual action involved. If you want to eliminate manual activities but still want control, you start talking about automatic approvals or release gates. Explore release gates. Completed 100 XP. 4 minutes. Release gates in Azure DevOps provide enhanced control over the initiation and completion of deployment pipelines, incorporating aspects of security and governance into the process. They designate conditions which must be satisfied in order for the deployment to either continue, pre-deployment gates, or to be considered successful, post-deployment gates. One of the important benefits of release gates is streamlining processes such as, for example, deploying a new version of an API, which would traditionally require manual intervention or dependency meetings. This way, instead of convening meetings, the gate mechanism allows stakeholders to indicate their approval to proceed with the click of a button, considerably reducing time and effort. In addition, gates can leverage scripts and APIs to automate the approval process and provide objective, data-driven assessments, extending beyond manual approvals. These automatic approvals facilitate a wide range of other scenarios, including incident and issues management. Gate mechanisms ensure the deployment proceeds only if the required status for work items, incidents, and issues is met. For instance, deployment may be contingent on the absence of software bugs. Approval integration with collaboration systems. Integration with platforms like Microsoft Teams or Slack promotes communication with stakeholders for deployment approval, awaiting their response before proceeding. Quality validation. Gates can query metrics from tests on build artifacts, such as pass rate or code coverage, and deploy within specified thresholds to maintain quality standards. Security scan on artifacts. Gate mechanisms verify completion of security scans, such as antivirus checks, code signing, and policy validation for build artifacts, ensuring compliance with security requirements before deployment. User experience monitoring. Leveraging product telemetry, gates validate that the user experience remains consistent with baseline standards, preventing deployment if regression is detected. Change management integration. Gates wait for change management procedures in systems like ServiceNow to conclude before proceeding with deployment. Infrastructure health checks. Post-deployment, gates execute monitoring processes and validate infrastructure compliance against predefined rules, ensuring resource utilization and security standards are met. Effectively, approvals and gates offer granular control over deployment pipelines, accommodating both manual and automated verification processes. Automation expedites deployments while, at the same time, helps incorporate security measures, governance protocols, and stakeholder approvals into software delivery processes. Support for manual approvals accommodates pausing deployments in environments that require additional scrutiny before resuming or rejecting the deployment process. Use release gates to protect quality. Completed 100 XP. 3 minutes. A quality gate is the best way to enforce a quality policy in your organization. It's there to answer one question: can I deliver my application to production or not? A quality gate is located before a stage that is dependent on the outcome of a previous stage. A quality gate was typically something that a QA department monitored in the past. They had several documents or guidelines, and they verified if the software was of a good enough quality to move on to the next stage. When we think about continuous delivery, all manual processes are a potential bottleneck. We need to reconsider the notion of quality gates and see how we can automate these checks as part of our release pipeline. By using automatic approval with a release gate, you can automate the approval and validate your company's policy before moving on. Many quality gates can be considered. No new blocker issues. Code coverage on new code greater than 80%. No license violations. No vulnerabilities in dependencies. No further technical debt was introduced. Is the performance not affected after a new release? Compliance checks. Are there work items linked to the release? Is the release started by someone else as the one who commits the code? Defining quality gates improves the release process, and you should always consider adding them. Explore GitOps release strategy and recommendations. Completed 100 XP. 3 minutes. GitOps is a modern software delivery approach that leverages Git repositories as the single source of truth for defining and managing infrastructure, configuration, and application code. In a GitOps release strategy, all changes to the system, including infrastructure provisioning, configuration updates, and application deployments, are made through Git commits and pull requests. The core principles of GitOps include declarative configuration, version control, automation, and continuous delivery. Defining a comprehensive GitOps release strategy. When defining a comprehensive GitOps strategy, you should take into account the following considerations. Declarative configuration. Express the desired system state in a declarative manner using configuration files by using tools such as PowerShell Desired State Configuration, DSC, or Ansible. Configuration files define how the system should behave, including environment variables, application settings, and service configurations. Infrastructure as code. IAC use the declarative configuration approach to define infrastructure components as code by using tools such as Bicep and Azure Resource Manager templates. Version control. Store all configuration files, infrastructure definitions, and application code in Git repositories, enabling versioning, change tracking, and collaboration among team members. Use branching strategies and pull requests for managing changes and enforcing code review processes. Continuous deployment. CD implement continuous deployment pipelines that automatically deploy changes to the system based on Git commits and pull requests. CI/CD services such as Azure Pipelines or GitHub Actions trigger pipeline executions in response to Git events, such as code merges or branch updates. Automated synchronization. Deployments are triggered automatically whenever changes are pushed to the Git repository. GitOps tools such as Flux or Argo CD continuously monitor Git repositories for changes and synchronize the desired state of the system with the configuration stored in Git. Immutable infrastructure. Adopt an immutable infrastructure approach where infrastructure components and application containers are treated as disposable artifacts. Each deployment creates a new immutable instance of the system, reducing configuration drift and ensuring consistency across environments. Rollback and recovery. Use Git-based workflows to manage rollbacks and recovery procedures in case of deployment failures or unexpected issues. As a result, reverting changes in Git repositories should trigger automatic rollback actions in the CI/CD pipeline, restoring the system to a previous known good state. Observability and monitoring. Implement monitoring, logging, and observability practices to track system health, performance metrics, and deployment status. Integrate monitoring tools such as Azure Monitor, Prometheus, or Grafana with GitOps workflows to gain visibility into system behavior and detect anomalies in real time. Control deployments using release gates. Completed 100 XP. 75 minutes. Estimated time, 75 minutes. Scenario. This lab covers the configuration of the deployment gates and details how to use them to control the execution of Azure pipelines. To illustrate their implementation, you'll configure a release definition with 2 environments for an Azure web app. You'll deploy to the Canary environment only when there are no blocking bugs for the app and mark the Canary environment complete only when there are no active alerts in application insights of Azure Monitor. A release pipeline specifies the end-to-end release process for an application to be deployed across various environments. Deployments to each environment are fully automated by using jobs and tasks. Ideally, you don't want new updates to the applications to be simultaneously exposed to all users. It's a best practice to expose updates in a phased manner, that is, expose them to a subset of users, monitor their usage, and expose them to other users based on the experience of the initial set of users. Approvals and gates enable you to control the start and completion of the deployments in a release. You can wait for users to approve or reject deployments with approvals manually. Using release gates, you can specify application health criteria to be met before the release is promoted to the following environment. Before or after any environment deployment, all the specified gates are automatically evaluated until they pass or reach your defined timeout period and fail. Gates can be added to an environment in the release definition from the pre-deployment conditions or the post-deployment conditions panel. Multiple gates can be added to the environment conditions to ensure all the inputs are successful for the release. As an example, pre-deployment gates ensure no active issues in the work item or problem management system before deploying a build to an environment. Post-deployment gates ensure no incidents from the app's monitoring or incident management system after being deployed before promoting the release to the following environment. There are 4 types of gates included by default in every account. Invoke Azure function, trigger the execution of an Azure function and ensures a successful completion. Query Azure Monitor alerts, observe the configured Azure Monitor alert rules for active alerts. Invoke REST API, make a call to a REST API and continues if it returns a successful response. Query work items, ensure the number of matching work items returned from a query is within a threshold. Objectives. After completing this lab, you'll be able to configure release pipelines, configure release gates, test release gates. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Identify an existing Azure subscription or create a new one. Verify that you have a Microsoft or Entra account with the contributor or the owner role in the Azure subscription. For details, refer to List Azure role assignments using the Azure portal. Exercises. During this lab, you'll complete the following exercises. Exercise 0, configure the lab prerequisites. Exercise 1, configure the build pipeline. Exercise 2, configure the release pipeline. Exercise 3, configure release gates. Exercise 4, test release gates. Exercise 5, remove the Azure lab resources. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices isn't a release trigger? A manual trigger. A continuous deployment trigger. A feature trigger. 2. Which of the following choices can you use to prevent deployment in Azure DevOps when a security testing tool finds a compliance problem? Work item. Release gate. Manual trigger. 3. Which of the following choices is a logical boundary in your release pipeline at which you can pause the pipeline and perform various checks? Stage. Trigger. Quality gate. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explored the critical release strategy recommendations that organizations must consider when designing automated deployments. It explained how to define components of a release pipeline and artifact sources, create approves, and configure release gates. You learned how to describe the benefits and usage of. Explain things to consider when designing your release strategy. Define the components of a release pipeline and use artifact sources. Create a release approval plan. Implement release gates. Learn more. Introduction. Completed 100 XP. 1 minute. This module details target environment provisioning, service connections creation process, and test infrastructure setup. Learn how to configure functional test automation and run availability tests. Learning objectives. After completing this module, students and professionals can provision and configure target environment. Deploy to an environment securely using a service connection. Configure functional test automation and run availability tests. Set up test infrastructure. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. You must create an Azure DevOps organization and a team project for some exercises. If you don't have it yet, see, create an organization Azure DevOps. Provision and configure target environments. Completed 100 XP. 5 minutes. The release pipeline deploys software to a target environment. But it isn't only the software that will be deployed with the release pipeline. If you focus on continuous delivery, infrastructure as code and spinning up infrastructure as part of your release pipeline is essential. When we focus on the deployment of the infrastructure, we should first consider the differences between the target environments that we can deploy to. On-premises servers. Cloud servers or infrastructure as a service, IaaS. For example, virtual machines or networks. Platform as a service, PaaS, and functions as a service, FaaS. For example, Azure SQL Database in both PaaS and serverless options. Clusters. Service connections. Let us dive a bit further into these different target environments and connections. On-premises servers. In most cases, when you deploy to an on-premises server, the hardware and the operating system are already in place. The server is already there and ready. In some cases, empty, but most of the time not. In this case, the release pipeline can only focus on deploying the application. You might want to start or stop a virtual machine, Hyper-V, or VMware. The scripts you use to start or stop the on-premises servers should be part of your source control and delivered to your release pipeline as a build artifact. Using a task in the release pipeline, you can run the script that starts or stops the servers. To take it one step further and configure the server, you should look at technologies like PowerShell Desired State Configuration, DSC. The product will maintain your server and keep it in a particular state. When the server changes its state, you can recover the changed configuration to the original configuration. Integrating a tool like PowerShell DSC into the release pipeline is no different from any other task you add. Infrastructure as a service. When you use the cloud as your target environment, things change slightly. Some organizations lift and shift from their on-premises servers to cloud servers. Then your deployment works the same as an on-premises server. But when you use the cloud to provide you with infrastructure as a service, IaaS, you can use the power of the cloud to start and create servers when needed. It's where infrastructure as code, IAC, starts playing a significant role. Creating a script or template can make a server or other infrastructural components like a SQL server, a network, or an IP address. By defining a template or using a command line and saving it in a script file, you can use that file in your release pipeline tasks to execute it on your target cloud. The server, or another component, will be created as part of your pipeline. After that, you can run the steps to deploy the software. Technologies like Azure Resource Manager are great for creating infrastructure on demand. Platform as a service. When you move from infrastructure as a service, IaaS, to platform as a service, PaaS, you'll get the infrastructure from the cloud you're running on. For example, in Azure, you can create a web application. The cloud arranges the server, the hardware, the network, the public IP address, the storage account, and even the web server. The user only needs to take care of the web application on this platform. You only need to provide the templates instructing the cloud to create a web app. Functions as a service, FaaS, or serverless technologies are the same. In Azure, it's called Azure Functions. You only deploy your application, and the cloud takes care of the rest. However, you must instruct the platform, the cloud, to create a placeholder where your application can be hosted. You can define this template in Azure Resource Manager. You can use the Azure CLI or command line tools. In all cases, the infrastructure is defined in a script file and lives alongside the application code in source control. Clusters. Finally, you can deploy your software to a cluster. A cluster is a group of servers that host high-scale applications. When you run an infrastructure as a service cluster, you must create and maintain the cluster. It means that you need to provide the templates to create a cluster. You must also ensure you roll out updates, bug fixes, and patches to your cluster. It's comparable with infrastructure as a service. When you use a hosted cluster, you should consider it a platform as a service. You instruct the cloud to create the cluster, and you deploy your software to the cluster. When you run a container cluster, you can use the container cluster technologies like AKS. Service connections. When a pipeline needs resource access, you must often create service connections. Summary. Whatever the technology you choose to host your application, your infrastructure's creation or configuration should be part of your release pipeline and source control repository. Infrastructure as code is a fundamental part of continuous delivery, allowing you to create servers and environments on demand. Links. Exercise: set up service connections. Completed 100 XP. 30 minutes. In this exercise, you'll investigate service connections. Note. To follow along with this walkthrough, you'll need an existing Azure subscription containing an existing storage account. Steps. You can set up a service connection to environments to create a secure and safe connection to the environment you want to deploy. Service connections are also used to get resources from other places in a secure manner. For example, you might need to get your source code from GitHub. Let's look at configuring a service connection to Azure in this case. From the main menu in the Parts Unlimited project, click Project Settings at the bottom of the screen. In the Project Settings pane, from the Pipeline section, click Service Connections. Click the drop-down beside plus New Service Connection. As you can see, there are many types of service connections. You can create a connection to Apple App Store, Docker Registry, Bitbucket, Azure Service Bus. In this case, we want to deploy a new Azure resource, so we'll use the Azure Resource Manager option. Click Azure Resource Manager to add a new service connection. Set the connection name to Azure Resource Manager Service Connection, click on an Azure subscription, then select an existing resource group. Note. You might be prompted to sign in Azure at this point. If so, sign in first. Notice that what we are creating is a service principal. We'll be using the service principal for authenticating to Azure. At the top of the window, there's an option to set up Managed Identity Authentication instead. The service principal is a service account with only permissions in the specific subscription and resource group. It makes it a safe way to connect from the pipeline. Important. When you create a service connection with Azure, the service principal gets a contributor role to the subscription or resource group. It's not enough to upload data to blob storage for the service principal. You must explicitly add the service principal to the storage blob data contributor role. Otherwise, the release gets failed with an authorization permission mismatch error. Click OK to create it. It will then be shown in the list. Click Pipelines, Releases, and Edit in the main Parts Unlimited menu to see the release pipeline. Click the link to view stage tasks. The current list of tasks is then shown. Because we started with an empty template, there are no tasks yet. Each stage can execute many tasks. Click the plus sign to the right of the agent job to add a new task. See the available list of task types. In the search box, enter the word storage and see the list of storage-related tasks. These include standard tasks and tasks available from the marketplace. We'll use the Azure File Copy task to copy one of our source files to a storage account container. Hover over the Azure File Copy task type and click Add when it appears. The task will be added to the stage but requires further configuration. Click the File Copy task to see the required settings. Select the latest task version. Set the display name to backup website zip file, click the ellipsis beside source, locate the file as follows, and click OK to select it. We then need to provide details on connecting to the Azure subscription. The easiest and most secure way is to use our new service connection. Find and select the Azure Resource Manager service connection we created from the Azure subscription drop-down list. From the destination type drop-down list, select Azure Blob, and from the RM storage account and container name, select the storage account, enter the container's name, then click Save at the top of the screen, OK. To test the task, click Create Release, and in the Create a New Release pane, click Create. Click the new release to view the details. On the release page, approve the release so that it can continue. Once the development stage has been completed, you should see the file in the Azure storage account. A key advantage of using service connections is that this type of connection is managed in a single place within the project settings. It doesn't involve connection details spread throughout the pipeline tasks. Configure automated integration and functional test automation. Completed 100 XP. 6 minutes. The first thing that comes to mind about continuous delivery is that everything needs to be automated. Otherwise, you can't deploy multiple times a day. But how to deal with testing then? Many companies still have a broad suite of manual tests to be run before delivering to production. Somehow these tests need to run every time a new release is created. Instead of automating all your manual tests into automated UI tests, you need to rethink your testing strategy. Lisa Crispin describes in her book Agile Testing that you can divide your tests into multiple categories. We can make 4 quadrants where each side of the square defines our targets with our tests. Business-facing the tests are more functional and often executed by end users of the system or by specialized testers that know the problem domain well. Supporting the team, it helps a development team get constant feedback on the product to find bugs quickly and deliver a quality build and product. Technology-facing the tests are rather technical and non-meaningful to business people. They're typical tests written and executed by the developers in a development team. Critique product tests that validate a product's workings on its functional and non-functional requirements. Now we can place different test types we see in the other quadrants. For example, we can put unit tests, component tests, and system or integration tests in the first quadrant. We can place functional tests, story tests, prototypes, and simulations in quadrant 2. These tests support the team in delivering the correct functionality and are business-facing since they're more functional. In quadrant 3, we can place tests like exploratory, usability, acceptance, etc. We place performance, load, security, and other non-functional requirements tests in quadrant 4. Looking at these quadrants, specific tests are easy to automate or automated by nature. These tests are in quadrants 1 and 4. Tests that are automatable but mostly not automated by nature are the tests in quadrant 2. Tests that are the hardest to automate are in quadrant 3. We also see that the tests that can't be automated or are hard to automate are tests that can be executed in an earlier phase and not after release. We call shift left, where we move the testing process towards the development cycle. We need to automate as many tests as possible and test them. A few of the principles we can use are: tests should be written at the lowest level possible. Write once and run anywhere, including the production system. The product is designed for testability. Test code is product code, only reliable tests survive. Test ownership follows product ownership. By testing at the lowest level possible, you'll find many tests that don't require infrastructure or applications to be deployed. We can use the pipeline to execute the tests that need an app or infrastructure. We can run scripts or use specific test tools to perform tests within the pipeline. On many occasions, you execute these external tools from the pipeline, like OWASP Zap, SpecFlow, or Selenium. You can use test functionality from a platform like Azure on other occasions. For example, availability or load tests executed from within the cloud platform. When you want to write your automated tests, choose the language that resembles the language from your code. In most cases, the application developers should also write the test, so it makes sense to use the same language. For example, write tests for your .NET application in .NET and your Angular application in Angular. The build and release agent can handle it to execute unit tests or other low-level tests that don't need a deployed application or infrastructure. When you need to do tests with a UI or other specialized functionality, you need a test agent to run the test and report the results. Installation of the test agent then needs to be done upfront or as part of the execution of your pipeline. Understand shift left. Completed 100 XP. 4 minutes. The goal for shifting left is to move quality upstream by performing tests early in the pipeline. It represents the phrase fail fast. Fail often. Combining test and process improvements reduces the time it takes for tests to be run and the impact of failures later on. The idea is to ensure that most of the testing is complete before merging a change into the main branch. Many teams find their test takes too long to run during the development lifecycle. As projects scale, the number and nature of tests will grow substantially, taking hours or days to run the complete test. They get pushed further until they're run at the last possible moment, and the benefits intended to be gained from building those tests aren't realized until long after the code has been committed. There are several essential principles that DevOps teams should adhere to in implementing any quality vision. Other important characteristics to take into consideration. Unit tests. These tests need to be fast and reliable. One team at Microsoft runs over 60,000 unit tests in parallel in less than 6 minutes, intending to get down to less than a minute. Functional tests must be independent. Defining a test taxonomy is an essential aspect of DevOps. The developers should understand the suitable types of tests in different scenarios. L0 tests are a broad class of fast in-memory unit tests. It's a test that depends on code in the assembly under test and nothing else. L1 tests might require assembly plus SQL or the file system. L2 tests are functional tests run against testable service deployments. It's a functional test category requiring a service deployment but may have critical service dependencies stubbed out. L3 tests are a restricted class of integration tests that run against production. They require a complete product deployment. Check the case study in Shifting Left at Microsoft. Shift left to make testing fast and reliable. For more information, see Set up and run availability tests. Completed 100 XP. 60 minutes. After you've deployed your web app or website to any server, you can set up tests to monitor its availability and responsiveness. It's helpful to check if your application is still running and gives a healthy response. Some applications have specific health endpoints that an automated process can check. The health endpoint can be an HTTP status or a complex computation that uses and consumes crucial parts of your application. For example, you can create a health endpoint that queries the database. This way, you can check that your application is still accessible, but also the database connection is verified. You can create your framework to create availability tests, ping test, or use a platform that can do it for you. Azure has the functionality to develop availability tests. You can use these tests in the pipeline and as release gates. In Azure, you can set up availability tests for any HTTP or HTTPS endpoint accessible from the public internet. You don't have to add anything to the website you're testing. It doesn't even have to be your site. You could try a REST API service you depend on. There are two types of availability tests. URL ping test, a simple test that you can create in the Azure portal. You can check the URL and check the response and status code of the response. Multi-step web test, several HTTP calls that are executed in sequence. For more information, see also. Explore Azure load testing. Completed 100 XP. 4 minutes. Azure Load Testing Preview is a fully managed load testing service that enables you to generate a high-scale load. The service simulates your application's traffic, helping you optimize application performance, scalability, or capacity. You can create a load test using existing test scripts based on Apache JMeter. Azure Load Testing abstracts the infrastructure to run your JMeter script and load test your application. Azure Load Testing collects detailed resource metrics for Azure-based applications to help you identify performance bottlenecks across your Azure application components. You can automate regression testing by running load tests as part of your continuous integration and continuous deployment (CI/CD) workflow. Note: the overview image shows how Azure Load Testing uses Azure Monitor to capture metrics for app components. Learn more about the supported Azure resource types. You can automatically run a load test at the end of each sprint or in a staging environment to validate a release candidate build. You can trigger Azure Load Testing from Azure Pipelines or GitHub Actions workflows. Get started with adding load testing to your Azure Pipeline CI/CD workflow, or use our Azure Load Testing GitHub action. For more information about the Azure Load Testing Preview, see Set up and run functional tests. Completed 100 XP. 60 minutes. Estimated time, 60 minutes. Scenario: Selenium is a portable open-source software testing framework for web applications. It can operate on almost every operating system. It supports all modern browsers and multiple languages, including .NET, C#, and Java. This lab will teach you how to execute Selenium test cases on a C# web application as part of the Azure DevOps release pipeline. Objectives: after completing this lab, you'll be able to configure a self-hosted Azure DevOps agent, configure the release pipeline, trigger build and release, run tests in Chrome and Firefox. Requirements: this lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Identify an existing Azure subscription or create a new one. Verify that you have a Microsoft account or an Entra account with the contributor or the owner role in the Azure subscription. For details, refer to List Azure role assignments using the Azure portal. Exercises. During this lab, you'll complete the following exercises. Exercise 0, configure the lab prerequisites. Exercise 1, implement Selenium tests by using a self-hosted Azure DevOps agent. Exercise 2, remove the Azure lab resources. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices isn't a technology or tool for configuring a target server during the deployment? PowerShell Desired State Configuration, DSC. Chef. Azure App Configuration. 2. Which of the following choices do you need to create when a pipeline needs access to resources? Service hook. Service connection. Agent pool. 3. Which of the following choices is recommended to authenticate to Azure with service connections? User and password. Personal access token. Service principal. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module detailed target environment provisioning, service connections creation process, and test infrastructure setup. You learned how to configure functional test automation and run availability tests. You learned how to describe the benefits and usage of provision and configure target environment. Deploy to an environment securely using a service connection. Configure functional test automation and run availability tests. Set up test infrastructure. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes the creation of task and variable groups, creating custom build and release tasks, and using release variables and stage variables in your pipeline. Learning objectives. After completing this module, students and professionals can use and manage task and variable groups. Use release variables and stage variables in your release pipeline. Use variables in release pipelines. Create custom build and release tasks. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. For some exercises, you need to create an Azure DevOps organization and a team project. If you don't have it yet, see Create an Organization Azure DevOps. Examine task groups. Completed 100 XP. 3 minutes. A task group allows you to encapsulate a sequence of tasks, already defined in a build or a release pipeline, into a single reusable task that can be added to a build or release pipeline, just like any other task. You can choose to extract the parameters from the encapsulated tasks as configuration variables and abstract the rest of the task information. Task groups are a way to standardize and centrally manage deployment steps for all your applications. When you include a task group in your definitions and then make a change centrally to the task group, the change is automatically reflected in all the definitions that use the task group. There's no need to change each one individually. For more information, see task groups for builds and releases. Note: task groups aren't currently supported in YAML. Use templates instead. See template references. Explore variables in release pipelines. Completed 100 XP. 4 minutes. Variables give you a convenient way to get critical bits of data into various parts of the pipeline. As the name suggests, the contents of a variable may change between releases, stages of jobs of your pipeline. The system predefines some variables, and you're free to add your own as well. The variable scope is the most important thing you need to think about when using variables in the release pipeline. You can imagine that a variable containing the target server's name may vary between a development environment and a test environment. Within the release pipeline, you can use variables in different scopes and different ways. For more information, see release variables and debugging. Predefined variables. When running your release pipeline, you always need variables that come from the agent or context of the release pipeline. For example, the agent directory where the sources are downloaded, the build number or build ID, the agent's name, or any other information. This information is accessible in predefined variables that you can use in your tasks. Release pipeline variables. Choose a release pipeline variable when you need to use the same value across all the stages and tasks in the release pipeline, and you want to change the value in a single place. Stage variables. Share values across all the tasks within one specific stage by using stage variables. Use a stage-level variable for values that vary from stage to stage, and are the same for all the tasks in a stage. Variable groups. Share values across all the definitions in a project by using variable groups. We'll cover variable groups later in this module. Normal and secret variables. Because the pipeline tasks are executed on an agent, variable values are passed to the various tasks using environment variables. The task knows how to read it. You should be aware that a variable contains clear text and can be exposed to the target system. When you use the variable in the log output, you can also see the variable's value. When the pipeline has finished, the values will be cleared. You can mark a variable in the release pipeline as secret. This way, the secret is hidden from the log output. It's beneficial when writing a password or other sensitive information. Exercise: create and manage variable groups. Completed 100 XP. 30 minutes. In this exercise, you'll investigate variable groups. Steps. Let's now look at how a release pipeline can use predefined variables, called variable groups. Like how we use task groups, variable groups provide a convenient way to avoid redefining many variables when defining stages within pipelines and even when working across multiple pipelines. Let's create a variable group and see how it can be used. On the main menu for the Parts Unlimited project, click Pipelines, then click Library. There are currently no variable groups in the project. Click plus variable group to start creating a variable group. Set variable group name to website test product details. In the variables section, click plus add, enter name, enter product code, and in value, enter red bloxel. You can see an extra column that shows a lock. It allows you to have variable values that are locked and not displayed in the configuration screens. While it's often used for values like passwords, notice an option to link secrets from an Azure Key Vault as variables. It would be a preferable option for variables that provide credentials that need to be secured outside the project. In this example, we're just providing details of a product used in testing the website. Add another variable called quantity with a value of 12. Add another variable called sales unit with a value of each. Click Save to save the new variable group. On the main menu, click Pipelines, click Releases and click Edit to return to editing the release pipeline we have been working on. From the top menu, click Variables. In the left-hand pane, click Variable Groups. Variable groups are linked to pipelines rather than being directly added to them. Click Link Variable Group, then in the Link Variable Group pane, click the Website Test Product Details variable group. Notice that it shows you how many variables are contained. In the variable group scope, select the Development, Test Team A, and Test Team B stages. We need the test product for development and testing, but we don't need it in production. If required in all stages, we would have chosen Release for the variable group scope instead. Click the link to complete the link. The variables contained in the variable group are now available for use within all stages except production, just the same way as any other variable. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices is correct about Azure Pipelines? Azure Pipelines allow creating custom build/release tasks. Azure Pipelines only allow native tasks or extensions from the marketplace. Azure Pipelines automatically create tasks based on PowerShell. 2. Which of the following choices should you create to store values that you want to make available across multiple builds and release pipelines? Task group. Variable group. Deployment group. 3. Which of the following choices isn't an advantage of creating your own task? You can safely and efficiently distribute across your organization. You can use and reuse a secure endpoint to a target server. Users can see the implementation details. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described the creation of task and variable groups, creating custom build and release tasks, and using release variables and stage variables in your pipeline. You learned how to describe the benefits and usage of. Use and manage task and variable groups. Use release variables and stage variables in your release pipeline. Use variables in release pipelines. Create custom build and release tasks. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes how to automate the inspection of health events, configure notifications, and set up service hooks to monitor pipelines. Learning objectives. After completing this module, students and professionals can implement automated inspection of health, create and configure events, configure notifications, create service hooks to monitor the pipeline. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. You need to create an Azure DevOps organization and a team project for some exercises. If you don't have it yet, see, create an organization Azure DevOps. Automate inspection of health. Completed 100 XP. 2 minutes. Inspection of the release pipeline and release is something you should consider from the start. When you run multiple deployments a day, you want to stay informed. Know whether a release passed or failed. Know the quality of the release. Know details about the release and how it has been done. Stop releases when you detect something suspicious. Visualize some of these things on a dashboard. You can do a few things to stay informed about your release pipeline. In the following chapters, we'll dive a bit deeper into these. Release gates. Release gates allow the automatic collection of health signals from external services and then promote the release when all the signs are booming simultaneously or stop the deployment on timeout. Typically, gates are connected with incident management, problem management, change management, monitoring, and external approval systems. Release gates are discussed in an upcoming module. Events, subscriptions, and notifications. Events are raised when specific actions occur, like when a release is started or a build is completed. A notification subscription is associated with a supported event type. The subscription ensures you get notified when a specific event occurs. Notifications are usually emails that you receive when an event occurs to which you're subscribed. Service hooks. Service hooks enable you to do tasks on other services when events happen in your Azure DevOps Services projects. For example, create a card in Trello when a work item is created or send a push notification to your team's Slack when a build fails. Service hooks can also be used in custom apps and services as a more efficient way to drive activities when events happen in your projects. Reporting. Reporting is the most static approach to inspection but also the most evident in many cases. Creating a dashboard that shows the status of your build and releases combined with team-specific information is, in many cases, a valuable asset to get insights. Read more about dashboards, charts, reports, and widgets. Explore events and notifications. Completed 100 XP. 2 minutes. One of the first requests many people have when working in a system that does asynchronous actions is to get notifications or alerts. Why? Because they don't want to open the application, log in and see if things changed repeatedly. The ability to receive alerts and notifications is a powerful mechanism to get notified about certain events in your system when they happen. For example, when a build takes a while to complete, you probably don't want to stare at the screen until it is finished. But you want to know when it does. Getting an email or another kind of notification instead is powerful and convenient. Another example is a system that needs to be monitored. You want to get notified by the system in real time. By implementing a successful alert mechanism, you can use alerts to react to situations proactively before anybody is bothered by them. Alerts. However, when you define alerts, you need to be careful. When you get alerts for every single event that happens in the system, your mailbox will quickly be flooded with numerous alerts. The more alerts you get that aren't relevant, the more significant the change that people will never look at the alerts and notifications and will miss the important ones. Target audience and delivery mechanism. When defining alerts or notifications, you need to think about the target audience. Who needs to react to the alerts? Don't send messages to people for information only. They'll stop looking at it quickly. Another thing to consider when defining alerts is the mechanism to deliver them. Do you want to send an email, or do you like to send a message in Slack for your team? Or do you want to call another system to do a particular action? Within Azure DevOps, there are multiple ways to define your alerts. By using query and filter mechanisms, you can filter out specific alerts. For example, you only want to get notified for failed releases and not for successful ones. Almost every action in the system raises an event to which you can subscribe. A subscription is personal or for your whole team. When you have made a subscription, you can select how you want the notification to be delivered. For more information, see also. Explore service hooks. Completed 100 XP. 1 minute. Service hooks enable you to do tasks on other services when your Azure DevOps Services projects happen. For example, create a card in Trello when a work item is created. Or send a push notification to your team's mobile devices when a build fails. Service hooks can also be used in custom apps and services. It's a more efficient way to drive activities when events happen in your projects. Azure DevOps includes built-in support for the following service hooks: build and release, collaborate, customer support, plan and track, integrate, AppVeyor, Campfire, user voice, Trello, Azure Service Bus, Bamboo, Flowdoc, Zendesk, Azure Storage, Jenkins, HipChat, Webhooks, MyGet, Qubit, Zapier, Slack. This list will change over time. To learn more about service hooks and how to use and create them, read Service Hooks in Azure DevOps. Configure Azure DevOps notifications. Completed 100 XP. 2 minutes. After defining your target audience, you need to configure your notifications. Using Azure DevOps, you can help your team stay informed about your project's activities. You can configure notifications to be set based on rules or subscriptions by default, out of the box, OOB, created by you or the team or group administrator. You can get a notification when the following items change: work items, code reviews, pull requests, source control files, TFVC or Git, builds, release. For example, you can get notified whenever your build completes or your release fails. There are 4 notification types that you can manage in Azure DevOps: personal notifications, team notifications, project notifications, global notifications. For each notification, you have a set of specific steps to configure. The following steps show how to manage global notifications. Open your Azure DevOps organization https://devazure.com/asterisk/organization overview. Click on Organization Settings at the bottom left side. Click on Global Notifications under the General tab. The Default Subscriptions tab lists all default global subscriptions available. The globe icon on a notification subscription indicates the subscription is a default subscription. You can view all default notification subscriptions. You can view and enable options available in the context menu for each subscription. Note: only Project Collection administrators can enable/disable any default subscription in this view. Project Collection valid users group can only view the details of the default subscription. In the Subscribers tab, you can see users subscribe to each notification item. The Settings section shows the default delivery option setting. All teams and groups inherit this setting. You can see how to manage your personal notifications following Manage Your Personal Notifications. For more information, see Configure GitHub notifications. Completed 100 XP. 2 minutes. GitHub.com notifications provide updates about the activity that you've subscribed to. You can use the notifications inbox to customize, triage, and manage your updates. You can choose to subscribe to notifications for a conversation in a specific issue, pull request, or gist. All activity in a repository or team discussion. CI activity, such as the status of workflows in repositories set up with GitHub Actions. Repository issues, pull requests, releases, security alerts, or discussions if enabled. By default, you automatically watch all repositories you create and own by your personal account and subscribe to conversations when you have not disabled automatic watching for repositories or teams you've joined in your notification settings. Been assigned to an issue or pull request. Opened a pull request issue or created a team discussion post. Commented on a thread. Subscribe to a thread manually by clicking Watch or Subscribe. Had your username it mentioned. Changed the thread state by closing an issue or merging a pull request. Had a team you're a member of it mentioned. Tip: to unsubscribe from conversations, you can change your notification settings or directly unsubscribe or unwatch activity on github.com. For more information, see Managing Your Subscriptions. Notification settings. Click on the notification icon in the upper right corner of any page. Click on the notification settings under the list of repositories in the left sidebar. On the notification settings page, choose how you receive notifications. Note that, from this page, you can configure notifications for GitHub Actions using GitHub and email channels. By default, they are generated for failed workflows only, but you have the option of including successful ones or disabling them altogether. For more information, see Explore how to measure quality of your release process. Completed 100 XP. 2 minutes. How do you measure the quality of your release process? The quality of your release process can't be measured directly because it's a process. What you can measure is how well your process works. If your release process constantly changes, it might indicate something wrong with the process. If your releases continuously fail, and you regularly must update your release process to make it work, it might also suggest that something is wrong with your release process. Maybe something is wrong with the schedule on which your release runs, and you notice that your release always fails on a particular day or at a specific time. Or your release always fails after the deployment to another environment. It might be an indication that some things are maybe dependent or related. You can keep track of your release process quality by creating visualizations about the quality of all the releases following that same release process or release pipeline. For example, we're adding a dashboard widget that shows you the status of every release. The release also has a quality aspect, but it's tightly related to the quality of the deployment and package deployed. When we want to measure the quality of a release itself, we can do all kinds of checks within the pipeline. You can execute all different types of tests like integration tests, load tests, or even UI tests while running your pipeline and checking the release's quality. Using a quality gate is also a perfect way to check the quality of your release. There are many different quality gates. For example, a gate that monitors to check if everything is healthy on your deployment targets, work item gates that verify the quality of your requirements process. You can add extra security and compliance checks. For example, do we follow the 4 Eyes principle, or do we have the proper traceability? Examine release notes and documentation. Completed 100 XP. 3 minutes. When you deploy a new release to a customer or install new software on your server, and you want to communicate what has been released to your customer, the usual way is to use release notes. But where do the release notes come from? There are different ways to store your release notes. Document store. An often used way of storing release notes is by creating text files or documents in some document store. This way, the release notes are stored together with other documents. The downside of this approach is that there's no direct connection between the release in the release management tool and the release notes that belong to this release. Wiki. The most used way for customers is to store the release notes in a wiki. For example, Confluence from Atlassian, SharePoint Wiki, Slim Wiki, Wiki in Azure DevOps. Release notes are created as a page in the wiki and by using hyperlinks. Relations can be associated with the build, the release, and the artifacts. In the codebase. When you look at it, release notes belong strictly to the release of the features you implemented and your code. In that case, the best option might be to store release notes as part of your code repository. Once the team completes a feature, they or the product owner also write the release notes and save them alongside the code. This way, it becomes living documentation because the notes change with the rest of the code. In a work item. Another option is to store your release notes as part of your work items. Work items can be bugs, tasks, product backlog items, or user stories. You can create or use a different field within the work item to save release notes in work items. In this field, you type the publicly available release notes that will be communicated to the customer. With a script or specific task in your build and release pipeline, you can generate the release notes and store them as artifacts or publish them to an internal or external website. There's a difference between functional and technical documentation. Also, a difference between documentation designing the product, primarily written up front, and documentation describing the product afterward, like manuals or help files. Storing technical documentation about your products in the design phase is done on a document sharing portal, like SharePoint or Confluence. Creating a wiki is a better and more modern way to store your documentation. Wikis don't contain documents, presentations, or spreadsheets but text files called markdown files. These markdowns can refer to pictures, hold code samples, and be part of your code repository. Code repositories can deal well with text files. Changes in history can be easily tracked by using the native code tools. However, the most significant advantage of using a wiki instead of documents is that a wiki is accessible to everyone in your team. People can work together on the documentation instead of waiting for each other when working on the same document by giving all the team members the correct permissions. Manuals or documentation you release together with the product should be treated as source code. When the product changes and new functionality are added, the documentation needs to change. You can store the documentation as part of your code repository or create a new repository containing your documentation. In any case, the documentation should be treated the same way as your source code. Create a documentation artifact in your build pipeline and deliver this artifact to the release pipeline. The release pipeline can then deploy the documentation to a site or include it in the boxed product. Examine considerations for choosing release management tools. Completed 100 XP. 5 minutes. When choosing the right release management tool, you should look at the possibilities of all the different components and map them to your needs. Many tools are available in the marketplace, which we'll discuss in the next chapter. The most important thing to notice is that not every vendor or tool treats release management similarly. The tools in the marketplace can be divided into 2 categories. Tools that can do build and continuous integration and deployment. Tools that can do release management. In many cases, companies only require the deployment part of release management. Many build or release tools can perform deployment or installation. Primarily because the technical aspect of the release is executing a script or running a program, release management, which requires approvals, quality gates, and different stages, needs a different kind of tool that tightly integrates with the build, and CI tools aren't the same. Artifacts and artifact source. Artifacts can come from different sources. Treating your artifact as a versioned package needs to be stored somewhere before your release pipeline consumes it. Considerations for choosing your tool can be: which source control systems are supported? Can you have one or more artifact sources in your release pipeline? In other words, can you combine artifacts from different sources into one release? Does it integrate with your build server? Does it support other build servers? Does it support container registries? How do you secure the connection to the artifact source? Can you extend the artifact sources? Triggers and schedules. Triggers are an essential component in the pipeline. Triggers are required to start a release, but if you want multiple stages, create a deployment. Considerations for choosing your trigger can be: Does your system support continuous deployment triggers? Can you trigger releases from an API for integration with other tools? Can you schedule releases? Can you schedule and trigger each stage separately? Approvals and gates. Starting a release using scripts, executables, or deployable artifacts doesn't differentiate between a continuous integration/build tool and a release management tool. Adding a release approval workflow to the pipeline is the critical component that does make the difference. Considerations when it comes to approvals. Do you need approvals for your release pipeline? Is the approvers part of your company? Do they need a tool license? Do you want to use manual or automatic approvals? Or both? Can you approve an API integration with other tools? Can you set up a workflow with approvers, optional and required? Can you have different approvers per stage? Can you have more than one approver? Do you need them all to approve? What are the possibilities for automatic approval? Can you have a manual approval or step in your release pipeline? Stages. Running a continuous integration pipeline that builds and deploys your product is a commonly used scenario. But what if you want to deploy the same release to different environments? When choosing the right release management tool, you should consider the following things when it comes to stages or environments. Can you use the same artifact to deploy to different stages? Can you differ the configuration between the stages? Can you have different steps for each stage? Can you follow the release between the stages? Can you track the artifact/work items and source code between the stages? Build and release tasks. Finally, the work needs to be done within the pipeline. It isn't only about the workflow and orchestration, the code must also be deployed or installed. Things to consider when it comes to the execution of tasks. How do you create your steps? Is it running a script, bat, shell, PowerShell CLI, or are there specialized tasks? Can you create your tasks? How do tasks authenticate to secure sources? Can tasks run on multiple platforms? Can tasks be easily reused? Can you integrate with multiple environments? Linux, Windows, container clusters, PaaS, cloud. Can you control the tasks that are used in the pipeline? Traceability, auditability, and security. One of the essential things in enterprises and companies that need to adhere to compliance frameworks is traceability, auditability, security. Although it isn't explicitly related to a release pipeline, it's essential. When it comes to compliance, 3 principles are fundamental. 4 Eyes principle. Does at least one other person review the deployed artifact? Is the person that deploys another person the one that writes the code? Traceability. Can we see where the released software originates from, which code? Can we see the requirements that led to this change? Can we follow the requirements through the code, build, and release? Auditability. Can we see who, when, and why the release process changed? Can we see who, when, and why a new release has been deployed? Security is vital in it. It isn't okay when people can do everything, including deleting evidence. Setting up the right roles, permissions, and authorization is essential to protect your system and pipeline. When looking at an appropriate release management tool, you can consider the following. Does it integrate with your company's Active Directory? Can you set up roles and permissions? Is there a change history of the release pipeline itself? Can you ensure the artifact didn't change during the release? Can you link the requirements to the release? Can you link source code changes to the release pipeline? Can you enforce approval or the 4 Eyes principle? Can you see the release history and the people who triggered the release? Explore common release management tools. Completed 100 XP. 3 minutes. The following tools are mainstream in the current ecosystem. You'll find links to the product websites to explore the product and see if it fits the needs we described in the previous chapter. What artifacts and artifact sources does the tool support? What triggers and schedules? Does the tool support approvals and gates? Can you define multiple stages? How do the build and release tasks work? How does the tool deal with traceability, auditability, and security? What is the extensibility model? Per tool is indicated if it's part of a more extensive suite. Integration with a bigger suite gives you many advantages regarding traceability, security, and auditability. Numerous integrations are already there out of the box. GitHub Actions. GitHub Actions help you build, test, and deploy your code. You can implement continuous integration and continuous delivery, CI/CD, that allows you to make code reviews, branch management, and issue triaging work the way you want. Trigger workflows with various events. Configure environments to set rules before a job can proceed and to limit access to secrets. Use concurrency to control the number of deployments running at a time. Links. Azure Pipelines. Azure Pipelines helps you implement a build, test, and deployment pipeline for any app. Tutorials, references, and other documentation show you how to configure and manage the continuous integration and continuous delivery, CI/CD, for the app and platform of your choice. Hosted on Azure as a SaaS in multiple regions and available as an on-premises product. Complete REST API for everything around build and release management. Integration with many build and source control systems. GitHub. Azure Repos. Jenkins. Bitbucket. And so on. Cross-platform support, all languages and platforms. Rich marketplace with extra plugins, build tasks and release tasks, and dashboard widgets. Part of the Azure DevOps suite. Tightly integrated. Fully customizable. Manual approvals and release quality gates supported. Integrated with Azure Active Directory. Extensive roles and permissions. Links. Jenkins. Jenkins' leading open-source automation server provides hundreds of plugins to support building, deploying, and automating any project. On-premises system. They're offered as SaaS by a third party. No part of a bigger suite. Industry standard, especially in the full-stack space. Integrates with almost every source control system. A rich ecosystem of plugins. CI/build tool with deployment possibilities. No release management capabilities. Links. Circle CI. Circle CI's continuous integration and delivery platform helps software teams rapidly release code with confidence by automating the build, test, and deploy process. Circle CI offers a modern software development platform that lets teams ramp quickly, scale easily, and build confidently every day. Circle CI is a cloud-based system or an on-premises system. REST API, you have access to projects, builds, and artifacts. The result of the build is going to be an artifact. Integration with GitHub and Bitbucket. Integrates with various clouds. Not part of a bigger suite. Not fully customizable. Links. GitLab pipelines. GitLab helps teams automate the release and delivery of their applications to shorten the delivery lifecycle, streamline manual processes, and accelerate team velocity. With continuous delivery, CD, built into the pipeline, deployment can be automated to multiple environments like staging and production and support advanced features such as canary deployments. Because the configuration and definition of the application are version controlled and managed, it's easy to configure and deploy your application on demand. Link. GitLab. Atlassian Bamboo. Bamboo is a continuous integration (CI) server that can automate the release management for a software application, creating a continuous delivery pipeline. Link. Atlassian Bamboo. Knowledge check. Completed 200 XP. 4 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices allows automatic collection of health signals from external services and promotes the release when all the signals are successful? Release gates. Events. Service hooks. 2. Which of the following choices are raised when certain actions occur, like when a release is started or a build completed? Service hooks. Events. Release gates. 3. Which of the following choices are usually emails you receive when an action occurs to which you're subscribed? Notifications. Service hook. Hooks. Events. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described how to automate the inspection of health events, configure notifications, and set up service hooks to monitor pipelines. You learned how to describe the benefits and usage of. Implement automated inspection of health. Create and configure events. Configure notifications. Create service hooks to monitor the pipeline. Learn more. Introduction. Completed 100 XP. 1 minute. This module introduces deployment patterns and explains microservices architecture to help improve the deployment cycle and examine classical and modern deployment patterns. Continuous delivery is an extension of continuous integration. It's all about getting changes to customers quickly and using sustainable methods. Continuous delivery goes further, and changes that pass through production pipelines are released to customers. Continuous delivery is more than release management. Continuous delivery is all about the process, the people, and the tools that you need to make sure that you can deliver your software on demand. Deployment is only one step within the continuous delivery process. To deploy on demand or multiple times a day, all the prerequisites need to be in place. For example, testing strategy. Your testing strategy should be in place. If you need to run many manual tests to validate your software, it is a bottleneck to delivering on demand. Coding practices. If your software isn't written in a safe and maintainable manner, the chances are that you can't maintain a high release cadence. When your software is complex because of a large amount of technical debt, it's hard to change the code quickly and reliably. Writing high-quality software and high-quality tests are an essential part of continuous delivery. Architecture. The architecture of your application is always significant. But when implementing continuous delivery, it's maybe even more so. If your software is a monolith with many tight coupling between the various components, it's challenging to deliver your software continuously. Every part that is changed might impact other parts that didn't change. Automated tests can track many of these unexpected dependencies, but it's still hard. There's also the time aspect when working with different teams. When Team A relies on the service of Team B, Team A can't deliver until Team B is done. It introduces another constraint on delivery. Continuous delivery for large software products is complex. For smaller parts, it's easier. So, breaking up your software into smaller, independent pieces is a good solution in many cases. One approach to solving these issues is to implement microservices. Continuous integration is one of the key pillars of DevOps. Once you have your code in a version control system, you need an automated way of integrating the code on an ongoing basis. Azure Pipelines can be used to create a fully featured cross-platform CI and CD service. It works with your preferred Git provider and can deploy to most major cloud services, including Azure. This module details continuous integration practice and the pillars for implementing it in the development lifecycle, its benefits and properties. Learning objectives. After completing this module, students and professionals can describe deployment patterns, explain microservices architecture, understand classical and modern deployment patterns, plan and design your architecture. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Explore microservices architecture. Completed 100 XP. 3 minutes. Today, you'll frequently hear the term microservices. A microservice is an autonomous, independently deployable, and scalable software component. They're small, focused on doing one thing well, and can run autonomously. If one microservice changes, it shouldn't impact any other microservices within your landscape. By choosing a microservices architecture, you'll create a landscape of services that can be developed, tested, and deployed separately. It implies other risks and complexity. It would be best if you created it to keep track of interfaces and how they interact. And you need to maintain multiple application lifecycles instead of one. In a traditional application, we can often see a multi-layer architecture. One layer with the UI, a layer with the business logic and services, and a layer with the data services. Sometimes there are dedicated teams for the UI and the backend. When something needs to change, it needs to change in all the layers. When moving towards a microservices architecture, all these layers are part of the same microservice. Only the microservice contains one specific function. The interaction between the microservices is done asynchronously. They don't call each other directly but use asynchronous mechanisms like queues or events. Each microservice has its lifecycle and continuous delivery pipeline. If you built them correctly, you could deploy new microservice versions without impacting other system parts. Microservice architecture is undoubtedly not a prerequisite for continuous delivery, but smaller software components help implement a fully automated pipeline. Examine classical deployment patterns. Completed 100 XP. 3 minutes. When we have our prerequisites to deliver our software continuously, we need to start thinking about a deployment pattern. Traditionally, a deployment pattern was straightforward. The software was built, and when all features had been implemented, the software was deployed to an environment where a group of people could start using it. The traditional or classical deployment pattern was moving your software to a development stage, a testing stage, maybe an acceptance or staging stage, and finally a production stage. The software moved as one piece through the stages. The production release was, in most cases, a big bang release, where users were confronted with many changes at the same time. Despite the different stages to test and validate, this approach still involves many risks. By running all your tests and validation on non-production environments, it's hard to predict what happens when your production users start using it. You can run load tests and availability tests, but in the end, there's no place like production. Understand modern deployment patterns. Completed 100 XP. 3 minutes. End users always use your application differently. Unexpected events will happen in a data center. Multiple events from multiple users will co-occur, triggering some code that hasn't been tested in that way. To overcome, we need to embrace that some features can only be tested in production. Testing in production sounds a bit scary, but that shouldn't be the case. When we talked about separating our functional and technical releases, we already saw that it's possible to deploy features without exposing them to all users. When we take this concept of feature toggling and use it with our deployment patterns, we can test our software in production. For example, blue-green deployments, canary releases, dark launching, A/B testing, progressive exposure or ring-based deployment, feature toggles. Take a critical look at your architecture. Are your architecture and the current state of your software ready for continuous delivery? Topics you might want to consider are: is your software built as one giant monolith, or is it divided into multiple components? Can you deliver parts of your application separately? Can you guarantee the quality of your software when deploying multiple times a week? How do you test your software? Do you run one or multiple versions of your software? Can you run multiple versions of your software side by side? What do you need to improve to implement continuous delivery? Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices describe microservice? A microservice is a multi-function software to deliver more than one thing very well. A microservice is software built as one monolith. A microservice is an autonomous, independently deployable, and scalable software component. 2. Which of the following choices is a microservice characteristic? Each microservice can be tested based on other microservice results. If one microservice changes, it shouldn't impact any other microservices within your landscape. If one microservice changes, it affects other services, and you need to wait for other services to go online. 3. Which of the following choices represent a classical deployment pattern? Dev, test, staging, and production deployment. Blue-green deployments. A/B testing. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module introduced deployment patterns and explained microservices architecture to help improve the deployment cycle and examine classical and modern deployment patterns. You learned how to describe the benefits and usage of. Describe deployment patterns. Explain microservices architecture. Understand classical and modern deployment patterns. Plan and design your architecture. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes the blue-green deployment process and introduces feature toggle techniques to implement in the development process. Learning objectives. After completing this module, students and professionals can explain deployment strategies, implement blue-green deployment, understand deployment slots, implement and manage feature toggles. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. You need to create an Azure DevOps organization and a team project for some exercises. If you don't have it yet, see, create an organization Azure DevOps. What is blue-green deployment? Completed 100 XP. 3 minutes. Blue-green deployment is a technique that reduces risk and downtime by running two identical environments. These environments are called blue and green. Only one of the environments is live, with the live environment serving all production traffic. For this example, blue is currently live and green is idle. As you prepare a new version of your software, the deployment and final testing stage occur in an environment that isn't live, in this example, green. Once you've deployed and thoroughly tested the software in green, switch the router or load balancer so all incoming requests go to green instead of blue. Green is now live, and blue is idle. This technique can eliminate downtime because of app deployment. Besides, blue-green deployment reduces risk. If something unexpected happens with your new version on the green, you can immediately roll back to the last version by switching back to blue. When it involves database schema changes, this process isn't straightforward. You probably can't swap your application. In that case, your application and architecture should be built to handle both the old and the new database schema. Explore deployment slots. Completed 100 XP. 3 minutes. When using a cloud platform like Azure, doing blue-green deployments is relatively easy. You don't need to write your code or set up infrastructure. You can use an out-of-the-box feature called deployment slots when using web apps. Deployment slots are a feature of Azure App Service. They're live apps with their host names. You can create different slots for your application, for example, dev, test, or stage. The production slot is the slot where your live app stays. You can validate app changes in staging with deployment slots before swapping them with your production slot. You can use a deployment slot to set up a new version of your application, and when ready, swap the production environment with the new staging environment. It's done by an internal swapping of the IP addresses of both slots. Swap. The swap eliminates downtime when you deploy your app with seamless traffic redirection, and no requests are dropped because of swap operations. To learn more about deployment slots and swap, see also. Introduction to feature toggles. Completed 100 XP. 3 minutes. Feature flags allow you to change how our system works without making significant changes to the code. Only a small configuration change is required. In many cases, it will also only be for a few users. Feature flags offer a solution to the need to push new code into the trunk and deploy it, but it isn't functional yet. They're commonly implemented as the value of variables used to control conditional logic. Imagine that your team is all working in the main trunk branch of a banking application. You've decided it's worth trying to have all the work done in the main branch to avoid messy operations of merge later. Still, you need to ensure that significant changes to the interest calculations can happen, and people depend on that code every day. Worse, the changes will take you weeks to complete. You can't leave the main code broken for that period. A feature flag could help you get around it. You can change the code so that other users who don't have the feature flag set will use the original interest calculation code. The members of your team who are working on the new interest calculations and set to see the feature flag will have the new interest calculation code. It's an example of a business feature flag used to determine business logic. The other type of feature flag is a release flag. Now, imagine that after you complete the work on the interest calculation code, you're nervous about publishing a new code out to all users at once. You have a group of users who are better at dealing with new code and issues if they arise, and these people are often called canaries. The name is based on the old use of the canaries in coal mines. You change the configuration so that the canary users also have the feature flag set, and they'll start to test the new code as well. If problems occur, you can quickly disable the flag for them again. Another release flag might be used for A/B testing. Perhaps you want to find out if a new feature makes it faster for users to complete a task. You could have half the users working with the original version of the code and the other half working with the new code version. You can then directly compare the outcome and decide if the feature is worth keeping. Feature flags are sometimes called feature toggles instead. By exposing new features by just flipping a switch at runtime, we can deploy new software without exposing any new or changed functionality to the end user. The question is, what strategy do you want to use in releasing a feature to an end user? Reveal the feature to a segment of users, so you can see how the new feature is received and used. Reveal the feature to a randomly selected percentage of users. Reveal the feature to all users at the same time. The business owner plays a vital role in the process, and you need to work closely with them to choose the right strategy. Just as in all the other deployment patterns mentioned in the introduction, the most crucial part is always looking at how the system behaves. The idea of separating feature deployment from feature exposure is compelling and something we want to incorporate in our continuous delivery practice. It helps us with more stable releases and better ways to roll back when we run into issues when we have a new feature that produces problems. We switch it off again and then create a hotfix. By separating deployments from revealing a feature, you make the opportunity to release a day anytime since the new software won't affect the system that already works. What are feature toggles? Feature toggles are also known as feature flippers, feature flags, feature switches, conditional features, and so on. Besides the power they give you on the business side, they also provide an advantage on the development side. Feature toggles are a great alternative to branching as well. Branching is what we do in our version control system. To keep features isolated, we maintain a separate branch. When we want the software to be in production, we merge it with the release branch and deploy it. With feature toggles, you build new features behind a toggle. Your feature is off when a release occurs and shouldn't be exposed to or impact the production software. How to implement a feature toggle. In the purest form, a feature toggle is an if statement. When the switch is off, it executes the code in the if, otherwise the else. You can make it much more intelligent, controlling the feature toggles from a dashboard or building capabilities for roles, users, and so on. If you want to implement feature toggles, many different frameworks are available commercially as open source. For more information, see also explore how to progressively expose your features in production for some or all users. Describe feature toggle maintenance. Completed 100 XP. 2 minutes. A feature toggle is just code. And to be more specific, conditional code. It adds complexity to the code and increases the technical debt. Be aware of that when you write them, and clean up when you don't need them anymore. While feature flags can be helpful, they can also introduce many issues of their own. The idea of a toggle is that it's short-lived and only stays in the software when it's necessary to release it to the customers. You can classify the different types of toggles based on 2 dimensions as described by Martin Fowler. He states that you can look at the dimension of how long a toggle should be in your codebase and, on the other side, how dynamic the toggle needs to be. Planning feature flag lifecycles. The most important thing is to remember that you need to remove the toggles from the software. If you don't do that, they'll become a form of technical debt if you keep them around for too long. As soon as you introduce a feature flag, you've added to your overall technical debt. Like other technical debt, they're easy to add, but the longer they're part of your code, the bigger the technical debt becomes because you've added scaffolding logic needed for the branching within the code. The cyclomatic complexity of your code keeps increasing as you add more feature flags, as the number of possible paths through the code increases. Using feature flags can make your code less solid and can also add these issues. The code is harder to test effectively as the number of logical combinations increases. The code is harder to maintain because it's more complex. The code might even be less secure. It can be harder to duplicate problems when they're found. A plan for managing the lifecycle of feature flags is critical. As soon as you add a flag, you need to plan for when it will be removed. Feature flags shouldn't be repurposed. There have been high-profile failures because teams decided to reuse an old flag that they thought was no longer part of the code for a new purpose. Tooling for release flag management. The amount of effort required to manage feature flags shouldn't be underestimated. It's essential to consider using tooling that tracks which flags exist, which flags are enabled in which environments, situations, or target customer categories. The plan for when the flags will be used in production. The plan for when the flags will be removed. Using a feature flag management system lets you get the benefits of feature flags while minimizing the risk of increasing your technical debt too high. Azure App Configuration offers a feature manager. See Azure App Configuration Feature Manager. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check Your Answers. Check your knowledge. 1. Which of the following choices is the easiest way to create a staging environment for an Azure web app? Create a deployment slot. Use application insights. Create an app close. 2. Which of the following choices describes a feature flag functionality? Feature flags allow teams to create automatic release notes. Feature flags can be used to control exposure to new product functionality. Feature flags help teams control deployment release gates. 3. Which of the following choices isn't a deployment pattern that allows you to plan to slowly increase the traffic to a newer version of your site? A/B testing. Blue-green. Canary release. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described the blue-green deployment process and introduced feature toggle techniques to implement in the development process. You learned how to describe the benefits and usage of. Explain deployment strategies. Implement blue-green deployment. Understand deployment slots. Implement and manage feature toggles. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes deployment strategies around canary releases and dark launching and examines traffic managers. Learning objectives. After completing this module, students and professionals can describe deployment strategies, Implement canary release. Explain traffic manager. Understand dark launching. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Explore canary releases. Completed 100 XP. 3 minutes. The term canary release comes from the days that miners took a canary with them into the coal mines. The purpose of the canary was to identify the existence of toxic gases. The canary would die much sooner than the miner, giving them enough time to escape the potentially lethal environment. A canary release is a way to identify potential problems without exposing all your end users to the issue at once. The idea is that you tell a new feature only to a minimal subset of users. By closely monitoring what happens when you enable the feature, you can get relevant information from this set of users and either continue or roll back, disable the feature. If the canary release shows potential performance or scalability problems, you can build a fix for that and apply that in the canary environment. After the canary release has proven to be stable, you can move the canary release to the actual production environment. Canary releases can be implemented using a combination of feature toggles, traffic routing, and deployment slots. You can route a percentage of traffic to a deployment slot with the new feature enabled. You can target a specific user segment by using feature toggles. Examine traffic manager. Completed 100 XP. 3 minutes. In the previous module, we saw how deployment slots in Azure Web Apps enable you to swap between two different versions of your application quickly. Suppose you want more control over the traffic that flows to your other versions. Deployment slots alone aren't enough. To control traffic in Azure, you can use a component called Azure Traffic Manager. Azure Traffic Manager. Azure Traffic Manager is a DNS-based traffic load balancer that enables you to distribute traffic optimally to services across global Azure regions while providing high availability and responsiveness. Traffic Manager uses DNS to direct client requests to the most appropriate service endpoint based on a traffic routing method and the health of the endpoints. An endpoint is an internet-facing service hosted inside or outside of Azure. Traffic Manager provides a range of traffic routing methods and endpoint monitoring options to suit different application needs and automatic failover models. Traffic Manager is resilient to failure, including the breakdown of an entire Azure region. While the available options can change over time, the Traffic Manager currently provides 6 options to distribute traffic. Priority. Select priority when you want to use a primary service endpoint for all traffic and provide backups if the primary or the backup endpoints are unavailable. Weighted. Select weighted when you want to distribute traffic across a set of endpoints either evenly or according to weights, which you define. Performance. Select performance when you have endpoints in different geographic locations, and you want end users to use the closest endpoint for the lowest network latency. Geographic. Select geographic so that users are directed to specific endpoints, Azure, external, or nested, based on which geographic location their DNS query originates from. It empowers Traffic Manager customers to enable scenarios where knowing a user's geographic region and routing them based on that is necessary. Examples include following data sovereignty mandates, localization of content and user experience, and measuring traffic from different regions. Multi-value. Select multi-value for Traffic Manager profiles that can only have IPv4/IPv6 addresses as endpoints. When a query is received for this profile, all healthy endpoints are returned. Subnet. Select the subnet traffic routing method to map sets of end-user IP address ranges to a specific endpoint within a Traffic Manager profile. The endpoint returned will be mapped for that request source IP address when a request is received. When we look at the options the Traffic Manager offers, the most used option for continuous delivery is routing traffic based on weights. Note: traffic is only routed to endpoints that are currently available. For more information, see also. Controlling your canary release. Using a combination of feature toggles, deployment slots, and Traffic Manager, you can achieve complete control over the traffic flow and enable your canary release. You deploy the new feature to the new deployment slot or a new instance of an application, and you enable the feature after verifying the deployment was successful. Next, you set the traffic to be distributed to a small percentage of the users. You carefully watch the application's behavior, for example, by using application insights to monitor the performance and stability of the application. Understand dark launching. Completed 100 XP. 3 minutes. Dark launching is in many ways like canary releases. However, the difference here is that you're looking to assess users' responses to new features in your frontend rather than testing the performance of the backend. The idea is that rather than launch a new feature for all users, you instead release it to a small set of users. Usually, these users aren't aware they're being used as test users for the new feature, and often you don't even highlight the new feature to them, as such the term dark launching. Another example of dark launching is launching a new feature and using it on the backend to get metrics. Let me illustrate with a real-world launch example. As Elon Musk describes in his biography, they apply all kinds of agile development principles in SpaceX. SpaceX builds and launches rockets to launch satellites. SpaceX also uses dark launching. When they have a new version of a sensor, they install it alongside the old one. All data is measured and gathered both by the old and the new sensor. Afterward, they compare the outcomes of both sensors. Only when the new one has the same or improved results the old sensor is replaced. The same concept can be applied to software. You run all data and calculations through your new feature, but it isn't exposed yet. How to implement dark launching. In essence, dark launching doesn't differ from a canary release or the implementation and switching of a feature toggle. The feature is released and only exposed at a particular time. As such, the techniques, as described in the previous chapters, do also apply for dark launching. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices is an Azure-based tool can you use to divert a percentage of your web traffic to a newer version of an Azure website? Load Balancer. Application Gateway. Traffic Manager. 2. Which of the following choices is a characteristic that makes users suitable for working with Canary deployments? Uses the app irregularly. High tolerance for issues. It depends highly on the app working all the time. 3. Which of the following choices describes the difference dark launching has from Canary releases? You're looking to assess users' responses to new features in your frontend rather than testing the performance of the backend. You're looking to assess users' responses to new features in your backend and frontend. You're looking to assess users' responses to new features in your backend rather than testing the performance of the frontend. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described deployment strategies around Canary releases and dark launching and examined traffic managers. You learned how to describe the benefits and usage of. Describe deployment strategies. Implement Canary release. Explain traffic manager. Understand dark launching. Learn more. Introduction. Completed 100 XP. 1 minute. This module introduces A/B testing and progressive exposure deployment concepts and explores CI/CD with deployment rings ring-based deployment. Learning objectives. After completing this module, students and professionals can implement progressive exposure deployment. Implement A/B testing. Implement CI/CD with deployment rings. Identify the best deployment strategy. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. What is A/B testing? Completed 100 XP. 2 minutes. A/B testing, also known as split testing or bucket testing, compares two versions of a web page or app against each other to determine which one does better. A/B testing is mainly an experiment where two or more page variants are shown to users at random. Also, statistical analysis is used to determine which variation works better for a given conversion goal. A/B testing isn't part of continuous delivery or a prerequisite for continuous delivery. It's more the other way around. Continuous delivery allows you to deliver MVPs to a production environment and your end users quickly. Common aims are to experiment with new features, often to see if they improve conversion rates. Experiments are continuous, and the impact of change is measured. A/B testing is out of scope for this course. But because it's a powerful concept that is enabled by implementing continuous delivery, it's mentioned here to dive into further. Explore CI/CD with deployment rings. Completed 100 XP. 3 minutes. Progressive exposure deployment, also called ring-based deployment, was first discussed in Jez Humble's Continuous Delivery book. They support the production-first DevOps mindset and limit the impact on end users while gradually deploying and validating changes in production. Impact, also called blast radius, is evaluated through observation, testing, analysis of telemetry, and user feedback. In DevOps, rings are typically modeled as stages. Rings are, in essence, an extension of the Canary stage. The Canary releases to a stage to measure impact. Adding another ring is essentially the same thing. With a ring-based deployment, you first deploy your changes to risk-tolerant customers and progressively roll out to a more extensive set of customers. The Microsoft Windows team, for example, uses these rings. When you have identified multiple groups of users and see value in investing in a ring-based deployment, you need to define your setup. Some organizations that use Canary releasing have multiple deployment slots set up as rings. The first release of the feature to Ring 0 targets a well-known set of users, mostly their internal organization. After things have been proven stable in Ring 0, they propagate the release to the next ring. It's with a limited set of users outside their organization. And finally, the feature is released to everyone. It is often done by flipping the switch on the feature toggles in the software. As in the other deployment patterns, monitoring and health checks are essential. By using post-deployment release gates that check a ring for health, you can define an automatic propagation to the next ring after everything is stable. When a ring isn't healthy, you can halt the deployment to the following rings to reduce the impact. For more information, see also explore how to progressively expose your Azure DevOps extension releases in production to validate before impacting all users. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices is a deployment pattern extension of Canary release? Blue-green. A/B testing. Progressive exposure. 2. Which of the following choices is another way A/B testing is called? Smoke testing. Split testing or bucket testing. Integration testing. 3. Which of the following choices is a correct statement about A/B testing? A/B testing isn't part of continuous delivery or a prerequisite for continuous delivery. A/B testing can be implemented using Azure artifacts and multiple environments. A/B testing is a prerequisite and part of continuous delivery. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module introduced A/B testing and progressive exposure deployment concepts and explored CI/CD with deployment rings ring-based deployment. You learned how to describe the benefits and usage of. Implement progressive exposure deployment. Implement A/B testing. Implement CI/CD with deployment rings. Identify the best deployment strategy. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes the integration with GitHub and single sign-on (SSO) for authentication, service principal, and managed service identities. Learning objectives. After completing this module, students and professionals can integrate Azure DevOps with identity management systems. Integrate GitHub with single sign-on (SSO). Understand and create a service principal. Create managed service identities. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Integrate GitHub with single sign-on (SSO). Completed 100 XP. 1 minute. GitHub provides multiple ways to authenticate and authorize access to its resources. Username and password, in combination with another authentication factor, the traditional interactive method where users provide their GitHub username and password to authenticate. GitHub requires all users who contribute code to have one or more forms of two-factor authentication, 2FA, enabled. SSH keys, keys generated by users and stored in their GitHub accounts, allowing secure access to repositories via the SSH protocol. They accommodate scenarios in which Git operations need to be performed as part of automated scripts or processes, such as continuous integration workflows, without requiring manual input of credentials. Personal access tokens, PATs, tokens generated in GitHub that act as alternative passwords, allowing access to the GitHub resource that individual users designate. They're commonly used for web-based applications, automation, and accessing the GitHub API. They also provide an alternative to SSH keys in scenarios where firewall restrictions block SSH connectivity. OAuth apps, custom-developed and third-party apps that authorize access to GitHub resources without an explicit use of users' credentials. They facilitate integration of third-party applications with GitHub. GitHub apps, custom-developed and third-party apps similar to OAuth apps but with additional capabilities, including support for more granular permissions. They constitute the recommended approach to providing programmatic access to GitHub API. GitHub apps provide a way to integrate third-party applications with GitHub repositories and organizations. The facilitated workflow automation, policy enforcement, and the use of custom tools within the GitHub ecosystem. GitHub_token, a built-in authentication token provided by GitHub Actions and automatically available during workflow execution. It provides scoped access to the repository and is commonly used for automating workflows within GitHub Actions. Implementing username and password, including two-factor authentication. You're automatically prompted to create a password when you create a GitHub account. After entering your username and password, you'll be asked to provide a verification code sent to you via email. If you enable 2FA, after you successfully enter your username and password, you'll also be prompted to provide a code that's generated by a time-based one-time password, TOTP, application on your mobile device or sent as a text message, SMS. GitHub also supports SAML, Security Assertion Markup Language, based single sign-on for organization and enterprise account. In such cases, when you attempt to access the account's resources, GitHub will redirect you to the organization's SAML identity provider, IDP, to authenticate. After you successfully authenticate with your IDP credentials, you'll be automatically redirected back to GitHub account's hosted resources. Implementing SSH keys authentication. To start, if you don't already have an SSH key pair, generate one using the SSH keygen utility. This generates a new SSH key pair, public and private keys, and prompts you to choose a location to save the keys. Then copy the contents of the public key, typically id_rsa.pub or id_rsa.pub in the .ssh directory, to your clipboard. Use a web browser to open your GitHub account settings page. Navigate to the SSH and GPG key section, select the new SSH key button, and use the content of the clipboard to assign the value to the key, along with assigning to it a descriptive name. Subsequently, you'll be able to use SSH from any computer where the private key is stored to access the target GitHub account. Alternatively, if you first authenticate by using GitHub CLI, the CLI finds SSH public keys on your machine and will prompt you to select one for upload. In addition, if GitHub CLI doesn't find an SSH public key for upload, it can generate a new SSH public/private key pair and upload the public key to your GitHub account. Implementing Personal Access Token, PAT, authentication. To start, use a web browser to open your GitHub account settings page and navigate to the Developer Settings section. Select Personal Access Tokens and then select the Generate New Token button. Specify the desired scopes, duration, and a descriptive name, and generate it. Subsequently, you can use the Personal Access Token in workflows, scripts, or applications to authenticate with GitHub APIs. Personal Access Tokens can be used as an alternative to GitHub_token in GitHub Actions workflows. However, you should avoid hard-coding personal access tokens in public repositories or exposing them in unsecured environments. Implementing GitHub Apps Authentication. To start, you need to create a GitHub app. Use a web browser to open your GitHub account settings page and navigate to the Developer Settings section. Select GitHub Apps and then select the New GitHub App button. Provide the required details such as the app name, description, permissions, and webhook configuration. Generate and securely store the private key associated with the GitHub app. After creating the GitHub app, install it on the repositories or organizations where you want to use it. During installation, you're prompted to grant the necessary permissions to the GitHub app. GitHub apps use access tokens to authenticate API requests. These tokens are generated dynamically and have limited scopes based on the permissions granted to the GitHub app. The GitHub app's access token can be used in workflows, scripts, or applications to interact with GitHub's APIs. GitHub apps offer fine-grained permissions control. You can manage the permissions granted to the GitHub app from the GitHub app settings page. Implementing GitHub_token authentication. GitHub_token is generated automatically by GitHub Actions for each workflow run. The token is automatically added as a secret to the repository's environment, making it accessible within workflows. The GitHub_token has read and write access to the repository where the workflow runs. It can be used to perform various actions such as cloning the repository, creating issues, and triggering other workflows. To access the GitHub_token within workflows, use the secrets context. The following example illustrates how to leverage GitHub_token to automatically generate a comment on an issue when a pull request is opened. YAML. Name, comment on issue on, pull_request, types, opened, jobs, comment, runs on, Ubuntu latest steps, name, comment on issue uses, action/GitHub script at v4 with, GitHub token, $secrets.github_token, script, const issue number equals context.payload.pull_request.issue_url.split, /.pop, await github.issues.create comment, owner, context.repo.owner, repo, context.repo.repo. Issue_number, issue number, body, we appreciate opening this pull request. We will review it shortly. Design and implement permissions and roles in GitHub. Completed 100 XP. 3 minutes. In GitHub personal accounts, organizations, and enterprises, roles play an essential role in managing access to repositories, projects, and settings. The roles facilitate efficient collaboration and effective governance. Personal accounts have a single user having full control over all repositories, while organizations and enterprises offer a more granular model that facilitates delegation of responsibilities aligned with the typical structure of information technology departments. Personal GitHub accounts. Personal GitHub accounts have two roles, owner and collaborator. The owner has full control over the account's repositories and can invite collaborators to grant them access to individual private repositories. Accepting an invitation grants both read and write access to the corresponding repository, effectively allowing completing the pull and push tasks. Collaborators can also perform several other repository-related actions such as creating, editing, and deleting comments on commits, submitting pull requests, merging and closing pull requests, as well as creating and editing releases. It isn't possible to limit private repository permissions assigned to collaborators to read only. GitHub organizations. GitHub organizations offer several built-in roles that provide means for delegating operational responsibilities to individuals and teams. These roles, assigned by organization owners, determine the level of permissions required to perform specific actions within the organization's GitHub ecosystem. Organization owners have complete administrative access to the organization. They're responsible for managing all aspects of the organization, including its repositories, teams, settings, and member permissions. It's recommended to limit the number of organization owners, but ensure there are at least 2 for redundancy and contingency reasons. Organization members constitute the default non-administrative role for individuals in an organization. By default, they have limited permissions, including the ability to create repositories and projects, without broader, organization-wide privileges. Organization moderators are organization members with additional permissions, allowing them to block and unblock non-member contributors, set interaction limits, and hide comments in public repositories owned by the organization. They assist in managing community interactions and maintaining order within the organization's repositories. Billing managers are users who have permission to manage the billing settings for the organization, including payment information. This role is intended for scenarios in which organization members don't have access to billing resources. Security managers designate an organization-level role that grants permissions to view security alerts, manage code security settings, and access read permissions for all repositories in the organization. This role is beneficial for organizations with dedicated security teams. As of March 2024, Security Manager's role is in public beta and subject to change. GitHub App Managers, typically organization owners, are responsible for managing the settings of GitHub app registrations owned by the organization. They can grant additional users GitHub App Manager permissions to manage specific GitHub app registration settings. This role doesn't grant users access to install and uninstall GitHub apps on the organization. Outside collaborators are individuals who have access to one or more organization repositories but aren't formal members of the organization. They may include consultants, temporary employees, or external contributors. Outside collaborators have limited access to organization resources and repositories, ensuring data security while allowing necessary access for collaboration. GitHub Enterprise Organizations. GitHub Enterprise introduces additional roles beyond those available in standard GitHub personal accounts and organizations. These roles are geared within enterprise-level functionality. Enterprise owners have full control over the enterprise, including managing administrators, adding or removing organizations, enforcing policies, and managing billing settings. Enterprise members are automatically included in organizations owned by the enterprise and can collaborate within these organizations. However, they lack access to enterprise settings and are limited to accessing repositories with the internal visibility within the enterprise. Guest collaborators are intended to provide restricted access to the organization's internal repositories by external vendors and contractors. The restrictions are based on the organization's permission policy. Design and implement permissions and security groups in Azure DevOps. Completed 100 XP. 3 minutes. Azure DevOps Access Control Model offers highly customizable and granular protection against unauthorized use, suitable to accommodate the principle of least privilege. It relies on several interconnected functional areas including membership in built-in and custom security groups, inherited and explicit permissions assigned at organizational, project, and object scope, and access levels. Understanding these functional areas and their dependencies is essential for efficiently designing and implementing permissions within Azure DevOps. Access Control Model. The effective permissions are derived through a combination of 3 main authorization mechanisms. Membership management involves adding security principles to built-in or custom Azure DevOps groups, each associated with specific set of permissions. Azure DevOps groups can include users, other Azure DevOps groups, and, in Azure DevOps organizations integrated with Microsoft Entra ID, Entra groups. Permission management controls access to specific functional tasks at various levels of the system, such as organization, project, or object. Object-level permissions allow setting permissions on such entities as dashboards, wikis, area paths, shared queries and query folders, pipelines, deployment groups, Git repositories and branches, as well as artifacts and feeds. Permissions support explicit and inherited allow and deny. Role-based assignments manage additional permissions, such as team administration and pipeline resource roles. Permissions can be assigned to Azure DevOps groups or users, but not directly to Microsoft Entra ID groups. Access level management relies on the user license to determine the visibility of web portal features. Users can be assigned access levels of Stakeholder, Basic, Basic Plus Test Plans, or Visual Studio Enterprise, depending on the licenses assigned to them. Note that setting the access level for users or groups doesn't provide them with access to a project or the web portal. Only users or groups added to the relevant Azure DevOps groups can connect to the web portal and access the corresponding organization, project, or object level features. The following security groups are defined by default for each project and organization. Organization. Project Collection Administrators. Project Collection Build Administrators. Project Collection Build Service Accounts. Project Collection Proxy Service Accounts. Project Collection Service Accounts. Project Collection Test Service Accounts. Project Collection Valid Users. Project Scoped Users. Security Service Group. Project. Build Administrators. Contributors. Project Administrators. Project Valid Users. Readers. Release Administrators. Project_name team, where project_name designates the name of the project. Most Azure DevOps users are added to the Contributor Security Group and granted basic access level. The Contributors Group provides by default read and write access to the primary DevOps capabilities, including repositories, work tracking, and pipelines. Basic access provides access to all features and tasks for using Azure Boards, Azure Repos, Azure Pipelines, and Azure Artifacts. Users who need to be able to manage Azure Test Plans must be granted the Basic Plus Test Plans access level. When you add accounts of users to an Azure DevOps Security Group, they're automatically added to one of the valid user groups. Project Collection Valid Users, all members added to an organization level group. Project Valid Users, all members added to a project level group. The default permissions assigned to these groups are primarily limited to read access, such as view build resources, view project level information, and view collection level information. Design and implementation. To design and implement an optimal access control model in Azure DevOps that enhances security while minimizing the management and maintenance overhead, use the following guidance. Plan Microsoft Entra ID groups. Utilize Microsoft Entra ID groups to manage user access, rather than adding users directly to Azure DevOps groups. Create groups based on team roles, project requirements, and access level. Consider the permissions needed for different teams and organize Microsoft Entra ID groups accordingly. Automate associating Microsoft Entra ID groups to Azure DevOps groups. Use Azure DevOps Group rules to automatically associate Microsoft Entra ID groups with Azure DevOps groups. Configure group rules to map Microsoft Entra ID groups to project-level Azure DevOps groups and assign the appropriate access level. Consider using default Azure DevOps groups. Avoid creating custom groups unless the default ones do not meet your requirements. Do not modify permissions of the default groups. If you define custom groups, avoid using explicit deny. Delegate management. If users are tasked with managing project-level features such as teams, area and iteration paths, repositories, service hooks, and service endpoints, then consider adding them to the project administrators group. If users are tasked with managing organization-level features such as projects, policies, processes, retention policies, agent and deployment pools, and extension, consider adding them to the project collection administrators group. Review and test permissions. Regularly review and test permissions to ensure that users have the appropriate level of access to resources. Conduct access reviews, audit logs, and security assessments to identify and remediate any security vulnerabilities or misconfigurations. Monitor and audit access. Monitor user activity, track changes, and audit access to Azure DevOps resources using built-in logging and monitoring features. Use Azure DevOps audit streaming and reporting capabilities to monitor user actions, detect unauthorized access attempts, and investigate security incidents. Explore workload identities. Completed 100 XP. 3 minutes. A workload identity is an identity you assign to a software workload, such as an application, service, script, or container, to provide access to protected environments. For example, in order for Azure pipelines or GitHub actions to be able to deploy resources into Azure subscriptions, their individual actions need to establish a security context that would grant them required privileges in these subscriptions. Workload identities provide that security context through their support for authentication and authorization. Microsoft Entra ID offers supports for 3 types of workload identities. Application is a Microsoft Entra ID object that is the global representation of a software application as defined by its developer. This object, created as part of application registration by the developer, determines the mechanism used by the application to issue tokens, the resources the application needs to access, and the actions that the application can take. Service Principal is a Microsoft Entra ID object that is a local representation of a software application. This object gets created when the corresponding application is registered in the Entra tenant where the application will be used. The application object is used as a template to create the corresponding Service Principal object. The Service Principal object defines what the app is permitted to do in the local tenant, what resources the app can access, and who can access the app. Managed Identity is a special type of Service Principal that is associated with an Azure resource in order to allow that resource to authenticate and get authorized on its own. Managed Identity offers additional benefit by eliminating the need to maintain credentials. Instead, the credentials used by Managed Identity are maintained automatically by the platform. Implement Service Principals. The traditional approach to granting Azure pipelines and GitHub Actions access to Azure subscriptions relies on Service Principals. Microsoft Entra Applications. Applications are registered with a Microsoft Entra tenant within Microsoft Entra ID. Registering an application creates an identity configuration. You also determine who can use it. Accounts in the same organizational directory. Accounts in any organizational directory. Accounts in any organizational directory and personal Microsoft accounts. Personal accounts only. Client secret. Once the application is created, you then should create at least one client secret for the application. Grant permissions. The application identity can then be granted permissions within services and resources that trust Microsoft Entra ID, such as those hosted in Azure subscriptions. Service Principal. To access resources, an entity must be represented by a security principal. To connect, the entity must know. Tenant ID. Application ID, also referred to as Client ID. Client secret. For more information on Service Principals, see App Objects and Service Principals. Implement Managed Identities. Completed 100 XP. 2 minutes. Imagine that you need to connect from an Azure Data Factory, ADF, to an Azure SQL database. What identity should ADF present to the database? The traditional answer would have been to use SQL authentication with a username and password. It leaves yet another credential that needs to be managed on an ongoing basis. Identity of the service. Many Azure services expose their own identity. It isn't an identity that you need to manage. For example, you don't need to worry about password policies and so on. You can assign permissions to that identity, as with any other Microsoft Entra identity. In the ADF example, you can add the ADF MSI as an Azure SQL database user and add it to roles within the database. Managed identity types. There are 2 types of managed identities. System assigned, it's the types of identities described above. Many, but not all, services expose these identities. User assigned, you can create a managed identity as an Azure resource. It can then be assigned to one or more instances of a service. For more information, see, what are managed identities for Azure resources? Implement workload identities. Azure pipelines and GitHub Actions support workload identities for access to Azure resources. You can use for this purpose managed identities or service principals. The advantage of using the first of these 2 options is that you can implement it even if you don't have permissions to create service principals or if you're using a different Microsoft Entra tenant than your Azure DevOps user. Azure DevOps facilitates implementing workload identity federation-based service connections by exposing this feature directly in the new service connection interface. There's even the automatic option, which generates the service principal for you and assigns to it permissions to the resource group or subscription that you designate. The manual option requires that you pre-provision a user-assigned managed identity or a service principal with the required permissions. You also need to include in its configuration federated credentials, which you need to specify when setting up the service connection. For Azure pipelines, select the other federation credential scenario. You need to update its issuer and subject identifier settings by referencing the service connection attributes. For more information, refer to use an Azure Resource Manager service connection and set a Resource Manager workload identity service connection. For GitHub Actions, select the GitHub Actions deploying Azure Resources option. In this case, you need to provide your GitHub organization, repository, and the branch containing the workflow YAML file. This will establish a federation trust between the Microsoft Entra ID tenant and the respective DevOps platforms. Once you establish this trust, add the service principals client ID and tenant ID as secrets to the target GitHub repository. Reference the secrets in the workflow to allow its jobs to gain access to the Azure subscription. For more information, refer to Configuring OpenID Connect in Azure. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following level choices do you need to connect your identity provider to GitHub to use SSO? At the organization level. At the project level. At the repository level. 2. Applications are registered with an Azure AD tenant within Azure Active Directory. Registering an application creates an identity configuration. Which of the following choices isn't correct about who can use it? Accounts in the same organizational directory. Azure DevOps groups. Accounts in any organizational directory and Microsoft accounts, personal. 3. Which of the following choices isn't a type of managed identities? Organization assigned. System assigned. User assigned. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module describes the integration with GitHub and Single Sign-On (SSO) for authentication, service principal, and managed service identities. You learned how to describe the benefits and usage of. Integrate Azure DevOps with identity management systems. Integrate GitHub with Single Sign-On (SSO). Understand and create a service principal. Create managed service identities. Learn more. Introduction. Completed 100 XP. 1 minute. This module explores ways to rethink application configuration data and the separation of concerns method. It helps you understand configuration patterns and how to integrate Azure Key Vault with Azure pipelines. Learning objectives. After completing this module, students and professionals can rethink application configuration data. Understand separation of concerns. Integrate Azure Key Vault with Azure pipelines. Manage secrets, tokens, and certificates. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Rethink application configuration data. Completed 100 XP. 4 minutes. Configuration information in files. Most application runtime environments include configuration information that is held in files deployed with the application. In some cases, it's possible to edit these files to change the application behavior after deploying. However, changes to the configuration require the application to be redeployed, often resulting in unacceptable downtime and other administrative overhead. Local configuration files also limit the configuration to a single application, but sometimes it would be helpful to share configuration settings across multiple applications. Examples include database connection strings, UI theme information, or the URLs of queues and storage used by a related set of applications. It's challenging to manage changes to local configurations across multiple running instances of the application, especially in a cloud-hosted scenario. It can result in instances using different configuration settings while the update is being deployed. Also, updates to applications and components might require changes to configuration schemas. Many configuration systems don't support different versions of configuration information. Example. It's 2 a.m. Adam is done making all changes to his super fantastic code piece. The tests are all running fine. They hit commit-push-all commits pushed successfully to Git. Happily, Adam drives back home. 10 minutes later, they get a call from the security ops engineer. Adam, did you push the secret key to our public repo? Yikes. That blah.config file, Adam thinks. How could I have forgotten to include that in .gitignore? The nightmare has already begun. We can surely blame Adam for sinning, checking in sensitive secrets, and not following the recommended practices of managing configuration files. Still, the bigger question is that if the underlying toolchain had abstracted out the configuration management from the developer, this fiasco would have never happened. History. The virus was injected a long time ago. Since the early days of .NET, the app.config and web.config files have the notion that developers can make their code flexible by moving typical configuration into these files. When used effectively, these files are proven to be worthy of dynamic configuration changes. However, much time, we see the misuse of what goes into these files. A common culprit is how samples and documentation have been written. Most samples on the web would usually use these config files to store key elements such as connection strings and even passwords. The values might be obfuscated, but what we are telling developers is that, hey, it's a great place to push your secrets. So, in a world where we're preaching using configuration files, we can't blame the developer for not managing its governance. We aren't challenging the use of configuration here. It's an absolute need for an exemplary implementation. Instead, we should debate using multiple JSON, XML, and YAML files to maintain configuration settings. Configs are great for ensuring the flexibility of the application, config files. However, they aren't straightforward, especially across environments. A ray of hope, the DevOps movement. In recent years, we've seen a shift around following some excellent practices around effective DevOps and some great tools, Chef, Puppet, for managing configuration for different languages. While these have helped inject values during CI/CD pipeline and greatly simplified configuration management, the blah.config concept hasn't moved away. Frameworks like ASP.NET Core support the notion of app settings.json across environments. The framework has made it practical to use across environments through interfaces like iHosting environment and iConfiguration, but we can do better. Explore separation of concerns. Completed 100 XP. 2 minutes. One of the key reasons we would want to move the configuration away from source control is to outline responsibilities. Let's define some roles to elaborate on them. None of those are new concepts, but rather a high-level summary. Configuration custodian, responsible for generating and maintaining the lifecycle of configuration values. These include CRUD on keys, ensuring the security of secrets, regeneration of keys and tokens, defining configuration settings such as log levels for each environment. This role can be owned by operation engineers and security engineering while injecting configuration files through proper DevOps processes and CI/CD implementation. They do not define the actual configuration but are custodians of their management. Configuration consumer, responsible for defining the schema, loose term, for the configuration that needs to be in place and then consuming the configuration values in the application or library code. It's the dev. And test teams shouldn't be concerned about the value of keys but rather what the key's capability is. For example, a developer may need a different connection string in the application but not know the actual value across different environments. Configuration store, the underlying store used to store the configuration. While it can be a simple file, but in a distributed application, it needs to be a reliable store that can work across environments. The store is responsible for persisting values that modify the application's behavior per environment but aren't sensitive and don't require any encryption or HSM modules. Secret store, while you can store configuration and secrets together, it violates our separation of concern principle, so the recommendation is to use a different store for persisting secrets. It allows a secure channel for sensitive configuration data such as connection strings, enables the operations team to have credentials, certificate, token in one repository, and minimizes the security risk if the configuration store gets compromised. Understand external configuration store patterns. Completed 100 XP. 3 minutes. These patterns store the configuration information in an external location and provide an interface that can be used to quickly and efficiently read and update configuration settings. The type of external store depends on the hosting and runtime environment of the application. A cloud-hosted scenario is typically a cloud-based storage service but could be a hosted database or other systems. The backing store you choose for configuration information should have an interface that provides consistent and easy-to-use access. It should expose the information in a correctly typed and structured format. The implementation might also need to authorize users access to protect configuration data and be flexible enough to allow storage of multiple configuration versions, such as development, staging, or production, including many release versions of each one. Many built-in configuration systems read the data when the application starts up and cache the data in memory to provide fast access and minimize the impact on application performance. Depending on the type of backing store used and its latency, it might be helpful to implement a caching mechanism within the external configuration store. For more information, see the caching guidance. The figure illustrates an overview of the external configuration store pattern with optional local cache. This pattern is helpful for configuration settings are shared between multiple applications and application instances, or where a standard configuration must be enforced across various applications and application instances. A standard configuration system doesn't support all the required configuration settings, such as storing images or complex data types. As a complementary store for some application settings, they allow applications to override some or all the centrally stored settings. To simplify the administration of multiple applications and optionally monitor configuration settings by logging some or all types of access to the configuration store. Implement Azure DevOps Secure Files. Completed 100 XP. 3 minutes. Azure DevOps Secure Files allow you to securely store sensitive files, such as code signing certificates, SSH keys, or third-party provisioning profiles within your Azure DevOps organization. These files are encrypted at rest with a 2048-bit RSA key and, as an Azure DevOps protected resource, can only be accessed by authorized users and pipelines. The key is stored in Azure Key Vault, maintained internally by Azure DevOps. They're tightly integrated with Azure DevOps and provide a convenient way to consume sensitive files directly within CI/CD workflows. Access to secure files is managed within Azure DevOps, supporting fine-grained control over who can upload, download, and use them in pipelines and releases. Implementation. Implementing secure files involves uploading the sensitive files to Azure DevOps and then referencing them in your pipelines or releases. Use the following sequence of steps to upload a file to secure files. In the Azure DevOps web portal, navigate to your Azure DevOps project. Navigate to the Pipelines or Releases tab, depending on where you intend to use the secure files. Select Library from the left side navigational menu. Select Secure Files followed by + Secure File to upload a secure file. Select the file you want to upload and provide a descriptive name. Use the following sequence of steps to grant pipeline permissions to the newly created secure file. Select the newly created secure file. On the page displaying the properties of the secure file, select Pipeline Permissions from the toolbar. In the Configure Secure File pane, select the Add Pipeline + button. In the list of the pipelines in the current project, select the pipeline or pipelines that should have access to the secure file. To reference the secure file in a YAML pipeline, you can use the download secure file at one task, as in the following example, which illustrates how to download a secure file storing a certificate and installs it on a Linux system. YAML. Task, download secure file at one name, CA certificate display name, download CA certificate inputs, secure file, my CA certificate.pem script, echo installing $CA certificate.secure file path, sudo chown root $CA certificate.secure file path, sudo chmod a plus or $CA certificate.secure file path, sudo lnst /etc/ssl/cert/$ CA certificate.secure file path. Introduction to Azure App Configuration. Completed 100 XP. 3 minutes. Azure App Configuration is a service for central management of application settings and feature flags. Modern programs include distributed components, each that needs its settings. It's prevalent with microservice-based applications and with serverless applications. Distributed configuration settings can lead to hard-to-troubleshoot deployment errors. Azure App Configuration Service stores all the settings for your application and secures their access in one place. Azure App Configuration Service provides the following features. A fully managed service that can be set up in minutes. Flexible key representations and mappings. Tagging with labels. A point-in-time replay of settings. Dedicated UI for feature flag management. Comparison of two sets of configurations on custom-defined dimensions. Enhanced security through Azure Managed Identities. Complete data encryptions, at rest or in transit. Native integration with popular frameworks. App configuration complements Azure Key Vault, which is used to store application secrets. App configuration makes it easier to implement the following scenarios. Centralized management and distribution of hierarchical configuration data for different environments and geographies. Dynamically change application settings without the need to redeploy or restart an application. Control feature availability in real time. Use app configuration. The easiest way to add an app configuration store to your application is through one of Microsoft's client libraries. Based on the programming language and framework, the following best methods are available to you. Programming language and framework. How to connect. .NET Core and ASP.NET Core. App configuration provider for .NET Core. .NET Framework and ASP.NET. App configuration builder for .NET. Java Spring. App configuration client for Spring Cloud. Others. App configuration REST API. Examine key value pairs. Completed 100 XP. 4 minutes. Azure App Configuration stores configuration data as key value pairs. Keys. Keys serve as the name for key value pairs and are used to store and retrieve corresponding values. It's common to organize keys into a hierarchical namespace by using a character delimiter, such as /or. Use a convention that's best suited for your application. App configuration treats keys as a whole. It doesn't parse keys to figure out how their names are structured or enforce any rule on them. Keys stored in app configuration are case-sensitive, Unicode-based strings. The keys app1 and app1 are distinct in an app configuration store. When you use configuration settings within an application, keep it in mind because some frameworks handle configuration keys case-insensitively. You can use any Unicode character in key names entered into app configuration except for * and \. These characters are reserved. If you need to include a reserved character, you must escape it by using / reserved character. There's a combined size limit of 10,000 characters on a key value pair. This limit includes all characters in the key, its value, and all associated optional attributes. Within this limit, you can have many hierarchical levels for keys. Design key namespaces. There are two general approaches to naming keys used for configuration data, flat or hierarchical. These methods are similar from an application usage standpoint, but hierarchical naming offers several advantages. Easier to read. Instead of one long sequence of characters, delimiters in a hierarchical key name function as spaces in a sentence. Easier to manage. A key name hierarchy represents logical groups of configuration data. Easier to use. It's simpler to write a query that pattern matches keys in a hierarchical structure and retrieves only a portion of configuration data. Below are some examples of how you can structure your key names into a hierarchy. Based on component services. AppName Service 1 API Endpoint AppName Service 2 API Endpoint. Based on deployment regions. AppName Region 1 DB Endpoint AppName Region 2 DB Endpoint. Label keys. Key values in app configuration can optionally have a label attribute. Labels are used to differentiate key values with the same key. A key app1 with labels A and B forms two separate keys in an app configuration store. By default, the label for a key value is empty or null. Label provides a convenient way to create variants of a key. A common use of labels is to specify multiple environments for the same key. Key equals appname, DB endpoint and label equals test key equals appname, DB endpoint and label equals staging key equals appname, DB endpoint and label equals production. Version key values. App configuration doesn't version key values automatically as they're modified. Use labels as a way to create multiple versions of a key value. For example, you can input an application version number or a Git commit ID in labels to identify key values associated with a particular software build. Query key values. Each key value is uniquely identified by its key plus a label that can be null. You query an app configuration store for key values by specifying a pattern. The app configuration store returns all key values that match the pattern and their corresponding values and attributes. Values. Values assigned to keys are also Unicode strings. You can use all Unicode characters for values. There's an optional user-defined content type associated with each value. Use this attribute to store information, for example, an encoding scheme, about a value that helps your application process it properly. Configuration data stored in an app configuration store, which includes all keys and values, is encrypted at rest and in transit. App configuration isn't a replacement solution for Azure Key Vault. Don't store application secrets in it. Examine app configuration feature management. Completed 100 XP. 4 minutes. Feature management is a modern software development practice that decouples feature release from code deployment and enables quick changes to feature availability on demand. Feature flags are discussed in another module, but at this point, it's worth noting that Azure App Configuration Service can be used to store and manage feature flags. It's also known as feature toggles, feature switches, and other names. Basic concepts. Here are several new terms related to feature management. Feature flag. A feature flag is a variable with a binary state of on or off. The feature flag also has an associated code block. The state of the feature flag triggers whether the code block runs or not. Feature manager. A feature manager is an application package that handles the lifecycle of all the feature flags in an application. The feature manager typically provides more functionality, such as caching feature flags and updating their states. Filter. A filter is a rule for evaluating the state of a feature flag. A user group, a device or browser type, a geographic location, and a time window are all examples of what a filter can represent. Effective implementation of feature management consists of at least two components working in concert. An application that makes use of feature flags. A separate repository that stores the feature flags and their current states. How these components interact is illustrated in the following examples. Feature flag usage in code. The basic pattern for implementing feature flags in an application is simple. You can think of a feature flag as a Boolean state variable used with an if conditional statement in your code. C#. If feature flag // run the following code. In this case, if feature flag is set to true, the enclosed code block is executed, otherwise it's skipped. You can set the value of feature flag statically, as in the following code example. C#. Bool feature flag equals true. You can also evaluate the flag state based on certain rules. C#. Bool feature flag equals is beta user. A slightly more complicated feature flag pattern includes an else statement as well. C#. If feature flag // this following code will run if the feature flag value is true, else // this following code will run if the feature flag value is false. Feature flag declaration. Each feature flag has two parts, a name and a list of one or more filters used to evaluate if a feature state is on, that is when its value is true. A filter defines a use case for when a feature should be turned on. When a feature flag has multiple filters, the filter list is traversed until one of the filters determines the feature should be enabled. At that point, the feature flag is on, and any remaining filter results are skipped. If no filter indicates the feature should be enabled, the feature flag is off. The feature manager supports appsettings.json as a configuration source for feature flags. The following example shows how to set up feature flags in a JSON file. JSON. Feature management, feature A, true, // feature flag set to on feature B, false, // feature flag set to off feature C, enabled for name, percentage, parameters, value, 50. Feature flag repository. To use feature flags effectively, you need to externalize all the feature flags used in an application. This approach allows you to change feature flag states without modifying and redeploying the application itself. Azure App Configuration is designed to be a centralized repository for feature flags. You can use it to define different kinds of feature flags and manipulate their states quickly and confidently. You can then use the app configuration libraries for various programming language frameworks to easily access these feature flags from your application. Integrate Azure Key Vault with Azure Pipelines. 1 minute. Applications contain many secrets, such as connection strings, passwords, certificates, tokens, which, if leaked to unauthorized users, can lead to a severe security breach. It can result in severe damage to the organization's reputation and compliance issues with different governing bodies. Azure Key Vault allows you to manage your organization's secrets and certificates in a centralized repository. The secrets and keys are further protected by hardware security modules, HSMs. It also provides versioning of secrets, full traceability, and efficient permission management with access policies. For more information on Azure Key Vault, visit what is Azure Key Vault. Manage secrets, tokens, and certificates. Completed 100 XP. 4 minutes. Azure Key Vault helps solve the following problems. Secrets management. Azure Key Vault can be used to store securely and tightly control access to tokens, passwords, certificates, API keys, and other secrets. Key management. Azure Key Vault can also be used as a key management solution. Azure Key Vault makes it easy to create and control the encryption keys used to encrypt your data. Certificate Management. Azure Key Vault is also a service that lets you easily provision, manage, and deploy public and private secure sockets layer/transport layer security, SSL/TLS, certificates for use with Azure and your internal connected resources. Store secrets backed by hardware security modules. The secrets and keys can be protected by software or FIPS 140-2 Level 2 validates HSMs. Why use Azure Key Vault? Centralize application secrets. Centralizing the storage of application secrets in Azure Key Vault allows you to control their distribution. Key Vault dramatically reduces the chances that secrets may be accidentally leaked. When using Key Vault, application developers no longer need to store security information in their applications. It eliminates the need to make this information part of the code. For example, an application may need to connect to a database. Instead of storing the connection string in the app codes, store it securely in Key Vault. Your applications can securely access the information they need by using URIs that allow them to retrieve specific versions of a secret after the application's key or secret is stored in Azure Key Vault. It happens without having to write custom code to protect any of the secret information. Securely store secrets and keys. Secrets and keys are safeguarded by Azure using industry-standard algorithms, key lengths, and hardware security modules, HSMs. The HSMs used are Federal Information Processing Standards, FIPS, 140-2 Level 2 validated. Access to a Key Vault requires proper authentication and authorization before a caller, user, or application can get access. Authentication establishes the identity of the caller, while authorization determines the operations that they can do. Authentication is done via Azure Active Directory. Authorization may be done via Role-Based Access Control, RBAC, or Key Vault Access Policy. RBAC is used when dealing with the management of the vaults, and a Key Vault Access Policy is used when attempting to access data stored in a vault. Azure Key Vaults may be either software or hardware HSM protected. You can import or generate keys in hardware security modules, HSMs, that never leave the HSM boundary when you require added assurance. Microsoft uses Thales hardware security modules. You can use Thales tools to move a key from your HSM to Azure Key Vault. Finally, Azure Key Vault is designed so that Microsoft doesn't see or extract your data. Monitor access and use. Once you've created a couple of Key Vaults, you'll want to monitor how and when your keys and secrets are accessed. You can do it by enabling logging for Key Vault. You can configure Azure Key Vault to archive to a storage account, stream to an event hubs, send the logs to Log Analytics. You have control over your logs, and you may secure them by restricting access, and you may also delete logs that you no longer need. Simplified administration of application secrets. When storing valuable data, you must take several steps. Security information must be secured. It must follow a lifecycle. It must be highly available. Azure Key Vault simplifies it by removing the need for in-house knowledge of hardware security modules, scaling up on short notice to meet your organization's usage spikes, replicating the contents of your Key Vault within a region and to a secondary region. It ensures high availability and takes away the need for any action from the administrator to trigger the failover. Providing standard Azure administration options via the portal, Azure CLI, and PowerShell. Automating specific tasks on certificates that you purchase from public CAs, such as enrollment and renewal. Also, Azure Key Vaults allow you to segregate application secrets. Applications may access only the vault they can access, and they can only do specific operations. You can create an Azure Key Vault per application and restrict the secrets stored in a Key Vault to a particular application and team of developers. Integrate with other Azure services. As a secure store in Azure, Key Vault has been used to simplify scenarios like Azure Disk Encryption, the always encrypted functionality in SQL Server and Azure SQL Database, Azure Web Apps. Key Vault itself can integrate with storage accounts, event hubs, and log analytics. Examine DevOps inner and outer loop. Completed 100 XP. 2 minutes. While you can store configuration and secrets together, it violates our separation of concern principle, so the recommendation is to use a different store for persisting secrets. It allows a secure channel for sensitive configuration data, such as connection strings. It enables the operations team to have credentials, certificates, and tokens in one repository and minimizes the security risk if the configuration store gets compromised. The following diagram shows how these roles play together in a DevOps inner and outer loop. The inner loop is focused on the developer teams iterating over their solution development. They consume the configuration published by the outer loop. The ops engineer governs the configuration management. They push changes into Azure Key Vault and Kubernetes that are further isolated per environment. Integrate Azure Key Vault with Azure DevOps. Completed 100 XP. 40 minutes. Estimated time, 40 minutes. Scenario. Azure Key Vault provides secure storage and management of sensitive data, such as keys, passwords, and certificates. Azure Key Vault includes support for hardware security modules and a range of encryption algorithms and key lengths. Using Azure Key Vault can minimize the possibility of disclosing sensitive data through source code, a common mistake developers make. Access to Azure Key Vault requires proper authentication and authorization, supporting fine-grained permissions to its content. In this lab, you see how you can integrate Azure Key Vault with an Azure pipeline by using the following steps. Create an Azure Key Vault to store an ACR password as a secret. Create a service principal to access Azure Key Vault secrets. Configure permissions to allow the service principal to read the secret. Configure the pipeline to retrieve the password from the Azure Key Vault and pass it on to subsequent tasks. Objectives. After completing this lab, you'll be able to create a Microsoft Entra ID service principal. Create an Azure Key Vault. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Identify an existing Azure subscription or create a new one. Verify that you have a Microsoft account or Microsoft Entra account with the owner role in the Azure subscription and the global administrator role associated with the Azure subscription. For details, refer to List Azure role assignments using the Azure portal and view and assign administrator roles in Microsoft Entra ID. Exercises. During this lab, you complete the following exercises. Exercise 0. Configure the lab prerequisites. Exercise 1. Set up CI pipeline to build eShop on web container. Exercise 2. Remove the Azure Lab resources. Enable dynamic configuration and feature flags. Completed 100 XP. 60 minutes. Estimated time, 60 minutes. Scenario. Azure App Configuration provides a service to manage application settings and feature flags centrally. Modern programs, especially those running in a cloud, generally have many distributed components. Spreading configuration settings across these components can lead to hard-to-troubleshoot errors during application deployment. Use app configuration to store all the settings for your application and secure their accesses in one place. Objectives. After completing this lab, you'll be able to enable dynamic configuration. Manage feature flags. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Identify an existing Azure subscription or create a new one. Verify that you have a Microsoft account or Microsoft Entra with the contributor or the owner role in the Azure subscription. For details, refer to List Azure role assignments using the Azure portal and view and assign administrator roles in Microsoft Entra ID. Exercises. During this lab, you'll complete the following exercises. Exercise 0. Configure the lab prerequisites. Exercise 1. Import and run CI/CD pipelines. Exercise 2. Manage Azure App Configuration. Exercise 3. Remove the Azure Lab resources. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following roles is responsible for generating and maintaining the lifecycle of configuration values? Configuration custodian. Configuration consumer. Developer. 2. Which of the following choices enables applications to have no direct access to the secrets, which helps improve the security and control? Library. Azure Key Vault. Azure Pipelines. 3. Which of the following choices isn't a benefit of Azure Key Vault? Code secure files. Certificate management. Secrets management. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explored ways to rethink application configuration data and the separation of concerns method. It helped you understand configuration patterns and how to integrate Azure Key Vault with Azure Pipelines. You learned how to describe the benefits and usage of rethink application configuration data. Understand separation of concerns. Integrate Azure Key Vault with Azure Pipelines. Manage secrets, tokens, and certificates. Learn more. Introduction. Completed 100 XP. 2 minutes. Infrastructure as code, IAC, doesn't quite trip off the tongue, and its meaning isn't always straightforward. But IAC has been with us since the beginning of DevOps, and some experts say DevOps wouldn't be possible without it. As the name suggests, infrastructure as code is the concept of managing your operations environment like you do applications or other code for general release. Rather than manually making configuration changes or using one-off scripts to make infrastructure changes, the operations infrastructure is managed instead using the same rules and strictures that govern code development, particularly when new server instances are spun up. That means that the core best practices of DevOps, like version control, virtualized tests, and continuous monitoring, are applied to the underlying code that governs the creation and management of your infrastructure. In other words, your infrastructure is treated the same way that any other code would be. The elasticity of the cloud paradigm and the disposability of cloud machines can only be used by applying the principles of infrastructure as code to all your infrastructure. This module describes key concepts of infrastructure as code and environment deployment creation and configuration. Also, understand the imperative, declarative, and idempotent configuration and how it applies to your company. Learning objectives. After completing this module, students and professionals can understand how to deploy your environment. Plan your environment configuration. Choose between imperative versus declarative configuration. Explain idempotent configuration. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Explore environment deployment. Completed 100 XP. 3 minutes. Suppose you've ever received a middle-of-the-night emergency support call because of a crashed server. In that case, you know the pain of searching through multiple spreadsheets or even your memory to access the manual steps of setting up a new machine. Then there's also the difficulty of keeping the development and production environments consistent. An easier way to remove the possibility of human error when initializing machines is to use infrastructure as code. Manual deployment versus infrastructure as code. A common analogy for understanding the differences between manual deployment and infrastructure as code is the distinction between owning pets and owning cattle. When you have pets, you name each one and regard them as individuals. If something terrible happens to one of your pets, you're inclined to care a lot. If you have a herd of cattle, you might still name them, but you consider their herd. In infrastructure terms, there might be severe implications with a manual deployment approach if a single machine crashes and you need to replace it, pets. If you adopt infrastructure as a code approach, you can more easily provision another machine without adversely impacting your entire infrastructure, cattle, if a single machine goes down. Implementing infrastructure as code. With infrastructure as code, you capture your environment or environments in a text file, script, or definition. Your file might include any networks, servers, and other computing resources. You can check the script or definition file into version control and then use it as the source for updating existing environments or creating new ones. For example, you can add a new server by editing the text file and running the release pipeline rather than remoting it into the environment and manually provisioning a new server. The following table lists the significant differences between manual deployment and infrastructure as code. Manual deployment. Infrastructure as code. Snowflake servers. A consistent server between environments. Deployment steps vary by environment. Environments are created or scaled easily. More verification steps and more elaborate manual processes. Fully automated creation of environment updates. Increased documentation to account for differences. Transition to immutable infrastructure. Deployment on weekends to allow time to recover from errors. Use blue/green deployments. Slower release cadence to minimize pain and long weekends. Treat servers as cattle, not pets. Master Minos. Benefits of infrastructure as code. The following list is benefits of infrastructure as code. Promotes auditing by making it easier to trace what was deployed, when, and how. In other words, it improves traceability. Provides consistent environments from release to release. Greater consistency across development, test, and production environments. Automates scale-up and scale-out processes. Allows configurations to be version controlled. Provides code review and unit testing capabilities to help manage infrastructure changes. Uses immutable service processes, meaning if a change is needed to an environment, a new service is deployed, and the old one was taken down, it isn't updated. Allows blue/green deployments. This release methodology minimizes downtime where two identical environments exist, one is live, and the other isn't. Updates are applied to the server that isn't live. When testing is verified and complete, it's swapped with the different live servers. It becomes the new live environment, and the previous live environment is no longer the live. Treats infrastructure as a flexible resource that can be provisioned, deprovisioned, and reprovisioned as and when needed. Examine environment configuration. Completed 100 XP. 3 minutes. Configuration management refers to automated configuration management, typically in version-controlled scripts, for an application and all the environments needed to support it. Configuration management means lighter-weight, executable configurations that allow us to have configuration and environments as code. For example, adding a new port to a firewall could be done by editing a text file and running the release pipeline, not by remoting into the environment and manually adding the port. Note: the term configuration as code can also be used to mean configuration management. However, it isn't used as widely, and in some cases, infrastructure as code is used to describe both provisioning and configuring machines. The term infrastructure as code is also sometimes used to include configuration as code, but not vice versa. Manual configuration versus configuration as code. Manually managing the configuration of a single application and environment can be challenging. The challenges are even more significant for managing multiple applications and environments across multiple servers. Automated configuration, or treating configuration as code, can help with some of the manual configuration difficulties. The following table lists the significant differences between manual configuration and configuration as code. Manual configuration. Configuration as code. Configuration bugs are challenging to identify. Bugs are easily reproducible. Error-prone. Consistent configuration. More verification steps and more elaborate manual processes. Increased deployment cadence to reduce the amount of incremental change. Increased documentation. Treat environment and configuration as executable documentation. Deployment on weekends to allow time to recover from errors. Slower release cadence to minimize the requirement for long weekends. Master Minos. Benefits of configuration management. The following list is benefits of configuration management. Bugs are more easily reproduced, audit help, and improve traceability. Provides consistency across environments such as dev, test, and release. It increased deployment cadence. Less documentation is needed and needs to be maintained as all configuration is available in scripts. Enables automated scale-up and scale-out. Allows version-controlled configuration. Helps detect and correct configuration drift. Provides code review and unit testing capabilities to help manage infrastructure changes. Treats infrastructure as a flexible resource. Promotes automation. Understand imperative versus declarative configuration. Completed 100 XP. 3 minutes. There are a few different approaches that you can adopt to implement infrastructure as code and configuration as code. Two of the main methods of approach are declarative, functional. The declarative approach states what the final state should be. When run, the script or definition will initialize or configure the machine to have the finished state declared without defining how that final state should be achieved. Imperative, procedural. In the imperative approach, the script states the how for the final state of the machine by executing the steps to get to the finished state. It defines what the final state needs to be, but also includes how to achieve that final state. It also can consist of coding concepts such as for, if-then, loops, and matrices. Best practices. The declarative approach abstracts away the methodology of how a state is achieved. As such, it can be easier to read and understand what is being done. It also makes it easier to write and define. Declarative approaches also separate the final desired state and the coding required to achieve that state. So, it doesn't force you to use a particular approach, allowing for optimization. A declarative approach would generally be the preferred option where ease of use is the primary goal. Azure Resource Manager template files are an example of a declarative automation approach. An imperative approach may have some advantages in complex scenarios where changes in the environment occur relatively frequently, which need to be accounted for in your code. There's no absolute on which is the best approach to take, and individual tools may be used in either declarative or imperative forms. The best approach for you to take will depend on your needs. Understand idempotent configuration. Completed 100 XP. 3 minutes. Idempotence is a mathematical term that can be used in infrastructure as code and configuration as code. It can apply one or more operations against a resource, resulting in the same outcome. For example, running a script on a system should have the same outcome despite the number of times you execute the script. It shouldn't error out or do the same actions irrespective of the environment's starting state. In essence, if you apply a deployment to a set of resources 1,000 times, you should end up with the same result after each application of the script or template. You can achieve idempotency by automatically configuring and reconfiguring an existing set of resources, discarding the existing resources and recreating a new environment. When defining infrastructure as code and configuration as code, as a best practice, build the scripts and templates in such a way as to embrace idempotency. It's essential when working with cloud services because resources and applications can be scaled in and out regularly. New instances of services can be started up to provide service elasticity. Note: you can read more about idempotence at idempotency for Windows Azure Message Queues. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices represents when using this approach the methodology of how a state is achieved is abstracted away? Declarative. Imperative. Exclamatory. 2. Which of the following choices defines the ability to apply one or more operations against a resource, resulting in the same outcome every time? Increment. Idempotence. Configuration drift. 3. Which of the following choices is a benefit of infrastructure as code? Treats infrastructure as a flexible resource that can be provisioned, deprovisioned, and reprovisioned as and when needed. Uses mutable service processes. Manual scale up and scale out. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described key infrastructure concepts as code and environment deployment creation and configuration and explored imperative, declarative, and idempotent configuration and how it applies to your company. You learned how to describe the benefits and usage of. Understand how to deploy your environment. Plan your environment configuration. Choose between imperative versus declarative configuration. Explain idempotent configuration. Learn more. Introduction. Completed 100 XP. 5 minutes. This module explores Azure Resource Manager templates and their components and details dependencies and modularized templates with secrets. Learning objectives. After completing this module, students and professionals can create Azure resources using Azure Resource Manager templates. Understand Azure Resource Manager templates and template components. Manage dependencies and secrets in templates. Organize and modularize templates. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Why use Azure Resource Manager templates? Completed 100 XP. 3 minutes. Using Resource Manager templates will make your deployments faster and more repeatable. For example, you no longer must create a VM in the portal, wait for it to finish, and then create the next VM. The Resource Manager takes care of the entire deployment for you. Here are some other template benefits to consider. Templates improve consistency. Resource Manager templates provide a common language for you and others to describe your deployments. Despite the tool or SDK that you use to deploy the template structure, format, and expressions remain the same. Templates help express complex deployments. Templates enable you to deploy multiple resources in the correct order. For example, you wouldn't want to deploy a VM before creating an operating system, OS, disk, or network interface. Resource Manager maps out each resource and its dependent resources and creates dependent resources first. Dependency mapping helps ensure that the deployment is carried out in the correct order. Templates reduce manual, error-prone tasks. Manually creating and connecting resources can be time-consuming, and it's easy to make mistakes. The Resource Manager ensures that the deployment happens the same way every time. Templates are code. Templates express your requirements through code. Think of a template as a type of infrastructure as code that can be shared, tested, and versioned like any other piece of software. Also, because templates are code, you can create a record that you can follow. The template code documents the deployment. Also, most users maintain their templates under revision control, such as Git. Its revision history also records how the template and your deployment has evolved when you change the template. Templates promote reuse. Your template can contain parameters that are filled in when the template runs. A parameter can define a username or password, a domain name, and other necessary items. Template parameters also enable you to create multiple versions of your infrastructure, such as staging and production, while still using the same template. Templates are linkable. You can link Resource Manager templates together to make the templates themselves modular. You can write small templates that define a solution and then combine them to create a complete system. Azure provides many quick start templates. You might use it as a base for your work. Explore template components. Completed 100 XP. 4 minutes. Azure Resource Manager templates are written in JSON, which allows you to express data stored as an object, such as a virtual machine, in text. A JSON document is essentially a collection of key-value pairs. Each key is a string that values can be a string, a number, a Boolean expression, a list of values, an object, which is a collection of other key-value pairs. A Resource Manager template can contain sections that are expressed using JSON notation but aren't related to the JSON language itself. JSON. $schema, http://schema.management.azure.com/schemas/2015-01-01-deployment template.json #sign, content version, parameters, variables, functions, resources, outputs. Let's review each of these sections in a little more detail. Parameters. This section is where you specify which values are configurable when the template runs. For example, you might allow template users to set a username, password, or domain name. Here's an example that illustrates two parameters, one for a virtual machine's, VM's, username and one for its password. JSON. Parameters, admin username, type, string, metadata, description, username for the virtual machine. Admin password, type, secure string, metadata, description, password for the virtual machine. Variables. This section is where you define values that are used throughout the template. Variables can help make your templates easier to maintain. For example, you might define a storage account name one time as a variable and then use that variable throughout the template. If the storage account name changes, you need only update the variable once. Here's an example that illustrates a few variables that describe networking features for a VM. JSON. Variables, nickname, myVMNick, address prefix, 10.0.0.0.0/16, subnet name, subnet prefix, 10.0.0.0.0/24, public IP address name, my public IP, virtual network name, myVNet. Functions. This section is where you define procedures that you don't want to repeat throughout the template. Like variables, functions can help make your templates easier to maintain. Here's an example that creates a function for creating a unique name to use when creating resources that have globally unique naming requirements. JSON. Functions, namespace, contoso, members, unique name, parameters, name prefix, type, string, output, type, string, value, concat, to lower, parameters, name prefix, unique string, resource group, .id. Resources. This section is where you define the Azure resources that make up your deployment. Here's an example that creates a public IP address resource. JSON. Type, Microsoft network/public IP addresses, name, variables, public IP address name, location, parameters, location, API version, August 1st, 2018, properties, public IP allocation method, dynamic, DNS settings, domain name label, parameters, DNS label prefix. Here, the type of resource is Microsoft network/public IP addresses. The name is read from the variables section, and the location, or Azure region, is read from the parameters section. Because resource types can change over time, API version refers to the version of the resource type you want to use. As resource types evolve, you can modify your templates to work with the latest features. Outputs. This section is where you define any information you'd like to receive when the template runs. For example, you might want to receive your VM's IP address or fully qualified domain name, FQDN, the information you won't know until the deployment runs. Here's an example that illustrates an output named hostname. The FQDN value is read from the VM's public IP address settings. JSON. Outputs, hostname, type, string, value, reference, variables, public IP address name, .dns settings, .fqdn. Manage dependencies. Completed 100 XP. 3 minutes. For any given resource, other resources might need to exist before you can deploy the resource. For example, a Microsoft SQL Server must exist before attempting to deploy a SQL database. You can define this relationship by marking one resource as dependent on the other. You define a dependency with the depends on element or by using the reference function. Resource Manager evaluates the dependencies between resources and deploys them in their dependent order. When resources aren't dependent on each other, the Resource Manager deploys them in parallel. You only need to define dependencies for resources that are deployed in the same template. The depends on element. Within your template, the depends on element enables you to define one resource dependent on one or more other resources. Its value can be a comma-separated list of resource names. Circular dependencies. A circular dependency is a problem with dependency sequencing, resulting in the deployment going around in a loop and unable to continue. As a result, the Resource Manager can't deploy the resources. Resource Manager identifies circular dependencies during template validation. If you receive an error stating that a circular dependency exists, evaluate your template to find whether any dependencies are unnecessary and can be removed. If removing dependencies doesn't resolve the issue, you can move some deployment operations into child resources that are deployed after the resources with the circular dependency. Modularized templates. Completed 100 XP. 4 minutes. When using Azure Resource Manager templates, it's best to modularize them by breaking them into individual components. The primary methodology to use is by using linked templates. It allows you to break the solution into targeted components and reuse those various elements across different deployments. Linked template. Add a deployment resource to your main template to link one template to another. JSON. Resources, API version, May 10, 2017, name, linked template, type, Microsoft Resources/deployments, properties, mode, incremental, link to external template. Nested template. You can also nest a template within the main template, use the template property, and specify the template syntax. It does somewhat aid modularization, but dividing up the various components can result in a sizable main file, as all the elements are within that single file. JSON. Resources, API version, May 10, 2017, name, nested template, type, Microsoft Resources/deployments, properties, mode, incremental, template, $schema, https://schema.management.azure.com/schemas/2015-01-01-deployment template.json #, content version, 1.0.0.0, resources, type, Microsoft storage/storage accounts, name, variables, storage name. API version, June 15, 2015, location, West US, properties, account type, standard_LRS. Note: you can't use parameters or variables defined within the nested template itself for nested templates. You can only use parameters and variables from the main template. The properties you provide for the deployment resource will vary based on linking to an external template or nesting an inline template within the main template. Deployments modes. When deploying your resources using templates, you have 3 options. Validate. This option compiles the templates, validates the deployment, ensures the template is functional, for example, no circular dependencies, and correct syntax. Incremental mode, default. This option only deploys whatever is defined in the template. It doesn't remove or modify any resources that aren't defined in the template. For example, if you've deployed a VM via template and then renamed the VM in the template, the first VM deployed will remain after the template is rerun. It's the default mode. Complete mode, Resource Manager deletes resources that exist in the resource group but isn't specified in the template. For example, only resources defined in the template will be present in the resource group after the template deploys. As a best practice, use this mode for production environments to achieve idempotency in your deployment templates. When deploying with PowerShell, to set the deployment mode, use the mode parameter, as per the nested template example earlier in this topic. Note: as a best practice, use one resource group per deployment. Note: you can only use incremental deployment mode for both linked and nested templates. External template and external parameters. To link to an external template and parameter file, use template link and parameters link. When linking to a template, ensure that the Resource Manager service can access it. For example, you can't specify a local file or a file only available on your local network. You can only provide a Uniform Resource Identifier, URI, value that includes HTTP or HTTPS. One option is to place your linked template in a storage account and use the URI for that item. You can also provide the parameter inline. However, you can't use both inline parameters and a link to a parameter file. The following example uses the template link parameter. JSON. Resources, name, link template, type, Microsoft Resources/deployments, API version, May 1, 2018, properties, mode, incremental, template link, URI://https://linked template teak1store.blog.core.windows.net/link templates/link storage account.json. SB equals 2018-03-28 and SR equals B and SIG equals do 9P7XNBHGQ56BO. %2BSW309TX7E2WUD8% 2BPF1MTK2Fs% 3D and SE equals 2018-12-31T14% 3A32%. 3A29Z and SP equals R. Parameters. Storage account name : value, variables, storage account name, location : value, parameters, location. Securing an external template. Although the linked template must be available externally, it doesn't need to be made available to the public. Instead, you can add your template to a private storage account accessible to only the storage account owner, creating shared access signature (SAS) tokens to enable access during deployment. You add that SAS token to the URI for the linked template. Even though the token is passed in as a secure string, the linked template's URI, including the SAS token, is logged in the deployment operations. To limit exposure, you can also set an expiration date for the token. Manage secrets in templates. Completed 100 XP. 4 minutes. When passing a secure value, such as a password, as a parameter during deployment, you can retrieve the value from an Azure Key Vault. Reference the Key Vault and secret in your parameter file. The value is never exposed because you only reference its Key Vault ID. The Key Vault can exist in a different subscription than the resource group you're deploying it to. Deploy a Key Vault in secret. To create a Key Vault in secret, use either Azure CLI or PowerShell. To access the secrets inside this Key Vault from a Resource Manager deployment, the Key Vault property enabled for template deployment must be true. Using Azure CLI. The following code snippet is an example of how you can deploy a Key Vault in secret using Azure CLI. PowerShell. Key Vault name equals your unique vault name, resource group name equals your resource group name, location equals centralist user principal name equals your email address associated with your subscription, hashtag create a resource group AZ group, create name $resource group name location $location, hashtag create a Key Vault AZ Key Vault, create \name $Key Vault name \resource group name \location $location, enabled for template deployment, true AZ Key Vault set policy UPN user principal name. Name $Key Vault name secret permissions set delete get list hashtag create a secret with the name VM admin password equals $o pencil rand base 6432 echo $password AZ Key Vault secret set vault name $Key Vault name VM admin password value $password. Enable access to the secret. Other than setting the Key Vault property enabled for template deployment to true, the user deploying the template must have Microsoft.keyvault/vault/deploy/action permission for the Key Vault scope, also including the resource group and Key Vault. The owner and contributor roles both grant this access. If you create the Key Vault, you're the owner, so you inherently have permission. However, if the Key Vault is under a different subscription, the owner of the Key Vault must grant access. Reference a secret with static ID. The Key Vault is referenced in the parameter file and not the template. The following image shows how the parameter file references the secret and passes that value to the template. The following template deploys in SQL database that includes an administrator password. The password parameter is set to a secure string. However, the template doesn't specify where that value comes from. JSON. $schema, https://schema.management.azure.com/schemas/2015-01-01/deployment template.json #sign, content version 1.0.0.0, parameters, admin login, type, string, admin password, type, secure string, SQL server name, type, string, resources, name, parameters, SQL server name, type, Microsoft, SQL/servers, API version, 2015-05-01 preview, location, resource group. Location, tags, properties, administrator login, parameters, admin login, administrator login password, parameters, admin password, version 12.0, outputs. Now you can create a parameter file for the preceding template. In the parameter file, specify a parameter that matches the parameter's name in the template. For the parameter value, reference the secret from the Key Vault. You reference the secret by passing the resource identifier of the Key Vault and the secret's name. The Key Vault secret must already exist in the following parameter file, and you provide a static value for its resource ID. Copy this file locally and set the subscription ID, vault name, and SQL server name. JSON. $schema, https://schema.management.azure.com/schemas/2015-01-01/deployment parameters.json #sign, content version 1.0.0.0, parameters, admin login, value, example admin password, reference, Key Vault ID, /subscription/subscription ID, /resource groups, /example group, /providers, /microsoft.keyvault/vault/vault name, secret name. Example secret, SQL server name, value, your server name. You would need to deploy the template and pass the parameter file to the template. For more information, use Azure Key Vault to pass secure parameter values during deployment for more details. There are also details on this webpage for reference to a secret with a dynamic ID. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select check your answers. Check your knowledge. 1. Which of the following choices are the deployment modes available when using Azure Resource Manager templates? Transactional, complete. Incremental, complete. Differential, validate. 2. Which of the following choices isn't a component or section of an Azure Resource Manager template? Outputs. Functions. Secrets. 3. Which of the following choices is an element that enables you to define one resource as dependent on one or more other resources? Template. Properties. Depends on. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explores Azure Resource Manager templates and their components and details dependencies and modularized templates with secrets. You learned how to describe the benefits and usage of. Create Azure resources using Azure Resource Manager templates. Understand Azure Resource Manager templates and template components. Manage dependencies and secrets in templates. Organize and modularize templates. Learn more. Introduction. Completed 100 XP. 1 minute. This module explains Azure CLI to create Azure resources, run templates, and detail Azure CLI commands. Learning objectives. After completing this module, students and professionals can create Azure resources using Azure CLI. Understand and work with Azure CLI. Run templates using Azure CLI. Explains Azure CLI commands. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. You need to create an Azure DevOps organization and a team project for some exercises. If you don't have it yet, see, create an organization Azure DevOps. What is Azure CLI? Completed 100 XP. 3 minutes. Azure CLI is a command line program you use to connect to Azure and execute administrative commands on Azure resources. It runs on Linux, Mac OS, and Windows operating systems. Instead of a web browser, it allows administrators and developers to execute their commands through a terminal or a command line prompt or script. For example, to restart a VM, you would use a command such as Azure CLI AZ-VM restart gMyResourceGroup and MyVM. Azure CLI provides cross-platform command line tools for managing Azure resources. You can install it locally on computers running the Linux, Mac OS, or Windows operating systems. You can also use Azure CLI from a browser through Azure Cloud Shell. In both cases, you can use Azure CLI interactively or through scripts. Interactive. For Windows operating systems, launch a shell such as Command .exe, or for Linux or Mac OS, use bash. Then issue the command at the shell prompt. Scripted. Assemble the Azure CLI commands into a shell script using the script syntax of your chosen shell, and then execute the script. Work with Azure CLI. Completed 100 XP. 4 minutes. Azure CLI lets you control nearly every aspect of every Azure resource. You can work with Azure resources such as resource groups, storage, VMs, Azure Active Directory, containers, and machine learning. Commands in the CLI are structured in groups and subgroups. Each group represents a service provided by Azure, and the subgroups divide commands for these services into logical groupings. So, how do you find the commands you need? One way is to use the AZ find command. For example, if you want to find commands that might help you manage a storage blob, you can use the following find command. Azure CLI AZ find blob. If you know the command's name you want, the help argument for that command will get you more detailed information on the command, also, a list of the available subcommands for a command group. For example, here's how you would get a list of the subgroups and commands for managing blob storage. Azure CLI AZ storage blob help. Creating resources. When creating a new Azure resource, typically, there are 3 high-level steps. Connect to your Azure subscription. Create the resource. Verify that creation was successful. 1. Connect. Because you're working with a local Azure CLI installation, you'll need to authenticate before you can execute Azure commands. You do it by using the Azure CLI login command. Azure CLI AZ login. Azure CLI will typically launch your default browser to open the Azure sign-in page. If it doesn't work, follow the command line instructions and enter an authorization code in the Enter Code dialog box. After a successful sign-in, you'll be connected to your Azure subscription. 2. Create. You'll often need to create a new resource group before you create a new Azure service. So we'll use resource groups as an example to show how to create Azure resources from the Azure CLI. The Azure CLI group create command creates a resource group. You need to specify a name and location. The name parameter must be unique within your subscription. The location parameter determines where the metadata for your resource group will be stored. You use strings like West US, North Europe, or West India to specify the location. Instead, you can use single-word equivalents such as Westus, North Europe, or West India. The core syntax to create a resource group is Azure CLI AZ group create name location. 3. Verify installation. For many Azure resources, Azure CLI provides a list subcommand to get resource details. For example, the Azure CLI group list command lists your Azure resource groups. It's helpful to verify whether resource group creation was successful. Azure CLI AZ group list. To get more concise information, you can format the output as a simple table. Azure CLI AZ group list output table. If you have several items in the group list, you can filter the return values by adding a query option using, for example, the following command. Azure CLI AZ group list query, name equals RG name. Note: you format the query using JMES path, which is a standard query language for JSON requests. You can learn more about this filter language at http://jmespath.org. Using Azure CLI in scripts. To use Azure CLI commands and scripts, you'll need to be aware of any issues around the shell or environment you use to run the script. For example, in a bash shell, you can use the following syntax when setting variables. Azure CLI variable equals value, variable equals integer. If you use a PowerShell environment for running Azure CLI scripts, you'll need to use the following syntax for variables. PowerShell $variable equals value, $variable equals integer. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select check your answers. Check your knowledge. 1. Which of the following choices can you use to get a list of VM using Azure CLI? List VM. AZ VM list. Get AZ VM. 2. Which of the following choices can you use to create a resource group using Azure CLI? AZ group create. AZ creates group. AZ deployment group create. 3. Which of the following choices is a valid syntax for string variables if you want to use Azure CLI commands in PowerShell? Variable equals value. Variable equals value. $variable equals value. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explained Azure CLI to create Azure resources, run templates, and detailed Azure CLI commands. You learned how to describe the benefits and usage of. Create Azure resources using Azure CLI. Understand and work with Azure CLI. Run templates using Azure CLI. Explains Azure CLI commands. Learn more. Introduction. Completed 100 XP. 4 minutes. Manually executing environment provisioning and configuration management is both laborious and error-prone. Microsoft Azure DevOps advocates automation to reduce the probability of errors introduced through manual execution. Automation also delivers the added advantage of completing the work more quickly without relying on subject experts. Microsoft Azure is built to support automation from the ground up. Azure Automation is an Azure service that provides a way for users to automate the manual, long-running, error-prone, and frequently repeated tasks commonly done in a cloud and enterprise environment. Azure Automation saves time and increases the reliability of regular administrative tasks. You can even schedule the tasks to be executed automatically at regular intervals. You can automate processes using runbooks or automate configuration management by using desired state configuration, DSC. For more information about Azure Automation, review an introduction to Azure Automation. Azure Automation isn't the only way to automate within Azure. You can also use open source tools to do some of these operations. However, the integration hooks available to Azure Automation remove much of the integration complexity you would have to manage if you did these operations manually. Some Azure Automation capabilities are: Process Automation. Azure Automation provides you with the ability to automate frequent, time-consuming, and error-prone cloud management tasks. Azure Automation State Configuration is an Azure service that allows you to write, manage, and compile Windows PowerShell DSC configurations, import DSC resources, and assign configurations to target nodes, all in the cloud. For more information, visit Azure Automation State Configuration Overview. Azure Update Manager. Manage operating system updates for Windows and Linux computers in Azure, on-premises environments, or other cloud providers. Get update compliance visibility across Azure, on-premises, and for other cloud services. You can create scheduled deployments to orchestrate update installations within a defined maintenance window. For more information, visit Azure Update Manager. Integration with GitHub, Azure DevOps, Git, or Team Foundation version control repositories. For more information, go to Source Control Integration in Azure Automation. Automate Amazon Web Services, AWS, resources. Automate common tasks with resources in AWS using automation runbooks in Azure. For more information, go to Authenticate Runbooks with Amazon Web Services. Manage shared resources. Azure Automation consists of a set of shared resources, such as connections, credentials, modules, schedules, and variables, that make it easier to automate and configure your environments at scale. Run backups. Azure Automation allows you to run regular backups of non-database systems, such as backing up Azure Blob Storage at certain intervals. Azure Automation works across hybrid cloud environments in addition to Windows and Linux operating systems. This module describes Azure Automation with Azure DevOps, using runbooks, webhooks, and PowerShell workflows. You'll learn how to create and manage automation for your environment. Learning objectives. After completing this module, students and professionals can Implement automation with Azure DevOps. Create and manage runbooks. Create webhooks. Create and run a workflow runbook and PowerShell workflows. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Create automation accounts. Completed 100 XP. 4 minutes. To start using the Microsoft Azure Automation Service, you must create an automation account from within the Azure portal. Steps to create an Azure Automation account are available on the Create an Azure Automation Account page. Automation accounts are like Azure storage accounts, serving as a container to store automation artifacts. These artifacts could be a container for all your runbooks, runbook executions, jobs, and the assets on which your runbooks depend. An automation account allows you to manage all Azure resources via an API. To safeguard it, the automation account creation requires subscription owner access. You must be a subscription owner to create the run as accounts that the service creates. If you don't have the proper subscription privileges, you'll see the following warning. You'll need at least one Azure Automation account to use Azure Automation. However, as a best practice, you should create multiple automation accounts to segregate and limit the scope of access and minimize any risk to your organization. For example, you might use one account for development, another for production, and another for your on-premises environment. You can have up to 30 automation accounts. What is a runbook? Completed 100 XP. 4 minutes. Runbooks serve as repositories for your custom scripts and workflows. They also typically reference automation shared resources such as credentials, variables, connections, and certificates. Runbooks can also contain other runbooks, allowing you to build more complex workflows. You can invoke and run runbooks on demand or according to a schedule using automation schedule assets. Creating runbooks. When creating runbooks, you have two options. You can either create your runbook and import it. For more information about creating or importing a runbook in Azure Automation, go to Start a Runbook in Azure Automation. Modify runbooks from the Runbook Gallery. It provides a rich ecosystem of runbooks that are available for your requirements. Visit Runbook and Module Galleries for Azure Automation for more information. A vibrant open source community also creates runbooks you can apply directly to your use cases. You can choose from different runbook types based on your requirements and Windows PowerShell experience. If you prefer to work directly with Windows PowerShell code, you can use a PowerShell runbook or a PowerShell workflow runbook. You can edit offline or with the textual editor in the Azure portal using either of these. If you prefer to edit a runbook without exposure to the underlying code, you can create a graphical runbook using the Azure portal's graphic editor. Graphical runbooks. Graphical runbooks and graphical PowerShell workflow runbooks are created and edited with the graphic editor in the Azure portal. You can export them to a file and import them into another automation account, but you can't create or edit them with another tool. PowerShell runbooks. PowerShell runbooks are based on Windows PowerShell. You edit the runbook code directly using the text editor in the Azure portal. You can also use any offline text editor and import the runbook into Azure Automation. PowerShell runbooks don't use parallel processing. PowerShell workflow runbooks. PowerShell workflow runbooks are text runbooks based on Windows PowerShell workflow. You directly edit the runbook code using the text editor in the Azure portal. You can also use any offline text editor and import the runbook into Azure Automation. PowerShell workflow runbooks use parallel processing to allow for the simultaneous completion of multiple tasks. Workflow runbooks take longer to start than PowerShell runbooks because they must be compiled before running. Python runbooks. You can directly edit the code of the runbook using the text editor in the Azure portal, or you can use any offline text editor and import the runbook into Azure Automation. You can also use Python libraries. You must first import the package into the automation account to use third-party libraries. Note: you can't convert runbooks from graphical to textual type and vice versa. For more information on the different types of runbooks, visit Azure Automation Runbook Types. Understand automation shared resources. Completed 100 XP. 3 minutes. Azure Automation contains shared resources that are globally available to be associated with or used in a runbook. There are currently 8 shared resources categories. Schedules, it allows you to define a one-off or recurring schedule. Modules, contains Azure PowerShell modules. Modules Gallery, it allows you to identify and import PowerShell modules into your Azure Automation account. Python packages, allows you to import a Python package by uploading .whl or tar.gz packages. Credentials, it allows you to create username and password credentials. Connections, it allows you to specify Azure, Azure Classic Certificate, or Azure Service Principal connections. Certificates, it allows you to upload certificates in .ser or PFX format. Variables, it allows you to define encrypted or unencrypted variables of types, for example, string, boolean, datetime, integer, or no specific type. As a best practice, always try to create global assets to be used across your runbooks. It will save time and reduce the number of manual edits within individual runbooks. Explore Runbook Gallery. Completed 100 XP. 3 minutes. Azure Automation runbooks are provided to help eliminate the time it takes to build custom solutions. The runbooks have already been built by Microsoft and the Microsoft community. You can use them with or without modification. Also, you can import runbooks from the Runbook gallery at Azure Automation GitHub in the Runbooks repository Azure Automation Runbooks. Note: the Azure RM PowerShell module has been officially deprecated as of February 29, 2024. Users are advised to migrate from Azure RM to the AZ PowerShell module to ensure continued support and updates. For more general details on the new AZ PowerShell module, go to Introducing the new Azure PowerShell AZ module. Choosing items from the Runbook gallery. In the Azure portal, you can import directly from the Runbook gallery using the following high-level steps. Open your automation account, and then select Process Automation Runbooks. In the Runbooks pane, select Browse Gallery. From the Runbook gallery, locate the Runbook item you want, select it, and select Import. When browsing through the runbooks in the repository, you can review the code or visualize the code. You can also check information such as the source project and a detailed description, ratings, and questions and answers. For more information, see Azure Automation. Note: Python runbooks are also available from the Azure Automation GitHub in the Runbooks repository. To find them, filter by language and select Python. Note: you can't use PowerShell to import directly from the Runbook gallery. Examine webhooks. Completed 100 XP. 4 minutes. You can automate starting a runbook either by scheduling it or by using a webhook. A webhook allows you to start a particular runbook in Azure Automation through a single HTTPS request. It allows external services such as Azure DevOps, GitHub, or custom applications to start runbooks without implementing more complex solutions using the Azure Automation API. More information about webhooks is available at starting an Azure Automation runbook with a webhook. Create a webhook. You create a webhook linked to a runbook using the following steps. In the Azure portal, open the runbook that you want to create the webhook. In the Runbook pane, under Resources, select Webhooks, and then choose Add Webhook. Select Create New Webhook. In the Create New Webhook dialog, there are several values you need to configure. After you configure them, select Create. Name. Specify any name you want for a webhook because the name isn't exposed to the client. It's only used for you to identify the runbook in Azure Automation. Enabled. A webhook is enabled by default when it's created. If you set it to disabled, then no client can use it. Expires. Each webhook has an expiration date, at which time it can no longer be used. You can continue to modify the date after creating the webhook providing the webhook isn't expired. URL. The webhook URL is the unique address that a client calls with an HTTP post to start the runbook linked to the webhook. It's automatically generated when you create the webhook, and you can't specify a custom URL. The URL contains a security token that allows the runbook to be invoked by a third-party system with no further authentication. For this reason, treat it like a password. You can only view the URL in the Azure portal for security reasons when the webhook is created. Make a note of the URL in a secure location for future use. Note: when creating it, make sure you copy the webhook URL and then store it in a safe place. After you create the webhook, you can't retrieve the URL again. Select the Parameters Run Settings, Default, Azure option. This option has the following characteristics, which allows you to complete the following actions. If the runbook has mandatory parameters, you'll need to provide these required parameters during creation. You aren't able to create the webhook unless values are provided. If there are no mandatory parameters in the runbook, there's no configuration required here. The webhook must include values for any mandatory parameters of the runbook and include values for optional parameters. When a client starts a runbook using a webhook, it can't override the parameter values defined. To receive data from the client, the runbook can accept a single parameter called $webhook_data of type object that contains data that the client includes in the post request. There's no required webhook configuration to support the $webhook_data parameter. When finished, select Create. Using a webhook. To use a webhook after it has been created, your client application must issue an HTTP post with the URL for the webhook. The syntax of the webhook is in the following format. HTTP://webhook server/token equals token value. The client receives one of the following return codes from the post request. Code. Test. Description. 202. Accepted. The request was accepted, and the runbook was successfully queued. 400. Bad request. The request wasn't accepted because the runbook has expired, been disabled, or the token in the URL is invalid. 404. Not found. The request wasn't accepted because the webhook, runbook, or account wasn't found. 500. Internal server error. If successful, the webhook response contains the job ID in JSON format as follows. JSON. Job ID's frowny face job ID. The response will contain a single job ID, but the JSON format allows for potential future enhancements. You can't determine when the runbook job completes or determine its completion status from the webhook. You can only choose this information using the job ID with another method such as PowerShell or the Azure Automation API. More details are available on the Starting an Azure Automation Runbook with a webhook page. Explore source control integration. Completed 100 XP. 4 minutes. Azure Automation supports source control integration that enables you to keep your runbooks in your automation account up to date with your scripts in your GitHub or Azure DevOps source control repository. Source control allows you to collaborate with your team more efficiently, track changes, and roll back to earlier versions of your runbooks. For example, source control will enable you to sync different branches in source control to your development, test, or production automation accounts. It makes it easier to promote code you've tested in your development environment to your production automation account. Azure Automation supports 3 types of source control: GitHub, Azure DevOps, Git, Azure DevOps, TFVC. Source control allows you to push code from Azure Automation to source control or pull your runbooks from source control to Azure Automation. Source control sync jobs run under the user's automation account and are billed at the same rate as other automation jobs. Integrate source control with Azure Automation. You integrate source control with Azure Automation using the following steps. In the Azure portal, access your automation account. Under Account Settings, select Source Control, and then choose +Add. In the source control type, select GitHub as source control type and then select Authenticate. Note, you'll require a GitHub account to complete the next step. When the browser page opens, prompting you to authenticate to https://www.github.com, select Authorize Azure Automation and enter your GitHub account password. If successful, you should receive an email notification from GitHub stating that a third-party OAuth application, Automation Source Control, with repo scope was recently authorized to access your account. After authentication completes, fill in the details based on the following table and then select Save. Property. Description. Name. Friendly name. Source control type. GitHub, Azure DevOps Git, or Azure DevOps TFVC. Repository. The name of the repository or project. Branch. The branch from which to pull the source files. Branch targeting isn't available for the TFVC source control type. Folder path. The folder that contains the runbooks to sync. Autosync. Turns on or off automatic sync when a commit is made in the source control repository. Publish runbook. If set to on, after runbooks are synced from source control, they'll be automatically published. Description. A text field to provide more details. Más términos. If you set autosync to yes, full sync will start. If you set autosync to no, open the source control summary blade again by selecting your repository in Azure Automation and then selecting Start Sync. Verify that your source control is listed on the Azure Automation source control page for you to use. Explore PowerShell workflows. Completed 100 XP. 4 minutes. IT pros often automate management tasks for their multi-device environments by running sequences of long-running tasks or workflows. These tasks can affect multiple managed computers or devices at the same time. PowerShell Workflow lets IT pros and developers apply the benefits of Windows Workflow Foundation with the automation capabilities and ease of using Windows PowerShell. Tip. Refer to a developer's introduction to Windows Workflow Foundation, WF, in .NET 4 for more information. Windows PowerShell workflow functionality was introduced in Windows Server 2012 and Windows 8 and is part of Windows PowerShell 3.0 and later. Windows PowerShell workflow helps automate distribution, orchestration, and completion of multi-device tasks, freeing users and administrators to focus on higher-level tasks. Activities. An activity is a specific task that you want a workflow to do. Just as a script is composed of one or more commands, a workflow is composed of activities carried out in sequence. You can also use a script as a single command in another script and use a workflow as an activity within another workflow. Workflow characteristics. A workflow can be long-running, be repeated over and over, run tasks in parallel, be interrupted, can be stopped and restarted, suspended, and resumed, continue after an unexpected interruption, such as a network outage or computer/server restart. Workflow benefits. A workflow offers many benefits, including Windows PowerShell scripting syntax, is built on PowerShell, multi-device management, simultaneously apply workflow tasks to hundreds of managed nodes, single task runs multiple scripts and commands, combine related scripts and commands into a single task, then run the single task on multiple computes. The activity status and progress within the workflow are visible at any time. Automated failure recovery. Workflows survive both planned and unplanned interruptions, such as computer restarts. You can suspend a workflow operation, then restart or resume the workflow from the point it was suspended. You can author checkpoints as part of your workflow so that you can resume the workflow from the last persisted task, or checkpoint, instead of restarting the workflow from the beginning. Connection and activity retries. You can retry connections to managed nodes if network connection failures occur. Workflow authors can also specify activities that must run again if the activity cannot be completed on one or more managed nodes, for example, if a target computer was offline while the activity was running. Connect and disconnect from workflows. Users can connect and disconnect from the computer running the workflow, but the workflow will remain running. For example, suppose you're running the workflow and managing the workflow on 2 different computers. In that case, you can sign out of or restart the computer from which you're managing the workflow and continue to monitor workflow operations from another computer without interrupting the workflow. Task scheduling. You can schedule a task to start when specific conditions are met, as with any other Windows PowerShell complet or script. Create a workflow. Completed 100 XP. 3 minutes. Use a script editor such as the Windows PowerShell Integrated Scripting Environment, ISE, to write the workflow. It enforces workflow syntax and highlights syntax errors. For more information, review the tutorial Create a PowerShell Workflow Runbook in Azure Automation. A benefit of using PowerShell ISE is that it automatically compiles your code and allows you to save the artifact. Because the syntactic differences between scripts and workflows are significant, a tool that knows both workflows and scripts will save you considerable coding and testing time. Syntax. When you create your workflow, begin with the workflow keyword, which identifies a workflow command to PowerShell. A script workflow requires the workflow keyword. Next, name the workflow and have it follow the workflow keyword. The body of the workflow will be enclosed in braces. A workflow is a Windows command type, so select a name with a verb-noun format. PowerShell. Workflow test workflow. To add parameters to a workflow, use the perm keyword. It's the same techniques that you use to add parameters to a function. Finally, add your standard PowerShell commands. PowerShell. Workflow My first runbook workflow, perm, string, $VM name, string, $resource group name. Start Azure VM name, $VM name, resource group name, $resource group name. Explore hybrid management. Completed 100 XP. 3 minutes. The Hybrid Runbook Worker feature of Azure Automation allows you to run runbooks that manage local resources in your private data center on machines located in your data center. Azure Automation stores and manages the runbooks and then delivers them to one or more on-premises machines. The Hybrid Runbook Worker functionality is presented in the following graphic. Hybrid Runbook Worker workflow and characteristics. The following list is characteristics of the Hybrid Runbook Worker workflow. You can select one or more computers in your data center to act as a Hybrid Runbook Worker and then run runbooks from Azure Automation. Each Hybrid Runbook Worker is a member of a Hybrid Runbook Worker group, which you specify when you install the agent. A group can include a single agent, but you can install multiple agents in a group for high availability. There are no inbound firewall requirements to support Hybrid Runbook Workers, only Transmission Control Protocol, TCP, 443 is required for outbound internet access. The agent on the local computer starts all communication with Azure Automation in the cloud. When a runbook is started, Azure Automation creates an instruction that the agent retrieves. The agent then pulls down the runbook and any parameters before running it. To configure your on-premises servers that support the Hybrid Runbook Worker role with DSC, you must add them as DSC nodes. For more information about onboarding them for management with DSC, see Onboarding Machines for Management by Azure Automation State Configuration. For more information on installing and removing Hybrid Runbook Workers and groups, see Examine Checkpoint and Parallel Processing. Completed 100 XP. 4 minutes. Workflows let you implement complex logic within your code. Two features available with workflows are checkpoints and parallel processing. Checkpoints. A checkpoint is a snapshot of the current state of the workflow. Checkpoints include the current value for variables and any output generated up to that point. For more information on what a checkpoint is, read the checkpoint webpage. If a workflow ends in an error or is suspended, the next time it runs, it will start from its last checkpoint instead of at the beginning of the workflow. You can set a checkpoint in a workflow with the checkpoint workflow activity. For example, if an exception occurs after activity 2, the workflow will end in the following sample code. When the workflow is rerun, it starts with activity 2, followed just after the last checkpoint set. PowerShell. Activity 1 checkpoint workflow activity 2 exception activity 3. Parallel processing. A script block has multiple commands that run concurrently or in parallel instead of sequentially, as for a typical script. It's referred to as parallel processing. More information about parallel processing is available on the parallel processing webpage. In the following example, two VM0 and VM1 VMs will be started concurrently, and VM2 will only start after VM0 and VM1 has started. PowerShell. Parallel, start Azure VM name, $VM0 resource group name, $RG, start Azure VM name, $VM1 resource group name, $RG, start Azure VM name, $VM2 resource group name, $RG. Another parallel processing example would be the following constructs that introduce some extra options. For each parallel. You can use the for each parallel construct to concurrently process commands for each item in a collection. The items in the collection are processed in parallel while the commands in the script block run sequentially. In the following example, activity 1 starts at the same time for all items in the collection. For each item, activity 2 starts after activity 1 completes. Activity 3 starts only after both activity 1 and activity 2 have been completed for all items. Throttle limit. We use the throttle limit parameter to limit parallelism. Too high of a throttle limit can cause problems. The ideal value for the throttle limit parameter depends on several environmental factors. Try starting with a low throttle limit value, and then increase the value until you find one that works for your specific circumstances. PowerShell. For each parallel throttle limit $10 item in $collection, activity 1, activity 2, activity 3. A real-world example of it could be similar to the following code. A message displays for each file after it's copied. Only after all files are copied does the completion message display. PowerShell. Workflow copy files, $files equals at, c /localpath /file1.txt, c /localpath /file2.txt, c /localpath /file3.txt. For each parallel throttle limit 10, $file and $files. Copy item path $file destination / network path write output $file copied. Write output all files copied. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select check your answers. Check your knowledge. 1. Which of the following choices isn't an option when creating runbooks? Import runbooks from Azure Artifacts. Create your runbook and import it. Modify runbooks from the runbook gallery. 2. Which of the following choices isn't a supported source control by Azure Automation? Azure DevOps, Git or Team Foundation version control. Bitbucket. GitHub. 3. Which of the following choices is the required keyword at the beginning when creating your workflow to PowerShell? Resource group name. Param. Workflow. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described Azure Automation with Azure DevOps, using runbooks, webhooks, and PowerShell workflows. You learned how to create and manage automation for your environment. You learned how to describe the benefits and usage of. Implement automation with Azure DevOps. Create and manage runbooks. Create webhooks. Create and run a workflow runbook and PowerShell workflows. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes desired state configuration, DSC, and its components for implementation. You can exercise how to import, compile, and automate your environment creation, and use DSC for Linux automation on Azure. Learning objectives. After completing this module, students and professionals can implement desired state configuration, DSC. Describe Azure Automation state configuration. Implement DSC and Linux automation on Azure. Plan for hybrid management. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Understand configuration drift. Completed 100 XP. 3 minutes. Configuration drift is the process of a set of resources changing over time from their original deployment state. It can be because of changes made manually by people or automatically by processes or programs. Eventually, an environment can become a snowflake. A snowflake is a unique configuration that cannot be reproduced automatically and is typically a result of configuration drift. With snowflakes, infrastructure administration and maintenance invariably involve manual processes, which can be hard to track and prone to human error. The more an environment drifts from its original state, the more likely it is for an application to find issues. The greater the degree of configuration drift, the longer it takes to troubleshoot and rectify issues. Security considerations. Configuration drift can also introduce security vulnerabilities into your environment. For example, ports might be opened that should be kept closed. Updates and security patches might not be applied across environments consistently. The software might be installed that doesn't meet compliance requirements. Solutions for managing configuration drift. While eliminating configuration drift can be difficult, there are many ways you can manage it in your environments using configuration management tools and products such as Windows PowerShell Desired State Configuration. It's a management platform in PowerShell that enables you to manage and enforce resource configurations. For more information about Windows PowerShell Desired State Configuration, go to Windows PowerShell Desired State Configuration Overview. Azure Policy. Use Azure Policy to enforce policies and compliance standards for Azure resources. For more information about Azure Policy, go to Azure Policy. There are also other third-party solutions that you can integrate with Azure. Explore Desired State Configuration, DSC. Completed 100 XP. 3 minutes. Desired State Configuration, DSC, is a configuration management approach that you can use for configuration, deployment, and management of systems to ensure that an environment is maintained in a state that you specify, define state, and doesn't deviate from that state. DSC helps eliminate configuration drift and ensures the state is maintained for compliance, security, and performance. Windows PowerShell DSC is a management platform in PowerShell that provides desired state. PowerShell DSC lets you manage, deploy, and enforce configurations for physical or virtual machines, including Windows and Linux. For more information, visit Windows PowerShell Desired State Configuration Overview. DSC Components. DSC consists of 3 primary parts. Configurations. These are declarative PowerShell scripts that define and configure instances of resources. Upon running the configuration, DSC, and the resources being called by the configuration, will apply the configuration, ensuring that the system exists in the state laid out by the configuration. DSC configurations are also idempotent. The local configuration manager, LCM, will ensure that machines are configured in whatever state the configuration declares. Resources. They contain the code that puts and keeps the target of a configuration in the specified state. Resources are in PowerShell modules and can be written to a model as generic as a file or a Windows process or as specific as a Microsoft Internet Information Services, IIS, server or VM running in Azure. Local Configuration Manager, LCM. The LCM runs on the nodes or machines you wish to configure. It's the engine by which DSC facilitates the interaction between resources and configurations. The LCM regularly polls the system using the control flow implemented by resources to maintain the state defined by a configuration. If the system is out of state, the LCM calls the code in resources to apply the configuration according to specified. There are two methods of implementing DSC. Push mode: a user actively applies a configuration to a target node and pushes out the configuration. Pull mode is where pull clients are automatically configured to get their desired state configurations from a remote pull service. This remote pull service is provided by a pull server that acts as central control and manager for the configurations, ensures that nodes conform to the desired state, and reports on their compliance status. The pull server can be set up as an SMB-based pull server or an HTTPS-based server. HTTPS-based pull server uses the Open Data Protocol (OData) with the OData web service to communicate using REST APIs. It's the model we're most interested in, as it can be centrally managed and controlled. The following diagram provides an outline of the workflow of DSC pull mode. Explore Azure Automation State Configuration, DSC. Completed 100 XP. 3 minutes. Azure Automation State Configuration DSC is an Azure cloud-based implementation of PowerShell DSC, available as part of Azure Automation. Azure Automation State Configuration allows you to write, manage, and compile PowerShell DSC configurations, import DSC resources, and assign configurations to target nodes, all in the cloud. Why use Azure Automation DSC? The following outlines some of the reasons why we would consider using Azure Automation DSC. Built-in pull server. Provides a DSC pull server like the Windows feature DSC service so that target nodes automatically receive configurations, conform to the desired state, and report back on their compliance. The built-in pull server in Azure Automation eliminates the need to set up and maintain your pull server. Management of all your DSC artifacts. You can manage all your DSC configurations, resources, and target nodes from the Azure portal or PowerShell. Import reporting data into log analytics. Nodes managed with Azure Automation State Configuration send detailed reporting status data to the built-in pull server. You can configure Azure Automation State Configuration to send this data to your log analytics workspace. How Azure Automation State Configuration works. The general process for how Azure Automation State Configuration works is as follows. Create a PowerShell script with the configuration element. Upload the script to Azure Automation and compile the script into a MOF file. The file is transferred to the DSC pull server, provided as part of the Azure Automation service. Define the nodes that will use the configuration, and then apply the configuration. For more information, visit Managed Object Format, MOF, file. Examine DSC configuration file. Completed 100 XP. 3 minutes. DSC configurations are Windows PowerShell scripts that define a special type of function. You can view some syntax examples and scenarios on the configuration syntax page. DSC configuration elements. We'll provide the example configurations and then discuss the elements within them. Let's start with the following example configuration. PowerShell. Configuration lab config, node web server, Windows feature IIS, ensure equals present name equals web server include all subfeature equals $true. Configuration block. The configuration block is the outermost script block. In this case, the name of the configuration is lab config. Notice the curly brackets to define the block. Node block. There can be one or more node blocks. It defines the nodes, computers, and VMs that you're configuring. In this example, the node targets a computer called web server. You could also call it localhost and use it locally on any server. Resource blocks. There can be one or more resource blocks. It's where the configuration sets the properties for the resources. In this case, there's one resource block called Windows feature. Notice the parameters that are defined. You can read more about resource blocks at DSC resources. Here's another example. PowerShell. Configuration MyDSC configuration, param, string, $computer name equals localhost, no $computer name, Windows feature my feature instance, ensure equals present name equals RSAT, Windows feature my 2ND feature instance, ensure equals present name equals BitLocker, MyDSC configuration. In this example, you specify the node's name by passing it as the computer name parameter when you compile the configuration. The name defaults to localhost. Within a configuration block, you can do almost anything that you normally could in a PowerShell function. You can also create the configuration in any editor, such as PowerShell ISE, and save the file as a PowerShell script with a .ps1 file type extension. Implement DSC and Linux automation on Azure. Completed 100 XP. 2 minutes. Follow more specific and up-to-date details are available at Get Started with Desired State Configuration, DSC, for Linux. The following Linux operating system versions are currently supported by both PowerShell DSC and Azure Automation DSC. CentOS 6, 7, and 8, x64. Debian GNU/Linux 8, 9, and 10, x64. Oracle Linux 6 and 7, x64. Red Hat Enterprise Linux Server 6, 7, and 8, x64. SUSE Linux Enterprise Server 12 and 15, x64. Ubuntu Server 14.04 LTS, 16.04 LTS, 18.04 LTS, and 20.04 LTS, x64. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices is the process whereby a set of resources change their state over time from the desired state in which they were deployed? Configuration drift. Idempotence. Increment. 2. Which of the following choices isn't a primary component of DSC? Configuration. Resources. PowerShell. 3. Which of the following choices isn't a method of implementing DSC? Pull mode. Fetch mode. Push mode. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described desired state configuration, DSC, and its components for implementation. You exercised how to import, compile, and automate your environment creation, and use DSC for Linux automation on Azure. You learned how to describe the benefits and usage of implement desired state configuration, DSC. Describe Azure automation state configuration. Implement DSC and Linux automation on Azure. Plan for hybrid management. Learn more. Introduction. Completed 100 XP. 1 minute. This module explains what Bicep is and how it's integrated into different tools such as Azure CLI and Visual Studio Code for environment deployment configuration. Learning objectives. Learn what Bicep is. Learn how to install it and create a smooth authoring experience. Use Bicep to deploy resources to Azure. Deploy Bicep files in Cloud Shell and Visual Studio Code. Prerequisites. Basic understanding of DevOps and its concepts. Familiarity with version control principles. Beneficial if responsible for deploying resources to Azure via Infrastructure as Code, IAC. What is Bicep? Completed 100 XP. 2 minutes. Azure Bicep is the next revision of ARM templates designed to solve some of the issues developers were facing when deploying their resources to Azure. It's an open source tool and, in fact, a domain-specific language, DSL, that provides a means to declaratively codify infrastructure, which describes the topology of cloud resources such as VMs, web apps, and networking interfaces. It also encourages code reuse and modularity in designing the infrastructure as code files. The new syntax allows you to write less code compared to ARM templates, which are more straightforward and concise and automatically manage the dependency between resources. Azure Bicep comes with its command line interface, CLI, which can be used independently or with Azure CLI. Bicep CLI allows you to transpile the Bicep files into ARM templates and deploy them and can be used to convert an existing ARM template to Bicep. Note: beware that when converting ARM templates to Bicep, there might be issues since it's still a work in progress. There's also an excellent integration with Visual Studio Code that creates a superb authoring experience. Azure Bicep supports types that are used to validate templates at development time rather than runtime. The extension also supports linting, which can be used to unify the development experience between team members or across different teams. For more information about Azure Bicep, see Bicep language for deploying Azure resources. Next steps. In the next unit, you'll find out various ways to install Bicep and set up your development environment. Install Bicep. Completed 100 XP. 3 minutes. To start, install the Bicep CLI or the Visual Studio Code extension. Having both installed will give you a great authoring experience. Installing the VS Code extension. The extension provides language support, IntelliSense, and linting support. To verify you've installed, create a file with the .bicep extension and watch the language mode change in the lower right corner of VS Code. Installing Bicep CLI. You need to have Azure CLI version 2.20.0 or later installed to be able to install the Bicep CLI. When you're ready, run the install command. Azure CLI. AZ Bicep install. You can upgrade the Bicep CLI by running the AZ Bicep upgrade, and for validating the installation, use the AZ Bicep version. We deliberately avoided breaking down the installation for Windows, Mac OS, and Linux since Azure CLI is cross-platform, and the steps would be the same. Manual installation. You can manually install it if you don't have Azure CLI installed but still want to use Bicep CLI. Windows. You can use Chocolatey or Wingit to install the Bicep CLI. Azure CLI. Choco install Bicep Wingit install EID Microsoft Bicep help. Linux. To install the Bicep CLI on Linux manually, use the below script. Bash. curl low bicep https://github.com/azure/bicep/releases/latest/download/bicep/linux-x6forge mod+x/bicep sudo mv/bicep/usr/local/bin/bicep help. Mac OS. And for Mac OS, use Homebrew or the previous script for Linux. Bash. brew tap azure/bicep brew install bicep version. Troubleshooting the installation. If any errors or issues were faced during the installation, make sure you visit the troubleshooting guide on Azure Bicep documentation. Next steps. In the next unit, you'll create your first Bicep template and deploy it to Azure. Exercise: Create Bicep templates. Completed 100 XP. 3 minutes. It's time to create your first Bicep template. After following this unit, you'll learn how the Bicep extension in VS Code simplifies development by providing type safety, syntax validation, and auto-completion. Prerequisites. To follow along, you'll need to have access to an Azure subscription. You also need to have VS Code, Azure CLI, Bicep extension for VS Code. Create your first template. Open your VS Code and create a new file called main.bicep. When it's done, open the file and start typing storage. You should see a menu appears from which select the first option, Res Storage, by pressing Enter or Tab. You should end up with a snippet that looks like Bicep. Resource storage account Microsoft storage/storage accounts at 2021-02-01 equals name location kind storage v2 SKU name premium_LRS. This file will deploy an Azure storage account. However, we need to modify the file to make it ready for deployment. First, let's add 2 parameters, one for the name since it should be unique and one for the location. Bicep. Perm storage name string equals $, unique string, resource group, .id, perm location string equals resource group, .location. The value you assign to the parameters is the default value that makes the parameters optional. Replace the name property with storage name, and since the location is already used, you're good to go ahead with the deployment. Visualize resources. You can use VS Code to visualize the resources defined in your Bicep file. Click on the Visualizer button at the top right-hand corner. Compile the file. You don't need to compile the file to be able to deploy it, but it's good to know how you can do it. Open the integrated terminal in VS Code by right-clicking on your Bicep file and selecting the Open in Integrated Terminal menu. Use the build command as follows. Bash AZ-bicep build f/main.bicep. Feel free to take a look at the resulting ARM template and compare the two. Deploying the Bicep file. Now is the time to deploy the Bicep file you've created. In the same terminal, run the following commands. Azure CLI. AZ group, create name Bicep location Eastus AZ deployment group, create resource group Bicep template file main.bicep parameters storage name equals unique name. Note. Replace the unique name with a unique name, but you can also ignore providing the parameter since it has a default value. When the deployment finishes, you'll be getting a message indicating the deployment succeeded. Next steps. Now that you've learned how to create a basic template and deploy it, head over to the next unit to learn more about the constructs in a Bicep file. Understand Bicep file structure and syntax. Completed 100 XP. 3 minutes. Azure Bicep comes with its own syntax, however, it's easy to understand and follow. We won't go deep into the syntax and structure, but let's review the main concepts using an example. Sample bicep.bicep file. Bicep. At min length 3, at max length 11, perm storage prefix string perm storage SKU string equals standard_LRS perm location string equals resource group, .location var unique storage name equals $storage prefix, $unique string resource group, .id, resource STG Microsoft storage/storage accounts at 2019-04-01 equals name unique storage name location SKU name storage SKU kind storage v2 properties supports HTTPS traffic only true resource service. File services equals name default resource shares equals name example share module web module /webapp.bicep equals name web deploy perms SKU name s1 location output storage endpoint object equals stg properties primary endpoints. Scope. By default, the target scope of all templates is set for resource group. However, you can customize it by setting it explicitly. As other allowed values, subscription, management group, and tenant. Parameters. You've already used the parameters in the previous unit. They allow you to customize your template deployment at runtime by providing potential values for names, location, prefixes, etc. Parameters also have types that editors can validate and also can have default values to make them optional at deployment time. Additionally, you can see they can have validation rules to make the deployment more reliable by preventing any invalid value right from the authoring. For more information, see parameters in Bicep. Variables. Similar to parameters, variables play a role in making a more robust and readable template. Any complex expression can be stored in a variable and used throughout the template. When you define a variable, the type is inferred from the value. In the above example, the unique storage name is used to simplify the resource definition. For more information, see variables in Bicep. Resources. The resource keyword is used when you need to declare a resource in your templates. The resource declaration has a symbolic name for the resource that can be used to reference that resource later, either for defining a subresource or use its properties for an implicit dependency like a parent-child relationship. There are certain properties that are common for all resources, such as location, name, and properties. There are resource-specific properties that can be used to customize the resource pricing tier, SKU, and so on. You can define sub-resources within a resource or outside by referencing the parent. In the above example, a file share is defined within the storage account resource. If the intention was to define the resource outside of it, you would need to change your template. Bicep. Resource storage Microsoft storage/storage accounts at 2021-02-01 equals name, example storage location, resource group, location kind, storage v2 SKU, name, standard_LRS, resource service Microsoft storage/storage accounts/file services at 2021-02-01 equals name, default parent, storage, resource share Microsoft. Storage/storage accounts/file services/shares at 2021-02-01 equals name, example share parent, service. For more information, see resource declaration in Bicep. Modules. If you want truly reusable templates, you can't avoid using a module. Modules enable you to reuse a Bicep file in other Bicep files. In a module, you define what you need to deploy, and any parameters needed, and when you reuse it in another file, all you need to do is reference the file and provide the parameters. The rest is taken care of by Azure Bicep. In the above example, you're using a module that presumably is deploying an app service. For more information, see using modules in Bicep. Outputs. You can use outputs to pass values from your deployment to the outside world, whether it is within a CI/CD pipeline or in a local terminal or cloud shell. That would enable you to access a value such as storage endpoint or application URL after the deployment is finished. All you need is the output keyword and the property you would like to access. Cloud. Output storage endpoints equals stg properties.primary endpoints. To find more information, see outputs in Bicep. Other features. There are many other features available within a Bicep file such as loops, conditional deployment, multi-line strings, referencing an existing cloud resource, and many more. In fact, any valid function within an ARM template is also valid within a Bicep file. Next steps. In the next unit, you'll learn how to use Bicep in an Azure pipeline. Exercise: deploy a Bicep file from Azure Pipelines. Completed 100 XP. 3 minutes. Now that you know how to validate, compile, and deploy your resources from your local environment, it's time to extend that and see how to bring that into an Azure pipeline to streamline your deployment process even further. Prerequisites. You'll need an Azure subscription. If you don't have one, create a free account before you begin. You also need an Azure DevOps organization. Similarly, if you don't have one, create one for free. You'll need to have a configured service connection in your project that is linked to your Azure subscription. Don't worry if you haven't done this before, we'll show you an easy way to do it when you're creating your pipeline. You also need to have that Bicep file you created earlier pushed into the Azure repository of your project. Creating the pipeline. From within your Azure DevOps project, select Pipelines and New Pipeline. Select Azure Repos Git, YAML, and specify your Azure repo as a source. Select the starter pipeline from the list of templates. Replace everything in the starter pipeline file with the following snippet. Bicep. Main name, deploy Bicep files variables, VM image name, Ubuntu latest Azure service connection, my service connection resource group name, Bicep location, ESTIS template file, main.bicep pool, VM image, $VM image name, steps, task, Azure CLI at 2 inputs, Azure subscription, Azure service connection, script type, bash script location, inline script, AZ version, AZ group. Create name, resource group name, location, location, AZ deployment group, create resource group, resource group name, template file, template file. Note. Don't forget to replace the service connection name with yours. Select Save and Run to create a new commit in your repository containing the pipeline YAML file, and then run the pipeline. Wait for the pipeline to finish running and check the status. Once the pipeline runs successfully, you should be able to see the resource group and the storage account. Exercise: deploy a Bicep file from GitHub Workflows. Completed 100 XP. 3 minutes. GitHub Actions are similar to Azure Pipelines in nature. They provide a way to automate software development and deployments. In this exercise, you'll learn how to deploy a Bicep file using a GitHub action. Prerequisites. You'll need a GitHub account that you can create for free here. A GitHub repository is also required to store your Bicep file and workflows created earlier in the exercise, create Bicep templates. Once you've created your GitHub repository, push the Bicep file into it. For deployment to Azure, access to an Azure subscription is needed, which can be created for free here. Creating a service principal in Azure. To deploy your resources to Azure, you'll need to create a service principal which GitHub can use. So open a terminal or use Cloud Shell in the Azure portal and type the following commands. Cloud. AZ login AZ add SP create for RBAC name my app role contributor scopes /subscription ID /resource groups /Bicep SDK auth. Note. Don't forget to replace the subscription ID with yours. When the operation succeeds, it should output a JSON object that contains your tenant ID, subscription ID, client secret, and a few more properties, such as the following. JSON. client ID, GUID, client secret, GUID, subscription ID, GUID, tenant ID, GUID. Note this object since you'll need to add it to your GitHub secrets. Creating a GitHub secret. In your GitHub repository, navigate to Settings, Secrets, Actions. Create a new secret called Azure_credentials and paste the entire JSON object you got from the previous step. Create another secret for the name of the resource group with a name such as Azure_RG and one for the subscription. Creating a GitHub action. First, navigate to your repository and select the Actions menu. Then, set up a workflow to create an empty workflow in your repository. You can rename the file to a different name if you prefer. Replace the content of the file with the following snippet. YAML. On, push, name, Azure ARM jobs, build and deploy, runs on, Ubuntu latest steps, hashtag checkout code uses, action/checkout at main, hashtag login to Azure uses, Azure/login at v1 with, creds, $secrets.azure_credentials, hashtag deploy bicep file name, deploy uses, Azure/ARM deploy at v1 with, subscription ID, $secrets.azure_subscription, resource group name, $secrets.azure_RG, template, /main.bicep parameters, storage prefix equals stg fail on stdr, false. Feel free to replace the storage account prefix with your own. Note: the first part of the workflow defines the trigger and its name. The rest defines a job and uses a few tasks to check out the code, sign into Azure, and deploy the bicep file. Select Start Commit and enter a title and a description in the pop-up dialog. Then select Commit directly to the main branch, followed by Commit a new file. Navigate to the Actions tab and select the newly created action that should be running. Monitor the status, and when the job is finished, check the Azure portal to see if the storage account is being created. Deployments using Azure Bicep templates. Completed 100 XP. 60 minutes. Scenario. In this lab, you'll create an Azure Bicep template and modularize it using the Azure Bicep modules concept. You'll then modify the main deployment template to use the module and finally deploy all the resources to Azure. Objectives. After completing this lab, you'll be able to understand and create an Azure Bicep templates. Create a reusable Bicep module for storage resources. Upload linked template to Azure Blob Storage and generate a SAS token. Modify the main template to use the module. Modify the main template to update dependencies. Deploy all the resources to Azure using Azure Bicep templates. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Identify an existing Azure subscription or create a new one. Verify that you have a Microsoft account or an Entra account with the owner role in the Azure subscription and the global administrator role associated with the Azure subscription. For details, refer to list Azure role assignments using the Azure portal. Visual Studio Code. This will be installed as part of the prerequisites for this lab. Exercises. During this lab, you'll complete the following exercises. Exercise 0, configure the lab prerequisites. Exercise 1, author and deploy Azure Bicep templates. Exercise 2, remove the Azure lab resources. Knowledge check. Completed 200 XP. 3 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following describes how to define the dependencies in a Bicep file? Bicep uses implicit dependency using symbolic names and parent-child properties. By adding the link to property. Bicep doesn't support resource dependencies. 2. Which of the following choices best describe the behavior of the web app name parameter for a team that created a template that contains this line, perm web app name string equals mysite $unique string resource group .id? Whoever is deploying the template must provide a value for the web app name. When you redeploy the template to the same resource group, the value of the web app name remains the same. The web app name parameter will have a different value every time the template gets deployed. 3. Which of the following choices describe how you can reuse a Bicep template in other Bicep templates? By adding a local reference to that file. By defining a module and referencing it in other files. By adding a remote reference to a template from an online repository. You must answer all questions before checking your work. Summary. Completed 100 XP. 3 minutes. This module introduced the new revision of ARM templates called Azure Bicep that is designed to help developers have a great authoring experience with its integration with Visual Studio Code and Azure CLI. You learned how it simplifies the deployment and encourages reusability, less code, and is easy to write and deploy. You also learned some of the benefits and how to. Intro and installing Azure Bicep. Understands its syntax and basics. Write and deploy Azure Bicep templates locally. Deploy Azure Bicep templates using Azure DevOps. Deploy Azure Bicep templates using GitHub Actions. Learn more. Introduction. Completed 100 XP. 1 minute. In this module, we'll talk about managing dependencies in software development. We're going to cover what dependencies are and how to identify them in your codebase. Then you'll learn how to package these dependencies and manage the packages in package feeds. Finally, you're going to learn about versioning strategies. We'll look at dependency management as a concept in software and why it's needed. We're going to look at dependency management strategies and how you can identify components in your source code and change these to dependencies. This module explores dependency management concepts and helps to identify project dependencies. You'll learn how to decompose your system, identify dependencies, and package componentization. Learning objectives. After completing this module, students and professionals can define dependency management strategy, identify dependencies, describe elements and componentization of dependency management, scan your codebase for dependencies. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. What is dependency management? Completed 100 XP. 3 minutes. Before we can understand dependency management, we'll need first to get introduced to the concepts of dependencies. Dependencies in software. Modern software development involves complex projects and solutions. Projects have dependencies on other projects, and solutions aren't single pieces of software. The solutions in software built consist of multiple parts and components and are often reused. As codebases are expanding and evolving, it needs to be componentized to be maintainable. A team that is writing software won't write every piece of code by itself but use existing code written by other teams or companies and open source code that is readily available. Each component can have its maintainers, speed of change, and distribution, giving both the creators and consumers of the components autonomy. A software engineer will need to identify the components that make up parts of the solution and decide whether to write the implementation or include an existing component. The latter approach introduces a dependency on other components. Why is dependency management needed? Software dependencies that are introduced in a project and solution must be appropriately declared and resolved. You need to manage the overall composition of the project code and the included dependencies. Without proper dependency management, it will be hard to keep the components in the solution controlled. Management of dependencies allows a software engineer and team to be more efficient working with dependencies. With all dependencies being managed, it's also possible to control the consumed dependencies, enabling governance and security scanning to use known vulnerabilities or exploits packages. Describe elements of a dependency management strategy. Completed 100 XP. 2 minutes. There are many aspects of a dependency management strategy. Standardization. Managing dependencies benefit from a standardized way of declaring and resolving them in your codebase. Standardization allows a repeatable, predictable process and usage that can be automated as well. Package formats and sources. The distribution of dependencies can be performed by a packaging method suited for your solution's dependency type. Each dependency is packaged using its usable format and stored in a centralized source. Your dependency management strategy should include the selection of package formats and corresponding sources where to store and retrieve packages. Versioning. Just like your own code and components, the dependencies in your solution usually evolve. While your codebase grows and changes, you need to consider the changes in your dependencies as well. It requires a versioning mechanism for the dependencies to be selective of the version of a dependency you want to use. Identify dependencies. Completed 100 XP. 2 minutes. This process begins with identifying the dependencies in your codebase and determining which ones will be officially recognized. Your software project and its associated solutions already use various dependencies. The use of libraries and frameworks authored by others is a widespread practice. Your current codebase may contain internal dependencies that need to be officially acknowledged as such. Consider a segment of code that encapsulates a specific business domain model. This code might be integrated as source code in your project and utilized across different projects and teams. A thorough investigation of your codebase is necessary to pinpoint sections of code that should be classified as dependencies. This calls for modifying how you arrange your code and construct the solution. Eventually, it will contribute to the refinement of your components. Understand source and package componentization. Completed 100 XP. 2 minutes. Current development practices already have the notion of componentization. There are 2 ways of componentization commonly used. Source componentization. The first way of componentization is focused on source code. It refers to splitting the source code in the codebase into separate parts and organizing it around the identified components. It works if the source code isn't shared outside of the project. Once the components need to be shared, it requires distributing the source code or the produced binary artifacts created from it. Package componentization. The second way uses packages. Distributing software components is performed utilizing packages as a formal way of wrapping and handling the components. A shift to packages adds characteristics needed for proper dependency management, like tracking and versioning packages in your solution. See also collaborate more and build faster with packages. Decompose your system. Completed 100 XP. 3 minutes. You'll need to get better insights into your code and solution before you can change your codebase into separate components to prepare for finding dependencies that can be taken out of your system. It allows you to decompose your system into individual components and dependencies. The goal is to reduce the size of your codebase and system, making it more efficient to build and manageable in the end. You achieve it by removing specific components of your solution. These are going to be centralized, reused, and maintained independently. You'll remove those components and externalize them from your solution at the expense of introducing dependencies on other components. This process of finding and externalizing components is effectively creating dependencies. It may require some refactoring, such as creating new solution artifacts for code organization or code changes to cater for the unchanged code to take a dependency on an external component. You might need to introduce some code design patterns to isolate and include the componentized code. Examples of patterns are abstraction by interfaces, dependency injection, and inversion of control. Decomposing could also mean replacing your implementation of reusable code with an available open source or commercial component. Scan your codebase for dependencies. Completed 100 XP. 3 minutes. There are several ways to identify the dependencies in your codebase. These include scanning your code for patterns and reuse and analyzing how the solution is composed of individual modules and components. Duplicate code. When certain pieces of code appear in several places, it's a good indication that this code can be reused. Keep in mind that code duplication isn't necessarily a bad practice. However, if the code can be made available properly, it does have benefits over copying code and must manage that. The first step to isolate these pieces of duplicate code is to centralize them in the codebase and componentize them in the appropriate way for the type of code. High cohesion and low coupling. A second approach is to find code that might define components in your solution. You'll look for code elements that have high cohesion and low coupling with other parts of code. It could be a specific object model with business logic or code related to its responsibility, such as a set of helper or utility codes, or perhaps a basis for other code to be built upon. Individual lifecycle. Related to high cohesion, you can look for parts of the code that have a similar lifecycle and can be deployed and released individually. If such code can be maintained by a team separate from the codebase that it's currently in, it's an indication that it could be a component outside of the solution. Stable parts. Some parts of your codebase might have a slow rate of change. That code is stable and isn't altered often. You can check your code repository to find the code with a low change frequency. Independent code and components. Whenever code and components are independent and unrelated to other parts of the system, they can be isolated to a separate component and dependency. You can use different kinds of tools to assist you in scanning and examining your codebase. These range from tools that scan for duplicate code and draw solution dependency graphs to tools that compute metrics for coupling and cohesion. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select check your answers. Check your knowledge. 1. Which of the following choices isn't a correct aspect of a dependency management strategy? Standardization. Versioning. Binary sharing. 2. Which of the following choices isn't a way of componentization commonly used? Symbol componentization. Source componentization. Package componentization. 3. Which of the following choices is the aspect of dependency management that allows a repeatable, predictable process and usage that can be automated? Versioning. Package formats and sources. Standardization. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explored dependency management concepts and helped to identify project dependencies. You learned how to decompose your system, identify dependencies, and package componentization. You learned how to describe the benefits and usage of. Define dependency management strategy. Identify dependencies. Describe elements and componentization of dependency management. Scan your codebase for dependencies. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes package feeds, common public package sources, and how to create and publish packages. Learning objectives. After completing this module, students and professionals can implement package management, manage package feed, consume and create packages, publish packages. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. For some exercises, you need to create an Azure DevOps organization and a team project. If you don't have it yet, see. Create an organization Azure DevOps. Explore packages. Completed 100 XP. 4 minutes. Packages are used to define the components you rely on and depend upon in your software solution. They provide a way to store those components in a well-defined format with metadata to describe them. What is a package? A package is a formalized way of creating a distributable unit of software artifacts that can be consumed from another software solution. The package describes the content it contains and usually provides extra metadata, and the information uniquely identifies the individual packages and is self-descriptive. It helps to better store packages in centralized locations and consume the contents of the package predictably. Also, it enables tooling to manage the packages in the software solution. Types of packages. Packages can be used for different kinds of components. The type of components you want to use in your codebase differ for the different parts and layers of the solution you're creating. They range from front-end components, such as JavaScript code files, to back-end components like .NET assemblies or Java components, complete self-contained solutions, or reusable files in general. Over the past years, the packaging formats have changed and evolved. Now there are a couple of de facto standard formats for packages. NuGet packages, pronounced NuGet, are a standard used for .NET code artifacts. It includes .NET assemblies and related files, tooling, and sometimes only metadata. NuGet defines the way packages are created, stored, and consumed. A NuGet package is essentially a compressed folder structure with files in zip format and has the .NUP extension. See also an introduction to NuGet. NPM package is used for JavaScript development. It originates from Node.js development, where it's the default packaging format. An NPM package is a file or folder containing JavaScript files and a package.json file describing the package's metadata. For Node.js, the package usually includes one or more modules that can be loaded once the package is consumed. See also about packages and modules. Maven is used for Java-based projects. Each package has a project object model file describing the project's metadata and is the basic unit for defining a package and working with it. PyPI, the Python package index, abbreviated as PyPI and known as the cheese shop, is the official third-party software repository for Python. Docker packages are called images and contain complete and self-contained deployments of components. A Docker image commonly represents a software component that can be hosted and executed by itself without any dependencies on other images. Docker images are layered and might be dependent on other images as their basis. Such images are referred to as base images. Understand package feeds. Completed 100 XP. 3 minutes. Packages should be stored in a centralized place for distribution and consumption to take dependencies on the components it contains. The centralized storage for packages is commonly called a package feed. There are other names in use, such as repository or registry. We'll refer to all of these as package feeds unless it's necessary to use the specific name for clarity. Each package type has its type of feed. Put another way, one feed typically contains one type of packages. There are NuGet feeds, NPM feeds, Maven repositories, PyPI feed, and Docker registries. Package feeds offer version storage of packages. A particular package can exist in multiple versions in the feed, catering for consumption of a specific version. Private and public feeds. The package feeds are centralized and available for many different consumers. Depending on the package, purpose, and origin, it might be generally available or to a select audience. Typically, open source projects for applications, libraries, and frameworks are shared with everyone and publicly available. The feeds can be exposed in public or private to distinguish invisibility. Anyone can consume public feeds. There might be reasons why you don't want your packages to be available publicly. It could be because it contains intellectual property or doesn't make sense to share with other software developers. Components developed for internal use might be available only to the project, team, or company that developed it. In such cases, you can still use packages for dependency management and choose to store the package in a private package feed. Private feeds can only be consumed by those who are allowed access. Explore package feed managers. Completed 100 XP. 2 minutes. Each of the package types has a corresponding manager that takes care of one or more of the following aspects of package management. Installation and removal of local packages. Pushing packages to a remote package feed. Consuming packages from a remote package feed. Searching feeds for packages. The package manager has cross-platform command line interface, CLI, tools to manage the local packages and feeds that host the packages. The CLI tooling is part of a local install on a development machine. Choosing tools. The command line nature of the tooling offers the ability to include it in scripts to automate package management. Ideally, one should use the tooling in build and release pipelines for component creating, publishing, and consuming packages from feeds. Additionally, developer tooling can have integrated support for working with package managers, providing a user interface for the raw tooling. Examples of such tooling are Visual Studio 2017, Visual Studio Code, and Eclipse. Explore common public package sources. Completed 100 XP. 3 minutes. The various package types have a standard source that is commonly used for public use. It's a go-to place for developers to find and consume publicly available components as software dependencies. These sources are package feeds. Public. In general, you'll find that publicly available package sources are free to use. Sometimes they have a licensing or payment model for consuming individual packages or the feed itself. These public sources can also be used to store packages you've created as part of your project. It doesn't have to be open source, although it is in most cases. Public and free package sources that offer feeds at no expense will usually require that you make the packages you store publicly available as well. The table above doesn't contain an extensive list of all public sources available. There are other public package sources for each of the types. Explore self-hosted and SaaS-based package sources. Completed 100 XP. 3 minutes. The following private package sources will give you a starting point for finding the most relevant feeds. Private. Private feeds can be used where packages should be available to a select audience. The main difference between public and private feeds is the need for authentication. Public feeds can be anonymously accessible and optionally authenticated. Private feeds can be accessed only when authenticated. There are 2 options for private feeds. Self-hosting. Some of the package managers are also able to host a feed. One can host the required solution to offer a private feed using on-premises or private cloud resources. SaaS services. A variety of third-party vendors and cloud providers offer software-as-a-service feeds that can be kept private. It typically requires a consumption fee or a cloud subscription. The following table contains a non-exhaustive list of self-hosting options and SaaS offerings to host private package feeds for each type covered. Package type: self-hosted private feed, SaaS private feed, NuGet, NuGet server, Azure Artifacts, MyGet, NPM, Sinopia, C NPM.js, Verdacho, NPM.js, MyGet, Azure Artifacts, Maven, Nexus, Artifactory, Archivia, Azure Artifacts, Bintray, Jetpack, Docker, Portis, Quay, Harbor, Docker Hub, Azure Container Registry, Amazon Elastic Container Registry, Python, PyPI Server, GemFury, Consume Packages, Completed 100 XP, 4 minutes. Each software project that consumes packages to include the required dependencies will use the package manager and more package sources. The package manager will download the individual packages from the sources and install them locally on the development machine or build server. The developer flow will follow this general pattern. Identify a required dependency in your codebase. Find a component that satisfies the requirements for the project. Search the package sources for a package offering a correct component version. Install the package into the codebase and development machine. Create the software implementation that uses the new components from the package. The package manager tooling will help search and install the components in the packages. How it's achieved varies for the different package types. Refer to the documentation of the package manager for instructions on consuming packages from feeds. To get started, you'll need to specify the package source. Package managers will have a default source defined as the standard package feed for its type. Alternative feeds will need to be configured to allow consuming the packages they offer. Upstream sources. Part of package management involves keeping track of the various sources. It's possible to refer to multiple sources from a single software solution. However, when combining private and public sources, the order of resolution of the sources becomes essential. One way to specify multiple package sources is by choosing a primary source and an upstream source. The package manager will evaluate the primary source first and switch to the upstream source when the package isn't found there. The upstream source might be one of the official public or private sources. The upstream source could refer to another upstream source, creating a chain of sources. A typical scenario is to use a private package source referring to a public upstream source for one of the official feeds. It effectively enhances the packages in the upstream source with packages from the private feed, avoiding publishing private packages in a public feed. A source with an upstream source defined may download and cache the requested packages if the source doesn't contain those packages themselves. The source will include these downloaded packages and starts to act as a cache for the upstream source. It also offers the ability to keep track of any packages from the external upstream source. An upstream source can be a way to avoid direct access of developers and build machines to external sources. The private feed uses the upstream source as a proxy for the external source. It will be your feed manager and private source that have the communication to the outside. Only privileged roles can add upstream sources to a private feed. See also upstream sources. Packages graph. A feed can have one or more upstream sources, which might be internal or external. Each of these can have additional upstream sources, creating a package graph of the source. Such a graph can offer many possibilities for layering and indirection of origins of packages. It might fit well with multiple teams taking care of packages for frameworks and other base libraries. The downside is that package graphs can become complex when not correctly understood or designed. It's essential to know how you can create a proper package graph. See also constructing a complete package graph. Introduction to Azure Artifacts. Completed 100 XP. 4 minutes. Previously you learned about packaging dependencies and the various packaging formats, feeds, sources, and package managers. Now, you'll know more about package management, creating a feed, and publishing packages. During this module, NuGet and Azure Artifacts are used as an example of a package format and a particular package feed and source type. Microsoft Azure DevOps provides various features for application lifecycle management, including work item tracking, source code repositories, build and release pipelines, artifact management. The artifact management is called Azure Artifacts and was previously known as package management. It offers public and private feeds for software packages of various types. Types of packages supported. Azure Artifacts currently supports feeds that can store 5 different package types. NuGet packages, NPM packages, Maven, Universal packages, Python. Previously, we discussed the package types for NuGet, NPM, Maven, and Python. Universal packages are an Azure Artifacts-specific package type. In essence, it's a versioned package containing multiple files and folders. A single Azure Artifacts feed can contain any combination of such packages. You can connect to the feed using the package managers and the corresponding tooling for the package types. For Maven packages, this can also be the Gradle build tool. Selecting package sources. When creating your solution, you'll decide which packages you want to consume to offer the dependent components. The next step is to determine the sources for these packages. The main choice is selecting public and private feeds or a combination of it. Publicly available packages can usually be found in the public package sources. It would be NuGet.org, NPM.js, and PyPI.org. Your solution can select these sources if it only consumes packages available there. Whenever your solution also has private packages that can't be available on public sources, you'll need to use a private feed. In the previous module, you learned that public package sources could be upstream sources to private feeds. Azure Artifacts allows its feeds to specify one or more upstream sources, public or other private feeds. Publish packages. Completed 100 XP. 4 minutes. As software is developed and components are written, you'll most likely produce components as dependencies packaged for reuse. Discussed previously was guidance to find components that can be isolated into dependencies. These components need to be managed and packaged. After that, they can be published to a feed, allowing others to consume the packages and use the components it contains. Creating a feed. The first step is to create a feed where the packages can be stored. In Azure Artifacts, you can create multiple feeds, which are always private. During creation, you can specify the name, visibility, and pre-populate the default public upstream sources for NuGet, NPM, and Python packages. What are feeds in Azure Artifacts? Most package management systems provide endpoints where you can request packages to install in your applications. Those endpoints are called feeds. In Azure Artifacts, you can have multiple feeds in your projects, and you can make them available to only users authorized in your project or for your entire organization. Each feed can contain any packages, even mixed types, but it's recommended that you create one feed per type you want to support in your organization. This way, it's clear what the feed contains. Each feed can contain one or more upstream and can manage its security. Controlling access. The Azure Artifacts feed you created is always private and not available publicly. You need access to it by authenticating to Azure Artifacts with an account with access to Azure DevOps and a team project. By default, a feed will be available to all registered users in Azure DevOps. You can select it to be visible only to the team project where the feed is created. Whichever option is chosen, you can change the permissions for a feed from the settings dialog. Push packages to a feed. Once you've authenticated to Azure DevOps, you can pull and push packages to the package feed, provided you have permission to do so. Pushing packages is done with the tooling for the package manager. Each of the package managers and tooling has a different syntax for pushing. To manually push a NuGet package, you would use the NuGet.exe command line tool. For a package called myDemoPackage, the command would resemble cmd. NuGet.exe push source, NuGet package source URL, API key your package / your package.nuc. Updating packages. Packages might need to be updated during their lifetime. Technically, updating a package is made by pushing a new version of the package to the feed. The package feed manager manages to properly store the updated package with the existing packages in the feed. Note: updating packages requires a versioning strategy. Package management with Azure Artifacts. Completed 100 XP. 40 minutes. Estimated time, 40 minutes. Scenario. Azure Artifacts facilitate discovery, installation, and publishing NuGet, NPM, and Maven packages in Azure DevOps. It's deeply integrated with other Azure DevOps features such as build, making package management a seamless part of your existing workflows. Objectives. After completing this lab, you'll be able to create and connect to a feed. Create and publish a NuGet package. Import a NuGet package. Update a NuGet package. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Visual Studio 2022 Community Edition is available from the Visual Studio Downloads page. Visual Studio 2022 installation should include ASP.NET and Web Development, Azure Development, and .NET Core cross-platform development workloads. Exercises. During this lab, you'll complete the following exercises. Exercise 0. Configure the lab prerequisites. Exercise 1. Working with Azure Artifacts. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following visibility should you choose if you create a feed that will allow yourself and the users you invite to publish? Private. Public. Local. 2. Which of the following choices isn't an option for private feeds? Self-hosting. Database hosting. SaaS services. 3. Which of the following choices isn't a package type supported by Azure DevOps? PHP. NPM. Python. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module describes package feeds, common public package sources, and how to create and publish packages. You learned how to describe the benefits and usage of implement package management, manage package feed, consume and create packages, publish packages. Learn more. Introduction. Completed 100 XP. 1 minute. This module details package migration, consolidation, and configuration to secure access to package feeds and artifact repositories. Learning objectives. After completing this module, students and professionals can identify artifact repositories, migrate and integrate artifact repositories, secure package feeds, understand roles, permissions, and authentication. Prerequisites: understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Identify existing artifact repositories. Completed 100 XP. 3 minutes. An artifact is a deployable component of your application. Azure pipelines can work with a wide variety of artifact sources and repositories. When you're creating a release pipeline, you need to link the required artifact sources. Often, it will represent the output of a build pipeline from a continuous integration system like Azure Pipelines, Jenkins, or TeamCity. The artifacts that you produce might be stored in source control, like Git or Team Foundation version control. But you might also be using package management tools when you get repositories. When you need to create a release, you must specify which version of the artifacts is required. By default, the release pipeline will choose the latest version of the artifacts. But you might not want that. For example, you might need to choose a specific branch, a specific build version, or perhaps you need to specify tags. Azure Artifacts are one of the services that's part of Azure DevOps. Using it can eliminate the need to manage file shares or host private package services. It lets you share code easily by allowing you to store Maven, NPM, or NuGet packages together, cloud-hosted, indexed, and matched. Now, while we can do so, there's also no need to store your binaries in Git. You can keep them directly using universal packages. It's also a great way to protect your packages. Azure Artifacts provide universal artifact management for Maven, NPM, and NuGet. And sharing packages, you can easily access all of your artifacts in builds and releases because it integrates naturally with Azure Pipelines and its CI/CD tooling, along with versioning and testing. Migrate and integrating artifact repositories. Completed 100 XP. 2 minutes. While you can continue to work with your existing artifact repositories in their current locations when using Azure Artifacts, there are advantages to migrating them. NuGet and other packages. Azure Artifacts provides hosted NuGet feeds as a service. Using this service, you can often eliminate the dependencies on on-premises resources such as file shares and locally hosted instances of NuGet server. The feeds can also be consumed by any continuous integration system that supports authenticated NuGet feeds. Walkthroughs. For details on how to integrate NuGet, NPM, Maven, Python, and universal feeds, see the following walkthroughs. Secure access to package feeds. Completed 100 XP. 3 minutes. Trusted sources. Package feeds are a trusted source of packages. The offered packages will be consumed by other codebases and used to build software that needs to be secure. Imagine what would happen if a package feed would offer malicious components in its packages. Each consumer would be affected when installing the packages onto its development machine or build server. It also happens at any other device that will run the end product, as the malicious components will be executed as part of the code. Usually, the code runs with high privileges, giving a large security risk if any packages cannot be trusted and might contain unsafe code. Securing access. Package feeds must be secured for access by authorized accounts, so only verified and trusted packages are stored there. None should push packages to a feed without the proper role and permissions. It prevents others from pushing malicious packages. It still assumes that the persons who can push packages will only add safe and secure packages. Especially in the open source world, it's done by the community. A package source can further guard its feed with the use of security and vulnerability scan tooling. Additionally, consumers of packages can use similar tooling to do the scans themselves. Securing availability. Another aspect of security for package feeds is about the public or private availability of the packages. The feeds of public sources are available for anonymous consumption. Private feeds have restricted access most of the time. It applies to the consumption and publishing of packages. Private feeds will allow only users in specific roles or teams access to its packages. Package feeds need to have secure access for different kinds of reasons. The access should involve allowing restricted access for consumption. Whenever a particular audience should only consume a package feed and its packages, it's required to restrict its access. Only those allowed access will consume the packages from the feed. Restricted access for publishing. Secure access is required to restrict who can publish, so feeds and unauthorized or untrusted persons and accounts can't modify their packages. Examine roles. Completed 100 XP. 2 minutes. Azure Artifacts has 4 different roles for package feeds. These are incremental in the permissions they give. The roles are in incremental order. Reader can list and restore or install packages from the feed. Collaborator can save packages from upstream sources. Contributor can push and unlist packages in the feed. Owner has all available permissions for a package feed. When creating an Azure Artifacts feed, the project collection build service is given contributor rights by default. This organization-wide build identity in Azure Pipelines can access the feeds it needs when running tasks. If you change the build identity to be at the project level, you need to give that identity permissions to access the feed. Any contributors to the team project are also contributors to the feed. Project collection administrators and administrators of the team project, plus the feed's creator, are automatically made owners of the feed. The roles for these users and groups can be changed or removed. Examine permissions. Completed 100 XP. 3 minutes. The feeds in Azure Artifacts require permission to the various features it offers. The list of permissions consists of increasing privileged operations. The list of privileges is as follows. You can assign users, teams, and groups to a specific role for each permission, giving the permissions corresponding to that role. You need to have the owner role to do so. Once an account has access to the feed from the permission to list and restore packages, it's considered a feed user. Like permissions and roles for the feed itself, there are extra permissions for access to the individual views. Any feed user has access to all the views, whether the default views of at local, at release, at pre-release, or newly created ones. When creating a feed, you can choose whether the feed is visible to people in your Azure DevOps organization or only specific people. See also, secure and share packages using feed permissions. Examine authentication. Completed 100 XP. 2 minutes. Azure DevOps users will authenticate against Microsoft Entra ID when accessing the Azure DevOps portal. After being successfully authenticated, they won't have to provide any credentials to Azure Artifacts itself. The roles for the user, based on its identity, or team and group membership, are for authorization. When access is allowed, the user can navigate to the Azure Artifacts section of the team project. The authentication from Azure Pipelines to Azure Artifacts feeds is taken care of transparently. It will be based upon the roles and their permissions for the build identity. The previous section on roles covered some details on the required roles for the build identity. The authentication from inside Azure DevOps doesn't need any credentials for accessing feeds by itself. However, when accessing secured feeds outside Azure Artifacts, such as other package sources, you most likely must provide credentials to authenticate to the feed manager. Each package type has its way of handling the credentials and providing access upon authentication. The command line tooling will provide support in the authentication process. For the build tasks in Azure Pipelines, you'll provide the credentials via a service connection. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check Your Answers. Check your knowledge. 1. Which of the following choices is the minimum feed permission that will allow you to list available packages and install them? Collaborator. Reader. Contributor. 2. Which of the following roles is given to the project collection build service when creating an Azure Artifacts feed by default? Owner. Reader. Contributor. 3. Which of the following choices is a recommended place to store binaries? Universal packages. Git. Team Foundation version control. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module detailed package migration, consolidation, and configuration to secure access to package feeds and artifact repositories. You learned how to describe the benefits and usage of. Identify artifact repositories. Migrate and integrate artifact repositories. Secure package feeds. Understand roles, permissions, and authentication. Learn more. Introduction. Completed 100 XP. 3 minutes. Software changes over time. The requirements for the software don't stay the same. The functionality it offers and its use will grow, change, and adapt based on feedback. The hosting of an application might evolve as well, with new operating systems, new frameworks, and versions thereof. The original implementation might contain flaws and bugs. Whatever the reason for the change, it's unlikely that the software is stable and doesn't need to change. Since the software you build takes dependencies on other components, the same holds for the components and packages you build or use while building your software. Correct versioning becomes essential to maintaining a codebase to keep track of which piece of software is currently being used. Versioning is also relevant for dependency management, as it relates to the versions of the packages and the components within. Each dependency is identified by its name and version. It allows keeping track of the exact packages being used. Each of the packages has its lifecycle and rate of change. Immutable packages. As packages get new versions, your codebase can choose when to use a new version of the packages it consumes. It does so by specifying the specific version of the package it requires. This implies that packages themselves should always have a new version when they change. Whenever a package is published to a feed, it shouldn't be allowed to change anymore. If changed, it would be at the risk of introducing potential breaking changes to the code. In essence, a published package is immutable. Replacing or updating an existing version of a package isn't allowed. Most package feeds don't allow operations that would change a current version. Regardless of the size of the change, a package can only be updated by introducing a new version. The new version should indicate the type of change and impact it might have. This module explains versioning strategies for packaging, best practices for versioning, and package promotion. Learning objectives. After completing this module, students and professionals can implement a versioning strategy, promote packages, push packages from pipeline, describe semantics and explore best practices for versioning. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. You need to create an Azure DevOps organization and a team project for some exercises. If you don't have it yet, see. Create an organization Azure DevOps. Understand versioning of artifacts. Completed 100 XP. 3 minutes. It's proper software development practice to indicate changes to code with the introduction of an increased version number. However small or large a change, it requires a new version. A component and its package can have independent versions and versioning schemes. The versioning scheme can differ per package type. Typically, it uses a scheme that can indicate the kind of change that is made. Most commonly, it involves 3 types of changes. Major change. Major indicates that the package and its contents have changed significantly. It often occurs at the introduction of a new version of the package. It can be a redesign of the component. Major changes aren't guaranteed to be compatible and usually have breaking changes from older versions. Major changes might require a large amount of work to adopt the consuming codebase to the new version. Minor change. Minor indicates that the package and its contents have extensive modifications but are smaller than a major change. These changes can be backward compatible with the previous version, although they aren't guaranteed to be. Patch. A patch or revision is used to indicate that a flaw, bug, or malfunctioning part of the component has been fixed. Usually, it's a backward compatible version compared to the previous version. How artifacts are versioned technically varies per package type. Each type has its way of indicating the version in the metadata. The corresponding package manager can inspect the version information. The tooling can query the package feed for packages and the available versions. Additionally, a package type might have its conventions for versioning and a particular versioning scheme. See also published to NuGet feeds. Explore semantic versioning. Completed 100 XP. 3 minutes. One of the predominant ways of versioning is the use of semantic versioning. It isn't a standard but does offer a consistent way of expressing the intent and semantics of a particular version. It describes a version for its backward compatibility with previous versions. Semantic versioning uses a 3-part version number and an extra label. The version has the form of major, minor, patch, corresponds to the 3 types of changes covered in the previous section. Examples of versions using the semantic versioning scheme are 1.0.0 and 3.7.129. These versions don't have any labels. For pre-release versions, it's customary to use a label after the regular version number. A label is a textual suffix separated by a hyphen from the rest of the version number. The label itself can be any text describing the nature of the pre-release. Examples of these are RC1, Beta 27, and Alpha, forming version numbers like 1.0.0. RC1 is a pre-release for the upcoming 1.0.0 version. Pre-release are a common way to prepare for the release of the label-less version of the package. Early adopters can take a dependency on a pre-release version to build using the new package. Generally, using a pre-release version of packages and their components for released software isn't a good idea. It's good to expect the impact of the new components by creating a separate branch in the codebase and using the pre-release version of the package. Chances are that there will be incompatible changes from a pre-release to the final version. See also semantic versioning 2.0.0. Examine release views. Completed 100 XP. 4 minutes. When building packages from a pipeline, the package needs to have a version before being consumed and tested. Only after testing is the quality of the package known. Since package versions can't and shouldn't be changed, it becomes challenging to choose a specific version beforehand. Azure Artifacts recognizes the quality level of packages in its feeds and the difference between pre-release and release versions. It offers different views on the list of packages and their versions, separating these based on their quality level. It fits well with the use of semantic versioning of the packages for predictability of the intent of a particular version. Still, its extra metadata from the Azure Artifacts feed is called a descriptor. Feeds in Azure Artifacts have 3 different views by default. These views are added when a new feed is created. The 3 views are: Local. The @local view contains all release and pre-release packages and the packages downloaded from upstream sources. Pre-release. The @pre-release view contains all packages that have a label in their version number. Release. The @release view contains all packages that are considered official releases. Using views. You can use views to offer help consumers of a package feed filter between released and unreleased versions of packages. Essentially, it allows a consumer to make a conscious decision to choose from released packages or opt in to pre-release of a certain quality level. By default, the @local view is used to offer the list of available packages. The format for this URI is URL https://packages.dev.azure.com/left brace your team project right brace /_packaging/left brace feed name right brace /nuget/v3/index.json. When consuming a package feed by its URI endpoint, the address can have the requested view included. For a specific view, the URI includes the name of the view, which changes to be URL https://packages.dev.azure.com/left brace your team project right brace /_packaging/left brace feed name right brace at left brace view name right brace /nuget/v3/index.json. The tooling will show and use the packages from the specified view automatically. Tooling may offer an option to select pre-release versions, such as shown in this Visual Studio 2017 NuGet dialog. It doesn't relate or refer to the pre-release view of a feed. Instead, it relies on the presence of pre-release labels of semantic versioning to include or exclude packages in the search results. See also. Promote packages. Completed 100 XP. 3 minutes. Azure Artifacts has the notion of promoting packages to views to indicate that a version is of a certain quality level. By selectively promoting packages, you can plan when packages have a certain quality and are ready to be released and supported by the consumers. You can promote packages to one of the available views as the quality indicator. Release and pre-release 2 views might be sufficient, but you can create more views when you want finer-grained quality levels if necessary, such as alpha and beta. Packages will always show in the local view, but only in a particular view after being promoted. Depending on the URL used to connect to the feed, the available packages will be listed. Upstream sources will only be evaluated when using the @local view of the feed. After they've been downloaded and cached in the @local view, you can see and resolve the packages in other views after being promoted to it. It's up to you to decide how and when to promote packages to a specific view. This process can be automated by using an Azure Pipelines task as part of the build pipeline. Packages that have been promoted to a view won't be deleted based on the retention policies. Explore best practices for versioning. Completed 100 XP. 2 minutes. There are several best practices to effectively use versions, views, and promotion flow for your versioning strategy. Here's a couple of suggestions. Have a documented versioning strategy. Adopt SemVer 2.0 for your versioning scheme. Each repository should only reference one feed. On package creation, automatically publish packages back to the feed. It's good to adopt a best practice yourself and share these with your development teams. It can be made part of the definition of done for work items related to publishing and consuming packages from feeds. See also best practices for using Azure Artifacts. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices is a correct fix if an existing package is broken or buggy? Use an older version. Publish a new version. Repair and save. 2. Which of the following action is required to make a package visible in release views other than @local? Promote. Move. Push. 3. Which of the following choices isn't a default feed view in Azure Artifacts? Remote. Pre-release. Local. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explained versioning strategies for packaging, best practices for versioning, and package promotion. You learned how to describe the benefits and usage of. Implement a versioning strategy. Promote packages. Push packages from pipeline. Describe semantic and explore best practices for versioning. Learn more. Introduction. Completed 100 XP. 3 minutes. This module introduces you to GitHub packages. It explores ways to control permissions and visibility, publish, install, delete, and restore packages using GitHub. GitHub Packages is a software package hosting service that allows you to host your packages, containers, and other dependencies. It's a central place to provide integrated permissions management and billing for software development on GitHub. GitHub Packages can host NPM, Ruby Gems, Apache Maven, Gradle, Docker, NuGet. GitHub's container registry is optimized for containers and supports Docker and OCI images. GitHub Packages give you the flexibility to control permissions and visibility for your packages. You can publish packages in a public or private repository. The permission can be inherited from the repository where the package is hosted or defined for specific user or organization accounts for packages in the container registry. You can integrate GitHub Packages with GitHub APIs, GitHub Actions, and webhooks. Learning objectives. After completing this module, students and professionals can publish packages, install packages, delete and restore packages, configure access control and visibility. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. You need to create a GitHub account at github.com and a project for some exercises. If you don't have it yet, join GitHub. If you already have your GitHub account, create a new repository creating a new repository GitHub Docs. Publish packages. Completed 100 XP. 5 minutes. GitHub Packages use native package tooling commands to publish and install package versions. Support for package registries. Language. Package format. Package client. JavaScript. Package.json. NPM. Ruby. Gemfile. Gem. Java. Pom.xml. MVN. Java. Build.gradle or build.gradle.kts. Gradle. .NET. NUPC. .NET CLI. Not applicable. Dockerfile. Docker. When creating a package, you can provide a description, installation and usage instructions, and other details on the package page. It helps people consuming the package understand how to use it and its purposes. If a new package version fixes a security vulnerability, you can publish a security advisory to your repository. Tip: you can connect a repository to more than one package. Ensure the README and description provide information about each package. Publishing a package. Using any supported package client to publish your package, you need to create or use an existing access token with the appropriate scopes for the task you want to accomplish, creating a personal access token. When you create a personal access token, PAT, you can assign the token to different scopes depending on your needs. See about permissions for GitHub packages. Authenticate to GitHub packages using your access token and the instructions for your package client. Publish the package using the instructions for your package client. Choose your package and check how to authenticate and publish, working with a GitHub packages registry. You'll see below examples for NuGet and NPM. NuGet registry. You can authenticate to GitHub packages with the .NET command line interface, CLI. Create a NuGet.config file in your project directory and specify GitHub packages as a source under package sources. XML. XML version equals 1.0 encoding equals UTF-8 configuration package sources clear / add key equals GitHub value equals https //nuget.package github.com /owner /index.json / package sources package source credentials GitHub add key equals username value equals username / add key equals clear text password value equals token / /GitHub /package source credentials / configuration. Note: replace username with the name of your personal account on GitHub, token with your PAT, and owner with the name of the user or organization account that owns your project's repository. You can publish a package authenticating with a NuGet.config file, or using the API key command line option with your GitHub PAT. .NET. .NET NuGet push bin /release /opticat app .1.0.0.nup API key your _GitHub _PAT source GitHub. NPM registry. You can authenticate using NPM by either editing your per user / .npm-rc file to include your PAT or by logging into NPM on the command line using your username and personal access token. Edit your / .npm-rc file for your project to include the following line: / npm.package github.com /:auth token equals token. Create a new / .npm-rc file if one doesn't exist. If you prefer to authenticate by logging into NPM, use the npm login command. $npm login scope equals at owner registry equals https / npm.package github.com. Username password, token email, public email address. Note: replace username with your GitHub username, token with your PAT, and public email address with your email address. To publish your NPM package, see working with the NPM registry GitHub docs. After you publish a package, you can view the package on GitHub. See viewing packages. For an example package page, see codertocat /hello world npm, github.com. For more information, see install a package. Completed 100 XP. 5 minutes. You can install any package you have permission to view from GitHub packages and use the package as a dependency in your project. You can search for packages globally across all of GitHub or within a particular organization. For details, see searching for packages. After you find a package, read the package's installation and description instructions on the package page. You can install a package using any supported package client following the same general guidelines. Authenticate to GitHub packages using the instructions for your package client. Install the package using the instructions for your package client. NuGet. To use NuGet packages from GitHub packages, you must add dependencies to your docs.proj file. For more information on using a docs.proj file in your project, see working with NuGet packages. If you're using Visual Studio, expand your solution project right-click on dependencies manage NuGet packages. You can browse, install, and update dependencies from multiple registries. For more information, see create and remove project dependencies. Or, you can update your docs.proj file directly. Authenticate to GitHub packages. Add item group and configure the package reference field in the docs.proj project file. Project SDK equals Microsoft.NET. SDK property group output type exe /output type target framework netcarap 3.0 /target framework package ID octocat app package ID version 1.0.0 version authors octocat authors company GitHub company package description. This package adds an octocat package description repository URL https //github.com owner repository URL property group item group. Package reference include equals octokit nap version equals 12.0.2 / item group project. Note: replace the octokit nap package with your package dependency and 1.0.0 with the version you want to use. Install the packages with the restore command. npm. You need to add the .npm-rc file to your project to install packages from GitHub packages. Authenticate to GitHub packages. In the same directory as your package.json file, create or edit a .npm-rc file. Include a line specifying GitHub package's URL and the account owner. At owner registry equals https://npm.package.github.com. Note, replace owner with the name of the user or organization account. Add the .npmrc file to the repository. See adding a file to a repository. Configure package.json in your project to use the package you're installing. JSON. Name at myorg/server, version 1.0.0, description, server app that uses the octorg/octoapp package, main, index.js, author, license, MIT, dependencies, at octorg/octoapp, 1.0.0. Install the package. Optional, if you need to install packages from other organizations, you can add extra lines to your .npmrc file. For more information, see. Delete and restore a package. Completed 100 XP. 4 minutes. You can delete it on GitHub if you have the required access. An entire private package. If there aren't more than 5,000 downloads of any version of the package, an entire public package. A specific version of a private package. A specific version of a public package if the package version doesn't have more than 5,000 downloads. For packages that inherit their access permissions from repositories, you can delete a package if you have admin permissions to the repository. You can also restore an entire package or package version if you restore the package within 30 days of its deletion. The same package namespace is still available and not used for a new package. You can use the REST API to manage your packages. For more information, see the GitHub Packages API. Deleting a package version. You can delete a package version. Deleting a version of a repository scoped package on GitHub. Deleting a version of a repository scoped package with GraphQL. Deleting a version of a user scoped package on GitHub. Deleting a version of an organization scoped package on GitHub. To delete a version of a repository scoped package, you must have admin permissions to the repository that owns the package. On github.com, navigate to the main page of the repository. To the right of the list of files, click Packages. Search for and select your package. In the top right of your package's landing page, click Package Settings. On the left, click Manage Versions. To the right of the version you want to delete, click and select Delete Version. To confirm the deletion, type the package name and click I understand the consequences, delete this version. Deleting an entire package. You can delete a package version. Deleting an entire repository scoped package on GitHub. Deleting an entire user scoped package on GitHub. Deleting an entire organization scoped package on GitHub. To delete an entire repository scoped package, you must have admin permissions to the repository that owns the package. On github.com, navigate to the main page of the repository. To the right of the list of files, click Packages. Search for and select your package. In the top right of your package's landing page, click Package Settings. Under Danger Zone, click Delete this package. Review the confirmation message, enter your package name, click I understand, and delete this package. Restoring a package version. You can restore a package version from your package's landing page. Navigate to your package's landing page. On the right, click Package Settings. On the left, click Manage Versions. Use the Versions drop-down menu and select Deleted on the top right. Next to the deleted package version you want to restore, click Restore. To confirm, click I understand the consequences, restore this version. For more information, see. Explore Package Access Control and Visibility. Completed 100 XP. 3 minutes. You can only use granular permissions with the container registry, scoped to a personal user or organization account. GitHub.com doesn't support granular permissions in other package registries, like the NPM registry. You can change the package access control and visibility separately from the repository. For more information about permissions, see About Permissions for GitHub packages. Container images visibility and access permissions. If you have admin permissions to a container image, you can set the access permissions for the container image to private or public. As an admin, you can also grant access permissions for a container image separate from your set permissions at the organization and repository levels. You can give any person an access role for container images published and owned by a personal account. For container images published and owned by an organization, you can provide any person or team in the organization an access role. Permission. Access description. Read. Can download the package. Can read package metadata. Write. Can upload and download this package. Can read and write package metadata. Admin. Can upload, download, delete, and manage this package. Can read and write package metadata. Can grant package permissions. For more information about the package's access control and visibility configuration, see Configuring a package's access control and visibility GitHub Docs. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices contains valid packages that GitHub packages can host? Apache Maven, Gradle, and Go modules. Ruby Gems, Docker, and NuGet. NuGet, Conan, for C/C++, and Cargo, for Rust. 2. Which of the following choices is the most secure and recommended authentication method for GitHub packages? Personal Access Token, PAT. User and Password. OAuth Token. 3. Which of the following choices is the minimum user or team permission within the GitHub organization that allows a package delete action? Write. Read. Admin. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module introduced you to GitHub packages. It explored ways to control permissions and visibility, publish, install, delete and restore packages using GitHub. You learned how to describe the benefits and usage of publish packages, install packages, delete and restore packages, configure access control and visibility. Learn more. Introduction. Completed 100 XP. 1 minute. This module introduces you to continuous feedback practices and tools to track usage and flow, such as Azure Logs Analytics, Kusto Query Language, KQL, and Application Insights. Learning objectives. After completing this module, students and professionals can implement tools to track feedback, plan for continuous monitoring, implement application insights, use Kusto Query Language, KQL. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Understand the inner loop. Completed 100 XP. 1 minute. It isn't clear who coined the term inner loop in the context of software engineering, but within Microsoft, at least, the word seems to have stuck. Many of the internal teams I work with see it as something they want to keep as short as possible, but what is the inner loop? Definitions. The easiest way to define the inner loop is the iterative process that a developer does when writing, building, and debugging code. There are other things that a developer does. It's the right set of steps to be done repeatedly before sharing their work with their team or the rest of the world. Exactly what goes into an individual developer's inner loop will depend significantly on the technologies they're working with, the tools used, and their preferences. If I were working on a library, my inner loop would include coding, building, testing, execution, and debugging with regular commits to my local Git repository. On the other hand, if I were doing web front-end work, I would probably be optimized around hacking on HTML and JavaScript, bundling, and refreshing the browser, followed by regular commits. Most codebases comprise multiple moving parts, so the definition of a developer's inner loop on any single codebase might alternate depending on what is being worked on. Understanding the loop. The steps within the inner loop can be grouped into 3 broad activity buckets: experimentation, feedback collection, and tax. If we flick back to the library development scenario I mentioned, I said 4 steps and how to bucket them. Coding, experimentation. Building, feedback collection. Testing/debugging, feedback collection. Committing, tax. Of all the steps in the inner loop, coding is the only one that adds customer value. Building and testing code is essential, but ultimately, we use them to give the developer feedback about their writing to see if it delivers sufficient value. Putting committing code in the tax bucket is perhaps a bit harsh, but the purpose of the bucket is to call out those activities that neither add value nor provide feedback. Tax is necessary to work. If it's unnecessary work, it's waste and should be eliminated. Loop optimization. Having categorized the steps within the loop, it's now possible to make some general statements. You want to execute the loop as fast as possible and for the total loop execution time to be proportional to the changes made. You want to minimize the time feedback collection takes, but maximize the quality of the feedback that you get. You want to minimize the tax you pay by eliminating it where it's unnecessary to run through the loop. Can you defer some operations until you commit, for example? As new code and more complexity is added to any codebase, the amount of outward pressure to increase the size of the inner loop also increases. More code means more tests, which means more execution time and slow execution of the inner loop. Suppose you have ever worked on a large monolithic codebase. In that case, it's possible to get into a situation where even small changes require a disproportionate amount of time to execute the feedback collection steps of the inner loop. It's a problem, and you should fix it. There are several things that a team can do to optimize the inner loop for larger codebases. Only build and test what was changed. Cache intermediate build results to speed up to complete builds. Break up the codebase into small units and share binaries. How you tackle each one of those is probably a blog post. At Microsoft, for some of our genuinely massive monolithic codebases, we're investing heavily in number 1 and number 2, but number 3 requires a special mention because it can be a double-edged sword and can have the opposite of the wished impact if done incorrectly. Tangled loops. To understand the problem, we need to look beyond the inner loop. Let us say that our monolithic codebase has an application-specific framework that does much heavy lifting. It would be tempting to extract that framework into a set of packages. To do this, you would pull that code into a separate repository, optional, but this is generally how it's done, then set up a different CI/CD pipeline that builds and publishes the package. A different pull request process would also front this separate build and release pipeline to inspect changes before the code is published. When someone needs to change this framework code, they clone down the repository, make changes, a separate inner loop, and submit a PR that transitions the workflow from the inner loop to the outer loop. The framework package would then be available to be pulled into dependent applications, in this case, the monolith. Initially, things might work out well. However, at some point in the future, you'll likely want to develop a new feature in the application that requires extensive new capabilities to be added to the framework. It's where teams that have broken up their codebases in suboptimal ways will start to feel pain. If you have to co-evolve code in two separate repositories where a binary/library dependency is present, you'll experience some friction. In loop terms, the original codebase inner loop now, temporarily at least, includes the outer loop of the previously broken out framework code. Outer loops include tasks, including code reviews, scanning passes, binary signing, release pipelines, and approvals. You don't want to pay that every time you've added a method to a class in the framework and now want to use it in your application. What generally ends up happening next is a series of local hacks by the developer to stitch the inner loops together so they can move forward efficiently, but it gets messy quickly. You must pay that outer loop tax at some point. It isn't to say that breaking code into separate packages is inherently bad, it can work brilliantly. You need to make those incisions carefully. Closing thoughts. There's no silver bullet solution to ensure that your inner loop doesn't start slowing down, but it's essential to understand when it starts happening, what the cause is, and work to address it. Decisions such as how you build, test, and debug the architecture will all impact developers' productivity. Improving one aspect will often cause issues in another. Introduction to continuous monitoring. Completed 100 XP. 4 minutes. Continuous monitoring refers to the process and technology required to incorporate monitoring across each DevOps and IT operations lifecycles phase. It helps to continuously ensure your application's health, performance, reliability, and infrastructure as it moves from development to production. Continuous monitoring builds on the concepts of continuous integration and continuous deployment, CI/CD, which help you develop and deliver software faster and more reliably to provide continuous value to your users. Azure Monitor is a unified monitoring solution in Azure that provides full-stack observability across applications and infrastructure in the cloud and on-premises. It works seamlessly with Visual Studio and Visual Studio Code during development and testing and integrates with Azure DevOps for release management and work item management during deployment and operations. It even integrates across your ITSM and CM tools to help track issues and incidents within your existing IT processes. This article describes specific steps for using Azure Monitor to enable continuous monitoring throughout your workflows. It includes links to other documentation that provides details on implementing different features. Enable monitoring for all your applications. To gain observability across your entire environment, you need to enable monitoring on all your web applications and services. It will allow you to visualize end-to-end transactions and connections across all the components easily. Azure DevOps Projects gives you a simplified experience with your existing code and Git repository, or choose from one of the sample applications to create a continuous integration, CI, and continuous delivery, CD, pipeline to Azure. Continuous monitoring in your DevOps release pipeline allows you to gate or roll back your deployment based on monitoring data. Status Monitor allows you to instrument a live .NET app on Windows with Azure Application Insights without modifying or redeploying your code. If you have access to the code for your application, then enable complete monitoring with Application Insights by installing the Azure Monitor Application Insights SDK for .NET, Java, Node.js, or any other programming language. It lets you specify custom events, metrics, or page views relevant to your application and business. Enable monitoring for your entire infrastructure. Applications are only as reliable as their underlying infrastructure. Monitoring enabled across your entire infrastructure will help you achieve full observability and make discovering a potential root cause easier when something fails. Azure Monitor helps you track the health and performance of your entire hybrid infrastructure, including resources such as VMs, containers, storage, and network. You automatically get platform metrics, activity logs, and diagnostics logs from most of your Azure resources with no configuration. Enable deeper monitoring for VMs with Azure Monitor. Enable deeper monitoring for AKS clusters with Azure Monitor for containers. Add monitoring solutions for different applications and services in your environment. Infrastructure as code manages infrastructure in a descriptive model, using the same versioning as DevOps teams use for source code. It adds reliability and scalability to your environment and allows you to apply similar processes to manage your applications. Use Resource Manager templates to enable monitoring and configure alerts over a large set of resources. Use Azure Policy to enforce different rules over your resources. It ensures those resources comply with your corporate standards and service level agreements. Combine resources in Azure Resource Groups. Today, a typical application on Azure includes multiple resources such as VMs and app services or microservices hosted on cloud services, AKS clusters, or Service Fabric. These applications frequently use dependencies like event hubs, storage, SQL, and Service Bus. Combine resources in Azure Resource Groups to get complete visibility of all the resources that make up your different applications. Azure Monitor for Resource Groups provides a simple way to keep track of the health and performance of your entire full-stack application and enables drilling down into respective components for any investigations or debugging. Ensure quality through continuous deployment. Continuous integration/continuous deployment allows you to automatically integrate and deploy code changes to your application based on automated testing results. It streamlines the deployment process and ensures the quality of any changes before they move into production. Use Azure pipelines to implement continuous deployment and automate your entire process from code commit to production based on your CI/CD tests. Use quality gates to integrate monitoring into your pre-deployment or post-deployment. It ensures that you meet the key health/performance metrics, KPIs, as your applications move from dev to production. Any differences in the infrastructure environment or scale aren't negatively impacting your KPIs. Maintain separate monitoring instances between your different deployment environments, such as dev, test, canary, and prod. It ensures that collected data is relevant across the associated applications and infrastructure. If you need to correlate data across environments, use multi-resource charts in Metrics Explorer or create cross-resource queries in Log Analytics. Create actionable alerts with actions. A critical monitoring aspect is proactively notifying administrators of current and predicted issues. Create alerts in Azure Monitor based on logs and metrics to identify predictable failure states. It would be best if you had a goal of making all alerts actionable, meaning that they represent actual critical conditions and seek to reduce false positives. Use dynamic thresholds to automatically calculate baselines on metric data rather than defining your static thresholds. Define actions for alerts to use the most effective means of notifying your administrators. Available actions for notification are SMS, emails, push notifications, or voice calls. Use more advanced actions to connect to your ITSM tool or other alert management systems through webhooks. Remediate situations identified in alerts with Azure Automation Runbooks or Logic apps that can be launched from an alert using webhooks. Use autoscaling to dynamically increase and decrease your compute resources based on collected metrics. Prepare dashboards and workbooks. Ensuring that your development and operations have access to the same telemetry and tools allows them to view patterns across your entire environment and minimize your mean time to detect, MTTD, and mean time to restore, MTTR. Prepare custom dashboards based on standard metrics and logs for the different roles in your organization. Dashboards can combine data from all Azure resources. Prepare workbooks to ensure knowledge sharing between development and operations. It could be prepared as dynamic reports with metric charts and log queries or as troubleshooting guides designed by developers to help customer support or operations handle fundamental problems. Continuously optimize. Monitoring is one of the fundamental aspects of the popular build, measure, learn philosophy, which recommends continuously tracking your KPIs and user behavior metrics and optimizing them through planning iterations. Azure Monitor helps you collect metrics and logs relevant to your business and add new data points in the following deployment. Use tools and application insights to track end user behavior and engagement. Use impact analysis to help you prioritize which areas to focus on to drive to important KPIs. Explore Azure Monitor and Log Analytics. Completed 100 XP. 6 minutes. When you run at a cloud scale, you need intelligent logging and monitoring tools that scale to your needs and provide real-time insight into your data. Azure Monitor is Microsoft's native cloud monitoring solution. Azure Monitor collects monitoring telemetry from different kinds of on-premises and Azure sources. Azure Monitor provides management tools, such as those in Azure Security Center and Azure Automation, enabling ingestion of custom log data to Azure. The service aggregates and stores this telemetry in a log data store optimized for cost and performance. With Azure Monitor, you can analyze data, set up alerts, and get end-to-end views of your applications. And use machine learning-driven insights to identify and resolve problems quickly. In this tutorial, we focus on the log analytics part of Azure Monitor. You'll learn how to set up Log Analytics Workspace, connect virtual machines to a Log Analytics Workspace, configure Log Analytics Workspace to collect custom performance counters, analyze the telemetry using Kusto query language. Getting started. You need a resource group with one or more virtual machines that you have access to RDP to follow along. Log into Azure Shell. Execute the command following. It creates a new resource group and Log Analytics Workspace. Take a record of the workspace seed of the Log Analytics Workspace as we're using it again. PowerShell. $resource group equals as we rg dev test log 001 $workspace name equals as we dev test log 01 $location equals West Europe hashtag list of solutions to enable $solutions equals capacity performance. Log management, change tracking, process investigator hashtag create the resource group if needed try. Get AZ resource group name $resource group error action stop. Catch. New AZ resource group name $resource group location $location. Hashtag create the workspace new AZ operational insights workspace location $location. Name $workspace name resource group name $resource group hashtag list all solutions and their installation status get AZ operational insights intelligence packs resource group name $resource group workspace name $workspace name hashtag add solutions for each $solution in $solutions set AZ operational insights intelligence pack resource group name $resource group workspace name intelligence pack name $solution enable $true hashtag list enabled solutions get AZ operational insights intelligence packs resource group name $resource group workspace name where $enabled EQ $true hashtag enable IIS log collection using the agent enable AZ operational insights IIS log collection resource group name $resource group workspace name hashtag Windows event new AZ operational insights Windows event data source resource group name $resource group workspace name event log name application collect errors collect warnings name example application event log retrieve the Log Analytics Workspace secure key PowerShell. Get AZ Operational Insights Workspace Shared Key Resource Group Name as we rg dev test log 001 name as we dev test log 01. Map existing virtual machines with the Log Analytics Workspace. The following query uses the Workspace and Workspace secret key of the Log Analytics Workspace to install the Microsoft Enterprise Cloud Monitoring extension onto an existing VM. PowerShell. $public settings equals at workspace ID equals my workspace ID. $protected settings equals at workspace key equals my workspace key. Set AZDM extension name Microsoft.Enterprise Cloud. Monitoring resource group name as we RG dev test log 001 VM name as a D SQL 0101 publisher Microsoft.Enterprise Cloud. Monitoring extension type Microsoft Monitoring Agent type handler version 1.0 settings $public settings protected settings location. West Europe. Run the script to configure the below listed performance counters to be collected from the virtual machine. PowerShell. Hashtag login Azure account. Hashtag instance hashtag $instance name all equals asterisk $instance name total equals underscore total. Hashtag objects hashtag $object cache equals cache $object logical disk equals logical disk $object memory equals memory $object network adapter equals network adapter $object network interface equals network interface $object paging file equals paging file $object process equals process $object processor information equals processor information $object processor equals processor Object SQL agent alerts equals SQL agent. Alerts $object SQL agent jobs equals SQL agent. Jobs $object SQL agent statistics equals SQL agent. Statistics $object SQL server access methods equals SQL server. Access methods $object SQL server exec statistics equals SQL server. Exec statistics $object SQL server locks equals SQL server. Locks $object SQL server SQL errors equals SQL server. SQL errors $object system equals system hashtag counters hashtag $counter cache equals copy read hits $counter logical disk equals %free space. Average disk SEC/read, average disk SEC/transfer, average disk SEC/write, current disk queue length, disk read bytes/SEC, disk read/SEC, disk transfers/SEC, disk writes/SEC $counter memory equals %committed bytes in use, available MBytes, page fault/SEC, pages input/SEC, pages output/SEC, pool non-paged bytes $counter network adapter equals bytes received/SEC, bytes sent/SEC Counter network interface equals bytes total/SEC $counter paging file equals %usage. %usage peak $counter process equals %processor time $counter processor information equals %interrupt time. Interrupt/SEC $counter processor equals %processor time $counter processor total equals %processor time $counter SQL agent alerts equals activated alerts. $counter SQL agent jobs equals failed jobs $counter SQL agent statistics equals SQL server restarted $counter SQL server access methods equals table lock escalations/SEC. $counter SQL server exec statistics. Equals distributed query $counter SQL server locks equals number of deadlocks/SEC $counter SQL server SQL errors equals errors/SEC $counter system equals processor queue length. Hashtag $global number equals 1 hashtag name parameter needs to be unique. That why we'll use number plus plus in function hashtag function add perf counters, $perf object, $perf counters, $instance, for each, $counter and $perf counters, new. AZ Operational Insights Windows Performance Counter Data Source Resource Group Name as we RG Dev Test Log 001 Workspace Name as we Dev Test Log 01 Object Name $perf Object Instance Name $instance Counter Name $counter Interval Seconds 10 Name Windows Performance Counter $global Number plus plus Add perf counters perf object $object Logical Disk perf counter $counter logical disk instance $instance name all add perf counters perf object $object network adapter perf counter $counter network adapter instance $instance name all add perf counters perf object $object network interface perf counter $counter network interface instance $instance name all add perf counters perf object $object paging file perf counter $counter paging file instance $instance name all add perf counters perf object $object process perf counter $counter process instance $instance name all add perf counters perf object $object processor information perf counter $counter processor information instance $instance name all add perf counters perf object $object processor perf counter $counter processor instance $instance name all add perf counters perf object $object processor perf counter $counter processor total instance $instance name total add perf counters perf object $object SQL agent alerts perf counter $counter SQL agent alerts instance $instance name all add perf counters perf object $object SQL agent jobs perf counter $counter SQL agent jobs instance $instance name all add perf counters perf object $object SQL agent statistics perf counter $counter SQL agent statistics instance $instance name all add perf counters perf object $object SQL server access methods perf counter $counter SQL server access methods instance $instance name all add perf counters perf object $object SQL server exec statistics perf counter $counter SQL server exec statistics instance $instance name all add perf counters perf object $object SQL server locks perf counter $counter SQL server locks instance $instance name all add perf counters perf object $object SQL server SQL errors perf counter $counter SQL server SQL errors instance $instance name all add perf counters perf object $object system perf counter $counter system instance $instance name all add perf counters perf object $object memory perf counter $counter memory instance $instance name all add perf counters perf object $object cache perf counter $counter cache instance $instance name all to generate some interesting performance statistics. Download the Heavy Load utility, a free load testing utility, and run it on the virtual machine to simulate high CPU, memory, and IOPS consumption. How it works. Log Analytics works by running the Microsoft Monitoring Agent service on the machine. The service locally captures and buffers the events and pushes them securely out to the Log Analytics workspace in Azure. Log into the virtual machine, navigate to the C:\program files /Microsoft Monitoring Agent /MMA, and open the control panel. It shows you the details of the Log Analytics workspace connected. You also can add multiple Log Analytics workspaces to publish the log data into various workspaces. Summary. So far, we've created a Log Analytics workspace in a resource group. The Log Analytics workspace has been configured to collect performance counters, event logs, and IIS logs. The Microsoft Enterprise Cloud Monitoring extension has mapped a virtual machine to the Log Analytics workspace. Heavy Load has been used to simulate high CPU, memory, and IOPS on the virtual machine. Examine Kusto Query Language, KQL. Completed 100 XP. 5 minutes. Kusto is the primary way to query Log Analytics. It provides both a query language and a set of control commands. Kusto can be used directly within Azure Data Explorer. Azure Data Studio also offers a Kusto query experience and supports the creation of Jupyter-style notebooks for Kusto queries. See Getting Started with Kusto Queries. Walkthrough. Note, this walkthrough continues the previous lesson on Azure Log Analytics, and the walkthrough started within it. Log into the Azure portal and navigate to the Log Analytics workspace. From the left blade in the Log Analytics workspace, click Logs. It will open the Logs window, ready for you to start exploring all the data points captured into the workspace. We'll need to use the Kusto query language to query the logs. Run the following query to list the last heartbeat of each machine connected to the Log Analytics workspace. C# / last heartbeat of each computer / show the last heartbeat set by each computer heartbeat, summarize arg_max, time generated, * by computer. Show a list of all distinct counters being captured. C# / what data is being collected? / list the collected performance counters and object types, process, memory, processor. Perf, summarized by object name, counter name. Show a count of the data points collected in the last 24 hours. The result shows that we have 88 M data points. We can query against them in near real time to analyze and correlate insights. Run the following query to generate the max CPU utilization trend over the last 24 hours, aggregated at a granularity of 1 minute, render the data as a time chart. C#. Perf, where object name equals processor and instance name equals _total, summarize max, counter value, by computer, bin, time generated, 1M, render time chart. Run the following query to see all the processes running on that machine contributing to the CPU utilization. Render the data in a pie chart. C#. Perf, where object name contains process and instance name, in_total, idle, and counter name equals % processor time, summarize average, counter value, by instance name, counter name, bin, time generated, 1M, render pie chart. There's more. This unit has introduced the basic concepts of Log Analytics and how to get started with the basics. We've only scratched the surface of what is possible with Log Analytics. We would encourage you to try out the advanced tutorials available for Log Analytics on Microsoft Learn. Explore application insights. Completed 100 XP. 5 minutes. You install a small instrumentation package in your application and set up an Application Insights resource in the Microsoft Azure portal. The instrumentation monitors your app and sends telemetry data to the portal. The application can run anywhere, it doesn't have to be hosted in Azure. You can instrument the web service application, background components, and JavaScript in the web pages. Also, you can pull in telemetry from the host environments such as performance counters, Azure Diagnostics, or Docker logs. You can also set up web tests periodically, sending synthetic requests to your web service. All these telemetry streams are integrated into the Azure portal, where you can apply powerful analytic and search tools to the raw data. What's the overhead? The impact on your app's performance is minimal. Tracking calls are non-blocking and are batched and sent in a separate thread. What do Application Insights monitor? Application Insights is aimed at the development team to help you understand how your app is doing and being used. It monitors request rates, response times, and failure rates. Find out which pages are most popular, at what times of day, and where your users are. See which pages do best. If your response times and failure rates increase with more requests, perhaps you have a resourcing problem. Dependency rates, response times, and failure rates. Find out whether external services are slowing you down. Exceptions analyze the aggregated statistics, pick specific instances, and drill into the stack trace and related requests. Both server and browser exceptions are reported. Page views and load performance reported by your users' browsers. AJAX calls from web pages rates, response times, and failure rates. User and session count. Performance counters from your Windows or Linux server machines include CPU, memory, and network usage. Host diagnostics from Docker or Azure. Diagnostic trace logs from your app so you can correlate trace events with requests. Custom events and metrics that you write yourself in the client or server code to track business events such as items sold or games won. Where do I see my telemetry? There are plenty of ways to explore your data. Check out this article for more information, smart detection, and manual alerts. Automatic alerts adapt to your app's usual patterns of telemetry and trigger when there's something outside the usual pattern. You can also set alerts on levels of custom or standard metrics. Application app. The components of your app with key metrics and alerts. Profiler. Inspect the execution profiles of sampled requests. Usage analysis. Analyze user segmentation and retention. Diagnostic search, for instance, data. Search and filter events such as requests, exceptions, dependency calls, log traces, and page views. Metrics Explorer for aggregated data. Explore, filter, and segment aggregated data such as rates of requests, failures, exceptions, response times, and page load times. Dashboards. Mash up data from multiple resources and share it with others. Great for multi-component applications and continuous display in the team room. Live metrics stream. When you deploy a new build, watch these near real-time performance indicators to ensure everything works as expected. Analytics. Answer challenging questions about your app's performance and usage by using this powerful query language. Visual Studio. See performance data in the code. Go to code from stack traces. Snapshot debugger. Debug snapshots sampled from live operations with parameter values. Power BI. Integrate usage metrics with other business intelligence. REST API. Write code to run queries over your metrics and raw data. Continuous export. Bulk export of raw data to storage as soon as it arrives. Implement Application Insights. Completed 100 XP. 3 minutes. Monitor. Install Application Insights in your app, set up availability web tests, and set up a dashboard for your team room to keep an eye on load, responsiveness, and the performance of your dependencies, page loads, and AJAX calls. Discover which are the slowest and most failing requests. Watch live stream when you deploy a new release to know immediately about any degradation. Detect, diagnose. If you receive an alert or discover a problem. Assess how many users are affected. Correlate failures with exceptions, dependency calls, and traces. Examine profiler, snapshots, stack dumps, and trace logs. Build, measure, learn. Measure the effectiveness of each new feature that you deploy. Plan to measure how customers use new UX or business features. Write custom telemetry into your code. Base the next development cycle on hard evidence from your telemetry. Get started. Application Insights is one of the many services hosted within Microsoft Azure, and telemetry is sent there for analysis and presentation. So, before you do anything else, you'll need a subscription to Microsoft Azure. It's free to sign up, and if you choose the basic pricing plan of Application Insights, there's no charge until your application has grown to have large usage. If your organization already has a subscription, they could add your Microsoft account to it. There are several ways to get started. Begin with whichever works best for you. You can add the others later. At runtime. Instrument your web app on the server. Avoids any update to the code. You need admin access to your server. At development time. Add Application Insights to your code. Allows you to write custom telemetry and to instrument backend and desktop apps. Visual Studio 2013 Update 2 or later. Java. Node.js. Other platforms. Instrument your web pages for page view and another client-side telemetry. Analyze mobile app usage by integrating with Visual Studio App Center. Availability tests. Ping your website regularly from our servers. Design and implement metrics and queries. Completed 100 XP. 3 minutes. Collecting metrics associated with project lifecycle allows organizations to gain insights into their software development practices and streamline their DevOps processes. By enabling telemetry data collection from project activities, teams can track pipeline runs, work item updates, and other DevOps-related events in real time. This approach is important for enhancing visibility, monitoring performance, and optimizing the software development lifecycle. It empowers teams to make data-driven decisions, identify bottlenecks in the project workflow, and continuously improve their development practices. Both GitHub and Azure DevOps include support for collecting and analyzing project-related telemetry. GitHub implements a few built-in metrics that reflect repository activity, pull request performance, and community engagement through its Insights feature, but its project tracking and analytics capabilities are limited. Azure DevOps, on the other hand, offers a comprehensive set of analytics and reporting features specifically designed to support project monitoring and management. It provides customizable dashboards, rich reporting capabilities, and a wide range of predefined metrics and queries that facilitate tracking work progress throughout the software development lifecycle. In addition to the telemetry functionality built into GitHub and Azure DevOps, you can extend the scope of monitoring by taking advantage of Azure services such as Azure Monitor and Application Insights. In this case, Azure DevOps also offers richer and more streamlined integration than GitHub. Using GitHub built-in project tracking. In GitHub projects, tracking progress involves monitoring metrics such as issue throughput, issue aging, code review turnaround time, pull request merge time, and contributor activity. These metrics offer insights into project health, team efficiency, and code quality, helping with identifying areas for improvement and project execution. The simplest way to review metrics in GitHub projects is to use the Insights functionality, which supports visualizing repository activity, pull request performance, and community engagement. In addition, it is possible to create custom GitHub Actions workflows that automate the collection and processing of project metrics. Such workflows can be triggered based on events such as pull requests, issues, or code pushes, and include actions to collect and analyze metrics. Another option is to leverage GitHub REST API to programmatically access project data, including metrics related to issues, pull requests, and contributors. Such data can serve as the basis for building custom dashboards or reports using other analytics tools. Using Azure DevOps built-in project tracking. Azure DevOps offers a large number of built-in metrics that reflect various aspects of project management, such as cycle time, lead time, workflow efficiency, and backlog health. In general, these metrics can be grouped into several categories. Work item metrics. Count of work items. Monitor the total number of work items created, completed, or in progress over time. Work item age. Track the age of open work items to identify overdue tasks. Velocity. Measure the rate at which work items are completed over iterations or sprints. Build and release metrics. Build success rate. Monitor the percentage of successful builds versus failed builds. Release deployment frequency. Track how frequently releases are deployed to production or other environments. Deployment success rate. Measure the percentage of successful deployments to identify any deployment issues. Test metrics. Test case pass rate. Monitor the percentage of passed test cases versus failed test cases. Test case execution time. Track the time taken to execute test cases to identify performance bottlenecks. Test case failure trends. Analyze trends in test case failures to identify recurring issues. Code metrics. Code churn. Measure the amount of code added, modified, or deleted over time. Code quality metrics. Monitor code quality metrics such as code coverage, cyclomatic complexity, and maintainability index. Team performance metrics. Sprint burndown. Track the progress of sprint goals by monitoring the remaining work versus time. Team velocity. Measure the average amount of work completed by the team in each sprint. Lead time. Monitor the time taken from the creation of a work item to its completion. You can display and analyze these metrics by using dashboards accessible directly within Azure DevOps Portal. For additional insights into project progress and performance, consider creating custom, query-based reports in Azure DevOps Analytics. Some of the more commonly used queries, groupings, and visualizations that provide meaningful insights into Azure DevOps projects include cycle time analysis. Query to calculate the cycle time taken to complete a work item from start to finish for different types of work items, e.g., user stories, bugs, over time. Group the work items by their state, e.g., active, resolved, closed. Calculate the time difference between the creation date and the completion date of each work item. Visualize the average cycle time per state over time to identify bottlenecks and improve process efficiency. Lead time distribution. Query to analyze the lead time taken from the creation of a work item to its completion, distribution for different teams or areas of the project. Group the work items by their area path or team assignment. Calculate the lead time for each work item and visualize the distribution using a histogram or box plot. Identify outliers and investigate the reasons for longer lead times in specific areas to optimize workflow and reduce delivery time. Cumulative flow diagram, CFD. Query to create a cumulative flow diagram that tracks the number of work items in each state, e.g., to do, in progress, done, over time. Group the work items by their state and order them by their date of state change. Calculate the cumulative count of work items in each state at regular intervals, e.g., daily, weekly. Visualize the CFD to monitor the flow of work items through the project stages and identify areas of congestion or delays. Work item aging analysis. Query to analyze the aging of work items in the backlog or specific stages of the project. Group the work items by their age, e.g., days since creation, and their priority or type. Calculate metrics such as the average age of work items, the percentage of overdue work items, and the distribution of aging across different categories. Visualize the aging trends to prioritize backlog grooming activities and ensure timely delivery of high-priority items. Using Azure Monitor and Application Insights for project tracking. There are numerous ways to integrate project tracking with Azure Monitor and Application Insights, but one of the more commonly used approaches involves combining continuous monitoring, release annotations, and work items. This optimizes the software development lifecycle by providing valuable information on performance bottlenecks, facilitating proactive issue resolution, and enabling informed decision-making in order to successfully deliver high-quality software. With continuous monitoring, release pipelines can incorporate monitoring data from Application Insights. Effectively, an Application Insights alert can block or roll back a gated deployment until the alert is resolved. Conversely, if monitoring checks pass, deployments can proceed automatically, without the need for manual intervention. Annotations designate events in the CI/CD pipeline. They capture correlation between delivery of software releases and the resulting application performance. Azure DevOps support automatic generation of annotations by build pipelines. You can also create arbitrary annotations by using PowerShell. Work items integration functionality facilitates embedding contextual application insights data when generating work items in GitHub and Azure DevOps. This supports a number of features that facilitate data capture and work item generation, including advanced fields like assignee, projects, or milestones. Multiple configurations for any number of repositories or work items. Pre-built and customizable keyword query language, KQL, queries to add application insights data to work items. Customizable workbook templates. Monitor application performance with application insights. Completed 100 XP. 60 minutes. Estimated time, 60 minutes. Scenario. Application Insights is an extensible application performance management (APM) service for web developers on multiple platforms. You can use it to monitor your live web applications. It automatically detects performance anomalies, includes powerful analytics tools to help you diagnose issues, and helps you continuously improve performance and usability. It works for apps on various platforms, including .NET, Node.js, and Java EE, hosted on-premises, hybrid, or any public cloud. It integrates with your DevOps process with connection points available in various development tools. It also allows you to monitor and analyze telemetry from mobile apps through integration with Visual Studio App Center. In this lab, you'll learn how to add application insights to an existing web application and monitor the application via the Azure portal. Objectives. After completing this lab, you'll be able to deploy Azure App Service web apps. Generate and monitor Azure Web App application traffic by using Application Insights. Investigate Azure Web App performance by using Application Insights. Track Azure Web App usage by using Application Insights. Create Azure Web App alerts by using Application Insights. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Identify an existing Azure subscription or create a new one. Verify that you have a Microsoft or Microsoft Entra ID account with the owner role in the Azure subscription and the global administrator role in the Microsoft Entra ID tenant associated with the Azure subscription. For details, refer to List Azure role assignments using the Azure portal and view and assign administrator roles in Microsoft Entra ID. Exercises. During this lab, you'll complete the following exercises. Exercise 0, configure the lab prerequisites. Exercise 1, monitor an Azure App Service web app using Azure Application Insights. Exercise 2, remove the Azure Lab resources. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check your answers. Check your knowledge. 1. Which of the following choices Azure Monitor lets you create custom dashboards based on? Alerts, action groups. Metrics, logs. Action groups, workflows. 2. Which of the following query languages can you use to query Azure Log Analytics? Custo. T-SQL. XPath. 3. Which of the following choices is the unique key configured by Application Insights used by the Application Insights SDK? Application Insights key. App Insights SDK key. App Insights key. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module introduced you to continuous feedback practices and tools to track usage and flow, such as Azure Logs Analytics, Custo Query Language, KQL, and Application Insights. You learned how to describe the benefits and usage of. Implement tools to track feedback. Plan for continuous monitoring. Implement application insights. Use Custo query language, KQL. Learn more. Introduction. Completed 100 XP. 1 minute. This module explains steps to develop monitoring with Azure dashboards, work with View Designer and Azure Monitor, and create Azure Monitor workbooks. Also, explore tools to support monitoring with Power BI. Learning objectives. After completing this module, students and professionals can configure Azure dashboards, work with View Designer in Azure Monitor, create Azure Monitor workbooks, monitor with Power BI. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Configure monitoring in GitHub. Completed 100 XP. 3 minutes. GitHub offers native monitoring of project-related activities through its insights, including code changes and collaboration metrics. By enabling the monitoring functionality, you can track repository traffic, assess contributor activity, and identify trends over time. This enhances visibility, fosters collaboration, and helps making data-driven decisions. By default, charts are available to anyone that can view the project. With insights for projects, you can use the default or create custom charts. Insights support 2 types of charts, current and historical. Current charts. Current charts provide the ability to visualize project items. The default status chart shows the current total number of items in the project. You can create custom charts to show how many work items are assigned to each team member or how many issues are raised in each iteration. You also can modify the way data is presented through filtering, such as displaying the volume of remaining work, but limiting the results to particular labels or assignees. Historical charts. Historical charts provide the ability to track and visualize changes to project items over time. The default burn-up chart visualizes the progress of project issues over time, showing how much work is completed and how much is left. You can use this chart to view progress, spot trends, and identify bottlenecks to help move the project forward. With custom charts, you can target items with open issues and pull requests, items with issues that were closed as completed or merged via pull requests, as well as items with issues that were closed as not planned. Note that insights don't track items you have archived or deleted. Creating charts. Insights are available for all new projects by default, although historical charts require GitHub Team and GitHub Enterprise Cloud. You can create unlimited charts in private projects with GitHub Team and GitHub Enterprise Cloud for organizations and GitHub Pro for users. Users and organizations using public projects can create an unlimited number of charts. Users and organizations using GitHub Free are limited to 2 charts per private project. To create a chart, in github.com navigate to the target project and, in the top right corner of the page, select the Insights icon displaying a graph. Next, in the vertical navigation menu on the left side of the page, select New Chart. Assign a meaningful name to the chart and select Configure to modify the default chart settings. In the Configure Chart pane, select the values of the following properties: layout, bar, column, line, stacked area, stacked bar, or stacked column. X-axis, assignees, labels, milestone, repository, status, or time. Group by, optional none, assignees, labels, milestone, or repository. Y-axis, count of items, sum of a field, average of a field, minimum of a field, or maximum of a field. To create a historical chart, set your chart's X-axis to time. If needed, above the chart, enter filters to scope the data used to construct the chart. Explore Azure dashboards. 3 minutes. Visualizations such as charts and graphs can help you analyze your monitoring data to drill down on issues and identify patterns. Depending on the tool you use, you may also share visualizations with other users inside and outside of your organization. Azure dashboards are the primary dashboarding technology for Azure. They're handy in providing a single pane of glass over your Azure infrastructure and services, allowing you to identify critical issues quickly. Advantages. Deep integration into Azure. Visualizations can be pinned to dashboards from multiple Azure pages, including metrics analytics, log analytics, and application insights. Supports both metrics and logs. Combine data from multiple sources, including output from Metrics Explorer, log analytics queries, and maps and availability in application insights. Option for personal or shared dashboards. It's integrated with Azure Role-Based Authentication, RBAC. Automatic refresh. Metrics refresh depends on the time range with a minimum of 5 minutes. Logs refresh at 1 minute. Parameterized metrics dashboards with timestamp and custom parameters. Flexible layout options. Full screen mode. Limitations. Limited control over log visualizations with no support for data tables. The total number of data series is limited to 10, with different data series grouped under another bucket. No custom parameter support for log charts. Log charts are limited to the last 30 days. Log charts can only be pinned to shared dashboards. No interactivity with dashboard data. Limited contextual drill down. Explore Azure Monitor workbooks. Completed 100 XP. 3 minutes. Workbooks are interactive documents that provide deep insights into your data, investigation, and collaboration inside the team. Specific examples where workbooks are helpful are troubleshooting guides and incident postmortem. Advantages. Supports both metrics and logs. Supports parameters enabling interactive reports. Selecting an element in a table will dynamically update associated charts and visualizations. Document-like flow. Option for personal or shared workbooks. Easy, collaborative-friendly authoring experience. Templates support the public GitHub-based template gallery. Limitations. No automatic refresh. No dense layout like dashboards, which make workbooks less useful as a single pane of glass. It's intended more for providing more profound insights. Explore Power BI. Completed 100 XP. 1 minute. Power BI is beneficial for creating business-centric dashboards and reports analyzing long-term KPI trends. You can import the results of a log query into a Power BI dataset to take advantage of its features, such as combining data from different sources and sharing reports on the web and mobile devices. Advantages. Rich visualizations. Extensive interactivity, including zoom-in and cross-filtering. Easy to share throughout your organization. Integration with other data from multiple data sources. Better performance with results cached in a queue. Limitations. It supports logs but not metrics. No Azure RM integration. Can't manage dashboards and models through Azure Resource Manager. Need to import query results into the Power BI model to configure. Limitation on result size and refresh. For more details about limitations, see Limitations of Power BI Q&A. Power BI. Build your own custom application. Completed 100 XP. 2 minutes. You can access data in log and metric data in Azure Monitor through their API using any REST client. It allows you to build your custom websites and applications. Advantages. Complete flexibility in UI, visualization, interactivity, and features. Combine metrics and log data with other data sources. Disadvantages. Significant engineering effort is required. Monitor pipeline health, including failure rate, duration, and flaky tests. Completed 100 XP. 3 minutes. Monitoring the health of Azure pipelines is fundamental to ensuring the reliability and efficiency of software delivery processes. By tracking health metrics such as pipeline fail rates and duration in combination with assessing and remediating flaky tests, you can identify issues affecting the functionality of pipelines, optimize their performance, and enhance their resiliency. To simplify the monitoring process, you might want to leverage native Azure services such as Azure Pipelines reports and application insights, although you also have the option of using third-party tools that integrate with Azure DevOps or are accessible via Azure DevOps service hooks. Monitoring and assessment targets. There are several monitoring and assessment targets that provide insights into the overall health and reliability of Azure pipelines. Tracking and remediating their occurrences promotes continuous improvement and high-quality software releases. Fail rate. The failure rate of Azure pipelines reflects the frequency of build or deployment failures within a specified timeframe. Monitoring this metric helps identify trends and patterns in failures, pinpointing potential issues in code quality, configuration, or infrastructure. By establishing thresholds and alerts based on failure rate, you can promptly address issues, minimize downtime, and ensure the reliability of pipeline workflows. Duration. Tracking the duration of pipeline runs is critical for evaluating efficiency and performance of the software delivery process. Its monitoring helps identify processes that may be causing delays or inefficiencies. By analyzing duration trends over time, you can optimize resource utilization, streamline workflows, and accelerate the frequency of software releases. Flaky tests. Flaky tests are automated tests that produce inconsistent results, yielding different outcomes under the same conditions. Flaky tests can cause intermittent build failures, leading to unpredictable pipeline behavior, resulting in unnecessary alerts, consuming resources for investigations, and delaying the progression of the pipeline. They also tend to lead to false positives, where passing tests incorrectly indicate the absence of defects, or false negatives, where failing tests identify non-existing defects. While flaky tests originate from the testing phase of the pipeline, their impact extends to the overall health and reliability of the pipeline itself. Effectively, identifying flaky tests in Azure pipelines is essential for maintaining the integrity of test suites and ensuring the reliability of test-driven development practices. By detecting and eliminating flaky tests as part of pipeline health monitoring, you can ensure the stability, accuracy, and confidence of the software delivery processes, yielding higher quality software releases. Monitoring and assessment services and tools. In addition to identifying the monitoring and assessment targets, you also need to determine the most suitable service or tool to deliver the required functionality. Azure Pipelines reports. Azure Pipelines offer built-in pipeline run analytics. These analytics are collected and calculated over time and form the basis of the insights visualized through reports. The reports include metrics and trends that help improve pipeline efficiency. On the reports pages, you can review the status of builds and releases, as well as any pending or failed pipelines. The interface provides direct access to detailed logs and metrics for each pipeline. For example, the Pipeline Pass Rate report provides a granular view of the pipeline pass rate and its trend over time. You can also view which specific task failure contributes to a high number of pipelines run failures and use that insight to fix the top failing tasks. The pipeline duration report shows detailed breakdown of how long pipelines typically take to complete successfully. This helps with identifying trends and identifying the tasks which contribute most to the pipeline duration. The test failures report provides a granular view of the top failing tests in the pipeline, along with the failure details. Application Insights. Application Insights is a feature of Azure Monitor that allows you to monitor the performance of your applications, including Azure pipelines. You can use Application Insights to monitor the latency and throughput of your pipelines, as well as any errors or exceptions that occur. In addition, through integration of Azure pipelines with Application Insights, it becomes possible to implement continuous monitoring of the entire software development lifecycle. With continuous monitoring, release pipelines are able to leverage monitoring data from Application Insights and other Azure resources. When the release pipeline detects an Application Insights alert, the pipeline can gate or roll back the deployment until the alert is resolved. Conversely, if all checks pass, deployments can progress automatically to production, without the need for manual intervention. Service hooks. Service hooks in Azure DevOps facilitate integration with a wide range of external services. They allow you to trigger notifications and actions in response to Azure DevOps events, such as pipeline runs. By incorporating service hooks into your Azure pipeline's monitoring processes, you can, for example, implement real-time notifications in response to pipeline failures and performance issues. In addition, you have the option to automatically initiate corrective actions to enhance the reliability and stability of their software delivery processes. Third-party monitoring tools. There are also third-party monitoring tools that support integration with Azure pipelines, including, for example, Datadog, New Relic, and AppDynamics. This provides extra flexibility, especially in scenarios that involve integrating Azure pipeline monitoring into your existing monitoring strategy. Optimize a pipeline for cost, time, performance, and reliability. Completed 100 XP. 3 minutes. GitHub offers native monitoring of project-related activities through its insights, including code changes and collaboration metrics. By enabling the monitoring functionality, you can track repository traffic, assess contributor activity, and identify trends over time. This enhances visibility, fosters collaboration, and helps making data-driven decisions. By default, charts are available to anyone that can view the project. With Insights for projects, you can use the default or create custom charts. Insights support two types of charts, current and historical. Current charts. Current charts provide the ability to visualize project items. The default status chart shows the current total number of items in the project. You can create custom charts to show how many work items are assigned to each team member or how many issues are raised in each iteration. You also can modify the way data is presented through filtering, such as displaying the volume of remaining work, but limiting the results to particular labels or assignees. Historical charts. Historical charts provide the ability to track and visualize changes to project items over time. The default burn-up chart visualizes the progress of project issues over time, showing how much work is completed and how much is left. You can use this chart to view progress, spot trends, and identify bottlenecks to help move the project forward. With custom charts, you can target items with open issues and pull requests, items with issues that were closed as completed or merged via pull requests, as well as items with issues that were closed as not planned. Note that Insights don't track items you have archived or deleted. Creating charts. Insights are available for all new projects by default, although historical charts require GitHub Team and GitHub Enterprise Cloud. You can create unlimited charts in private projects with GitHub Team and GitHub Enterprise Cloud for organizations and GitHub Pro for users. Users and organizations using public projects can create an unlimited number of charts. Users and organizations using GitHub Free are limited to 2 charts per private project. To create a chart, in github.com navigate to the target project and, in the top right corner of the page, select the Insights icon displaying a graph. Next, in the vertical navigation menu on the left side of the page, select New Chart. Assign a meaningful name to the chart and select Configure to modify the default chart settings. In the Configure chart pane, select the values of the following properties: layout, bar, column, line, stacked area, stacked bar, or stacked column. X-axis, assignees, labels, milestone, repository, status, or time. Group by, optional none, assignees, labels, milestone, or repository. Y-axis, count of items, sum of a field, average of a field, minimum of a field, or maximum of a field. To create a historical chart, set your chart's X-axis to time. If needed, above the chart, enter filters to scope the data used to construct the chart. Optimize pipeline concurrency for performance and cost. Completed 100 XP. 3 minutes. Optimizing pipeline concurrency in Azure DevOps contributes to efficient resource utilization, cost reduction, and performance improvements. By balancing concurrency with performance and cost considerations, organizations can streamline pipeline workflows, accelerate software delivery, and maximize the benefits of their DevOps processes. Optimization involves balancing performance requirements against cost considerations in order to achieve the most efficient resource utilization. There are several considerations that you should take into account when defining the optimization strategy. Utilizing parallel jobs and stages. Divide task sequences in pipelines into parallel jobs and stages to maximize concurrency and reduce overall execution time. Utilize matrix builds and multi-stage pipelines to parallelize builds across different configurations or environments. In general, using parallelism allows for multiple jobs to run simultaneously, which tends to increase the efficiency of resource utilization and overall pipeline performance. However, this increase in performance needs to be weighed against the cost associated with running parallel jobs. It is important to find a proper balance between the desired performance and the number of parallel jobs to minimize costs. Leveraging job dependencies and conditions. Define dependencies between pipeline stages and jobs to prevent resource contention and optimize execution order. Use job dependencies and conditions to orchestrate pipeline execution and ensure optimal utilization of resources. Right-sizing pipeline agents. Choose the appropriate size and type of pipeline agents based on workload requirements. Create multiple agent pools with compute resources sized according to workload demands and avoid over-provisioning. Use dynamic agent allocation to scale pipeline based on workload demand. Implement policies to automatically scale up or down pipeline agent pools in response to workload fluctuations. Monitoring and adjusting concurrency settings. Monitor pipeline performance metrics, such as queue time and job duration, to identify opportunities for further optimization. Adjust concurrency settings, such as maximum parallelism and agent pool size, based on workload patterns and performance requirements. Knowledge check. Completed 200 XP. 5 minutes. Choose the best response for each question. Then select Check Your Answers. Check your knowledge. 1. Which of the following choices is a platform integration Azure Monitor provides to visualize your logs in real time? Azure Dashboards. Power BI. Excel. 2. Which of the following choices is an Azure Dashboards limitation? Log charts can only be pinned to shared dashboards. Full screen mode. Parameterized metrics dashboards with timestamp and custom parameters. 3. Which of the following choices is a feature in Azure Monitor that allows you to create custom visualizations with log data? Workbooks. View Designer. Data export. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module explains steps to develop monitoring with Azure Dashboards, work with View Designer and Azure Monitor, and create Azure Monitor workbooks. Also, explored tools to support monitoring with Power BI. You learned how to describe the benefits and usage of. Configure Azure Dashboards. Work with View Designer in Azure Monitor. Create Azure Monitor workbooks. Monitor with Power BI. Learn more. Introduction. Completed 100 XP. 1 minute. This module describes how to share knowledge within teams, Azure DevOps wikis, and integration with Azure boards. Learning objectives. After completing this module, students and professionals can share knowledge with development teams, work with Azure DevOps wikis, integrate with Azure boards. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Share acquired knowledge within development teams. Completed 100 XP. 1 minute. Organizational knowledge builds up within development teams over time. It's essential to avoid endlessly relearning the same lessons that the team and the organization has learned before. As staff turnover occurs in teams, it's easy for organizational knowledge to be lost. It's important to record this knowledge to avoid this loss. A simple example is if the team has developed coding standards. It should be captured and not just exist as word of mouth. Relearning old lessons is both wasteful and expensive. To reflect. Azure DevOps can be used with a wide range of existing tooling used to share knowledge. Which knowledge sharing tools do you currently use, if any? What do you or don't you like about the tools? Introduction to Azure DevOps Project Wikis. Completed 100 XP. 2 minutes. Azure DevOps Projects includes an option to create a project wiki. The wiki to share information with your team to understand and contribute to your project. Wikis are stored in a repository. No wiki is automatically provisioned. Prerequisites. You must have permission to create a repository to publish code as a wiki. While the project administrators group has this permission by default, it can be assigned to others. To add or edit wiki pages, you should be a member of the contributors group. All team project members, including stakeholders, can view the wiki. Creation. The following article includes details on creating a wiki. Create a wiki for your project. Editing the wiki. The following article includes details on publishing a Git repository to a wiki. Publish a Git repository to a wiki. Markdown. Azure DevOps wikis are written in Markdown and can also include file attachments and videos. Markdown is a markup language. The plain text includes formatting syntax. It has become the de facto standard for writing projects and software documentation. One key reason for this is that because it's made up of plain text, it's easier to merge in the same way that program code is merged. It allows documents to be managed with the same tools used to create other code in a project. GitHub Flavored Markdown, GFM. GFM is a formal specification released by GitHub that added extensions to a base format called CommonMark. GFM is widely used both within GitHub and externally. GFM is rendered in Azure DevOps wikis. Mermaid. Mermaid has become an essential extension to Markdown because it allows diagrams to be included in the documentation. It overcomes the difficulties of merging documentation, including diagrams represented as binary files. Details on Mermaid syntax can be found here. Mermaid Introduction. Integrate GitHub and Azure DevOps with Microsoft Teams. Completed 100 XP. 3 minutes. The ability to integrate both GitHub and Azure DevOps with Microsoft Teams fosters seamless collaboration and communication across a wide range of DevOps scenarios. Programmers and operational teams benefit from real-time notifications and updates directly within their team's channels, allowing for immediate visibility into events taking place throughout the entire software development lifecycle. This integration is particularly useful in tracking work item changes, monitoring build and release pipelines, generating alerts triggered by critical deployment issues, as well as facilitating discussions and feedback on code changes. By bringing together DevOps platforms and teams, organizations can enhance productivity, streamline workflows, and ensure that everyone stays informed and aligned with project goals and objectives. Integrating GitHub with Microsoft Teams. The GitHub app for Microsoft Teams allows seamless integration between the two platforms, enabling users to receive notifications and interact with GitHub directly from Teams. You can install the GitHub app for Microsoft Teams from the Teams App Store or directly from GitHub by navigating to the https://teams.github.com webpage. Following a successful installation, a welcome message will prompt you to use the @GitHub handle to interact with the app. To start, link to your GitHub accounts by entering @GitHub sign-in, which will trigger the GitHub authentication process. To subscribe to notifications for pull requests and issues in an organization or repository, use the @GitHub subscribe organization/repository command. Notifications can be customized by subscribing to specific features using @GitHub subscribe owner/repo feature, and unsubscribing from less relevant activities using @GitHub unsubscribe owner/repo feature. Default features include issues, pull requests, commits, comments, deployments, and releases. It's possible to selectively enable or disable other features, such as reviews, workflows, branches, and discussions. To further scope notifications, use filtering. Branch filters allow limiting commit notifications to specific branches or patterns of branches. Label filters limit incoming events based on whitelist labels, such as priority or specific team labels. You can also organize notifications by using pull request and issue notification cards and threading. Notifications for pull requests and issues are grouped under parent cards as replies, displaying relevant metadata and providing threading for improved collaboration. Teams conversations frequently result in actionable takeaways and drive decision-making. The integration facilitates these activities by supporting issue creation and management. You can create issues with a single click from Teams, accessing the Create an Issue option in the Message Options menu. The issue creation dialog automatically populates with message content, allowing selection of labels, assignees, and milestones, and confirming issue creation with a notification card. You can also perform various actions on issues and pull requests, such as closing, reopening, and commenting directly from Teams. Another integration area targets Actions workflow notifications. This allows you to subscribe to GitHub Actions workflow run notifications, with tracking workflow status and approvals available directly from Teams. Notifications provide updates on workflow progress, including job status and completion, with options to rerun workflows and enable debug logs. By default, the focus is on workflows triggered via pull requests on the default branch, but you have the option to customize filtering criteria based on name, event, actor, and branch. Separate notifications are available for deployments, with users mentioned in notifications requiring attention. Mentions work when logged into GitHub app from Teams, mapping GitHub ID with Teams ID to ensure notifications reach the intended recipients. GitHub links shared in Microsoft Teams channels automatically display previews with details such as pull requests, issues, discussions, comments, code snippets, repositories, and accounts. Similarly, discussions and their comments can be unfurled automatically in Teams, providing a preview of the discussion content. You can configure reminders for pending pull requests either in Teams channels or their personal chats. Configuration options include selecting days, times, time zones, teams, repositories, and advanced settings such as ignoring drafts, requiring review requests, and setting minimum age/staleness for pull requests. Integrating Azure DevOps with Microsoft Teams. The integration between Azure DevOps with Microsoft Teams offers a convenient collaboration experience across 3 key areas: boards, repos, and pipelines. With the Microsoft Teams GitHub app, you can manage your project's progress with boards, track code changes and collaborate on repos, and streamline CI/CD workflows with pipelines, all within the Microsoft Teams environment. This comprehensive integration enhances productivity and communication by providing a unified interface for project management and development activities. Azure Boards integration. The Azure Boards app for Microsoft Teams streamlines project management by allowing users to create, monitor, and collaborate on work items directly within their Teams channel. In order to use the Azure Boards app, ensure that you have at minimum the contributor's privileges in the Azure Boards project and that the app access via OAuth for the Azure DevOps organization is enabled. Once these prerequisites are satisfied, you can add the Azure Boards app to your Teams channel by accessing the App Store in Microsoft Teams, installing the app, and using the Azure Boards handle to interact with it. To take advantage of the app's features, link your Azure Boards project to your Teams channel. This involves connecting and authenticating with Azure Boards and using the Azure Boards link command in the Teams channel. To unlink using a project from a channel, use the Azure Boards unlink command. Next, create subscriptions to monitor work items using the Azure Boards Subscriptions command. They can select specific area paths and events they're interested in and customize their notifications accordingly. Notifications within the Teams channel are threaded to logically link and reduce related notifications, providing a more organized communication experience. You can add area paths from your projects to the channel to facilitate work item creation and subscriptions, especially for projects with numerous area paths. To create work items, use either the Azure Boards Create command or message actions within the Teams channel, which streamlines the process of converting discussions into actionable tasks. The app supports Compose extension, allowing you to search for and share work items directly within Teams. You can preview work item URLs shared within the channel. You can also configure Azure DevOps Services tabs in Microsoft Teams to bring Kanban boards or dashboards directly into your channel. This enhances visibility and accessibility of project-related information. Azure Repos integration. The Azure Repos app for Microsoft Teams facilitates monitoring of repositories for users of Microsoft Teams and Azure Repos. This integration simplifies repository management and enhances collaboration among team members. As with the Azure Boards app, before using the app, ensure they have the necessary permissions at the repository level and that the app access via OAuth for the Azure DevOps organization is enabled. Once these prerequisites are satisfied, you can add the Azure Repos app to your Teams channel by accessing the App Store in Microsoft Teams, installing the app, and using the Azure Repos handle to interact with it. After installing the app, connect it to your repos by using the Azure Repos sign-in command and specifying the project or repo URL, enabling monitoring of code changes and pull requests. To manage subscriptions to repo-related events, use commands such as @Azure Repos Subscribe and @Azure Repos Subscriptions, allowing customization of notifications based on specific conditions and filters. To remove subscriptions related to repositories, use the @Azure Repos Unsubscribe All, Project URL, command. The Azure Repos app supports a Compose extension, which supports searching for and sharing pull request information within Microsoft Teams. You can preview pull request URLs shared within the channel. This feature enhances visibility and understanding of pull request-related conversations. As with the Azure Boards app, notifications within the channel are threaded to logically link related notifications and reduce clutter. This provides a more organized communication experience and enhances visibility of pull request-related discussions. Azure Pipelines integration. The Azure Pipelines app for Microsoft Teams simplifies pipeline monitoring and management, providing notifications and pipeline management capabilities directly within Teams channels. This integration streamlines the pipeline monitoring process and facilitates efficient collaboration. As with the other two Azure DevOps-related Microsoft Teams apps, before using this one, ensure they have the necessary permissions at the level of the project hosting the pipelines and that the app access via OAuth for the Azure DevOps organization is enabled. Once these prerequisites are satisfied, you can add the Azure Repos app to your Teams channel by accessing the App Store in Microsoft Teams, installing the app, and using the Azure Pipelines handle to interact with it. After installing the app, connect it to your pipelines by using the Azure Pipelines sign-in command. Next, use the Azure Pipelines subscribe command to subscribe either to individual or all pipelines in a project. You can customize pipeline subscriptions to receive notifications for specific events, such as failed builds or deployments to production environments. The Azure Pipelines app supports filters to tailor notifications according to your preferences. The app supports approving deployments directly from their Teams channel without accessing the Azure Pipelines portal. Notifications with options to approve or reject deployment requests are posted in the channel, facilitating quick decision-making and enhancing workflow efficiency. Notifications linked to a particular run of a pipeline are logically linked together, providing a clear overview of pipeline activities and facilitating organized communication within the channel. The Azure Pipelines app also includes a Compose extension, allowing you to search for and share pipeline information directly within Microsoft Teams. When pipeline URLs are shared in Teams, you can preview them to monitor updates on pipeline-related conversations. These previews help keep discussions relevant and provide quick access to pipeline details. Share team knowledge using Azure Project Wiki. Completed 100 XP. 45 minutes. Estimated time, 45 minutes. Scenario. In this lab, you'll create and configure a wiki in Azure DevOps, including managing markdown content and creating a mermaid diagram. Objectives. After completing this lab, you'll be able to create a wiki in an Azure project. Add and edit markdown. Create a mermaid diagram. Requirements. This lab requires Microsoft Edge or an Azure DevOps supported browser. Set up an Azure DevOps organization. If you don't already have an Azure DevOps organization that you can use for this lab, create one by following the instructions available at Create an Organization or Project Collection. Exercises. During this lab, you'll complete the following exercises. Exercise 0, configure the lab prerequisites. Exercise 1, publish code as a wiki. Exercise 2, create and manage a project wiki. Knowledge check. Completed 200 XP. 4 minutes. Choose the best response for each question. Then select check your answers. Check your knowledge. 1. Which of the following choices is the minimum permission or group to add or edit wiki pages? Project administrator. Contributors. Stakeholders. 2. Which of the following choices is a functionality that allows you to easily create work items in Azure DevOps that have relevant application insights data embedded? Work item integration. Azure DevOps Wiki. AppStream. 3. Which of the following commands can you perform with the Azure pipelines with Microsoft Teams integration? Subscribe. Create. Unlink. You must answer all questions before checking your work. Summary. Completed 100 XP. 1 minute. This module described how to share knowledge within Teams, Azure DevOps Wikis, and integration with Azure boards. You learned how to describe the benefits and usage of. Share knowledge with development teams. Work with Azure DevOps Wikis. Integrate with Azure boards. Learn more. Introduction. Completed 100 XP. 1 minute. This module helps design process to application insights, explores telemetry and monitoring tools and technologies. Learning objectives. After completing this module, students and professionals can automate application analytics, assist DevOps with rapid responses and augmented search, integrate telemetry, implement monitoring tools and technologies. Prerequisites. Understanding of what DevOps is and its concepts. Familiarity with version control principles is helpful but isn't necessary. Beneficial to have experience in an organization that delivers software. Explore rapid responses and augmented search. Completed 100 XP. 5 minutes. In an agile environment, you may typically find multiple development teams that work simultaneously, introducing new code or code changes daily and sometimes several times a day. In such an immediate environment, it's prevalent to find problems that have slipped through the cracks to find themselves in the production environment. When these issues arise, they have probably already impacted end users, requiring a speedy resolution. It means that teams must conduct a rapid investigation to identify the root cause of the problem. Identifying where these symptoms are coming from and then isolating the root cause is a challenging task. Symptoms can be found across various layers of a large hybrid IT environment, such as different servers/VMs, storage devices, databases, to the front-end and server-side code. Investigations that traditionally would take hours or days to complete must be completed within minutes. Teams must examine the infrastructure and application logs as part of this investigation process. However, the massive amount of log records produced in these environments makes it impossible to do this manually. It's much like trying to find a needle in a haystack. In most cases, these investigations are conducted using log management and analysis systems that collect and aggregate these logs from infrastructure elements and applications, centralizing them in a single place and then providing search capabilities to explore the data. These solutions make it possible to conduct the investigation, but they still rely entirely on investigation skills and user knowledge. The user must know exactly what to search for and have a deep understanding of the environment to use them effectively. It's crucial to understand that the log files of applications are far less predictable than the log files of infrastructure elements. The errors are essentially messages and error numbers that have been introduced to the code by developers in a non-consistent manner. So, search queries yield thousands of results in most cases and do not include important ones, even when the user is skilled. That leaves the user with the same needle in a haystack situation. Assisting DevOps with augmented search. A new breed of log management and analysis technologies has evolved to solve this challenge. These technologies facilitate the identification and investigation processes using augmented search. Explicitly designed to deal with application logs' chaotic and unpredictable nature, augmented search considers that users don't necessarily know what to search for, especially in a chaotic application layer environment. The analysis algorithm automatically identifies errors, risk factors, and problem indicators while analyzing their severity by combining semantic processing, statistical models, and machine learning to analyze and understand the events in the logs. These insights are displayed as intelligence layers on top of the search results, helping the user quickly discover the most relevant and essential information. Although DevOps engineers may be familiar with the infrastructure and system architecture, the data is constantly changing with continuous fast-paced deployment cycles and constant code changes. It means that DevOps teams can use their intuition and knowledge to start investigating each problem, but they have blind spots that consume time because of the dynamic nature of the log data. Combining the decisions that DevOps engineers make during their investigation with the augmented search engine information layers on the critical problems that occurred during the period of interest can help guide them through these blind spots quickly. Combining the user's intellect, acquaintance with the system's architecture, and augmented search machine learning capabilities on the dynamic data makes it faster and easier to focus on the most relevant data. Here's how that works in practice. One of the servers went down, and any attempt to reinitiate the server has failed. However, since the process is running, the server seems to be up. In this case, end users are complaining that an application isn't responding. This symptom could be related to many problems in a complex environment with many servers. Focusing on the server behind this problem can be difficult, as it seems to be up. But finding the root cause of the problem requires a lengthy investigation, even when you know which server is behind this problem. Augmented search will display a layer that highlights critical events during the specified period instead of going over thousands of search results. These highlights provide information about the sources of the events, assisting in the triage process. At this point, DevOps engineers can understand the impact of the problem, for example, which servers are affected by it, and then continue the investigation to find the root cause of these problems. Using augmented search, DevOps engineers can identify a problem and the root cause in a matter of seconds instead of examining thousands of log events or running multiple checks on the various servers. Adding this type of visibility to log analysis and the ability to surface critical events out of tens of thousands and often millions of events is essential in a fast-paced environment that constantly introduces changes. Integrate telemetry. Completed 100 XP. 5 minutes. A key factor to automating feedback is telemetry. By inserting telemetric data into your production application and environment, the DevOps team can automate feedback mechanisms while monitoring applications in real time. DevOps teams use telemetry to see and solve problems as they occur, but this data can be helpful to both technical and business users. When properly instrumented, telemetry can also be used to see and understand how customers are engaging with the application in real time. It could be critical information for product managers, marketing teams, and customer support. So, feedback mechanisms must share continuous intelligence with all stakeholders. What is telemetry, and why should I care? In the software development world, telemetry can offer insights on which features end users use most, detect bugs and issues, and provide better visibility into the performance without asking for feedback directly from users. In DevOps and the world of modern cloud apps, we're tracking the health and performance of an application. That telemetry data comes from application logs, infrastructure logs, metrics, and events. The measurements are things like memory consumption, CPU performance, and database response time. Events can be used to measure everything else, such as when a user logged in, when an item is added to a basket, when a sale is made, and so on. The concept of telemetry is often confused with just logging. But logging is a tool used in the development process to diagnose errors in code flows. It's focused on the internal structure of a website, app, or another development project. Logging only gives you a single-dimension view. With insights into infrastructure logs, metrics, and events, you have a 360-degree view of understanding user intent and behavior. Once a project is released, telemetry is what you are looking for to enable data collection from real-world use. Telemetry is what makes it possible to collect all that raw data that becomes valuable, actionable analytics. Common sources of telemetry. When it comes to gathering telemetry, there are various sources to tap into for valuable insights. Azure offers a rich ecosystem of services that provide telemetry data from different aspects of your application and infrastructure. For instance, telemetry can be collected from Windows and Linux servers running in Azure, other cloud environments, or on-premises, containerized workloads, storage accounts, network services, and more. These sources offer a wealth of information about the health, performance, and usage of your resources. To harness the power of this telemetry data, Azure provides specialized insight services tailored to these different sources. One such service is Application Insights, which focuses on collecting telemetry from web applications hosted on app services, physical and virtual servers, containers, and other types of compute resources. It offers detailed monitoring and diagnostics capabilities, allowing you to track performance metrics, detect issues, and analyze user interactions. If you want to monitor physical and virtual servers running Windows or Linux, VM Insights provides deep visibility into their performance and health metrics, enabling proactive management and troubleshooting. It offers features like performance trend analysis, anomaly detection, and recommendations for performance optimization. Container Insights is designed to gather telemetry from containerized applications running on Azure Kubernetes Service, AKS, or Arc-enabled Kubernetes clusters. It provides insights into container performance, resource utilization, and application dependencies, helping you optimize containerized workloads and ensure their reliability and scalability. Storage Insights focuses on telemetry data related to Azure storage accounts, providing visibility into storage performance, usage patterns, and access trends. It enables you to monitor storage latency, throughput, and capacity utilization, helping you optimize storage configurations and identify potential bottlenecks. Lastly, Network Insights collects telemetry from Azure network services, such as Azure Virtual Networks, load balancers, and firewalls, to monitor network performance, connectivity, and security. It offers visibility into network traffic patterns, latency metrics, and security events, allowing you to troubleshoot network issues and optimize network configurations for better performance and reliability. Benefits of telemetry. The primary benefit of telemetry is the ability of an end user to monitor the state of an object or environment while physically far removed from it. Once you've shipped a product, you can't be physically present, peering over the shoulders of thousands, or millions, of users as they engage with your product to find out what works, what is easy, and what is cumbersome. Thanks to telemetry, those insights can be delivered directly into a dashboard for you to analyze and act. Because telemetry provides insights into how well your product is working for your end users, as they use it, it's a unique tool for ongoing performance monitoring and management. Plus, you can use the data you've gathered from version 1.0 to drive improvements and prioritize updates for your release of version 2.0. Telemetry enables you to answer questions such as: are your customers using the features you expect? How are they engaging with your product? How frequently are users engaging with your app, and for what duration? What settings options do users select most? Do they prefer certain display types, input modalities, screen orientation, or other device configurations? What happens when crashes occur? Are crashes happening more frequently when certain features or functions are used? What is the context surrounding a crash? The answers to these and the many other questions that can be answered with telemetry are invaluable to the development process. It will enable you to make continuous improvements and introduce new features that, to your end users, may seem as though you have been reading their minds, which you've been, thanks to telemetry. Challenges of telemetry. Telemetry is a fantastic technology, but it isn't without its challenges. The most prominent challenge, and a commonly occurring issue, isn't with telemetry itself but with your end users and their willingness to allow what some see as Big Brother-esque spying. In short, some users immediately turn it off when they notice it, meaning any data generated from their use of your product won't be gathered or reported. That means the experience of those users won't be accounted for when it comes to planning your future roadmap, fixing bugs, or addressing other issues in your app. Although it isn't necessarily a problem by itself, the issue is that users who tend to disallow these types of technologies can tend to fall into the more tech-savvy portion of your user base. It can result in the dumbing down of software. On the other hand, other users take no notice of telemetry happening behind the scenes or ignore it if they do. It's a problem without a clear solution, and it doesn't negate the overall power of telemetry for driving development, but one to keep in mind as you analyze your data. So, when designing a strategy for how you consider the feedback from application telemetry, it's necessary to account for users who don't participate in providing the telemetry. Examine monitoring tools and technologies. Completed 100 XP. 4 minutes. Continuous monitoring of applications in production environments is typically implemented with Application Performance Management (APM) solutions that intelligently monitor, analyze, and manage cloud, on-premises, and hybrid applications and IT infrastructure. These APM solutions enable you to monitor your user's experience and improve the stability of your application infrastructure. It helps identify the root cause of issues quickly to prevent outages and keep users satisfied proactively. With a DevOps approach, we also see more customers broaden the scope of continuous monitoring into the staging, testing, and even development environments. It's possible because development and test teams following a DevOps approach are striving to use production-like environments for testing as much as possible. By running APM solutions earlier in the lifecycle, development teams get feedback about how applications will eventually do in the production and take corrective action much earlier. Also, operations teams advising the development teams get advanced knowledge and experience to better prepare and tune the production environment, resulting in far more stable releases into production. Applications are more business critical than ever. They must always be up, always fast, and constantly improving. Embracing a DevOps approach will allow you to reduce your cycle times to hours instead of months, but you must keep ensuring a great user experience. Continuous monitoring of your entire DevOps lifecycle will ensure development and operations teams collaborate to optimize the user experience every step of the way, leaving more time for your next significant innovation. When shortlisting a monitoring tool, you should seek the following advanced features. Synthetic monitoring, developers, testers, and operations staff all need to ensure that their internet and internet mobile applications and web applications are tested and operate successfully from different points of presence worldwide. Alert management, developers, testers, and operations staff all need to send notifications via email, voicemail, text, mobile push notifications, and Slack messages when specific situations or events occur in development, testing, or production environments to get the right people's attention and to manage their response. Deployment automation, developers, testers, and operations staff use different tools to schedule and deploy complex applications and configure them in development, testing, and production environments. We'll discuss the best practices for these teams to collaborate effectively and efficiently and avoid potential duplication and erroneous information. Analytics, developers need to look for patterns in log messages to identify if there's a problem in the code. Operations need to do root cause analysis across multiple log files to identify the source of the problem in complex applications and systems. Explore IT Service Management Connector. Completed 100 XP. 2 minutes. Customers use Azure monitoring tools to identify, analyze, and troubleshoot issues. However, the work items related to an issue are typically stored in an ITSM tool. Instead of having to go back and forth between your ITSM tool and Azure monitoring tools, customers can now get all the information they need in one place. ITSMC will improve the troubleshooting experience and reduce the time it takes to resolve issues. IT Service Management Connector, ITSMC, for Azure provides bidirectional integration between Azure monitoring tools and your ITSM tools, ServiceNow, Province, Chartwell, and System Center Service Manager. Specifically, you can use ITSMC to create or update work items, event, alert, incident in the ITSM tools based on Azure Alerts, Activity Log Alerts, Near Real-Time Metric Alerts, and Log Analytics Alerts. Pull the incident and change request data from ITSM tools into Azure Log Analytics. You can set up ITSMC by following this overview. ITSMC Overview. Knowledge Check. Completed 200 XP. 5 minutes. Choose the best response for each question.